Hi everyone. So before starting the next session, we need to modify an error that we have done in the previous video. So there was an error in the previous video. So what kind of error that we have done? So for that, first we need to see one important concept. After that, we will be able to analyze what was the error and how to modify that error. That also we will see. Okay. So if you remember the basic concept of integration. So if I integrate ft with respect to dt and my limit is from a to b. So if I interchange my limit from b to a, so both will have the same magnitude, but there would be a negative sign. If you remember this particular, what you can say, this particular rule from your elementary 11th 12th classes, then you would know this particular rule is there, that if you interchange the limit, then there would be a negative sign. If I go from a to b, I take ft dt, and if I go from b to a ft dt, then there would be a negative sign. Say yes or no. You remember it, right? Now, in this particular question, you need to find two things. You need to find the area if I am integrating from minus infinity to infinity. If I am integrating from minus infinity to infinity. And other one you need to find if you are integrating from plus infinity to minus infinity. So, if you go from minus infinity to infinity, you are working in this direction. So, how much area do you see? This much area do I see, right? So, what is this? This is 5 and 5 into 3, 15. And if I work from plus infinity to minus infinity, so again I would see this much area only. If I am working from plus infinity to minus infinity, again I am seeing this much area. So what is this length? 5 into 3, again 15. Till now this is what we have seen, right? Till now this is what we have seen. According to our knowledge, till now this is what we have done, right? But here I told you that if you interchange the limit, if you go from a to b and you interchange it to b to a, then there would be a negative sign. So if I am saying that from here minus infinity to infinity, the answer is 15, then from plus infinity to minus infinity, answer would have been minus 15. Or you can say opposite as well, that if answer is from plus infinity to minus infinity, if the answer is plus 15, then from minus infinity to plus infinity, answer would have been minus 15. Are you getting this point? If here there is plus, then here there would have been minus. And if here there is minus, then here would have been plus. So where plus will come, where minus will come, think about it. Certainly we have done some error. What we did, we just calculated the area from plus infinity to minus infinity and minus infinity to plus infinity. In both of them, we calculated the area. And area here is coming out to be positive only. But I know one thing, that if I interchange the limit, then there should be a negative sign. Either this would be positive or this would be negative, or this would be positive, this would be negative. Which one would be negative? So let's check out the A. Okay, let's check out this area A. So if I am going from minus infinity to plus infinity, that means I am working like this. And if I work like this, my value of t is increasing. If I am going from minus 2 to 3, the value of t is increasing. That means my dt is positive here. For this particular case, my dt is positive, because I will work from 0 to 3, or I will work from 1 to 2, or I will work from 1.1 to 1.2. Basically, your dt will be positive. And here your xt is also positive. Say yes or no? Xt is also positive. So this guy is also positive. And this guy is also positive. So positive into positive, answer should be positive only. Say yes or no? Yes, answer is positive. So answer is 15. And if I go from plus infinity to minus infinity, if I work in this direction, plus infinity to minus infinity, that means I am decreasing from 3 to minus 2. So what does that mean? That if dt is less than 0, here what will happen? Dt will be less than 0, because you are decreasing from 3 to minus 2. You will go from 1.2 to 1.1. So dt is less than 0, and here xt is greater than 0. So what would be the answer? This is your positive and this is your negative. So positive into negative, answer would have been negative. So it's for sure that both will have opposite sign. If it is plus, it is minus. But how did I check which one will have plus sign, which one will have negative sign? So for that, let's just say I calculated this value first. When I calculated this value first, I got to know that my answer is 15. So here my answer would be minus 15. Are you getting this point? So integration simply means area only. So now what is the conclusion? The conclusion is, whenever you need to calculate the integration, you will always calculate the area. But the area that you have calculated, that should be from lower limit to higher limit. What is this? This is your lower limit. And what is this? This is your higher limit. So if your integration is going from lower limit to higher limit, then whatever the area that you have got, that would be the answer. But if your integration is going from higher limit to lower limit, then whatever the area that you have got, the answer would be negative of that. Let's take another example. Okay, I'm gonna take another example. Same question I'm going to take, but this time what I'm gonna do, I'm gonna take the magnitude to be negative. This time your magnitude is negative. This point is -2, this point is -3, and this point is -5. This is your xt versus t. Now if I ask you the same question, that what will be your a value if you go from -infinity to infinity xt dt. So what you need to do here, you go to know that I need to calculate the area. What is the area? 5 into minus, what is this gap? This gap is 5, right? Previously this gap was 3 or this was 3. So here also let's take the same thing. This is also -3. So this gap is 5. 5 into -3, area is -15. Now the second thing I will check, if my limit is from lower limit to upper limit, this was your lower limit and this was your higher limit. If it is from lower to higher, yes, then I don't need to interchange the sign. But if I calculate this thing, plus infinity to minus infinity xt dt. So what I'm gonna do? Again I know that I am taking my journey from here to here, from plus infinity to minus infinity. So what I will do, I need to calculate the area only. What is the area that is coming out to be? -15. But another thing I need to notice, I am going from higher to lower. If you are going from higher to lower, then another minus sign you need to add. So what will be the answer? Plus 15. And you can check here as well. If you are working in this direction, that means your dt is negative. From 3 to -2 you are going, that means your value of dt is decreasing. So this is negative. And what about xt? Xt is -3, so this is also negative. So negative into negative, positive should come. Yes. What about the first case? You are going from -infinity to plus infinity, -infinity to plus infinity. So what is here? dt is positive, and what is the value of xt? Xt is -3, which is negative. So negative into positive, what should come? Negative should come. So negative is only is coming. So what is the conclusion now? Whenever I ask you to calculate any area, or whenever I ask you to calculate any integration, you just need to calculate the area only. But later on you need to see, what you need to see, that whether the limit is increasing or decreasing. If the limit is going from higher to lower, then another minus sign you need to add. If it is going from lower to higher, then whatever the area that you have got, that would be the answer. Let's take another question. Let's make it a bit more complex. Charger to on है यार, still the screen is lagging. Let's do this thing. This point is -1, this point is +1, this point is 2, and this magnitude is 1, this magnitude is -1. Okay, yeah. So if I ask you value of a, if you are going from, one second guys, I need to pause the video because the screen is lagging, then I will come back. Yeah, welcome back. So I have written down the question as well. You need to solve a, b, c, d. So let's get started with a. So what I need to do, -1 to 0 xt dt. So between -1 to 0 I need to calculate the area. This is your 0. -1 to 0 I need to calculate the area. So what will be the area? This is your base. Base is 1. What is your height? Height is also 1. So half into base into height, because it's a triangular structure. So in a triangular, half into base into height, so area would be half. The next thing I need to see, this is my area. Next thing I need to see, if I am going from lower to higher. Yes, I am going from -1 to 0, I am going from lower to higher. So here I don't need to interchange the sign. Let's take area B. So from 2 to 1 I am going. So between 1 to 2 I need to calculate the area, between 1 to 2. So this length is 1 and this height is also This height is actually minus 1. You can directly see. This length is 1. This height is minus 1. So what would be the area? Area would be negative here. I can directly see the area is negative here. This area is negative. So half into base into what is the height? Height is minus 1. So what is the area that is coming out to be? Minus 1 by 2. So area is negative, that is coming out to be minus 1 by 2. Second thing what I would see, that limit, I am going from higher to lower. If you go from higher to lower, you need to add another negative sign. So here I need to add another negative sign. So my answer will be plus half. Although the area is negative, although this area is negative, but you are taking the limit from 2 to 1. That's why your answer is half here. Let's check this point from 0 to 2 if you are going. From 0 to 2. 0 to 2 means this much area you need to calculate. 0 to 2 means this much area I need to calculate. So 0 to 2. What is this area? 0 to 2. So what is this much area? That is a square. So that is 1. And what is this much area? This area, that is minus half. So answer is coming out to be half only. Right? But you need to see the limit now from lower to higher. That means no change of sign. Right? Now you need to calculate from 2 to minus 1. From 2 to minus 1. So what is this area? Plus half. What is this area? Plus 1. And what is this area? Minus half. So what is the answer coming out to be? Plus half, minus half and 1. So answer is coming out to be 1. But you are going from 2 to minus 1. That's why you need to add another negative sign. Say yes or no. So whenever I am going from higher limit to lower limit, I need to interchange the sign. Is that conclusion clear? So in the last 10 minutes, this is what you have seen, that higher limit to lower limit, you need to interchange the sign. It is not always certain that if you are going from higher to lower, then your answer will always be negative. No, here answer is negative. When I am going from higher to lower, here my answer is negative. But here if I am going from higher to lower, my answer is positive as well. So answer could be both positive and negative. You need to think whether it will be positive or negative. Okay, and how will you think? First I will calculate the area blindly, then I will see the limit. Higher to lower, then I need to interchange the sign. If I interchange the sign, it became positive. Say yes or no. What error we did in these kind of problems? The error we did here, if your t was greater than 0, let's take up this example. This was the solution of x5 of t. So if my t was greater than 0, then my area was coming out to be 0 only. No issue about that. But if t became less than 0, let's just say if I am calculating at t equals to minus 2. So what I need to do? Integration from plus infinity to minus 2 u of minus 2 d2. So there what I need to do? I need to calculate the area from plus infinity to minus 2. That means I need to calculate the area from 0 to 2. So what is this area? This area is 2 into 1. So area is 2. Here I have written down 2. Area is 2, but the limit is from higher limit to lower limit. So I need to add another negative sign. Say yes or no. Right? x5 of minus 10. That means you will be calculating the area from infinity to minus 10. If I am calculating the area from infinity to minus 10, then means I am going from higher limit to lower limit. So again my area would be infinity to minus 10. Again the area would be plus 10 only. But since I am going from higher to lower, there would be a negative sign. So here x5 of t is equals to t only. For t less than 0, your x5 of t is coming out to be t only. Because here if there was minus 10, answer was minus 10. If here there is minus 5, minus 2, answer is minus 2. If it would have been minus 5, answer would have been minus 5. So for t less than 0, it is equals to t only. So instead of getting this graph, what kind of graph we would have got? The slope would have been plus 1, not minus 1. So slope would have been plus 1 here. This would have been the slope. So here instead of writing r of minus t, this is r of minus t with the negative sign. R of minus t with the negative sign. Because this guy will say that slope should be minus 1, this guy will say that slope should be minus 1. So minus 1 into minus 1, slope would be plus 1 only. And r of minus t, that means it should be looking towards minus infinity. Yes, it is looking towards minus infinity only. So this would be the graph. So what did you understand here? That sir, yes, trick is applicable. Whatever the trick that you have told, that sir, that is applicable. You will put t here. Trick is applicable here. But I need to add up an extra negative sign as well. And why that negative sign is coming? That negative sign is coming because you are integrating from higher limit to lower limit. That's it. Here also the same thing. I am integrating from higher limit to lower limit. So the trick is applicable. What is the trick? First you reduce it to the least possible form, then you put this t here. But if I am integrating from higher limit to lower limit, I need to put an extra negative sign. So whatever that you are doing, infinity to t, then I will, this was your sixth problem, right? Infinity to t, reduce it to the least possible form, then put this t here, put this t here, but extra negative sign would also be there. This t has been put here, but extra negative sign will also be there. Another thing you can check, how you can check, when you are integrating from plus infinity to t, you are integrating from plus infinity to t. So you are working like this, here you worked, here you worked, here you worked, here you worked. So at t equals to 0, what did you see? That there is a sudden jump actually. From 0 to 1 it is going. So there is a jump. And if there is a jump, that means slope would be positive. If there was a decay, then the slope would have been negative, no? But if there is a jump, so slope would be certainly positive. So here, how we were writing the negative slope. So that was an error from my side. Before anyone points it out, I have modified my error because that was a conceptual error. It should not have happened, and I am really sorry for that particular error. Okay, so that error should not have taken place. But now I am modifying my error. I myself thought of this. Okay, when I was sleeping, I was thinking of it. Okay, if I am calculating the area from higher to lower limit, why I am not interchanging the sign? So sign should be interchanged, and this is completely visual as well, because if there is a jump, so slope would have been positive only, no? When I was explaining this particular question in the previous video, at that time also I thought that if there is a jump, slope should have been positive, but later on I thought that okay, area will be positive only, so slope might be negative, but that was absolutely wrong. The concept says if the jump is there, slope should be positive, and slope is coming out to be positive only, and the area is actually coming out to be negative. Final area is actually coming out to be negative, although here the area looks like positive, but if the limit is from higher to lower, we need to add up some extra negative sign. Is that clear to you? So here also you can verify with the diagram as well. In this particular problem also you can make the diagram, because what will be the diagram of u of minus 2 tau plus 3, u of minus 2 tau plus 3. So this will be the diagram, u of minus 2 tau plus 3. So the breakpoint will be at 3 by 2. So you are integrating from infinity to t. So if t is greater than 3 by 2, no issue. If t is less than 3 by 2, so here you can see a jump. So jump means the slope should be positive, right? So how will you integrate it? If I draw the integration. So till 3 by 2 everything was fine. Till 3 by 2 everything was fine. But at 3 by 2 there is a jump. If there is a jump, that means slope should be positive. Here the slope should be positive, and the slope will be m equals to plus 1. So this slope says m should be minus 1, and this says m should be plus 1. So now how will I write down the expression? This is the integrated one. This is your x5 of t or x6 of t. This is your x6 of t. So how will I write down x6 of t? So where it is looking? It is looking towards minus infinity. That means it has to be r of minus t. Where is the breakpoint? Breakpoint is at 3 by 2. This guy is saying that slope should be minus 1, but actually the slope is plus 1. That means I need to add up another extra negative sign. So there you go, this would be the answer. So by the graph as well, I could have solved it. Okay. So that was a big error from my side. It should not have happened. But before anyone points it out, I'm already modifying my error. Okay. Here also the same thing will happen. You can do the exactly ditto same thing. Reduce it to the least possible form, then put this t minus 2 here. Everything is same, but extra negative sign would be there. Extra negative sign would be there. Extra negative sign would be there. Because in this waveform as well, you can see there is a sudden jump. So there will be an extra negative sign. Rest all fine? Yeah. So what did you understand? What was our error? That whenever we are integrating from higher limit to lower limit, we will do the same kind of analysis. No need to issue. No need to worry about that. But in the end, what I need to do? I need to add up another extra negative sign. Okay. One more thing is there in another lecture. This kind of error has happened, right? That error was happened with the impulse function as well. When I was doing the this time domain analysis, or you can say running integration of impulse function, at that time as well I have done the same error. When I was going from higher to lower, I forgot to take the limit. Okay, higher to lower. If I am going from higher limit to lower limit, then extra negative sign would be there. So that negative sign I need to add up in that particular video as well. So let me go there and we will modify that error as well. Yeah, so this was our fifth lecture, I guess. So in the fifth lecture as well, we were doing the same thing. We were calculating the running integration. So here I was going from lower to higher. So whatever the answer that I have got, all fine, no issue. But here you are going from higher to lower, right? So here what did you say? That if t is greater than minus 2, area is 0. But if t is less than minus 2, the area you put to be plus 1, but it is actually minus 1. Why is that so? Because you will be calculating from, let's just say, from minus infinity to minus 3. Sorry, plus infinity to minus 3. So area is 1, but the limit is going from higher to lower. So there would be a negative sign. If there is a negative sign here, here also there would be a negative sign. So actually the graph would be made opposite. The graph would be made like this. So always we will solve with respect to the diagram. Whenever a running integration question is coming, the diagram has to be there. If we are not making the diagram of running integration, because the running integration we are going to see in convolution as well. There will be a in the next chapter only there will be a topic called convolution. So people find it very difficult. The reason is they never make the diagram. So if you are not making the diagram in the problem of convolution, then you will always find it difficult. Okay, so whenever there is a running integration, we will always make the diagram. Here lower to higher, no issue. Whatever that we have done, fine. Lower to higher, no issue. Lower to higher, issue is there, right? Sorry, higher to lower. Really sorry, higher to lower. So here, where is the issue? Here is the issue that if I am going from infinity to minus 2 or less than minus 2, let's just say if I am going from infinity to minus 3. So area is half, but it is actually minus half, right? So area is actually minus half. So there would be a negative sign. Are you getting this point? So there has to be a negative sign. Just one second. So this will go downward. This would be minus half, right? Okay. Again, you are going from higher to lower. If I am going from higher to lower, then area would be minus half. Area would be minus half. You are going from higher to lower again. So again area would be minus half. So all these error that we have done, it should not have happened, but sorry for the error. Although you are never going to find these kind of things in any class notes anywhere. This kind of intuition you are never going to get anywhere. Okay, you can call it self praise or you can call it self confidence, but whatever the content that I am teaching, these are neither found in textbook nor in any lecture, nor in it will never be found in NPTEL. Forget about the GATE lectures. So never ever it will be found. These are pure understanding that have been built by my own. So when I was building the understanding, there was an error from my side, and later on when I thought of it, then I modified my error. So such kind of question you will certainly see in future examination, because the understanding that I am having, certainly the IIT professor will be having that understanding for sure, right? Because he is teaching, that IIT professor is teaching this subject at least for 15 years. So wouldn't he have got these kind of questions in the classroom? Certainly he would have got these kind of problems in the classroom. He would have thought of it, or anyway, like if you keep on studying the same thing, if you keep on teaching the same thing, new points will add up. If I am teaching signal system after 10 years, I will teach complete different way, because till that time I would have got different points in my mind. Although there are a lot of educators who are teaching for more than 10 years, but still their content are same only. Like you see, I don't wanna talk bad about anyone. All teachers are very good, but you would see like there would be some teachers who will be teaching the same thing after 5 years as well. Their notes never change. They teach the same and same thing. So like even if next year if I teach signal system, the notes will be changing. There will be complete different content in signal system. I will take up the content in a very different manner. So whenever we teach again and again, we try to add up new things, right? So yeah, so here the area would be, so here the amplitude will be minus half, right? So here also I will modify, it would be minus half. Here also I will say that, yeah, here also you are going from higher limit to lower limit. So you would say that, okay sir, I am going from infinity to 1. That means the area is half, but the area is minus half, because I am going from higher to lower. Okay. Here also you are applying the trick. All everything is fine, but add up the negative sign, add up the negative sign. So slope will not be plus 2, it would be minus 2. Okay, slope would be minus 2. Sorry, here slope was minus 2, the slope would be plus 2 here. Really sorry, the slope would be plus 2. And if someone asks you the value of x of 0 here, x of 0, what would be the value of x of 0? If the slope is plus 2, if this is decreasing by 1 by 4, then this should decrease by 2 into 1 by 4. That means it should decrease by 1 by 2. So x of 0 would be minus of 1 by 2, right? I guess we solved it with the two different methods. So again we need to check. Yeah. So same question we solved with two different methods. So here also actually the area is, you are calculating from infinity to 1. So area is actually minus 1 by 2, not plus 1 by 2. So here the area is minus 1 by 2. Okay. So same thing is happening here. So let it be, because this was wrong only, right? This was wrong. This answer was wrong actually. So I am not changing the wrong answer. I have just made the correct answer. Okay. So let this wrong answer be there as it is. Here what did I understand, that if I calculate infinity to 1, then the area is minus half, not plus half. It looks like that area is plus half here, but limit is from higher to lower. So area will be minus half. So the same kind of area the same kind of value x of 0 I am getting here as well. Here also I was getting x of 0 to be minus half. Here also I am getting x of 0 to be minus half. So this would be the correct answer. The slope will neither be minus 1, slope will neither be minus 2, slope will actually be plus 2. Say yes or no. Okay. Is there anything? No. So here trick is applicable, here conventional method you should go. Then we solve this question. So here also x of minus 2, if I am calculating infinity to minus 4, area is coming out to be 8 by 3, but higher to lower, so negative sign. Okay. So here also there will be a negative sign, and here also everything is same, but negative sign, negative sign. So everywhere there would be a negative sign. So minus 3 r of minus t minus 10 by 9. So what will be the slope here? Slope will be plus 3, not minus 3. So here the slope will be plus 3, not minus 3. So here also negative sign, here also negative sign, here also negative sign, here also negative sign. So in the examination you need to follow the same process. Okay, the ditto same process you need to follow. You will make the, first you will reduce it to least possible form, then you will put this thing here. When I put this thing here, I got this particular answer. Just you need to notice one thing, that if you are going from higher to lower, you need to add up a extra negative sign. That's it, nothing else. Okay. Then you are supposed to calculate x of minus 2. So from here you got to know that x of minus 2 is minus of 8 by 3. Is that okay for you? And this was also a thing that for step you can apply the trick, but for impulse you need to go for conventional method. So first I will go with the conventional method. Let's just say I take this example of a step. So first I will draw the diagram. Then I go to know that if my 2t plus 1 is greater than 3 by 2, then my area is coming out to be 0. But if my 2t plus 1 is less than 3 by 2, then my area is coming out to be 1 by 2. But since the limit is from infinite, from higher to lower, then my area is actually minus 1 by 2. And if the area is actually minus 1 by 2 after that, so this kind of waveform I will get. And what is this? This is your u of minus t plus 1 by 4, and the amplitude is minus half. So minus half u of minus t plus 1 by 4. So this would be the answer. Okay. So I hope I have modified the error, and I hope you would have understood what was my point here. Well and good. So let's go to the next lecture now. In the next lecture, now we are going to understand the different type of signals, whatever that are left. Okay, doublet function is left. Although I have already recorded the video, this video has been already recorded. As of now, I am recording the power part, power, energy, that part I am recording. So that will come later on, but in between, I had to modify this error. Since the error is modified now we will move to the next part where we will study about doublet function. Okay. Yeah. Thank you. Hi everyone. Welcome back. Welcome back to PrepFusion. So in the last video, what did I tell you? That we are going to study about doublet function now. And what is doublet function? Doublet function is simply the differentiation of impulse function, or you can call it impulse signal as well. So differentiation of impulse signal is your doublet signal. Till now, what all signal we have seen? Ramp, step, and impulse. We saw the differentiation of ramp, we got step. We saw the differentiation of step, we got impulse. Now we will see the differentiation of impulse, we will get doublet function. Now second thing, is there any physical significance of doublet function? Is there any physical significance of doublet function? We have seen the physical significance of ramp function as well. Ramp function is simply a waveform. So that kind of waveform you will see in your control system as well. You will see these kind of waveform in analog electronics, in network analysis, everywhere you will see these kind of waveform. Same goes for step function as well. You will see step signal in a lot of places. You will see impulse function as well in a lot of places in analog electronics, and in your network analysis course, in the control system course as well, you will see impulse function as well. But doublet function you are going to see in this video only in this video. After this video, doublet function will never be discussed. So there is no physical significance of a doublet function. Even if it is there, then I don't know, because I have read enough books, I have read enough NPTEL lectures, I have seen enough NPTEL lectures. Nowhere I have seen the physical significance of doublet function. But why we are studying it? Because in ESE examination there has been some question from this particular topic. That's why we are studying it. In GATE examination till this date there has been no question from doublet function. If it was a crash course, I would not have teach doublet function. But since it is there, like teacher will also be teaching it, and it is there in ESE syllabus as well. So who knows, one day they can frame any question in GATE examination as well. So that's the thing. Okay, so that's why we are studying it. So here I'm not gonna teach you any derivation, or I'm not gonna go into the depth of a doublet function. I will just prove that from where it is coming, how it will be having the waveform, what will be its area, all these kind of things we will prove it, and that's it. That would be more than enough for your doublet function. Okay, so let's get started about doublet function. So what we need to do, we need to differentiate. How do we define our step function? This is how we define our step function. We need to differentiate now. With this definition, there will be one more thing, that is your delta should be tending to 0. And now what I need to do? I need to differentiate. So if I differentiate, what I will be getting? You already know. You will start from, whenever we differentiate, from where we start? We always start from minus infinity. Then there is a jump, right? If there is a jump, that means there will be an impulse. So there will be an impulse of how much area? There will be an impulse of area 1 by 2 delta. So this is the area, right? This is not the magnitude. Magnitude is infinity, because here the slope is infinity. Area will be 1 by 2 delta, and it will be there at minus delta. And then there is a decay of 1 by 2 delta. So there will be a negative impulse of area minus 1 by 2 delta. At which point? At delta point only. So this is the differentiation, and differentiation is del dash t. With all these things, what is the assumption? The assumption is that your delta should be tending towards 0, right? This delta should be tending towards 0. So if this delta tends to 0, that means this 0 would come here. This will also come here. And if delta tends to 0, then what will be its area? Area will become infinity. Area will become infinity. What this point will become? This point will become 0. This point will become 0. So doublet function is like two impulses at t equals to 0 only, with area being infinity. One is having plus infinity area, one is having, this would be minus infinity, sorry, because if you put delta, there would be a minus sign as well, no? So this kind of waveform you will get for doublet function. Say yes or no. Two impulses you are having, one is having plus infinity area, one is having minus infinity area, and both are there at t equals to 0 only. Are you getting this point? This time this infinity is not the magnitude, it is the area, right? In the last lecture when we defined delta t, what did we do there? There I told that minus infinity to infinity, delta t dt, the area was 1. So there, in place of infinity, what I was writing? Here I was writing 1. There I told that the magnitude is infinity. Here for impulse function, what did I say? That magnitude is infinity, but area is 1. This is what I said, right? So here I wrote 1 when we studied about impulse function. Now we are studying about doublet function. So I am having that there. So I am saying that there are two impulses. One is having infinity area, other one is having minus infinity area, and both are existing at t equals to 0 only. So this is the meaning of doublet function. That's it. So what do you think? What will be the answer of this? Minus infinity to infinity, del dash t dt. What should be the answer of this? One is positive area, other one is negative area. Both will cancel out. So what is the answer? 0. Okay. So we are looking at it just with respect to mathematics, because there is no physical significance. I cannot relate it to network analysis. In the previous video when we study about impulse signal, there I related it to network analysis. But now I cannot relate it to network analysis. The reason is because there is no actually physical significance of it. So you understood? We just need to differentiate. Differentiation we did, then we got to know the area would be 1 by 2. The amplitude will be infinity only, area will be 1 by 2 delta. Here the area will be minus 1 by 2 delta. Delta is tending to 0, that means here the area would be plus infinity, here area would be minus infinity, and it is existing at t equals to 0 only. And if any one of you ever get to know about the physical significance of a doublet function, then they can let me know on Telegram, okay? Because I tried searching for it. It might happen that there would be some professor in your college who told you about that, or you might have seen in some books as well. So you can refer to me, I will certainly read it, okay? But I did not get any physical significance of a doublet function. I asked ChatGPT as well, but ChatGPT is saying this or that thing. That doesn't make any sense, whatever ChatGPT is saying. So if you get anything, any information about doublet function, then certainly you can share with me. It will just help me improving my knowledge only, right? So let's get to the next thing. So just prove it. Del dash alpha t is equals to 1 by alpha mod of alpha del dash t. So this you need to prove. So whenever these kind of questions are coming, forget about this dash, okay? Whenever any question is coming from doublet function, your first priority would be that, sir, I will think of impulse signal. What I'm gonna do? I'm gonna think of impulse signal. This will be my first target. And one thing I already know, that I can replace it something like this. Say yes or no. I can just take this alpha outward. This alpha will come outward in the reciprocal. If it is negative, still I will take the magnitude here. Say yes or no. You remember this thing? So this is how I can take it out. Now what do I know? I need this thing in the left hand side. What does that mean? That I need to differentiate. So can I differentiate this? I need to differentiate on both of the side. So if I differentiate this, what I will get? Del dash alpha t. And now I need to differentiate this function as well, right? Now I need to differentiate alpha t as well, right? And if I am doing the differentiation on left hand side, then I do need to do the differentiation on right hand side as well, right? So if I do the differentiation here, what I will be left with? Alpha only. That alpha can go here. So what I am getting? So this is what I am getting. And usually people will remember this formula, but I don't think that you can remember it for a longer time. Right now you are seeing it and you will say that, sir, I can remember it. But after 30 days or 60 days, do you really think that you will be keeping it in your mind? No. So I don't recommend remembering any formula regarding doublet function, because first thing, that is not important. I always recommend remembering this thing. Like if 2t plus 3 is coming, so what did I tell you? Take minus outward, then take 2 outward. So you will be getting 1 by 2 t minus 3 by 2. So I always recommend remembering this thing. I don't recommend to derive it in the examination. I always recommend to remember this thing. I always recommend same for step as well, right? Minus cannot be taken outward, 2 can be eaten up. So minus t plus 3 by 2. This also I recommend. I recommend same for your ramp as well. 2 can be taken outward, but it will be taken outward as slope. Minus cannot be taken outward, minus cannot be eaten up as well. So this is how you will get it. So these things I always recommend to remember, but not for this one. You can always derive in the examination. Let's just say if this kind of question is coming and then they are asking you to the value of alpha and beta. So what you can do? That, sir, whenever there is any question based on doublet function, my first target would be that I will be thinking about impulse function. So here I am thinking about impulse function. So what I can do? I can take minus 2 outward. It will come out as minus will be eaten up. It will be coming out 1 by 2 delta of t minus 3 by 2. Say yes or no, right? Now, sir, I can differentiate on both of the side. So if I differentiate on both of the side, so now inside as well I need to differentiate. So what I will be getting? Minus 2 is equals to 1 by 2 delta of t minus 3 by 2. So what you are getting? Delta dash minus 2t plus 3. This minus 2 will go here. So minus 1 by 4 delta of t minus 3 by 2. So what is the value of alpha? Alpha is minus 1 by 4. What is the value of beta? Beta is 3 by 2. Okay, that's it. That's the answer. So also you could have done by this particular formula as well, that what you could have done, minus 2t plus 3. Then usually people remember this thing that I will take this 2 outward, one without the sign, other one with the mode, and then I will be left with t minus 3 by 2. Simply I will take minus 2 common, and then one will be getting out without the sign, with the sign, and one with the mode. So what I will be left with? Minus 1 by 4 delta of t minus 3 by 2. But this is something that you cannot remember for a longer time, right? In a longer time, you might be forgetting all these kind of things. So better do the derivation in the examination. It will take hardly 30 seconds to 40 seconds, right? So always you need to think with respect to impulse function, then you differentiate on both of the sides, and you will be getting these kind of answers, right? Okay, then let's see something different. So if it was about impulse function, okay, if it was about impulse function, so what was our answer? Xt dot delta of t minus t naught. If it was about our impulse, so what was our answer? X of t naught into delta of t minus t naught. Say yes or no, right? This was our answer. So here also I will try to do the same thing, that this t naught goes here, so x of t naught, and then this delta dash remains there as it is. But since this is delta dash, so something different would be there. What different would be there? This dash will be given to this x. This dash will be given to this x. T naught remains there as it is. Now this dash is given to this x, so this dash is gone. So actually this is the answer, and usually people remember it. You can prove it as well. Basically you need to differentiate this thing. If you need to get this particular thing, then there are a number of ways you can prove it. But that prove is not important. What is important for you? If you just differentiate it, you apply u into v, that formula you apply, and then you will get this answer only. Okay, try differentiating it on your own. Simple mathematics it is. You will get the final answer for sure. There is no doubt about that. Okay, but this I am asking you to remember. If you have good enough time, if you have started your preparation with good enough time, if you have good enough time left for your preparation, then I ask you to remember this particular expression. How will you remember? That first I will think, okay, it is simple impulse function, because I told you if there is a question on doublet function, first you treat it as an impulse function. So first I will treat it as a simple impulse function. So what will happen? This t naught goes here and this remains as it is. But then I will remember, okay, this is not a impulse function, this is a doublet function. So what I need to do? I need to put a negative sign. I am putting a negative sign. Then what will happen? This dash will go to x now. So x dash t naught. Then this dash is gone. So delta t minus t naught. And then there is a negative sign as well. What is the meaning of this thing? X dash t naught. That first you will differentiate. What is the meaning of x dash t naught? First you will differentiate xt. First you will differentiate xt and then you will put t equals to t naught. Okay. We will do the examples. You will understand it. So first what you are going to do? First you need to differentiate xt and then you put t equals to t naught. So in this slide there would be some formula. Okay, in this particular slide there would be some formula, so you need to have some patience. Now you need to find this value. Now you just need to find the integration. So can you find the integration? Let's try it out. So what this will be equivalent to? This will simply be equivalent to, let's write it down here, minus infinity to infinity x of t naught into delta dash t minus t naught minus x dash t naught delta t minus t naught dot dt. So the integration can be given to both of the parts, right? Basically this integration can be given to both of the parts, so that I am doing now. Dot dt, then minus infinity to infinity. Integration is given to both of the parts. X t naught is a constant value. Say yes or no. So x t naught can be taken aside. X t naught can be taken outward. X t naught was a constant value. So x t naught is taken outward. And now here you are having minus infinity to infinity. What is the value of this guy? In the first slide we have studied it, right? This value was 0. If you integrate that doublet function from minus infinity to infinity, value you get is 0. So 0 multiplied with anything will be 0 only. X dash t naught is a constant value, no? X dash t naught, because you have done the differentiation and you have put a constant value of t. That means it is a constant value. So x dash t naught can come outward. X dash t naught can come outward. X dash t naught can come outward. And then integration will be done from minus infinity to infinity. What is the value of this guy? If you have seen the previous lecture, 1, right? If there is an impulse of area 1 from minus infinity to infinity, then the value will be 1. The value of this guy will be 1 only. So what you are left with? Minus x dash t naught. So what is the answer you are getting? From here, what is the answer we are getting? Minus infinity to infinity xt delta dash t minus t naught. So what you are gonna think? That directly I cannot put x of t naught. Previously I used to do this thing. That directly you give this t equals to t naught and then you integrate, that would be 1 only. So answer would be x of t naught. So directly I don't need to do this thing. First I will say that okay, x of t naught will go there, right? But there is a dash also, that dash will also be supplied here. So that dash also be supplied, but there will be a minus sign as well. So this would be the answer. What would be the answer? Answer would be that there would be a minus sign x dash t naught. Even if you don't remember this thing, within second you can derive this in the examination. So at least try remembering this formula, that's it. And even if you don't remember this formula, you can derive it with this differentiation as well. So there is no need to worry about it. Okay, in the examination there is no need to worry. Do you want me to do this differentiation? Okay, because since this is a recorded video, so I will do the differentiation as well. Don't worry about it, I will do the differentiation. I am just letting you know that from where that formula is derived. So x of t, this thing I already know, that is equals to x of t naught delta of t minus t naught. Say yes or no. Can I do the differentiation on both of the side? Yes. First as it is, differentiation of second plus second as it is and differentiation of first. Do you agree to this point? Here also I will do the differentiation. So here this will be differentiated because this is a constant value, right? So x t naught is a constant value and this will be differentiated here. What actually we need to find? We need to find this particular thing, right? We need to find xt dot delta dash t minus t naught. Xt dot delta dash t minus t naught. So what we are getting? Xt dot delta dash t minus t naught is equals to, first what you do, you give this t naught here, do nothing, give this t naught here, do nothing, dash remains there as it is. Next what do? You take the minus sign, then you give this dash here to xt. If you give this dash here to xt and then put t equals to t naught, since this dash is gone, then you are left with nothing but this particular sign. So this is the answer we are getting. Here x dash t dot del t minus t naught. So if any function ft is multiplied with del t minus t naught, then what is the answer? Ft naught dot del t minus t naught. So this t naught will be supplied here as well. Say yes or no. So x dash t naught dot delta t minus t naught. This is what you will be getting. So that's the answer we are getting. Even if you forget anything regarding the doublet function in the examination, you still have every single thing that you can derive in the examination. Don't need to worry, no need to worry. Every single thing you can derive in the examination. What you need to think in the examination, that if any question is coming on doublet function, I can solve it with respect to impulse function. Okay, so just start from the impulse function, whatever that you know, and then just differentiate and you will be getting the answer. But if you try to remember it, if you are able to remember it, then remember it. But don't take pressure of this particular thing, because till this date in GATE examination there has been never a single question from doublet function, and there is very rare chance that they will be asking it, but still who knows, they may ask it. Okay, and after that we derived this thing. So here our answer was that you take the minus sign, one minus sign would be there, then what you need to do, just take this dash here and t is replaced with t naught. If in place of doublet function, what they are doing now, this impulse function has been differentiated n times. What they are saying, this impulse function has been differentiated n times. So now what will happen, this n will go here, n will go here, x to the power n, and this t naught will be supplied to t. So x to the power n t naught. Now power here, what you will write down, minus 1 to the power n. Okay, for this as well this formula is applicable. What did we do? This dash goes here, x dash, t naught goes here, t naught goes here, minus 1 to the power n. How many times differentiation was there? Only once. So minus 1 to the power 1. So what I am getting, minus x dash t naught, minus x dash t naught. Okay, so same thing we are getting. So even if there is differentiation for n times, then also for that as well there is an expression. But again saying, very tough to remember all these kind of things, but again we need to teach it, because these are asked in EAC examination. So any day these kind of things can be asked in your GATE examination as well. That's why we need to teach it. But in the examination there will be one question and you just need to solve that one problem, then you can certainly derive everything. That's why I am telling you the derivation as well. In the previous lecture we did the derivation with respect to waveforms and all these kind of things, but here we are just proving the mathematics, because this is only mathematics only. There is no physical significance of our doublet function. That's why we are just doing the mathematics. For impulse function, for ramp function, and for unit function, we did all kind of analysis by the waveform as well, because there was a physical significance. But here we will just do the mathematics. Okay, mathematics is done. Let's solve some problems. So first take the limit. So first what is the answer? First I will solve the problem A, minus infinity to infinity sine of pi t by 2 del dash t minus 2 dt. What I need to do? There would be a minus sign, then you need to differentiate. Differentiate what? Differentiate this function sine pi by 2t. Okay, and after the differentiation, what you need to do? You need to put t equals to t naught, that is equals to 2, right? Minus 1. Here this differentiation will go to this guy, differentiation will go to sine, then there would be minus sign as well, minus sign is outward. Then after the differentiation, what you need to do? Put t equals to 2, and you will put this t equals to 2. This t equals to 2 only if you will put it if this impulse or doublet function is defined in the given limit. So if this impulse is defined in the given limit, not impulse, sorry, this doublet function, where will be this doublet function? This doublet function would have been somewhere here. It would have been at 2, right? This doublet function would have been there at 2. One is having infinite area, other one is also having infinite area. So if it is defined in this particular region, if it is defined in this particular region, that is 2. So limit is from minus infinity to infinity. Then only you will do all this kind of analysis. Okay, so what I need to do? First differentiation is given to this guy, so if I differentiate, what I am getting? So what is the differentiation of sine? That is plus cos only, cos pi by 2 t, and then multiply with the differentiation of this guy, that is pi by 2, and then there is a minus sign, and you need to put t equals to 2. So if I put t equals to 2 here, cos pi I will be getting, cos pi value is minus 1, so answer is pi by 2. So this is the answer. Okay, not tough, not tough at all. What will be the answer of second one? What do you think? Limit is from 4 to 7. Whatever the function is there, I don't care. The impulse is at 2, but the limit is from 4 to 7. So what will be the area here? 0. This is the answer of the second one. This is the answer of the first one. Okay, so you understood what you need to do. Just give this dash to this other guy, put the minus sign outward, then just put t equals to t naught. Put t equals to 2 here. Differentiation of sine would be cos, pi by 2 would be a side. Put t equals to 2, cos pi minus 1, minus 1 into minus 1 would be 1 only, 1 into pi by 2 would be the answer. That's it. Okay, if you are able to remember all these things in the examination, again there is a limit, because if I had been a student, I am a teacher now, so as a teacher I can remember all these kind of things, but if I had been a student, then for a student it would be very tough for me to remember all these kind of things. At least I can remember the integration, or I can remember this result. Rest all things like this I don't recommend to remember in the examination. If I am a teacher who is writing down the examination, and if this question is coming in my examination, I will also solve it with this method only. But probably I will remember this formula and this formula. Probably I will remember these two formulas, because it will just reduce my calculation, and in the worst case if I am forgetting anything, then I can derive in this manner as well. Okay, everything is crystal clear. So you need to express this xt in terms of delta t. So what is this xt? This thing is there, right? Let's just say I don't remember any formula in the examination. Although I remember the formula, what I need to do? What did I tell you? That first thing, you treat this as simple impulse function. Okay, so if this impulse function was there, so t minus 0 is there, right? This is t minus 0. T minus 0 is there. So what will happen? First this 0 will be supplied here. So what you will be getting? 0 delta dash t minus 0. Next what will happen? This differentiation will be applied to this guy. This guy will be differentiated. Minus sign would be there. This differentiation is applied to this guy. Okay, and then differentiation is gone, so this guy will be simple delta t minus 0 only, and this t equals to 0 you will be putting here. So what you are getting? Minus delta dash t only you are getting. So what you got from here? T into delta dash t is equals to delta t minus delta t, sorry. You can go by the simple formula as well that we have studied. Or in the worst case, let's just say I forget everything in the examination, then what I would do? In the worst case, if I forget everything in the examination, so what did I tell you? Always start from t into delta t. What will be the answer of t into delta t? You should know this thing, right? T into delta t. So here there is 0. So this 0 goes here. So that would be equals to 0 into delta t minus 0. So that would be equals to 0 only. So basically t into delta t is equals to 0. That I already know from my previous lecture. Now what I need to do? I need to differentiate on both of the side. So if I differentiate, first as it is, differentiation of second, plus second as it is, differentiation of first, that is 1 only. That would be equals to 0. So what I am getting? T into delta dash t is equals to minus delta t. That's it. So no pressure in the examination. In the worst case, if I am forgetting everything regarding the impulse, regarding the doublet function, then I will start from the impulse function and will just differentiate. That's it. And there is no doubt that certainly I will be getting my answer. All good? All fine? Okay, let's do the next question. So that's it. That's it about the doublet function. We have done everything about the doublet function. Whatever that is required for your examination, we have done it. Now we are going to see some miscellaneous topics. Like I'm just expecting a mathematics from your side, because this kind of differentiation we need to do in network analysis. So I want you to do this differentiation. Do it very carefully. 1 minus e to the power minus t ut. Okay. Do this differentiation very carefully. Do this one as well. Do this thing as well. You need to integrate it. Okay. Xt is given, you need to integrate it. So try doing it on your own. You can certainly do it. Okay. Have the patience and try doing it. And then some important signals we will study, that is signum function and all these kind of views. So basically this is just a miscellaneous video now. Only miscellaneous concept we are going to see. So about doublet function, whatever that is required for your examination, a very less important topic. And I have given you enough concept as well that if you don't know, if you don't remember anything, then only thing you need to do is go by the impulse and then just differentiate. Now some miscellaneous topics are there. Those miscellaneous topics we are going to cover. So I will take a break. You also revise whatever that you have studied, and then we will get started. So I expect you to do this question as well and this question as well, and then we will get started. Okay. Yeah. So did you guys try this question? So what did you do with this ut? Did you just keep it outside, or did you consider this as a function? This is a function, right? You will apply u into v. This is a function u and this is a function v. So when we do the differentiation of u into v, how do we do it? First as it is, differentiation of second, right? That you already know. So in that manner you need to treat this ut as well. I have seen a lot of students, what they would do, they will keep this ut aside and they will differentiate this particular function. Although luckily here you will get the correct answer, but this is not how you do the differentiation. How will you do the differentiation? D by dt xt. So first as it is, 1 minus e to the power minus t as it is. Differentiation of second, what is the differentiation of ut? Delta t. Plus second as it is, that means ut as it is. Differentiation of first, what will be the differentiation of 1 minus e to the power minus t? So minus will come here, e to the power minus t only, right? Because the differentiation of 1 will be 0. This minus will come here, it will be e to the power minus t only, and second as it is, u of t there as it is. Now what is this? Delta t, or you can say delta of t minus 0. Delta of t minus 0. So what will happen? This 0 will be fed here. So what is e to the power 0? That is 1 only. Are you getting this point? 1 minus e to the power minus 0 delta t, e to the power minus t ut. So e to the power minus 0, that is 1 only. 1 minus 1, 0 only. So 0 into anything will be 0 only. So what you are left with? So d by dt xt, it is coming out to be e to the power minus t ut. Say yes or no? Although luckily, even if you have kept this ut aside, then also you would get the correct answer. But the actual method is this. Okay. So this is how you need to solve in the examination. If anywhere you need to do this particular, these kind of differentiation, then always treat ut as a function. Okay. Here what I need to do? I need to integrate here. So here by the waveform it will be much easier. Although without even waveform as well you can do it. So what I would have done? Yt equals to, limit is from minus infinity to t, e to the power minus t, not e to the power minus t, it would be x to d2, right? Because I cannot put t here. So it has to be e to the power minus 2 u of tau d2. Okay. So what is the graph of e to the power minus 2? At 0 it would be 1, at infinity it would be 0, and at minus infinity it would be infinity only. So this would be the graph, right? This kind of graph would be there. That would be multiplied with u of tau. Basically that would be multiplied with this function. So negative part will be gone, only the positive part will be left. Basically this part will be gone, only this part will be left. So these kind of waveform we have already seen in our first video only, when we studied about our step function. There also we have seen these kind of the same exactly ditto waveform we have seen, right? So this will be the graph. This will be the graph. So at t equals to 0 you are having this value e to the power minus t, not e to the power minus t, e to the power minus tau u of tau, right, versus tau. Now I need to integrate from minus infinity to t, minus infinity to some value t. But I know that from minus infinity to 0 there is nothing. Are you able to get this point? Between minus infinity to 0 there is nothing. So can I just take my limit from 0 to t? Say yes or no. If I just take my limit from 0 to t, what I am getting? E to the power minus tau d tau. I will integrate this particular function. But I know that it is existing after 0 only. And here I have removed this ut. Why did I remove this ut? Why did I remove this ut? Are you able to understand why did I remove this ut? Because this ut is not useful for me, because I have already taken the limit from 0 to t. So what was the job of this ut? The job of this ut was just to change the limit. So now I have taken the limit from 0 to t and e to the power minus tau d tau. This is what I need to do. And what will be the integration of e to the power minus tau? That would be minus e to the power minus tau from 0 to t. So minus e to the power minus t minus 0, it would be plus 1, right? There would be two negative sign, no? Basically e to the power, if you put t equals to t here, so e to the power minus t, basically just take this negative sign outward. This is just creating any confusion. So negative sign is out. So e to the power minus t minus 1. So what you are getting? 1 minus e to the power minus t. But is this the correct answer? No, because you know that when I start my integration, the integration will start taking some value from t equals to 0 only. Because what is integration? Integration simply means area, right? Till the point of 0, the area is 0. But after that, the area will start coming, right? So this waveform 1 minus e to the power minus t, that is correct. But it will start after t equals to 0 only. So what will be the final answer? What will be the final answer of your y of t? So your y of t would be 1 minus e to the power minus t ut. Say yes or no. And we can verify it as well, because in the last question, what did we do? We just did the differentiation of this particular function. We just differentiated this particular function and we got our this function. Now we just integrated this particular function, and we are getting our this function. So you know that differentiation and integration are opposite process, right? And why I use this ut here? How did I remove this ut? Did you understand this point? Because the function is starting from 0. So here I can remove it with the help of my limit. Okay, and then I got the answer. There I got to know that my area will be starting from 0 only. So that's why I need to add ut here. And what kind of graph I will be getting? Can you draw the graph of 1 minus e to the power minus t ut? Yes, certainly I can draw. It will be starting from 0 only. So at 0, what is the value? E to the power 0 is 1, 1 minus 1, that is 0 only. At infinity, e to the power minus infinity will be 0. So at infinity, value will be 1. So from 0 to 1, it is rising. From 0 to 1, it is rising. And you can see that slowly the area is getting increased only. But after some time, the increase in the area is very less. That means it is being saturated after some time. So these kind of waveform we will certainly see in network analysis. A lot of waveform we will see. These kind of a lot of waveform will be there. So steady state, it is reaching till 1 only. And you can put e to the power infinity here. So e to the power minus infinity will be 0. So 1 minus 0 will be 1 only. So till 1 it is reaching. From 0 to 1 it is reaching. So this is your y of t versus t. So if you integrate this particular function, then this is what you are getting. Are you able to understand these points? Very simple point. Let's see some different kind of signals now. Some miscellaneous signal we are going to see, but these are important. Okay, don't feel like that if these are miscellaneous, that means these are not important. These are certainly important. So signum function you can call it, or signum signal you can call it, but mostly it will be called signum function. Signum function. And you would have certainly seen it somewhere in your 11th 12th class. Signum. Okay. So x of t is equals to signum of t. Okay. How it is defined? So it is defined as it will be 1 for t greater than 0. The same definition was there for ut as well. But for ut, what was the scene? For t less than 0, it was equals to 0, but it is equals to minus 1. Okay. Signum t versus t. So in ut, we saw that for t greater than 0, it was 1 only. But for t less than 0, it was 0. But here it would be not 0, it would be minus 1. That's it. This is your signum function. Okay. When we study about Fourier transform, there I will be using it again and again. So this is my signum t. Can you write down signum t in terms of ut? Okay. Previously I have written. Here also I will write it down. Signum t in terms of ut. So I can start my journey from here. No, I cannot start. I just need to see there are two kind of function. I cannot start my journey from anywhere. Why is that so? Because one guy is looking here, other guy is looking here. And at t equals to minus infinity and at t equals to plus infinity and at t equals to minus infinity, none of the function is 0. Basically at x of minus infinity is also non-zero and x of infinity is also non-zero. That means you cannot start your journey. Now you need to break down the function into two parts. So how I can break it down? I can see that this is my ut. Say yes or no. So this is my ut. And what is this? This is your minus of u of minus t. Say yes or no. Because what would be your minus ut? Sorry, what will be your u of minus t? This would be your u of minus t. And then minus sign. Then minus sign, that means it would be coming downward. It would be coming downward. Right? So this is your minus of minus ut, minus of u of minus t, and this is your plus of ut. So ut minus u of minus t. So this is your signum t. I hope you are able to understand this point. Just broke it down into two parts, ut, and other one is minus u of minus t, minus u of minus t, right? Now can you differentiate here? Can you do the differentiation? Certainly I can do the differentiation. For differentiation, what did I tell you? That always you need to start your journey from minus infinity. Differentiation. So very basic thing, these are just interrelated. You just need to see them and just realize that I have studied it. And in the examination, if they are asked, then you should not be taking time to solve it. So where I will start my journey from? I will start my journey from minus infinity for differentiation. What is the slope here? Constant value, slope is 0. So till I reach the point 0, the slope is 0 only. Till I reach the point 0, the slope is 0 only. But at 0, what do I see? There is a sudden jump from minus 1 to 1. So there is a jump of 2. So here what I will have, although the area will be, although the jump is of magnitude 2. So here the area would be 2, but the amplitude is infinity. That means you will be having a impulse here. So what I have done here, d by dt of signum t. Okay. So I am having an impulse of amplitude infinity because here the slope is infinity. But what is the area? Area is 2. Area is 2. So that's it. This is the differentiation. Okay. And you can see from here as well, if I do the differentiation, d by dt of signum t. So what I will be getting? What is the differentiation of delta t? Minus sign will be there as it is. What will be the differentiation of u of minus t? So that would be delta of minus t, and inside the differentiation, what is the differentiation of minus t? That is minus 1. So into minus 1. So what I will be getting? Delta of t plus delta of minus t. And delta of minus t is equal to delta of t only, because delta has the ability of eating up negative sign. Right? So this will be equal to delta of t only. Are you getting this point? This minus remains there as it is. Then u is differentiated, it will give you delta. Then minus t should also be differentiated, so it would give you minus 1. Now minus 1 and minus 1, it will make plus 1, and inside there is minus sign, so delta can eat it up. So what you are getting? 2 delta t. Okay. And what is the expression here? The area is 2 and it is an impulse. So what is this? 2 delta t only. So by mathematics, by waveform, everywhere you are getting the same answer. So these are the very simple thing that you have studied. Can you define signum at t equals to 0? Can you define signum at t equals to 0? No. Because why is that so? Let's do it on the next page. Because we can, okay. This slide was all about differentiation only. So I already did it in the previous page. So I can just remove this slide. Right? Because this was all about differentiation that we have already done in the previous page. So in the previous page, first we defined signum t, minus 1, plus 1. We defined it. Then we wrote down in this manner. Then did the differentiation. 2 delta t we are getting. 2 delta t we are getting. area of 2, magnitude of infinity, right? And what I am doing now, I am defining the limit. Basically, I need to define signum t at t equals to 0. So if I approach from 0 minus, then what will be the value? And if I approach from 0 plus, then what will be the value? So just let me know all these kind of things. If I approach from 0 minus, if I approach from here, then what is the value? Minus 1. And if I approach from 0 plus, that means from here, what is the value? Plus 1. So what you are getting? Both are equal? No. Both are not equal. So can you define your signum at t equals to 0? No, not defined. Okay, not defined. And by other way also you can see it. Why is that so? Because what is your signum t? Signum t is u of t minus of u of minus t. So is it defined at t equals to 0? No. Is it defined at t equals to 0? No. That means this cannot be defined at t equals to 0. So this could be the other way. At somewhere you will find that signum t at t equals to 0 could be 0, but that is wrong. Okay, you will find that u of 0 is 1 by 2. That doesn't make any sense. It is simply not defined. The answer is not defined. Okay. Yeah. So next signal we need to study, that is sampling signal, and a very important signal, very important signal. Not for your initial phase, but when we study Fourier transform, it would be very important. The complete concept of Fourier transform, the intuitive explanation of Fourier transform will be explained by this signal only. So we need to study sampling, and then we will study about sinc function. Better we call it function, sampling function and sinc function. So first we will study about sampling function, and then we will study about sinc function. So what is a sampling function? How it is denoted? So it is denoted as sampling of t, SA of t, not South Africa, sampling of t. Okay, so xt is equals to sampling of t, and that would be equals to sin t by t. Okay, sin t by t. Now our whole target would be to make this waveform and understand this particular expression, that is sin t by t. So you need to remember the sampling word as well, because this is known as sampling signal, and in the Fourier transform I will tell you why it is known as sampling signal. You will understand why it is known as sampling signal. Okay, so sampling signal, that is equals to sin t by t. Now if I ask you what is the value of sampling signal at t equals to 0, so what I am asking, x of t equals to 0, or you can put sampling 0, or you can put sin 0 by 0. What is the value of sin 0? 0 divided by 0. This is your undeterminate form, right? So how will you solve it? This is simple mathematics. 0 by 0, how do you solve it? L'Hopital rule, right? L'Hopital rule. I don't think I remember the spelling. L'Hopital rule. So what do? We do the differentiation. So your xt is there. So what you are going to do? You differentiate the upper side. What you are going to get? Cos t. You differentiate the downside. Differentiation of t, that is 1, and then you put t equals to 0. Because at t equals to 0, I need to find the value. So whenever 0 by 0 form is there, you can apply this L'Hopital rule to find the value, to find the limit. So what did we do? Did the differentiation upper side, cos t, did the differentiation downward side, 1, and put t equals to 0, cos 0 is 1. So this was actually x of 0. So what you are getting? X at t equals to 0, or you can call it sampling of 0, that is equals to 1. And what will be the value at t equals to infinity? This is very simple actually. So x at t equals to infinity, that means sampling of infinity, or you can say sine of infinity divided by infinity. Now one thing I know, I don't know the value of sine of infinity, but I know that this value will be somewhere between minus 1 to 1, say yes or no, because this is the graph of sine. Even at t equals to infinity, this value would be somewhere between minus 1 to 1, say yes or no. I don't know what will be the value, but it will be somewhere between minus 1 to 1. So this value would be somewhere between minus 1 to 1, and that is divided by infinity. So what will be the answer? 0. Let's just say the value was 1 by 2 divided by infinity. What is the answer? 0. So somewhere between minus 1 to 1, any value would be there, that is divided by infinity, so answer would be 0. So what is something that you are getting? That your sampling function at infinity, or here I will write down x at t equals to infinity, that is sampling infinity is equals to 0. Why we are finding all these values? To make the graph. To make the graph, we are finding all these values, right? Now the next task would be to find the zero crossover. What is the meaning of zero crossover? The zero crossover simply means when your xt becomes 0. when your sampling t becomes 0. What does that mean? That when your sin t by t becomes 0. And what does that mean? T can go here, so sin t is equals to 0. So at what point your sin t becomes 0? So if you see the graph of sinusoid function, what is this point? Pi, right? Sin 0 is 0, sin pi is 0, this is 2 pi, this is 3 pi, next will be 4 pi. So at every n pi, at t equals to every n pi, your sinusoid is 0. That means your xt will be 0. Same goes here as well. Minus pi, minus 2 pi, right? So n could be any integer. N could be any integer. So your 0 crossovers are at plus minus n pi you can say, or t equals to n pi only you can say, and n is integer. So basically 0 crossover would be, yeah, you cannot say n integer, because at t equals to 0 you know that there will be undeterminate form. At t equals to 0 there will be undeterminate form. So at t equals to 0 you are getting the value to be 1. So it is not 0 crossover. Meaning of 0 crossover is when xt becomes 0, but xt is becoming 1 at t equals to 0. So here I cannot write n equals to integer. I should write n equals to integer but minus 0, then it is true. Okay, so your 0 crossovers are at pi, 2 pi, 3 pi in that manner, and minus pi, 2 pi, and minus 3 pi in that manner. These are our 0 crossovers. So the peak value was there at t equals to 0, that was 1. At infinity it is 0, and 0 crossovers are there at n pi. Okay, but now we can make the graph, but we will make the graph with our basic mathematics. So in the first lecture, what did I tell you? You can draw the multiplication of two graphs for sure. So sin t by t can be written as sin t into 1 by t. Say yes or no? Sin t by t can be written as sin t into 1 by t. Do you know how to make the graph of sin t? Yes. What will be these 2 points? 0, pi, 2 pi, 3 pi, minus pi, minus 2 pi. Do you know how to draw the graph of 1 by t? If you don't know, then we can tell it. At t equals to 0, what will be the value? If you put t equals to 0, value will be infinity. If you put t equals to infinity, value will be 0. In between, let's just say if I put t equals to 2, value will be half. If I put t equals to 3, value will be 1 by 3. If I put t equals to 7, value will be 1 by 7. So value is constantly decreasing. From infinity it will start, it will go to 0. So this is how it will go, right? And what about the negative value of t? So if t is equals to minus infinity, if t is equals to minus infinity, so the value will be 0 only. 1 by minus infinity, so value will be 0 only. And if t equals to 0, or you can say 0 minus, basically if you are somewhere here, then the value will be equals to minus infinity. 0 minus means just before 0, so value will be minus infinity here. If t equals to minus 2, then value will be minus 1 by 2. If t equals to minus 3, value will be minus 1 by 3. So what do you think, how will the graph go? From here it will start. Basically, how will the graph go? From here it will start and it will reach here till like this. So if I make it, this is how the graph would be looking like. So this is 1 by t graph, right? And what do we call it? Hyperbola, right? So these kind of graph we can see. Say yes or no. Okay. And what did I tell you? How do we do the multiplication? Did we do the multiplication of e to the power minus at sin t? Say yes or no. What did we do? We draw the graph of e to the power minus at. We draw the graph of sin t. Then what did I tell you? That either you can think about it, that negative value will be multiplied with the positive value only. So it will be increasing its amplitude but in the negative direction. So what was the conclusion that we made? That here you need to take the mirror image about x-axis. And then in between you need to make the sinusoid. But positive value remains there positive only, negative value remains there negative only. So there you go. So this kind of sinusoid we were getting, although it was decreasing. So it was decreasing and here it was increasing, right? Here it was increasing. Negative remains negative as only. So these kind of things we have seen in the very first lecture. So same thing we are going to do. Here what do you see? At t equals to 0, this is throwing infinite value. At t equals to 0, this is showing infinite value. So 0 into infinity, this is the condition we are getting. At t equals to 0, we are getting the condition of 0 into infinity. That is undefined. So at t equals to 0, I don't know what is the value. But here I have found out, no, at t equals to 0 value is 1. So at t equals to 0 value is 1. That I have find out. Because from this graph, sin t is saying that value should be 0 and 1 by t is saying that value should be infinity. So 0 into infinity, this is undetermined form. So now at t equals to 0, I need to find out the value by something else. So here I found out the value is 1. But after that, what is happening? Let's just say here, this value is 1. So this 1 value will be multiplied with this value. Then this negative value will be multiplied with this value. Then this negative value will be multiplied with this value. So slowly the amplitude is getting decreased, right? Because this value is getting decreased. So slowly the amplitude is getting decreased. Negative amplitude remains negative amplitude only and positive amplitude remains positive amplitude only. Why is that so? Because these are multiplied with the positive values. These are positive values and these are negative values. So here positive values will remain positive only and negative will remain negative only and amplitude will keep on decreasing. So what do you think, what kind of nature you will get? Okay, so here I just want to improve your mathematics, that's it, nothing else. So what actually the conclusion is always the conclusion we have already made, that always you need to take the mirror image about x-axis. So I could have directly told that this is how you need to take the mirror image. So this was our waveform and you can take the mirror image. But the other interesting point to notice here is that at t equals to 0, I need to find the value. Along with that, here, these values will be multiplied with the negative values. So now, what will happen? First thing, at t equals to 0, the value is 1 only. Now, let's just say, talking about this value. So this minus 1 will be multiplied with this negative value. So this will become positive now, right? Negative value is multiplied with negative value, it will become positive, and positive value will be multiplied with these values. So these will become negative, right? And here also the amplitude will keep on decreasing. So what kind of graph you will be getting? So here positive remains positive only, but slowly the amplitude keeps on decreasing. And wherever it is 0, it was 0 at pi. So this point doesn't change because 0 into anything would be 0 only. 2 pi into anything will be 0 only. So 0 crossover are not changing. And were we getting the same 0 crossover? Yes. Pi, 2 pi, 3 pi. Yes, we were getting the same 0 crossover. So in between these curves, I need to make the waveform. What about this side? This side, I will make the waveform like this. Okay, not getting it better. So here negative value was multiplied with negative value, so it became positive. In the next cycle, you were having positive value, but multiplied with the negative value, it became negative. And slowly the amplitude is decreasing. So this kind of waveform we are getting. Right? Although usually what is taught, they will teach this thing, L'Hopital rule. At t equals to 0, value is 1, at infinity it is 0, and then 0 crossover. And directly we make this waveform. But even if we don't know anything about 0 crossover or anything, if I directly given function sin t by t, what I would have thought in the examination, that I would make the waveform of 1 by t, I would make the waveform of 1 by t, then I know that I need to take the mirror image because it is being multiplied with sinusoid. Then positive values are being multiplied with positive value, so here it remains like this. Here negative values are being multiplied with negative value. So negative will become positive and positive will become negative, and slowly the amplitude is being decreased. So I need to take the mirror image, and this is how I need to make the waveform. The only interesting point here is that at t equals to 0, this guy is saying that value should be infinity and this guy is saying that value should be 0. So infinity into 0, that is the undeterminate form. So now I need to apply L'Hopital rule and I got to know that this value is 1. Right? Well and good. Okay. So basically this kind of waveform we get. Here these are just for the reference, no, these are actually not there. These are just for the reference that what will be the amplitude. So here also these are there, here also these are present, but I just removed them off because these are just for the reference. So this kind of waveform will get. At t equals to 0, the value is 1. 0 crossover are there at pi, 2 pi, 3 pi, and in that manner, and amplitude will keep on decreasing and eventually it will reach to 0. And here also it will reach to 0. And this point will be minus pi, minus 2 pi, and minus 3 pi. So this is the graph of sampling t, or you can say sin t by t. Very, very important graph. The complete frequency response, not frequency response, sorry, the complete frequency analysis will be based on this sampling function. A very, very important function for your Fourier transform. Now, here you need to remember one result. What is the area of sampling t? What do you think? Area from minus infinity to infinity. So I need to find this area, right? This area, then this area will be subtracted, then this area will be added, then this will be subtracted, then some will be added, then some will be subtracted. This is what will be happening, right? So total area, whatever that is enclosed by our complete lobes. So here this is the biggest lobe, right? This is the biggest lobe. So this would be having some area, then some area would be subtracted, then some area would be added. So if I tell that the area of this lobe is A1, area of this lobe is A2, area of this lobe is A3. So can you just let me know the order between mode of A1, mode of A2, mode of A3? And let's call this area as A4, this area as A5. A1 is the area of this complete lobe. So A1 will be the biggest area, right? Then A2, then A3, because these are being, the lobes are, these amplitude are being decreased, but this width is pi only, this width is pi only. From 2 pi to pi, this width is pi only, right? Width is same, this width is pi, this width is also pi, next width will also be pi, but the amplitude is being reduced. That means area is being reduced. The lobes are getting smaller. This is what I am calling lobe. These lobes are getting smaller. So area is continuously getting decreased. So when you find out the area, it comes out to be pi. And even if you square it, then also the area comes out to be pi only. So you need to remember this thing. I will give a mathematical explanation of this in Fourier transform. Okay. We are just studying this particular function for the reference of Fourier transform only. So why the area is coming out to be pi, the mathematical explanation will be given in the Fourier transform part. But you can estimate the area would be nearly around pi only, right? Let's just say if this was flat like this, then what would have been the area? 2 pi, right? 2 pi into 1, the area would be 2 pi if it was flat like this, but it is not flat, it is like this, and here other part will be added and some part will be subtracted as well. So eventually the area will come out to be pi only. So you try to relate it and remember it. The area of sampling function from minus infinity to infinity, that is pi only. And sampling square t, what is the meaning of sampling square t? What is sampling square t? What is sampling t? Sampling square t can be written as sampling t whole square, and that is written as sin t by t whole square, and that can be written as sin square t divided by t square. So sampling square t is equals to sin square t divided by t square. So from here what did we get to know? That from minus infinity to infinity, sin t by t dot dt, that would be equals to minus infinity to infinity sin square t divided by t square, that would be equals to 1. Okay. Not 1, really sorry, not 1, it is equals to pi. And here I wrote down this A4 area, A5 area. So you would know that this A4 area, this would be equals to this A2 area. This A5 area would be equals to this A3 area, because everything is symmetric, right? So here I can write down that A4 would be equals to A5. A4 would be equals to A5. And this, A4 would be equals to A2. A4 would be equals to A2 and A5 would be equals to A3. Right? So these kind of things you can conclude from sampling function. So will you be able to remember this particular thing? Here I forgot to write down dot dt. That area of sampling square or area of sampling, both will be pi only. Now someone would be having this doubt that sir, in sampling square these will be positive, no? These guys will be positive. So everything will be added. So area should be greater than pi. Here what I am saying, this is some part will be subtracted, then some part will be added. So area is coming out to be pi. But if I do the sampling square, sir, then all the negative part will become positive part. So all the parts will be added. So area should come greater than pi. This kind of doubt you will be having, right? But you forgot about the amplitude. Here the amplitude was 1. I don't remember whatever the amplitude is there. Let's just say this amplitude is 1 by 2. This is not a certain value. I'm just telling that let's just say this amplitude is 1 by 2. It would be something else. But I'm assuming this amplitude is 1 by 2. So if you do the square, then amplitude will be 1 by 4. So amplitude is reduced now. This amplitude was, let's just say, 1 by 4. So now the amplitude will be 1 by 16. So although you are doing the square, although all the areas will be added, but these amplitude are getting smaller. So that's why when we saw that when we take the area of sampling function or when we take the area of sampling square function, both of the times we are getting the integration to be pi only. Both of the times the area are pi only. Okay, because some people may have this doubt that square means area will be added, but square means area will be 1/4 as well. Basically, not area 1/4. Basically, the magnitude will be reducing as well. So this part that is being added, that is also reducing. This part is also reducing. Okay. So let's make it clear. Whatever the part that is required, that only I will keep. A3, A4, A2, A1. This 1/4 can also be removed. Yeah, so that's it. That's it about this slide. So notes are pretty clear. Notes should also be clear. That is also one of the tasks. Now we need to study about sinc function, but before going to our sinc function, we will understand an interesting point about area. So you know about area. Area means simply the integration over the area that is enclosed by the function. That you already know. But I give you a question that area enclosed by a function xt is equals to a. Find the area enclosed by function xt x at alpha xt minus t naught alpha x at minus t naught. Okay. This is the task that is given to you. I will pause the video, take some break. You try solving it on your own. You will be able to tell me the area. So you need to define the area with respect to A. Okay, so what will be the area here? It would be A or A into A or mode of A or A divided by mode of A. What will be the answer? So try getting to know about it. Okay, and same goes for these questions as well. So take a random example. What you can do? You can take a random example which is having an area of A. So I am taking an example of rect function. This is your rect function, which is there from minus t by 2 to t. Okay, or let's just take it minus 1 by 2 to plus 1 by 2. If I need to make the area to be A, so this amplitude has to be A, because A into 1 the area will be A now. Okay, so this is the xt I am taking. This is the xt I am taking. Now you need to find x of at. So A can be positive as well, A can be negative as well. So let's just find x of 2t and then find x of minus 2t. A value I am taking to be plus 2 and minus 2. So what you will do? Time domain is multiplied with 2. That means here time axis will be divided by 2. And even if there is negative sign, what is the meaning of this negative sign? The amplitude becomes negative. No, amplitude doesn't become negative. Only there is a mirror image. So mirror image will make no impact in the area. Let's just say if this guy is having an area of A and now I take its mirror image. So what is the area of this? That is also A only, no? So is there any meaning of this negative sign? No. So in case of area, this negative sign can be eaten up. So even if you take the mirror image, there is no impact. So will the area will be changing? Area will be changing because of this 2. Because time domain is multiplied with 2. That means time axis will be divided by 2. Right? So if I make the waveform of x of 2t, if I make the waveform of x of 2t or x of minus 2t, I was supposed to take a break because I need to drink water. Always, even if you are studying, no, so within 1 hour at least you should drink water. Have a water bottle with you always, because if you don't drink water, you might be like 21-year guy, 22-year guy, or 23-year guy, but later on all these things will become problematic to you. Okay, because I have been also in your stage. Like I have been in second year, third year. At that time I didn't used to sleep at all. Like I used to sleep, but my sleep cycle was very bad. Someday I am sleeping 3 hours, 4 hours, and I did not care about my sleep. And now I am having a lot of health issues because of that. So as the like you might feel like that, okay sir, I'm not sleeping that much, still I am doing good. I'm not having health issue. But these health issues will be reflected later on. Okay, in your progressive age. People used to tell me the same thing, but I did not care. Now I am realizing it because in every 3 to 4 days I'm getting some health issue. Now you see my eyes. This eye has been swollen up. So this kind of issue I'm getting. So you always take care of your health. Okay, have proper sleep, have proper food, and have proper water. Very important. Yeah, so I was drawing x of 2t. Amplitude is a. So this will be minus 1 by 4. Time domain is multiplied by 2, so it should be divided by 2. Here the area was a. Now what is the area? Area is a by 2, right? Because this window has been stringed. Now it was 1 by 2, 1 by 2. Now it has come to minus 1 by 4 and 1 by 4. So now what is the, here the area was a. Now what is the area? A into, what is this window? This window is 1 by 2. So a into 1 by 2. So the area is a by 2. So what is the area? Area is a by 2. And same you can do with x of minus 2t as well. So what I will do, I will just copy the graph, because the same graph we will be getting for x of minus 2t as well. X of minus 2t. So it has been stringed, right? So area is again a by 2. So from here what you are getting to know, that if you are multiplying it with the factor of a, that means area will be divided by a factor of a. Or here I should put mode of a, because a could be negative or positive. So if xt was having an area of a, here I ask you a question, if xt was having an area of a, then what would be the area of x of minus 3t? Tell me, not minus 3t, x of minus t by 3. So here time domain is being multiplied with 3. So time axis will, sorry, here time domain is divided by 3. So time axis will be multiplied with 3. So this part will be expanded. So area will be 3 times, right? A divided by mode of a. Here mode of a is minus 1 by 3. So what you are getting? 3a. But don't remember the formula, just remember the concept, right? So area would be 3a here. So this question I have asked. Now if you just multiply with the factor of alpha, what will happen? This a will be multiplied with the factor of alpha. This is my xt. Now it will be multiplied with the factor of alpha. Is there any change in the time domain? No. There is no change in the time domain. So even if it is multiplied with the factor of alpha, so what will happen? Now what will be the area? A into alpha into 1. So what is the area now? A into alpha. So here what will be the area? Alpha into a, you can write down. Alpha into a. Shall I put the mode here? No. Shall I put the mode here? No, I will not put the mode. Why is that so? Because let's just say alpha was minus 5. Alpha was minus 5. I am saying a is positive, alpha was minus 5. So a into minus 5. So this amplitude will be made something like this, right? And the area will come out to be negative, because if you take out the area here, this area would be negative. So if alpha is negative, then the area would be negative. If alpha is positive, then area would be positive. Are you getting this point? So here I am not putting the mode of alpha. Okay. So if I am multiplying with a certain factor, that means area will be increased by that particular factor. T minus T naught. If I do the shift, will there be any impact? Let's just say this is having an area of A. If I shift it somewhere here, or if I shift it somewhat like this, will there be any impact in the area? No, area will still be A only, no. So there will be no impact of the shift. You can shift it here, there, the area enclosed will remain same. So there will be no impact of the shift, right? And regarding this, I can ask you one question, that x of t is having an area of A. Then what will be the area of minus of 5xt? That would be minus 5a, right? So area here, the value here, the magnitude of alpha matters, but here the magnitude of A doesn't matter. All these things we are going to relate somewhere. That's why we are studying it. And here it will remain there as it is. What about alpha x at minus t naught? So here everything is happening. Here you are scaling the time domain, shifting is also there, and amplitude multiplication is also there. So because of the amplitude multiplication, this will be the scene. And because of this A, this will be the scene. Say yes or no, right? Both of the things are happening. No, alpha into A divided by mod of A. Let's take an example and then we will solve it. I hope you are able to understand. If you are multiplying the amplitude with alpha, then area would be increased by the factor of alpha. If your time domain is being multiplied with A, that means time axis will be divided by A, so area would be reducing in that manner. Shifting will have no impact, and if all are occurring at the same time, then you can see this is how it will be happening, because amplitude is being multiplied with alpha and time domain is being multiplied with A, that means time axis is divided by A. So alpha A divided by mod of A. say yes or no. Are you agreeing to this point? So let's take an example. So that example I have already written. So this time I will take a different function. Let's say move it over. Although everyone would know the answer, but still we need to spend some time here because there might be some people who might not be understanding it. And in place of -5, I am writing -1/2. -1/2. Okay. And in place of -2, I am writing -t/3. Okay. So I need to first assume a function of area A. Function of area A. This is what I am assuming. From 3 to 4, 1/2, base is 1. So what should be the height? Height should be 2. So this height should be 2. xt versus t. So what is the area? A. Area A, or you can say, let's keep that area is 1. Okay, area is 1. So area is 1 because half base is 1, height is 2. So area is 1. So now what would be the area of this particular function? So can you make this particular function? Yes. How will you start? You will start from here. So first you need to do the left shift by 3 because +3 is there. That means you need to do the left shift. So left shift by 3. That means it will be coming at origin itself. This will be coming at origin itself. So this will be between 0 to 1 and this would be 2. Right? So where we are going, x of t, then we will go to x of t plus 3, then we will go to x of t/3 plus 3, then we will go to x of minus t/3 plus 3, then we will go to -1/2 x of minus t/3 plus 3, right? इसको थोड़ा सा साइड में करना पड़ेगा. Yeah. So next step is divided by 3. So it will be multiplied with 3. It will be multiplied with 3. So this will become 0 and this will be becoming 3, right? Because it will be just be extended, right? And then you need to take the mirror image. So if I take the mirror image, then what will happen? This part will come to this side. This part will come to this side. 0 to -3. Amplitude is 2. Now this amplitude 2 is multiplied with -1/2. That means this part will be going downward. So 2 is multiplied with -1/2. So now the amplitude will be -1. So this part will be going downward. This amplitude will be -1. So -1/2 x of minus t/3 plus 3. This kind of graph you will be getting, and here you should have enough practice. We have done enough practice. You should be able to make these kind of waveform. So what is the area you are getting here? Area you are getting here is half base is 3, height is -1. Base is 3, height is -1. So here the area is -3/2. Or how I could have done it? One thing I know, that if initial area is 1, then this guy will just simply multiply, and if it is divided by 3, that means time axis would have multiplied with 3. If time axis is multiplied with 3, that means my signal will be extended, and if it is extended, then in the same manner my area will also be increasing. So what will be the answer? And there will be no point of shifting. Even if there is a shift, there is no use of that. So what will be the answer? -3/2 only. So this way I would have given the answer, or this way I would have given the answer. So now you should be comfortable with this particular analysis. Okay. Now we will move to our next function. After these two integration, we will move to our next function, that is sync function, or you can say sync signal. But before that, you try getting these two answers. First question is this: you need to find the all possible values of alpha, and then you try to get this answer. Okay, you can certainly do it. Think about it, and certainly you can do it. Okay, yeah. So I will take a pause, then we will
continue. Yeah, so welcome back. So did you attempt this question? What you need to find? You need to find area only, because if I am integrating from minus infinity to infinity, that means I am finding the area. So what is the area of a rect T? Rect T. What is the area of rect T? That is 1 only, right? Because if you see the diagram of rect T, what it would be? It would be from minus 1 by 2 to 1 by 2 with the amplitude of 1, right? Minus 1 by 2 to 1 by 2 with the amplitude of 1. So what will be the area? Area will be 1 only. So now if I am talking about rect of alpha T, so what will be the area? 1 by mode of alpha, right? Because alpha could be negative as well. So 1 by mode of alpha, because if time domain is multiplied with alpha, that means time axis would be divided by alpha. So that area is given as 2. That means mode of alpha is equals to 1 by 2. So from there, alpha can be either 1 by 2 or minus 1 by 2. So that's why I said all possible values, okay? So it could be plus 1 by 2 as well, it could be minus 1 by 2 as well. So that's the answer. Very simple. Try thinking of this question. What you can see here, sin t divided by t. So something regarding sampling is there, because I know that sampling of t is equals to sin t divided by t. So something regarding the sampling is there. If I say what will be your sampling of 3t, so that would be sin, in place of t you need to put 3t, sin 3t divided by 3t. So similarly, can I make something here? Yes. Integration is from minus infinity to infinity. Sin 3t, I need to make here 3t, but here I am having 2. So I am taking this 2 outward. If I have divided by 3 here, that means I need to multiply with 3 here as well, right? So this will be 3 here. Divided by 3 here, then I have to multiply by 3 here as well. Sin 3t divided by 3t, so 3 and 3 get cancelled out, it is same only. Now minus infinity to infinity, sampling of 3t dt. Now what is this? This is simply the area of sampling 3t. Say yes or no. What is the meaning of this integration? It is simply the area. So I know that area of sampling t is pi. So what will be the area of sampling 3t? That would be pi by 3. So what will be the value of this integration? Pi by 3 only. So 3 by 2 into pi by 3. So what is the answer? Pi by 2. Very simple, right? So whenever you are getting anything that is regarding t by t, sin t by t, so think of sampling function. I can make it sampling function and I already know the area of sampling function. Let's study about sync function. So sync signal is given by sync only. It is shown by sync t. Okay, it is shown by sync t. How it is shown? Sync t, and that is equals to sin pi t by pi t. Sin pi t by pi t. Can I write it down as sampling pi t? Say yes or no. Because what is my sampling t? That is sin t by t. In place of t, what I am putting? Pi t. So yes. So your sync t is sin pi t by pi t. Anywhere if you see sync t, that means sin pi t by pi t. How do I remember? That this c will be replaced by pi. C will be replaced by pi. So sin pi t, whatever that is there, the same would be coming out. Let's just say somewhere sync 3t is written. So what I will do? Sync sin c will be replaced by pi. So sin 3 pi t divided by whatever the angle is there, that will come out. That's it. So c will be replaced by pi, and whatever the angle we get here, that will come downward. This is how I remember it. Otherwise you can remember the basic definition as well, or you can directly remember that you just need to replace c with pi, and whatever the angle that you get here, that should be coming downward. Okay. So what do you think? What will be the value at t equals to 0? Again it would be sin 0 by 0. If I put at t equals to 0, same analysis I need to do. You can do the analysis on your own. X of t equals to 0, or you can say sync of 0, or you can say sin pi into 0 would be 0 only divided by pi into 0. So that would be sin 0 by 0. That would be 0 by 0. So what I need to do? I need to apply L'Hopital rule. I'm not sure if the spelling is correct or not. So what I will do? What I need to find? At 0 I need to find. So I will differentiate it. So what I will get? Cos pi t into pi. And downward if I differentiate, that would be pi only. So pi get cancelled. And what I need to put? At t equals to 0 I need to put. So what I am getting? Cos pi t at t equals to 0. So that value will be 1. So what you are getting? Sinc t at t equals to 0 would be 1 only. Same value we are getting. The same value we got in sampling function as well. So here also we are getting same value. And at t equals to infinity as well, we will get the same value, right? Because if I see at t equals to infinity, so x of t equals to infinity. So sinc of infinity, or you can say sine pi of infinity divided by pi into infinity. So it can be replaced as sine of infinity divided by infinity only. So it will be some value between -1 to 1, but it will be infinity. So the value will be 0. So what you are getting? Sinc of t equals to infinity, that would be equals to 0 only. So at 0 the value is 1, at infinity the value is 0, right? Well and good. Okay, now 0 crossover. What does that mean? That when my xt is becoming 0, that means when my sinc t is becoming 0, that means sin pi t by pi t is 0. So this pi t can go here. So my target is when this sin pi t becomes 0. When pi t goes here, one condition is there that t cannot be equal to 0, right? If I am writing down this particular expression, here I need to tell t cannot be equal to 0, because at t equals to 0 this is being undefined. At t equals to 0 the value is 1, that I already know. So sin pi t should be 0. When your sine function becomes 0, whenever the angle is multiple of pi, right? Whatever the angle pi t is equals to multiple of pi. What is the graph of sin theta? This is the graph of sin theta. No, I am drawing the graph of sin theta. Sin theta. So what will be this value? 0, pi, 2 pi. So whenever theta is equals to pi, 2 pi, 3 pi, in these kind of things are there. At that time, what will happen? At that time, what will happen? Your sine function will become 0. That means whenever this angle, whenever this pi t is equals to n pi, multiple of pi means n pi only. At that time, what will happen? This function will become 0. When pi t is equals to n pi, then sin pi t will be equals to 0. So that you already know. So that means from here, what we are getting? T equals to n, where n belongs to integer, but 0 cannot be there, right? So t value can be there as 1, 2, 3 and so on, -1, -2, -3 and so on. One more thing you can see. What did I write? What was my sinc t? What was my sinc t? एक तो इसको लिखना बहुत टफ है. Sinc t. So that was equals to sampling of pi t. Say yes or no? Here I have written no, sampling of pi t. Sinc t is sampling of pi t. So if you know the graph of sampling of t, if you know the graph of sampling of t, then can you go to sampling of pi t? Yes. How you can go there? If I know sampling of t, can I go to sampling of pi t? Yes. My time domain is multiplied with pi. That means time axis will be divided by pi. So whatever the graph that I got here, this will be just divided by pi. That means 0 crossover would be at 1, 2, 3, 4. -1, -2, -4, -3, -4. Basically, this will be divided by pi. So either you could have done this analysis that you find out 0 crossover in this manner, or you already know that sinc t can be written as sin pi t. So from sampling of, sinc t can be written as sampling of pi t. So from sampling of t, I can go to sampling of pi t. So the same kind of curve I will be getting. Just this was pi, so this will become 1. This will become 2. This will become 3. This will become 4. This will become -1. This will become -2. This will become -3 and -4. And at infinity, it will be going towards 0. And at 0, the value will be 1. Now you will answer me on your own. What will be the value of minus infinity to infinity sinc t dt. Basically, what will be the area and what will be the value of this particular thing? Sinc square t dt. I know that what will be my sinc square, by the way? What will be your sinc square t? So that can be written as sinc t whole square, right? So what is sinc t? Sin pi t by pi t whole square, and that can be equivalent to sin square pi t divided by pi t whole square, right? So this will be your sinc square t. Basically, square means you are getting t square, that's it, and sin square. Basically, in the integration, if any day you see sin t by t, something like that, then you need to think about sampling function. And if you are getting sin square t divided by t square, then you need to think about sampling square function, because in the sampling square you will have t square and here sin square t. So that's the meaning. So what do you think, what will be the area? What is the meaning of this area only? So I know one thing, that my sinc of t is nothing but sampling of pi t, and the area of sampling of t, area of sampling of t is pi. Then if I do the time scaling, if I multiply the time domain by pi, then what will happen to the area? Area will be divided by pi. So what will be the area? Area will be 1. So what will be the answer here? 1. So sinc has the area of 1 and sinc square also has the area of 1, but sampling has the area of pi. One more thing, what you can see, sampling of minus t would be equals to what, and sinc of minus t would be equals to what? They both will be equal. Why is that so? You can see the waveform, no? Whatever that is happening to the plus side, the same thing is happening to the minus sign as well. If you just take the mirror image of this particular structure, what you will get? The same structure only. So sampling of t is equals to sampling of minus t is equals to sampling of t. These are called as even signal that we are going to see in this particular chapter only. So these are called as even signal. Okay. So there we will learn it, that how you can determine even signal within seconds, how you can determine odd signal within seconds. So here you can see that even if I take the mirror image, it will be same only. So minus can be eaten up. What will happen? Minus can be eaten up. This minus can be eaten up. Okay, so all these points we have seen. Let's see some questions, or are we going to see something else? So this we have already seen, right? Sinc of t can be written in this manner, sampling of pi t. So this slide is needless now. So everything we have seen from this particular slide. So this slide is needless. Now sampling of t in terms of sinc function. Now opposite we need to do. Basically, you are given what I have studied till now. Till now I have studied that my sinc t is equals to sampling of pi t. Now how I will represent sampling function in terms of sinc? Okay, so this is my sampling function. Now if I need to make it sinc, what is the meaning of sinc? That there should be pi, right? So can I do in this manner? In the angle I multiply with pi and divided by pi. Divided by pi into t by pi. Say yes or no? And what that would be equivalent to? Sinc of t by pi. Basically, what will be your sinc of t by pi? What do you think? From here to here it is going easy, because what did I tell you? The c will be replaced with pi. So sinc c will be replaced with pi. C will be replaced with pi. So whatever the angle that you are getting here, what angle you are getting here, pi gets cancelled, that will come downward. So what you are getting? Sin t by t only. So from here what you are able to understand, that sinc t by pi is equals to sampling of t, and sinc of t is equals to sampling of pi t. There you go. So whenever you replace sinc with SA, then what you need to do, just multiply with pi. Here also if I multiply with pi, I get this thing. Here also I multiply with pi, I get this thing. That means if sinc of 3t by pi I need to write, so that would be equivalent to sampling of 3t. Okay, so very simple thing it is. Just you need to remember only two things, that this is your sampling function and what is your sinc function, that you already remember, that what is my sinc function, that is sin pi t by pi t. C will be replaced with pi and whatever the angle that is there in sine, that will be coming out downward. That's it. Very simple thing it is. Solve this question. Square is there, so I already know sampling square t, that is sin square t divided by t square, but here there is 2t, so that means certainly it would have been sampling square 2t square. So sin square 2t divided by 2t square. Say yes or no. So what it would have become? Sin square 2t divided by 4t square. So your sampling square 2t is this value. So here you need 4. Downward what do I need? Downward I need 4. That means here I need to multiply with 4. And just as I got 4 here, what I can do? I can write it down as 2t whole square. Right? So 4 equals to minus infinity to infinity sampling square 2t dt. Say yes or no. And one thing I know, that my area of sampling square t is equivalent to pi. So what will be my area of sampling square 2t? That would be equals to pi by 2. Right? So that would be equals to pi by 2. So 4 into pi by 2. Answer is 2 pi. Okay, very simple, very simple, very straightforward. So these kind of integration, you don't need to worry about all these kind of integration in the examination. Very easily you will be able to solve. What about this question? Sinc square 2t by pi would be coming in the examination, then how you will solve it? And now notice the limit. Limit is from 0 to infinity. So what do you think, what will be the answer? Are there any other question? Okay, no. So what do I know? This is area only, but this is half area. Basically, what do I know? The area of sinc square t is equals to 1, right? But this is the complete area, no? Area means limit is from minus infinity to infinity. And one thing I already told you, that in the graph of sinc t or sinc square t, everything will be symmetric. Say yes or no? Even if I do the square on both of the side, what I mean to say is that sinc square minus t would be equals to, sorry, sampling square minus t would be equals to sampling square of t, and sinc square minus t would be equals to sinc square t. Say yes or no? This is also true, right? This thing is also true. So whatever the area that you are getting here, the same kind of area you will be getting here as well. And if the total area is 1, then what will be the area of from 0 to infinity? That would be half. Very simple it is. I hope you are able to understand. The total area is 1. So if from 0 to infinity, area would be half. Why is that so? Because your waveform is symmetric. So this area would be half only. Right? Very easy. So here I have written down this thing, but area of sinc square t, considering that limit is from 0 to infinity, what would be the area? Half. Right? Now I need to see the area of sinc square t. Sinc square 2t by pi. 2t by pi. So what I need to do? Here it is sinc square 2t by pi. So 1 by 2 into pi by 2. So the area will be pi by 4. So what is the answer? Pi by 4. That's the answer. Okay, basically whatever that is in multiplication here, that will come into divide, or you can say 1 divided by 2, or what I can do, 1 into 1 by 2. So here 2 by pi should be coming 1 by 2 divided by 2 by pi. So if I get it upward, then what I can do? I just need to multiply with the reciprocal. So pi by 4 is the answer, right? Simple mathematics. Or what you could have done in the examination, that sir, I will open it. So 0 to infinity, I will take square outward. What is my sinc 2t by pi? So I just need to multiply with pi. So here pi get cancelled. So what is the angle? 2t. So 2t comes downward, and then there is a square. That's the scene. So what I am getting? 0 to infinity sine of 2t divided by 2t whole square dt. So what you can see, 0 to infinity sampling square 2t dt. You know the area of sampling square is pi. Area of sampling square to t is pi, but there is factor of 2, so divided by 2. But the limit is from 0 to infinity, so another factor would be coming. So answer is pi by 4. So from here as well you can solve it. So n number of ways are there. You just need to get one of the way in the examination, right? You just need to get only one of the way in the examination. There is very rare chance that they will be mentioning any sink or sampling. They will be just giving these kind of function. So there you need to think that how I can make it a sampling function or sink function. I usually prefer making sampling function. I remember that the area of sampling square and sampling is pi. That's it. These two things I remember. I don't remember the area of sink. I only remember the sampling. So if I know the area of sampling function, then I will reduce every kind of function into sampling function only. And once I have reduced every kind of function into sampling function, then I remember the area property as well, that if there is scaling or if there is any other kind of thing, then how area will behave. Okay, so that I can apply and get my answer. So my answer would be pi by 4 only. Draw this waveform. Xt is equals to signum of sin t. After that, what we are having? This question we are having. Okay, so draw this waveform. Xt equals to signum of sin t. What is the property of a signum function? So what signum function says? That whatever that is inside, if that is greater than 0, then I will throw 1. And whatever that is inside, if that is less than 0, then I will throw minus 1. That's it. So whatever that is inside, that is sin t. So if I draw the waveform of sin t, then this is how the waveform of sin t goes. Right? But I don't need to make the waveform of sin t. I need to make the waveform of signum of sin t. So if I am taking signum, what does that mean? Signum says that if it is greater than 0, then I will throw plus 1. If it is less than 0, then I will throw minus 1. So what will be the waveform of signum of t? So how I can reduce it? So let's reduce it in this manner. What will be the waveform of signum of t now? Signum of sin t. And yeah, here sin t, what will be this value? This value will be pi. This value will be 2 pi. This value will be 3 pi. This value will be minus pi. This value will be minus 2 pi and so on. Okay. So signum of sin t. So if it is greater than 0, then 1. Otherwise minus 1. 1. Then 1 and then minus 1. In that manner, we will keep on going, right? This is 1. For negative value, it will be minus 1. So this kind of waveform you will be getting. So this is 0. This is pi. This is 2 pi. This will be 3 pi and 4 pi in this manner. This will be minus pi. This will be minus 2 pi. In that manner it will go. So this will be your signum of sin t, right? Very easy. Just a basic question it was, nothing else. Tell the answer of this question. Take your time. X of 3t is given. Oh sorry, x of 3t. X of 3t. It is x of 3t. X of 3t is given. You need to draw the waveform of x of 3t plus 2. Take your time, think about it, don't get it wrong. Okay, if you get it wrong, it will be hurtful for me. Think about it and solve the problem. So what did you do? Just you shifted it this side. Basically, this was your answer. That sir, what I did was, sir, I am already at x of 3t, right? Sir, I am already at x of 3t. From there, I need to go to x of 3t plus 2. So plus 2 means, sir, I need to shift it here. So basically, sir, I will shift it here. So 2 comes to 0 and this comes to 1. This is what you did, right? And whatever the amplitude is there, I don't care. But this is wrong actually, wrong. Why it is wrong?
So were we ever going from x of 3t? No. Our journey was always coming from x of t, no. Where I need to go? X of 3t plus 2. This is my target. So always we started from x of t. We never started even from x of minus t. Once we started x of minus t, and then I told you that if you are starting from x of minus t, that means you need to do two mistakes. That was a different concept. But always we started from x of t. So if I am starting from x of t, then what will be the next step? My next step would be x of t plus 2. And then the next step would be x of 3t plus 2. But what we were doing, this would be the correct one. What we were doing, we were starting from here, x of 3t. This I was already having, and then next step, this is what I did. Is this correct step? No, this is wrong. This step is wrong. So my first target is from x of 3t. From this x of 3t, I need to get x of t. So how will I get x of t? From x of 3t, how will I get x of t? If you go from x of t to x of 3t, how do you go? That your time domain is multiplied with the factor of 3. That means time axis should have been divided by 3. That's how you go to x of 3t. Now you are coming from x of 3t to x of t. That means your time domain would have divided by 3. That means your time axis will be multiplied with 3. Say yes or no. What I need to do? First I need to get my x of t. Then I will do the shift. And then I will do x of 3t plus 2. So what will be my first step? That I need to have the x of t waveform, no? Because I don't even have the x of t waveform. So here from x of 3t waveform I am having, I need to go to x of t. What does that mean? That my time domain is divided by 3. That means time axis should be multiplied with 3. So if I need the waveform of x of t, if I need the waveform of x of t, that means from x of 3t to you are going to x of t. That means your time domain is divided by 3. That means this will be multiplied with 3. So what you will be getting? 6 to 9, right? 6 to 9 you will be getting. So this is my x of t. So what will be the next step? Next step will be x of t plus 2. That means this will be shifted to here. So 4 will be shifted by 2 to the left hand side. So 6 minus 2 and 9 minus 2. So this will be 4 to 7. So this will become 4. This will become 7. So this will be your x of t plus 2. X of t plus 2. And what will be the next step? Next step will be divided by 3. Because why divided by 3? Because time domain is multiplied with 3. So this will be divided by 3. So this will be the correct answer. This will be the waveform of x of 3t plus 2. So always we are starting from x of t, not from x of 3t. So this will be the correct answer. Why we went wrong? What actually happened? Let's just say my yt was method 2. Let's just say my yt was x of 3t, right? Now I want to go to x of 3t plus 2. So do I want this thing? Y of t plus 2? No. This is wrong. If I am saying that my yt is x of 3t and I need to go for to x of 3t plus 2. So do I need to add plus 2 here? No. What is the meaning of yt equals to x of 3t? That if you are replacing y with x, then whatever that is inside, that should be 3 times. So here y should be equals to t plus alpha, let's just say. So what will be my x? Whatever that is inside, that is inside, that would be 3 times. So 3t plus alpha is equals to 3t plus whatever that is inside, 3t plus 3 alpha. 3t plus 3 alpha should be equals to 3t plus 2. So from here I am getting that alpha should be 2 by 3. So basically this is your this should be 2 by 3 here, and then I will get 3t plus 2. Are you able to understand this point? Basically whatever that is inside, that should be 3 times. So whatever that is inside, what is inside? T plus 2 by 3, and that should be 3 times. It is being 3 times, yes. So 3t plus 2 you are getting. Yes, I need to go here only. So what is my target now? What did you understand from here? That your actual target was to go from
x of 3t to x of 3t plus 2. But actual reflected target was, if you start from y of t, then you need to go to y of 2 by 3, na? Y of t plus 2 by 3. So the waveform of y of t was given. This waveform was given, no? This particular waveform, although this is already copied, this waveform was given. So this waveform was of y of t. This was the waveform of y of t. And where I need to go? Plus 2 by 3. That means backward 2 by 3. So this will be subtracted by 2 by 3. This will be subtracted by 2 by 3. So what you are getting? 4 by 3. Here what you are getting? 7 by 3. So yes, this is the correct answer we are getting, and this will be your y of t plus 2 by 3. So are you able to understand where we are getting wrong? Directly we are trying to go to x of 3t to x of 3t plus 2. So directly I cannot move my waveform. I should start my journey from x of t. Either this way, or you can tell that x of 3t is y of t. Whatever the function that is given, that is y of t. So if you need to go to x of 3t plus 2, that means how much change you are doing in y of t. That is t plus 2 by 3. Right? So basically 2 by 3 should be shifted towards the left. So 2 minus 2 by 3, 3 minus 2 by 3. So 4 by 3 to 7 by 3. So from 4 by 3 to 7 by 3. So this kind of waveform we are getting. All good? So yeah, that's it. That's it about the basics of signal. We have studied about all kind of signals. Okay. Next, what we need to do? We need to see the classification. We can study about periodicity. Then we will study about energy power. Then we will study about even odd. These kind of things we will study. And after that, we will move to discrete time signal. Till now, everything was continuous. Whatever that we have seen, everything was continuous. From last 4 to 5 lectures, from last roughly around 13 to 14 hours, we have studied everything about continuous time. Now we are going to see power signal and all these kind of signal. That also we will discuss in continuous time only. After that, whatever that we have studied for continuous time, the same thing we will be studying for discrete time as well. Is that okay for you? All good? Thank you guys. Thank you very much. Okay, I hope you are enjoying the lectures. If you are enjoying it, you can consider liking it. Okay, yeah, thank you. Hi everyone, welcome back. So till now, what all things we have seen in our course? So we have studied all kind of signals, right? Step signal, ramp signal, impulse, doublet, sync, sampling, triangular, rectangular, all these kind of signals we have seen. Now we need to study the classifications. In classifications, what all things will come? Like even signal, odd signal, periodic signal, non-periodic signal, energy signal, power signal. We need to find the average. All these kind of things we need to study. Very, very simple things these are. But before starting that particular module, first we need to understand a complex exponential signal. So there will be a particular signal called complex exponential signal. So what is this? That we need to understand. So till now, what kind of signal we have seen? Let's just say xt equals to sin t. So this was completely real, no? It was real. There was no imaginary part. But now what if in the signal there is imaginary part? What is the meaning of that imaginary part? So a very, very important signal it is, that is complex exponential signal. Very important, and if you don't get your concentration here, then you will not be able to understand it. Okay. So keep your full concentration here, then only you will be able to understand. So have you studied complex number in mathematics? Yes, right? A plus iota b, or jb you can say. So basically, let's just say how we used to denote it. We used to denote it on Argand plane, right? We used to denote it on Argand plane. Even if you haven't studied, here you can study, right? So it has a real part. This is known as real part. And whatever that is connected with j, that is known as imaginary part. How do you show it? So usually we take this axis as imaginary and this axis as real. So real part, let's just say a is positive. So on real part the magnitude is a. On imaginary part the magnitude is b. I am assuming a and b both are positive. So this is the imaginary part, this is the real part. So what will be the equivalent? Equivalent will be somewhere in between. So this will be the equivalent. So this point is known as a plus jb. Right? What is the magnitude of this line? What is the magnitude of this particular line? So that is known as, if the number is a plus jb, so what will be the magnitude? Magnitude will be, if I make a right angle triangle here, so this length is a and this length is b. So magnitude will be under root a square plus b square. So this was a complex number. Now what is a complex exponential signal? So what was our exponential signal? It was something like this: e to the power a was the magnitude, or you can say amplitude. E to the power at. This was our complex exponential signal, or it was
a e to the power minus at, right? So here also magnitude is a, but it is complex exponential, so it will be written as e to the power j omega naught t, a e to the power j omega naught t. Okay, how do we break it down? So amplitude remains as it is. What is this omega naught? Omega naught is known as angular frequency. Okay, what is this omega naught? Omega naught is known as angular frequency. What is the meaning of this angular frequency? Certainly we will understand it. Okay, in a very good detail we are going to understand in the next part of this video. So omega naught is the angular frequency. How do you open it? E to the power j omega naught t. How do you open it? It is opened as cos omega naught t plus j sin omega naught t. So can I break it down in this manner? A cos omega naught t plus j sin omega naught plus a into j sin omega naught t. So this is your real part, right? And this is your imaginary part. This is your real part, this is your imaginary part. So this is a complex exponential signal. How do we draw it? What is the meaning of it? That all these things we need to understand. Very, very interesting it would be. So this is your complex exponential signal. It is a cos omega naught t plus j a sin omega naught t. It is denoted by a e to the power j omega naught t, where omega naught is the angular frequency, a is the amplitude. Now if I give you a real signal, let's just say I give you a signal xt equals to sin t, and I ask you to draw it with respect to t. So can I draw it in 2D? Yes. Xt versus t, I can draw it in 2D. I only need two axes. One would be xt, other one would be t. Just one second. Yeah, so what I was saying that if I give you a real signal, I can draw it in two axes. A real signal can be drawn in two axes. One will be y, one will be x. So it can be drawn in 2D. Because real signal is only having the real part. Say yes or no. It is not having any imaginary part. So only two axes I need. Now what is the meaning of this xt versus t? Let's just say I am at t equals to minus pi by 2. So at t equals to minus pi by 2, I know the value is minus 1. So I am at t equals to minus pi by 2. Just as I click on the time button, that means if my time gets started, so time will always increase, right? Time never decreases. Time will always increase. So from minus pi by 2 to time will increase. It can go to 0, then it can go to pi by 2, then it can go to pi, then it will go to 3 pi by 2. In that manner it will go. So what my waveform will say? My waveform will say that the value of xt will oscillate like this, from minus 1 to plus 1, then plus 1 to minus 1, then minus 1 to plus 1. So this is the meaning of this waveform. Basically, if I am at t equals to minus pi by 2, the value will start rising from minus 1 to 1, then 1 to 0, 0 to minus 1, minus 1 to 0. In between, this is how the values will go. So this is the meaning of the waveform. Say yes or no, right? Now, how do you draw a complex exponential function, which is like a e to the power j pi by 2 t? How will you draw this complex exponential function? So let's write down what is this xt. A e to the power j pi by 2t. So a, it will have a real part, that will be cos pi by 2t, and it will have a imaginary part, that will be sin pi by 2t, right? So this is the real part and this is the imaginary part. So now this xt function is having two parts. One is real, one is imaginary, and I need to draw it with respect to t. Here I was only having the real part and I needed to draw it with respect to t. But now I am having two parts, real and imaginary, and time t. So I need three axes now. So a complex exponential will be drawn in 3D. Okay. So let me show it to you that how I'm gonna draw it, and keep your full concentration here. Otherwise you are not going to understand it. Okay. So there will be an imaginary part. There will be an imaginary part. There will be a real part. And there will be an axis of time t. So I can take another color of pen. So this is the axis of time t. Here what was the scene? There was a real part and there was the axis of time t. So here what I am saying, that this is the imaginary part, this is the real part, and this is the axis of time t. On time t we can have 0 second, on time t we can have 1 second, on time t we can have 2 seconds, 3 seconds, in that manner. And we will have the amplitude of real part on this axis and amplitude of imaginary part on this axis. Say yes or no. amplitude of real part on this axis and amplitude of imaginary part on this axis with respect to time t. So we will draw it, have your patience. Now amplitude of real part could be negative as well, no? What I mean to say is that this part could be negative as well, and this part could also be negative, and the time could also be negative. The time could also be negative, right? So are you able to imagine it in 3D? If I show you imaginary, real, and the time axis is coming towards you, the time will run on this axis. It will have a real amplitude, it will have an imaginary amplitude, and the time axis will be coming towards you. Are you able to understand this? Are you able to visualize this? Oh, this is how I should show it. Yeah, this is in 3D. So what will happen? What will happen at t equals to 0? At t equals to 0, what will be the value of x of 0? Cos 0 will be 1, so value will be a, plus sin 0 will be 0. So at t equals to 0, this is the time window of t. So at t equals to 0, the real part is a, and imaginary part is 0. Here you saw this number, no? The real part is a, imaginary part is b. If the imaginary part was 0, then this is how I would have shown it, that b would have been somewhere here, right? So real part is a and imaginary part is 0. So what will be the equivalent? The equivalent will be this only. This will be the equivalent, right? This will be the equivalent. Say yes or no. Now let's talk about at t equals to half second. At t equals to half second. And we will talk about at t equals to 1 second as well. So first let's talk about at t equals to 1 second. At t equals to 1 second. At t equals to 1 second, what is the scene? I will put t equals to 1 here. What is the value of cos pi by 2? That is 0. Plus, what is the value of sin pi by 2? That is a. So at t equals to 1 second, let's just call, this was your t. Let's call this point as 1 by 2, and then let's call this point as 1. So at t equals to 1 second, your imaginary part is a and real part is 0. Imaginary part will be a. Let's just say a is somewhere here, and real part is 0. So what will be the equivalent? This will be the equivalent. But this equivalent is not at t equals to 0. This equivalent is there at t equals to 1. Are you getting this point? This equivalent is there at t equals to 1. Say yes or no. Now let's talk about at t equals to 1 by 2. So at t equals to 1 by 2, what will be the equivalent? If you put t equals to 1 by 2 here, cos pi by 4, that would be a by under root 2, plus sin pi by 4, what that would be? A by under root 2. I am assuming a is a positive value. So on imaginary you are having a by under root 2, on real you are having a by under root 2, on imaginary as well you are having a by under root 2. So what will be the equivalent? Equivalent will be somewhere here. Are you getting this point? Here we saw this complex number, no? A and b. So what was the equivalent? Equivalent was somewhere in between. So similarly here as well, on real you are having a by 2, on imaginary you are having a by under root 2. Real a by under root 2, imaginary a by under root 2. So what will be the equivalent? This will be the equivalent. But this equivalent you are getting at t equals to 1 by 2, right? So this is how you are getting this equivalent. Are you understanding what is happening with the time? You started from here. With the time, what is happening? You are moving somewhat like this. That at t equals to 1 by 2, you are having a amplitude of this. Then at t equals to 1, you are having this amplitude. Let's check out other points as well. At t equals to 3 by 2. At t equals to 3 by 2. You will slowly understand it. Just have the patience. Have the patience. What we are doing, you will certainly understand it. But you need to have the patience. Okay. So at t equals to 3 by 2, you see. What will be the value? Cos 3 pi by 4. Cos 3 pi by 4. So pi minus pi by 4, it would be minus a by under root 2. Plus sin 3 pi by 4, it would be plus a by under root 2. So minus a by under root 2 will be somewhere here, plus a by under root 2 will be somewhere here. So equivalent will be somewhat like this. But that equivalent will be somewhat like this, but that equivalent will be at 3 by 2. That equivalent will be at 3 by 2. So the equivalent will be somewhat like this. Okay. Next you check at t equals to 1. At t equals to 1. So what will be the value of cos pi by 2? That would be 0. Not at 1, sorry. You check at t equals to 2. Because at 1 we have already checked. So at t equals to 2, cos pi value will be minus a. Plus a sin pi value will be 0. So on real you are having minus a, on imaginary you are having 0. So what will be the equivalent? This will be the equivalent, but that equivalent you are getting at t equals to 2. So are you able to understand with respect to time what is happening? You started from here and you are moving somewhat like this. You are moving in a circle. If you see this waveform, so now this is a better visualization. You started from here, then with respect to time, you went on going like this. You reached at this point. You need to visualize this in 3D. It is like a spiral. Have you seen a spiral? Have you seen a spiral? From one we started, and it is going in a circle, but it is moving with respect to time as well. It is moving with respect to time as well. First we started with magnitude a, then we reached to magnitude of a by under root 2 plus j a by under root 2. So what will be the magnitude here? Can you calculate the magnitude? A by under root 2 plus j a by under root 2. So what do you think what will be the magnitude? Magnitude will be a only again. Basically, how do we calculate the magnitude? A by under root 2 whole square plus a by under root 2 whole square, and then take the under root. Say yes or no? So it would be a square by 2, it would be a square by 2, and the magnitude will be a only. So magnitude is a. So that magnitude of this line is a only. Magnitude of this line is also a. Magnitude of this line will also be a. Magnitude of this line will also be a. Always the magnitude is a. But we are moving ahead in time axis. We are moving ahead in time axis in that manner. Look, we started like this. Then in a circle we will keep on moving ahead. We will circle. We will keep on moving ahead. Let's just say there is a guy who is going in this direction. There is a guy who is walking in this direction. And there is another guy. This guy is walking in this direction. The another guy is just revolving around this guy. You can assume Earth and Moon. Earth will walk in this manner, and the Moon will be walking around the Earth. Say yes or no? So this guy is going like this, and another guy is just revolving around this guy. So a kind of spiral structure we will get. Say yes or no? I hope you are able to visualize this point. Look, no one is going to explain you all these kind of things, okay? But complex exponential, you need to have enough visualization. You need to know what is the actual meaning of a complex signal. This is the actual meaning of complex signal, that it is having two parts, real and imaginary. With respect to t, we need to draw it. So we need to see at a particular time what is the magnitude of real part, what is the magnitude of imaginary part, and what the equivalent we will get. So at t equals to 0, the equivalent was a on the real part. At t equals to 1 by 2, the equivalent was a, but some part was on real part, some part was on imaginary part. At t equals to 1, the amplitude was a only here, but the complete part was on imaginary axis. At t equals to 3 by 2, the amplitude was again 1. Sorry, the amplitude was again a, but some part was there on negative real axis, some part was there on positive imaginary axis. At t equals to 2, again the amplitude was a only, but some part was on, sorry, the complete part was on negative real axis only. After that, what will happen? Some part will be on negative real axis, some part will be on negative imaginary axis. So this will be the equivalent. So after that, the equivalent will be somewhat like this. So are you able to see how the equivalent is moving? Started from here, then going towards imaginary, started from here, then going towards imaginary, then from imaginary this direction we are getting the equivalent, from imaginary this direction we are getting the equivalent, then we are going downward. In that manner we are getting the equivalent. But it is going with respect to time t, so it is moving ahead. So on the time axis, this is your time axis. This is your time axis. So on the time axis it is moving ahead. But just let me know one thing. If someone is looking from here, basically if someone is only looking the imaginary axis and real axis, so what kind of structure he will see? Have you seen a spiral? Have you seen a spring? Have you seen a spring? Have you seen a spring like this? So if I look from the upper side, how the spring will look like? It will look like a complete circle. Say yes or no? If you are looking from the upper side, there is a spring, right? There is a spring like this. There is a spring like this. If you see from the upper side, how the spring will look like? It will look like a complete circle. Say yes or no? You would have seen a spring, right? So if someone is looking from imaginary and real axis only, he cannot see the time axis. He can only see these two axes. So if he is looking at it in 2D, then what he will see? He will see a complete circle and nothing else. So that's why complex exponential you would see it is shown like a circle only. And here also you can verify that previously my equivalent was a, then again always my equivalent is A only, but slowly we are moving towards imaginary axis. Then we reach at the imaginary axis completely. Then from here we started, then we moved here, then we reached to the imaginary axis completely. Then in this manner we are going, here we reached, then we reached to the real axis completely. Then after this what will happen, you can check at other time as well. You can check at 5 by 2, you can check at t equals to 3 seconds, you can check at t equals to 4 seconds. So in that manner we will keep on moving. In that manner we will keep on moving. In that manner we will keep on moving. But this we are moving with respect to time t. But if someone is looking in 2D, if someone is looking only these two axes, he cannot see the time axis. That means if someone is looking from this particular scenario, if someone is looking from here, from the backward side, this is real, this is imaginary, and this is the time axis t. Okay, or I can say this is, sorry, this was imaginary, this is real, and this is the time axis t, right? Imaginary, real, time axis t. If I am looking from here, from backward side, what I will see? I will only see a circle. Actually it will be a spring, it will be a spiral, that it will keep on going like this, it will keep on moving ahead. But if I see from here, I will only see a circle. Say yes or no. Are you able to see it? If I look from the backward side, I will only see a circle. So in 2D, you will see in a lot of textbook and in a lot of lectures as well, that they will say that it is complex exponential. Yeah, it is complex exponential, but it is complex exponential looking at a 2D. Actually, this is the complex exponential. That this is how it is going. This is how it is moving ahead. Okay. So they will say that this time is t equals to 0. Say yes or no. At t equals to 0, my magnitude was a. This time was t equals to half second. Magnitude was a only, but some part was on real axis, some part was on imaginary axis. At t equals to 1 second, what I was getting? At t equals to 1 second, I was getting the complete part on imaginary axis. This was your t equals to 1. Then at t equals to 3 by 2, t equals to 3 by 2, this was the same. At t equals to 2, this was the same. At t equals to 2 plus 1 by 2, what that would be? 5 by 2, this would be the same. At t equals to 3, this would be the same. 3 plus 1 by 2, what that would be? 7 by 2, this would be the same. And at t equals to 2 seconds, again I will get the same thing. Okay. So this was t equals to 3 by 2, this was 2, this you can check at other time as well. I am not going to draw the whole circle, but you can check other time as well. So this is how we are completely moving. Okay. Just 1 second, I need to drink water, then I will come back to that discussion. Yeah, so I hope you are able to visualize the complex exponential now. I have given enough intuition regarding the complex exponential. I just wanted to explain the meaning of complex exponential. This might not be used in your examination. It might be used in interview. In some interview, if someone asks you a very good question from signal system, then this is what they will ask at the first point, that explain about the complex exponential. So it might not be used in the examination. Whatever that is used in the examination, that we will see. But at least now you have an idea that the kind of signal that we study, what is the meaning of these kind of signals. Say yes or no, right? We will give you more visualization. This visualization you can see. What we can see? This is our imaginary axis, this is our real axis, and this is our time axis. With respect to time, it is moving forward in a spiral. If I look from here, if I look only imaginary and real axis, basically if I look only the imaginary and real axis, what I will see? This circle. If I look from here, that means if I only see the imaginary and time axis, what I will see? I will see sinusoid. What I will see? Sinusoid. Why I will see sinusoid? I am only seeing imaginary and time axis t. I will only see sinusoid. If I see real axis and time t, how would I see real axis and time t? I need to look from the upper side. How would I see imaginary axis and time t? I need to look from here. Say yes or no. Are you able to visualize? This is in 3D. If someone is looking in 2D from here, imaginary and real he will see. If someone is looking in 2D from here, imaginary and time t he will see. If someone is looking from 2D from the upper side, real and time axis he would see. Then from the upper side he will see cosinusoid, because the real part was cosinusoid only. If I had only plotted the real part versus time t, what kind of plot I would have got? This kind of plot I would have got. What this is? This is your real part of xt versus time t. And what is this? This is your imaginary part of xt versus time t. And when I combine both of them in one axis, when I combine both of them in a one 3D plane, I should not say plane, in one 3D structure, if I combine both of them, then this kind of structure I will get. And when I see imaginary and real axis together, then this kind of circle I will see. So usually this is how it is shown. So from now onwards, this is how I will show the complex exponential. But you would actually know the meaning, right? With respect to time we started, so we kept on moving in the anti-clockwise direction. T equals to 0, 1 by 2, 1 second, 3 by 2. In that manner, we kept on moving. And now you actually know the meaning of this particular structure as well, that actually this is how it is moving. Okay, so let me show you an animation as well. This pic also I got from internet, so credit goes to the guy who has actually made this pic. Okay, this picture also I got from internet only, so credit goes to internet. And one animation I will show you now, that for that also the credit goes to the website only. So let me show you the animation. Yeah, so this is the animation that we are going to see. You can see the function, it is same only, a to the power j. What is the meaning of 1.57? It is pi by 2, right? A to the power j pi by 2. So same kind of function we can see. Now we will see with respect to different axes. So this is the real axis they are saying, and this is the imaginary axis they are saying. In our diagram, imaginary we made here and real we made here. So this is the only visualization that I could see from internet, so that's why I'm showing it. And credit goes to this demonstration.wolframe.com, this website. I hope they will not be putting the copyright strike here. Okay, I'm really afraid of copyright strike, but let's see what we can see. Okay, so first I am going to show you the Argand plane. So you see the Argand plane, what kind of structure you can see? It is like a circle only. Now I need to see real axis and time t. Where is time t? This is the time t. This axis is time t. Okay, if I need to show you where is time t is somewhere here. This was your, here you are having some imaginary, here you are having some real axis, and time t is somewhat like this. You can see this is the time t. This is your imaginary, and real I cannot show it. Real is actually coming towards us, and this is the time t, right? So let's see the visualization now, that what all axes if we see and what kind of structure we are going to see. So here what I can see, imaginary versus time t, right? Imaginary versus time t only we can see. No, this is not imaginary versus time t actually, because here what I can see cosinusoid. So let's rotate this picture first. So this is the Argand plane that I told you, that it will look like a circle, right? Then if we see from here, if we see somewhat like this, yeah. So here what you can see, sinusoid, right? Kind of sinusoid you can see. So upper axis is imaginary, and this is the time axis. This is the time axis. This is the time axis, and this axis is the imaginary axis. So sinusoid you can see, right? And if I rotate it more, yeah. So now what is the scene? That this would be your real axis, and this would be your time axis. So now what you can see, cosinusoid. And when I only see real and imaginary axis together, when I only see real and imaginary together, that means I see somewhat like this. So what I can see only circle. Although I am not able to make it on the perfect angle, here you can see kind of spiral only, but it would be a circle. Actually, if you see from the perfect angle, where you can only see real and imaginary axis and not time axis, here a bit of time axis we can also see, but so that's why it is looking like a spiral, but it would be a circle. I hope you are getting my point. So imaginary and time if I see, I will get sinusoid. Real and time I will see, I will get cosinusoid. And if I see real and imaginary, I will get a circle. And how it is usually shown? Usually real and imaginary are shown. So that's why complex exponential is shown by the circle. But it is not actually a circle, it is actually a spiral. And we will discuss this complex exponential in a great detail when we study Fourier series. I will break down complete Fourier series in complex exponential only. Why this complex exponential is very important part, that we are going to understand in Fourier series, Fourier transform, everywhere we will be using e to the power j omega t. Why? Why is that so? Why this is so important? So first you need to understand the point that it is just a combination of cosinusoid and sinusoid. Complex exponential is a combination of cosinusoid and sinusoid. Cosinusoid is the real part, sinusoid is the imaginary part. When I plotted them, I kind of got a circle, and I got a circle, but looking at 2D, actually in 3D it is a spiral. With respect to time, we are moving on a circle only, but time is moving ahead. So in that manner we are moving ahead. Say yes or no. In this manner we are moving ahead. And if I see the 3D structure, this would be like this. If I look it in 2D, if I see only imaginary and time, then I will get sinusoid. If I see only real and time, then I will get cosinusoid. If I see only imaginary and real, then combination of both of them, I will see a circle. Right? Now, can you let me know? Here the amplitude was A, right? Here the amplitude was A. What if the amplitude was somewhat like this? A into e to the power minus 2t, and then it was multiplied with A e to the power j pi by 2t. What was the amplitude was like this? The amplitude was a function of t. So what do you think, what kind of waveform you would have got? Are you able to understand my point? What I am saying? That my xt is somewhat like this. What if my xt was A e to the power minus 2t e to the power j pi by 2t. So how will I break it down? Cos pi by 2t plus j sin pi by 2t. What I will get? Cos pi by 2t plus j a e to the power minus pi by 2t. Do you know the graph of this particular function? Do you know the graph of this particular function? What is this? This is your real part. What is this? This is your imaginary part. Do you know the graph of both of them? Certainly you know, right? You know it, right? How do we make it? Started with the maximum and slowly it will keep on reducing its amplitude. Here it will be more actually. This is your cosinusoid, no? So before that it will start by more. I am just making it for t greater than 0. What about sinusoid? Slowly it will lose its amplitude. If you remember, in the beginning only we have seen this graph, right? E to the power minus 2t, you will make the graph of e to the power minus 2t, then you will take the mirror image, and in between the mirror image you will make this graph. So basically it is sinusoid but with the losing amplitude. This is also cosinusoid with the losing amplitude. As you go ahead in time, this is your imaginary, right? And this is your real. So as you go ahead in time, the amplitude will be reducing. As you go ahead in the time, the amplitude will be reducing. So if I make them on one axis, real and imaginary together. So what I will start with? Initially, what is the real part? At t equals to 0. At t equals to 0. The real part is 1. Imaginary part is 0. So this will be my amplitude at t equals to 0. Now it will be moving in circle only, but with the losing amplitude. Are you getting to know this point? What I am saying? With time it will go like this. Here what is the amplitude? A. But let's just say I calculate the amplitude at some other time. Let's just say I calculate the amplitude at this time. So it is saying that at this time my amplitude should be, if this was A, then it would have been lesser than A for sure. Because let's just say this time is, I don't know what is this time. This time could be cos pi by 2t. So minus 1 is there. So this time could be 2 seconds. So if I calculate the value of x at 2 seconds, so what I will get? Cos pi value will be minus 1. So it would be A into e to the power minus 4 into minus 1 plus j A e to the power minus 4, and I am putting t equals to 2. So sin pi value will be 0. So what value I am getting? Minus A e to the power minus 4. So here the amplitude was A, but now what is the amplitude? Amplitude is A into e to the power minus 4, although in the negative part. So if I make imaginary real and then time axis here, this is the time axis. So at t equals to 2 second, the amplitude is A e to the power minus 4, which is very lesser than A. So with respect to time, your amplitude is getting decreased. Are you able to understand this point? You will start like this, you will go ahead, sir, I will go ahead, but amplitude is slowly decreasing. Why amplitude is slowly decreasing? Are you able to understand? I will start like this, and when I move on the time axis, my amplitude will keep on increasing. Sorry, keep on decreasing. My amplitude will keep on decreasing. Here you can see amplitude will keep on decreasing, because here you can see another exponential is added. Because of that, real versus time t, it is kind of cosinusoid but with the losing amplitude, and it is kind of sinusoid only but with the losing amplitude. So equivalent will also lose its amplitude. And if I show it in 2D, if I only show imaginary and real, so it will be like this. Initially the amplitude is maximum, then we will keep on losing the amplitude. Not looking perfect. With respect to time, we will keep on losing the amplitude in that manner, and eventually we will fall to 0. And when we will fall to 0? At t equals to infinity, because at t equals to infinity, what will happen? At t equals to infinity, a e to the power minus infinity, e to the power j, whatever it is, at t equals to infinity, this will give you some value that you don't know. It would be somewhere in between plus 1 to minus 1. This will be somewhere between plus 1 to minus 1. But e to the power minus infinity, that would be 0. So at infinity, the value of xt would be 0. So that will fall to 0 only. Here the value will be 0 only. So eventually it will fall down to 0. So this kind of a spiral you will get. Even in 2D, it is looking like a spiral. Here the magnitude was always constant. Here if you calculate the magnitude of xt, if I calculate the magnitude of xt here, what is the magnitude of xt? That is a only. So here always the magnitude is a. No matter whether the time is t equals to 0 or t equals to infinity, always the magnitude is a. So that's why you could draw this kind of circle saying that the magnitude will always be a. But here the magnitude is reducing. So starting with a, at t equals to 0, starting with a, and at t equals to infinity, you will be losing till 0. From a to 0, you will fall down. Right? Here we can see in the animation as well. I just need to put this part something. This part equivalent to something. So what I can do, let's put this part as minus 0.05. Okay, please show it now. Yeah, so what you can see here, what I have done, if you open it, e to the power minus 0.05t into e to the power j pi by 2t. So this is the graph I am drawing. This is equals to xt. So this was the complex exponential, and this is the magnitude. Magnitude is reducing with respect to time. So let's see what kind of waveform we can see here. You will see that the circle will keep on reducing. Okay, so let's get started. Let's see the. So you see, if I see it in 3D, how I can see it in 3D? Yeah, somewhat like this. So even if I am looking from here, you can see that we started with this point, and then slowly you can see the amplitude is reducing. So you are not going to see a circle here, you are seeing a spiral, right? If I increase it a bit more, what I can do? What I can do is that I can put 60 here. Then more perfect way you would be able to see now. Yeah, so this has reduced too much actually. Look, we started like this. This was our initial magnitude, and then this was our initial magnitude, then it kept on reducing, it kept on reducing, it kept on reducing. So this is how it is reducing. It will be going towards 0, because here I have increased the magnitude in a very greater manner, e to the power minus 0.60. So that is a very high value actually, e to the power minus 0.60, because if you go on, if you check the value of e to the power minus 1, what is that? 1 by e, 37%, 0.37. Am I correct? 1 by e is 0.37 only, no? Because I always get confused between 0.63 and 0.37. I guess it is 0.37 only. Gate calculator. Reciprocal of e. Yeah, 0.37. So amplitude reduces too much, right? So here we started with the maximum amplitude, whatever it was, 1. Then it was reducing too much with respect to time. Then it kept on reducing, and In that manner, it reduced to 0. So I'm just telling all the possible points regarding complex exponential, right? So you haven't studied about periodic signal, although till now you don't know what is a periodic signal, right? Just after 1 or 2 minutes, we will start studying about periodic signal. So, but if you already know about periodic signal, if you are a dropper who already know what is a periodic signal, so let me know whether this signal is periodic or not. Absolutely not, right? Because the value, we started with value A and we never reached to value A again. We never reached to this point again. But is this signal periodic? Yes. We started from here and after time 2 seconds, we again reached to this point only. So this is a periodic signal, but this is not a periodic signal. This is not a periodic signal. Other way could be, what could be the other way? You can see that, sir, this is also not periodic and this is also not periodic, because you can see the waveform, right? This is not periodic. This is also not periodic. So combination can never be periodic. That will also be non-periodic. And by the total waveform also you can see that total waveform is also not periodic. Say yes or no. So this periodic, aperiodic we are going to see in the next lecture. So there also again we will discuss the complex exponential. We will see that it is not a periodic signal when it is losing its amplitude with respect to time. But when the amplitude is constant, at that time it is a periodic signal. Okay, very good points these are. I hope you are able to understand why I spent 40 minutes on this complex exponential, and you will realize that without complex exponential, electronics engineering is not possible. I am not saying without complex exponential, signal system is not possible. Without complex exponential, signal system is certainly not possible. But without complex exponential, electronics engineering is also not possible. Okay, so very important function, and I tried to give everything that was necessary for this particular signal. Okay, in the next video we will start studying about periodicity of signal or some periodic signal. But before that, let's see some more important point regarding complex exponential only. So e to the power j omega naught t, it is cos omega naught t plus j sin omega naught t, right? How I can write down e to the power minus j omega naught t? So j should be replaced with minus j, right? So cos omega naught t, j should be replaced with minus j sin omega naught t. Or you could have said that omega naught should be replaced with minus omega naught, right? So here plus sign remains as it is, but omega naught is replaced with minus omega naught. So what is the value of sine of minus theta? That is equals to minus sine theta. Here also I need to replace with minus omega naught t. So what is the value of cos of minus theta? That is equals to cos theta only. So cos can eat up the negative sign, sine will not eat up the negative sign. So what you are getting? Cos of omega naught t minus j sine omega naught t. So this is your e to the power minus j omega naught t. When you add both of the function, this is my equation 1, this is my equation 2. When I do 1 plus 2, what I am gonna get? क्या कर रहा हूँ यार मैं? When I do equation 1 plus 2, what you will get? So minus j it will cancel out. 2 cos omega naught t would be equals to e to the power j omega naught t plus e to the power minus j omega naught t. So cos omega naught t is equivalent to e to the power j omega naught t plus e to the power minus j omega naught t divided by 2. Say yes or no. And if I do 1 minus 2, what you are going to get? So this would be j sin omega naught t, cos omega naught t and cos omega naught t will cancel out because you are doing 1 minus 2. So this would be 2j sin omega naught t. So from here what will come? Sin omega naught t is equals to e to the power j omega naught t minus e to the power minus j omega naught t, and here 2j was there, that can come downward, and it would become 2j, and this would be your sin omega naught t. So you need to remember both of them. If I ask you that represent cos signal in terms of complex exponential, then you would say e to the power j theta plus e to the power minus j theta divided by 2. If I say represent sinusoid in terms of complex exponential, you will say e to the power j theta minus e to the power minus j theta, e to the power j theta minus e to the power minus j theta divided by 2j. So you don't need to do this analysis again and again. This was just to prove it. Only once we are going to prove it. After that, we are never going to prove it. Say yes or no. What will be the value of e to the power j0? Cos 0 plus j sin 0. What is the value of cos 0? That is 1. And what is the value of sin j0? Or what is the value of sin 0? That is 0. So what is the answer? 1. E to the power j0, answer is 1. You need to remember it. Okay. E to the power j0. Anything multiplied with 0 will be 0. E to the power 0, that would be 1. This is the way of remembering it. Actually, what is happening? Cos 0 plus j sin 0. So cos 0 is 1 plus j sin 0. Sin 0 is 0. Okay. Now what is e to the power j pi? So what is the value of cos pi? Minus 1. What is the value of sin pi? 0. Cos pi is minus 1 plus. Here in place of omega naught t, what I am putting? I am putting pi. So cos pi is minus 1 plus j sin pi. What is the value of sin pi? That is 0. So what is the answer? Minus 1. What about this value? E to the power j2 pi. What it will be equivalent to? Cos 2 pi. What is the value of cos 2 pi? Cos 2 pi is 1. What is the value of sin 2 pi? Sin 2 pi is 0. So what you are getting? 1 only. So all these things you don't need to remember, but at least remember this thing, e to the power j0, that is 1, e to the power j pi, that is minus 1. Or you can do it in the examination whole as well, but it should take minimum of time, that e to the power j pi, okay, cos pi minus 1 plus j sin pi 0, so minus 1. It should take minimum time, right? What will be the value of e to the power j pi by 2? What do you think? What is the value of e to the power j pi by 2? So cos pi by 2 is 0 plus j sin pi by 2 is 1. So what you are getting? J. What is the value of e to the power j 5 pi by 2? 5 pi by 2. So pi by 2 plus 2 pi. Pi by 2 plus 2 pi. So cos 5 pi by 2. Cos 5 pi by 2. What that would be equivalent to? Cos pi by 2 only. Right? Cos 5 by 2 will be equivalent to cos pi by 2 only. Because you know that cos 2 pi plus theta is equivalent to cos theta. Basic trigonometry. Cos 2 pi plus theta is equal to cos theta. So cos pi by 2 plus 2 pi will be equal to cos pi by 2 only. So what is the value of cos pi by 2? That is 0. And what is the value of sin pi by 2? That is 1. So it would also be equal to j only. Right? What about this? E to the power j 3 pi by 2. So what is the value of cos 3 pi by 2? That is equivalent to cos 3 pi by 2. This is the graph of cos. So this value is pi. This is 3 pi by 2. So cos 3 pi by 2 is 0. Plus what is the value of sin 3 pi by 2? So this is pi, sin 3 pi by 2 is minus 1. So what you are getting? Minus j. So very quickly you should be able to do all these kind of things in the examination. Okay. You will write down e to the power j 3 pi by 2. That means cos 3 pi by 2. That would be 0 plus j sin 3 pi by 2. So that would be minus 1. So minus j is the answer. Okay. Here plus j is the answer. Here plus j is the answer. So anything could be written here. Anything could be written here. You should have the aptitude that I actually know the value of sinusoid and cosinusoid. Based on that, I can tell the equivalent value. Say yes or no. And all these will have the magnitude of 1 only, right? Magnitude xt is equals to a e to the power j omega naught t. So how will you take the magnitude? Magnitude. Here I should have shown the magnitude as well. You guys must have got confused. Here I did not show the magnitude. So how will I take the magnitude of mod of xt? Under root real part plus imaginary part. Can I take a square common? And then there is an under root. So that can come outward. In the under root, what will come? Cos square omega naught t plus sin square omega naught t. What is the value of cos square omega naught t plus sin square omega naught t? What is the value of cos square theta plus sin square theta? That is 1 only. So what is the magnitude? A. So eventually what did you understand here? What is the magnitude of e to the power j omega naught, e to the power j omega naught t? What is the magnitude of e to the power j omega naught t? xt is equals to e to the power j omega naught t. So if I take the magnitude of e to the power j omega naught t, so how e to the power j omega naught t can be written? So xt can be written as cos theta plus j sin theta. And if I take the magnitude, what I am getting? Under root of cos square plus sin square, that would be 1 only. So magnitude of e e to the power j omega naught t is 1 only. So e to the power j magnitude will be 1. E to the power j pi magnitude will be 1 only. E to the power j 2 pi magnitude is 1 only. E to the power j pi by 2 magnitude is 1 only, although the value is j. But what will be the magnitude of j? I hope you know complex signals. What is the magnitude of j? The complex value is 0 plus j into 1. So what will be the magnitude? 0 square plus 1 square and then under root, that would be 1 only. So here magnitude is also 1, here also magnitude is 1, here also magnitude is 1. Magnitude will always be 1 in all these cases. Say yes or no? So in complex number we see the polar form, we see Argand plane, all these kind of things we see, right? What is this? This is a polar form. This is a polar form. All these are the polar form. So in polar form, whatever that is written here, that is the magnitude. Here 1 is written, so 1 is the magnitude. 1 into anything is written, 1 into anything is written, so that is the magnitude. So magnitude is 1, or you can say amplitude is 1. Rest all things you can find out the value is j minus j, 1 minus 1, 1. I hope it is all clear to you. Okay. You can see some trigonometric function as well. So these are the trigonometric formula. If you want to remember, not, I should say you should remember it, because it will be used. In your complete electronics engineering, it will be used. Now the next topic we are going to study about periodicity, power, energy, there all these things will be used. So that's why I have written down these trigonometric formula. So can you remember all these things? Sin a plus b you need to remember, sin a minus b you need to remember, cos a plus b you need to remember, cos a minus b you need to remember. If you remember one formula, sin a plus b, sin a cos b plus cos a sin b. Sin a plus b is sin a cos b plus cos a sin b. Then you don't need to remember this formula, right? What you will do, in place of b you will put minus b. So in place of b you put minus b. Here if I put minus b, cos will eat up the negative sign. But here if I put minus b, sin minus b. So minus sign will come outward. So minus of sin b. If you remember cos a plus b, you don't need to remember this formula. What is cos a plus b? Cos a cos b minus sin a sin b. Right? If I put plus b, in place of plus b, if I put minus b, so what will happen? Here cos will eat up the negative sign, but sin cannot eat up the negative sign. So negative sign will come outward. So minus minus will become plus. Say yes or no? Right? So you will never have the confusion. In the examination, you will actually never have the confusion in the formula. You just need to remember one formula and this formula. Then you can write down the other formula as well. Okay. Then these formula you don't need to remember. Basically, if you add these two, if I add equation 1 and 2, I will get this formula. 1 plus 2. 2 sin a cos b would be equal to sin a plus b plus sin a minus b. What about this one? If I subtract 2 minus 1, what I need to get? I need to get 2 sin a sin b. So from here I need to subtract, not 2 minus 1, sorry. Let's call this as 4 and this as 3. So this is 4 minus 3. If I do 4 minus 3, I will get this formula. What about the other one? 2 cos a cos b. So I just need to add 3 plus 4. If I do 3 plus 4, this is what I'm going to get. And if I do 1 minus 2, what I will get? Cos a sin b, 2 cos a sin b. Well, that I should also have written. If you do 1 minus 2, then you can get 2 cos a sin b. Right? So that also you can see. So these kind of formula, you only need to remember this one. And then sin 2a, these two also you need to remember. In place of b, if you put a, here in place of b, if you put a, what you will get? Sin 2a. Sin a cos a plus cos a sin a. That means 2 sin a cos a. And here in place of b, if you put a, so what you will get? Cos a into cos a, that would be cos square a, minus sin a into sin a, that would be sin square a. So cos 2a is equal to cos square a minus sin square a. In place of cos square a, if you put 1 minus sin square a, what you will get? 1 minus 2 sin square a. And in place of sin square a, if you put 1 minus cos square a, what you will get? 2 cos square a minus 1. So it should be there on your tips. You need to remember them. Okay. No matter what, you need to remember this formula. Sin a plus b, sin a cos b plus cos a sin b. Cos a plus b, cos a cos b minus sin a sin b. Sin 2a, 2 sin a cos a. Cos 2a, cos square a minus sin square a, or 2 cos square a minus 2 cos square a minus 1, or 1 minus 2 sin square a. So these formula you need to remember. Sinusoids and cosinusoids. Very, very important. Next video we will study about periodicity. Hi everyone, welcome back. Welcome to PrepFusion. So in this video we are going to study about periodicity of a signal.
So we will see what is the meaning of periodicity, what is the meaning of periodic signal, what is the meaning of non-periodic signal, or what is the meaning of aperiodic signal. So the first point is, in this video we are going to study about continuous time signals only. Okay, continuous time periodic signal, because till now we have seen step signal, ramp signal, impulse signal, all these kind of signals we have seen, and every signal was continuous. We did not even discuss about discrete time. So from this video onwards, we will see periodic signal, we will see even signal, odd signal, energy signal, power signal. So first we will discuss everything about continuous time, and after that we will study discrete time signal. There we will talk about step sequence, ramp sequence, impulse sequence, and after that we will study periodicity, even, odd, in that manner we will go. So as of now we are only studying about continuous time signals, and in the continuous time signal I am talking about periodicity here. So continuous time periodic signal. So what do you mean by periodic signal? So periodic signal means it will repeat itself after a certain time. It will repeat itself after a certain time. So is the signal being repeated? Yes. From 0 to 2, what is the structure is there? The same structure is there from 2 to 4. The same structure is there from 4 to 6, and in that manner it is always repeating. Whatever the structure is there from 0 to 2, the same kind of waveform is there from 0 to -2 as well. The same will be there from -2 to -4 as well. So the signal is repeating itself, and it should repeat all the time. That means it should repeat from -infinity to infinity. Repeat itself after a certain window. After a certain time window for all the time. That means it should repeat itself, but for all the time it should repeat from -infinity to infinity. Are you getting this point? Now there is a term called fundamental time period. What is the term called? Fundamental time period. So what is the meaning of this fundamental time period? So fundamental time period is the minimum time after which the signal is repeating itself. The minimum time. What is that minimum time? That minimum time here is 2 seconds. Because from 0 to 1 it is 1. From 1 to -2, from 1 to 2 it is -1. Then from 2 to 1 it is again 1. From 3 to 4 it is again -1. 4 to 5, 1. 5 to 6 again -1. So it is repeating itself after a window of 2 seconds. Then again 2 seconds. Then again 2 seconds. In that manner it is repeating. Here also 2 seconds. Right? 1 -1, 1 -1, 1 -1. Here -1, 1. So 1 -1, 1 -1, 1 -1. In that manner it is repeating itself after a certain window of 2 seconds. So here the word would be, here the fundamental time period is 2 seconds. The important point to note here is that some student may come and he will say that, sir, what I feel is that the signal is repeating itself after 4 seconds as well. Whatever that is there between 0 to 4, the same waveform will be there from 4 to 8 as well. Are you getting this point? Or someone can say that, sir, whatever that is there between -2 to 2, the same waveform is there between 2 to 6 as well. This waveform is being repeated here as well, between -2 to 2 and between 2 to 6. So sir, this window is 4, and sir, this window is also 4. So I will say my time period is 4 seconds. No, whenever you talk about time period means it should be fundamental. It should be the minimum time. So this is the minimum time after which the signal is being repeated. Yes, it is certainly being repeated after 4 seconds. It is certainly being repeated after 6 seconds as well. It is certainly being repeated after 8 seconds as well. But the minimum time is 2 seconds. You cannot say the time period is 1 second. No. Because after 1 second it is not being repeated. 1 to -1, -1 to 1. It is not being repeated. Right? So you need to see that this waveform, this complete waveform is again and again being repeated, and the minimum time is 2 seconds. So fundamental time period is 2 seconds. Are you able to understand the meaning of fundamental time period? Right? In the examination, they may drop this word fundamental. So if only time period is written, you need to assume it as a fundamental time period only. Are you getting this point? In the examination, if they ask you to find the time period of this signal, so time period and fundamental time period both are the same thing. If they are asking the time period, that means they are asking the fundamental time period only. You cannot say, sir, it would be 4 seconds, or it would be 6 seconds, or it would be 8 seconds. Only the fundamental time period you need to take in action. Well and good. So this is the definition of fundamental time period, the minimum time over which the signal repeats. There are two important points about the fundamental time period. So what is the important point? Should be repeated after every t naught time for minus infinity to plus infinity. That means your signal should be repeated here. Signal should be repeated. Your signal should be repeated after every t naught time. After every 2 seconds, the signal is repeated. From 0 to 2, 2 to 4, 4 to 6. So after every 2 seconds, the signal is repeated, but it should be repeated from minus infinity to plus infinity. That means it should be always repeating. Now it should not happen that, sir, it was repeating like this, again it was repeating, and after that it was not repeating. After that some random waveform was there. After that some random waveform was there. Then you cannot say that it is a periodic signal. No, it should repeat for all the time. Started from here, it will keep on repeating. It will keep on repeating. Here also, it will keep on repeating. So it should repeat for minus infinity to infinity. Then only you will call it periodic signal. Otherwise, it would be aperiodic. And what is the meaning of T naught? That is your fundamental time period. Okay. Now the T naught cannot be 0, or it cannot be infinity, or it cannot be negative, or it cannot be a function of time. Function of time. So your T naught cannot be 0, infinity, negative, or a function of time. What do you mean by that? It cannot be negative. Someone will say that, sir, this time window is minus 2. No, you need to take the time. From minus 2 to 0, what is the time window? The time window is 2 seconds. That's why the word window is written here. After a certain time window. Not for the certain time. Because someone can say that, sir, this time from 0 to minus 2, this time is minus 2 seconds. But you need to take the window. So T naught will always be positive. It cannot be negative. It cannot be 0. It cannot be infinity. So these things we will see. About this we will talk about, and for this as well we will talk about. Okay. As of now you can get to know one thing, that T naught cannot be negative. It cannot be 0 as well, it cannot be infinity as well, and it cannot be a function of time t as well. We will talk about it. Okay. Now for a periodic signal, x of t plus t naught, where t naught is the fundamental time period. Where t naught is fundamental time period. So what do you think what this will be equivalent to? X of t plus t naught. What do I mean by that? What is the, where, this was your periodic signal, right? So what is the value of x at 1 by 2? Value of x at 1 by 2. What is the value? 1 only, right? Now if I check the value after 2 seconds, that means if I check the value at t naught, that means I am checking the value at after 2 seconds, means 1 by 2 plus 2, that would be 5 by 2. So after 2 seconds, where I will reach? Here I will reach. 1 by 2 to this would be your 5 by 2. What is the value? Again it is 1 only. Because signal is repeating itself after every t naught time. So for a periodic signal, x of t plus t naught will be equals to xt only. Or you can write down x of t plus 2 t naught. That would also be equals to xt only. Because here t naught was 2 seconds. After 4 seconds itself, after 4 seconds as well, it will repeat itself. After 6 seconds as well, it will repeat itself. And in that manner, and one more thing we can see, what if I go backward? I can go backward as well, no? X of t minus t naught. That means from here I am going backward for 2 seconds. So where I will reach? Here I will reach. So again the value is 1. So x of t minus t naught can also be equals to xt. X of t minus 2 t naught will also be equals to xt. Right? Signal will repeat itself. You either go forward or you go backward. So from here, what did you get to know? That x of t plus n t naught would be equals to x of t. Say yes or no. And where n is an integer. N has to be an integer. Now you cannot say that, sir, the value of n I will put as 3 by 2. So t plus 3 by 2 t naught. This cannot happen. No, this is wrong. X of t plus t naught, x of t plus 2 t naught, x of t plus 3 t naught, that will repeat itself. Right? X of 4 t naught. Because after every t naught time it is repeating. After t naught, 2 t naught, 3 t naught, 4 t naught, 5 t naught. In that manner it will keep on repeating itself. So for a periodic signal, x of t plus n t naught is equals to x of t. Right? Now answer this question. Is this signal periodic? You will say that, sir, it is repeating itself after every 2 seconds. So it is periodic with the time period of 2. No. What did I tell you? I told you that the signal should repeat itself but for the infinity time. From minus infinity to plus infinity. Here it is repeating itself.
But here what is the scene? Is this waveform being repeated? Is this waveform being repeated towards here? No. This waveform is not being repeated here. Are you able to understand this point? This particular waveform, if it was being repeated, then the signal would have been something like this and we would say that it is periodic. But this waveform is not being repeated here. That means it is your non-periodic signal, right? Because I told you it should repeat, but it should repeat for minus infinity to plus infinity window, non-periodic. What about this one? Y of t versus t, right? So at t equals to 0, the value is 1. Now some guy would say that, sir, at t equals to 0 plus, the value is 1. At t equals to, sir, 0 plus plus, the value is again 1. At t equals to, sir, 0 plus 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 plus, the value is again 1. So that means it is repeating itself after every 0 second. Some guy will say that, sir, t naught time would be 0 second. It is repeating itself after every 0 second. But I told you one thing, that t naught can never be 0. Right? Here t naught is coming out to be 0 second, but it is not possible. And if it is not possible, that means it is a non-periodic signal. Here what you can see, yt is a DC signal. What is this? This is known as DC. DC means it will always have a certain value. Yt is equals to 1. Yt equals to 1. So yt will always be 1. Whether it is minus infinity or plus infinity, everywhere it will always be 1. So different guys can say different thing here. That yt is being repeated after every 1 second. Some guy will say that, sir, yt is being repeated after every 1 second. Some guy will say that, sir, yt is being repeated after every 2 seconds. Some guy will say that yt is being repeated after every 3 seconds. Because from 0 to 2, the value is 1. From 2 to 4, the value is 1. From 4 to 6, the value is 1. So after every time it is being repeated. So DC has the capability of making its time period anything. Are you getting this point? What did I say? That DC has the capability of making its time period anything. If you say repeat yourself after 1 second, DC will say yes, I can repeat. Repeat yourself after 3 seconds, DC will say yes, I can do. Repeat yourself after 1000 seconds, DC will say yes, I can do. Repeat yourself after infinity seconds, DC will say yes, I can do. Because from 0 to infinity it is 1. From 0 to minus infinity as well it is 1. So it can repeat it after infinity seconds as well. So DC has the capability of making any time period. So a very important point it is, okay. Although DC is a non-periodic signal, but it has the capability of taking any kind of time period, whether it is 0, 1, 2, 0.5, 0.6, 0.9, 0.10, anything it can take, okay. So this was also not non-periodic, this was also non-periodic. Let's see this question. For a periodic signal, x of 1 is 3, fundamental time period is 2, you need to find these values. So what did I tell you? X of t plus n t naught is equals to x of t, right? What I need to find? X of 5 I need to find. What I have? X of 1 I have. What is the fundamental time period? That is equals to 2. So x of t plus 2n is equals to x of t. Now x of 1 I am already having. So if I put t equals to 1 here, so what I can see? X of 1 plus 2n is equals to x of 1. So what is the value of x of 1? That is 3. So x of 1 plus 2n is equals to 3. And here what was n? N was any integer. So if you put n equals to 1, if I put n equals to 1, what I am getting? X of 3, that is equals to 3. Did they ask x of 3? No, they did not ask x of 3. If I put n equals to 2, what I am getting? 2 into 2, 4, 4 plus 1, 5. X of 5 is equals to 3. Yeah, that's the answer. If I put n equals to, what I need to get? N equals to minus 1 I need to get. So let's try putting n equals to minus 1. If I put n equals to minus 1, so 1 of 2 minus 1, 1 minus 2. Here I am going to put minus 1. So 1 minus 2, that would be minus 1 only. So what is the value of x of minus 1? That is also equals to 3. What is the fundamental time period? 2. So x of minus 1, then you go backward by 2. X of minus 3, then you go backward by 2. X of minus 5, then you go backward by 2. X of minus 7. Are you getting this point? The value of x of 1 you know. If I make the time axis, so here the value of t I am putting. So value of t here you already know, x of 1 is whatever that is, you already know. Then the same value you will get at 5, 3, the same value you will get at 5, the same value you will get at 7 as well. The window is 2 second, right? Window is 2 second. Same value 1, 3, 5, 7. Now the same value at -1, -3, -5, -7. In that manner you will get the same values. -3, -5, -7. So what is the value of x of -7? That would be same as x of 1, or that would be same as x of 3, that would be same as x of 5, that would be same as x of -3 as well. So value of x of -7 would be equals to 3 only. Very simple equation, right? Very straightforward. Okay, let's see more problems. Now we will see this thing. So now you need to think about it, write down the values. If I do this operation, what is this operation? Mirror image. From x of t, if I do x of -t, that means if I am taking the mirror image, will that time period change? Let's just say this is a periodic signal. This is a periodic signal like this. Is this a periodic signal? Say yes or no. Is this a periodic signal? Yes. If I do periodic signal by, let's just say this is -2, this is +2. So it is periodic by 4 seconds. If I take the mirror image, then what will happen? Nothing will happen. The periodicity will remain same. Here it was, mirror image would have been same. Let's just say here if I take that different kind of function, if I take this kind of function, if I take this kind of function, and this was your x of t, here I am calling this is your -2, this is your +2. So here what is the periodicity? 4. Periodicity is 4. This point is -2, 2. So -2 to 2, the same thing is being repeated from 2 to 6 as well, right? The same thing is being repeated. Then again the same thing will be repeated. Then again the same thing will be repeated in that manner. So time period is 4. But if I take the mirror image, then what will happen? Nothing will happen. What will be the mirror image of this particular structure? This will be the mirror image. This will be the mirror image. This will be the mirror image, right? So again the mirror image is the, like even if I am taking the mirror image, it is still being repeated after 4 seconds only. So taking the mirror image doesn't change the time period. So here also time period will be t naught. If I take the mirror image, it is again being repeated after that same time only. It is again being repeated after that same time only. Now if I shift it, basically if I shift this by t naught, x of t plus t naught, if I shift this, still it will be repeated after the certain time only, no? Just there is a shift, nothing else. Repetition remains as it is. Basically if you shift this waveform, if you shift this waveform here or here, it will again be repeated after 2 seconds only. In this example also you can see, even if I shift any waveform, it will be repeated after a certain time window only, because you need to see the time window. This window will remain same only. So here also the time period will be t naught. What if I do the scaling in time function? That means your time domain is multiplied with a. Your time domain is multiplied with a. So your time axis will be divided by a. Time axis will be divided by a. So now what is this window? From 2 by a to -2 by a. The window will become 4 by a. Window will become 4 by a. So what is the time period now? 4 by a. Previously what was the time period? 4. Now what is the time period? T naught by a. So here what I will write? T naught by mod of a. Why mod of a? Because a could be negative as well. Let's just say if a was x of -2t. So what you would have done? You would have divided by 2 and then you would have taken the mirror image. So mirror image has no impact on the time period. Only the scaling has the impact on time period, because your time axis is divided by a factor of a. So if it is divided by a factor of a, so now x of -2t, if your x of t was having a time period of t naught, then what would be the time period of x of -2t? There is no impact of this minus sign, but there is impact of this 2. So answer would be t naught by 2. But what was the value of a here? It was -2. That's why I need to take the mode. So mode of a will be +2. So t naught by mode of a. Similarly here as well, in this particular question, in which one? In this one. So similarly here as well, what will happen? X of at plus b. So how you will go? First x of t, then x of t plus b, then x of at plus b. Here what was the time period? T naught. Here what was the time period? Even if you make any shift, no issue, t naught only. But if your time domain is multiplied with the factor of a, your time axis will be divided by the factor of a. So that means the time period will also change. So it will be t naught by mod of a. Take an example. The time period of xt is t naught. What will be the time period of x of minus 2t plus 3 divided by 4? So what you can see here, x of minus t by 2 plus 3 by 4. So t naught divided by, is there an impact? Is there any impact of shift? No. Is there any impact of, this is what we are calculating. Basically, I just divided by 4. So is there any impact of this negative sign? No. What is the impact? Impact is of 1 by 2, right? Because your time domain is being multiplied with a factor of 2. That means it will be, your time axis will be divided by a factor of 2. Or you can say your time axis is multiplied with a factor of 2. So here x of t was having a time period of t naught, but x of minus 2t plus 3 divided by 4, that will have a time period of 2t naught, right? So will you be able to think these kind of things in the examination? Certainly. There you are not going to do all these kind of calculations. There you will think, okay, or neither you are going to remember this formula. Just you will think, okay, shift, that means my waveform is being shifted. No impact on time period. But if I am multiplying with the factor of, with any factor on time domain, that means 80. If I am doing 80, that means my time domain is multiplying with the factor of a. That means my time axis will be divided by a factor of a. That means my time period will also be divided by a factor of a. So t naught by mod of a. Mod of a here is 1 by 2. So t naught by 1 by 2, that would be 2 t naught. Okay, very simple. Answer this thing, x of t. Make the waveform and tell me whether it is periodic or not, and if it is periodic, then what is the time period. So you can make the waveform on your own. Very simple. This kind of waveform we will get, but why we are making only for the positive side? We should make for the negative side as well. X of t versus t. So at t equals to 0, what is the value? 0. At t equals to pi by 2, what is the value? Sin pi by 2 is 1. At t equals to pi, sin pi, what is the value of sin pi? 0. At t equals to 3 pi by 2, what is the value of sin 3 pi by 2? That is minus 1. And at 2 pi, what is the value of sin 2 pi? That is 0. So from 0 to 2 pi, whatever the waveform is there, the same waveform is being repeated. The same waveform is being repeated. Whatever the waveform is there between 0 to 2 pi, then the same waveform will be there from 0 to 4 pi as well, 4 pi to 6 pi. So what is the time period here? 2 pi. Okay. And it is being repeated this side as well. It is being repeated this side as well. In that manner, it will keep on repeating. So what is the time period? That is 2 pi. Okay. Just let me know one thing. If the function was sin t into ut, will that be periodic? Is this periodic? Sin t into ut. So this function will be multiplied with u of t. That means all these will be multiplied with 0. Sin of t into ut. What kind of waveform you will get? This kind of waveform you will get, and here everything would be 0. This kind of waveform you will get, here everything would be 0. So is this periodic? Here you will see that, sir, it is being repeated for 2 pi time. But here it is not being repeated, no? But it should repeat between minus infinity to infinity. Then only you can call it periodic. If it is not repeating from minus infinity to plus infinity, then you cannot call it periodic. So that's why it would be non-periodic. Okay? Non-periodic. Are you getting this point? So these kind of analysis you would be able to do, right? Sin t into ut, non-periodic. Sin t, it is being repeated for 2 pi time. Without even drawing the waveform, let me know what will be the time period of sin pi by 2t. You know the time period of sin t, that is 2 pi. Time period of sin t is 2 pi. What will be the time period of sin of pi by 2t? Your time domain is multiplied with the factor of 2 pi. That means your time axis will be divided by a factor of pi by 2. So what we are getting? 2 pi divided by pi by 2, that would be equals to 4. So what will be the time period of sin pi by 2t? That is equals to 4. You can draw the waveform as well. In the same manner, we will get the waveform. So I will just copy this particular waveform here. These points I need to remove. So what is the value of sine 0, 0? If I put t equals to 1, so what is the value of sine pi by 2? That is 1. If I put t equals to 2, sine pi, that is 0. If I put t equals to 3, sine 3 pi by 2, that is minus 1. If I put t equals to 4, sine 2 pi, that is equals to 0. So it is being repeated after every 4 seconds. So after every 4 seconds, the waveform is being repeated, right? So you can see the time period is 4 seconds only, but you don't need to make the waveform again and again, because you know that the time period of sine t is 2 pi. Then what will be the time period of sine pi by 2t? Pi by 2t, that would be 2 pi divided by pi by 2, because time axis is time domain is being multiplied with the factor of pi by 2. That means time axis will be divided by a factor of pi by 2. So answer will be 4. Although we will develop a formula here, no need to worry about that. Sine pi t, what will be the time period? So sine t has a time period of 2 pi. So sine pi t will have a time period of, time domain is being multiplied with the factor of pi. That means time axis will be divided by a factor of pi. So what will be the time period? Time period is 2. Right? Very simple. Sine omega naught t. So sine t had a time period of 2 pi. So what will be the time period of sine omega naught t? That would be 2 pi by, time axis is multiplied with the, time domain is being multiplied with the factor of omega. That means time axis will be divided by a factor of omega naught. So what will be the time period? That would be equals to 2 pi by omega naught. So from now onwards, what you are going to do? This omega naught is known as angular frequency. Okay, angular frequency, and this is known as time period or fundamental time period, whatever you can call it. So from now onwards, if you see any kind of function, what will be the first task? First task you will write down omega naught. What is the omega naught? That is pi by 3. So in the examination, they can ask you the angular frequency as well. What is the angular frequency of this particular function? That is pi by 3. And what is the time period? 2 pi by omega naught. You will remember this formula, 2 pi by omega naught. 2 pi by omega naught. So what is the time period? That is 6. How you would have done these kind of problems? Here what you can see, omega naught is equals to 2. What will be the time t naught? 2 pi by omega naught. That is equals to, oh sorry, omega naught is pi, really sorry. Omega naught is pi. Omega naught is pi. So 2 pi by omega naught, that is 2. Okay. So from now onwards, you will remember sine of omega naught t. Same goes for cos as well. Same goes for cos as well. Here also you will do the same thing. T naught is equals to 4, but here what you will do? Sir, omega naught is pi by 2. Sine of omega naught t. Omega naught is pi by 2. So what will be the time period? 2 pi divided by pi by 2. So time period will be 4. Now what if in the same manner you can do here as well? What is the value of omega naught? So here the value of omega naught is 1, because sine of omega naught t, omega naught value is 1. So what will be t naught? 2 pi by omega naught. That is equals to 2 pi only. So value of t naught is 2 pi. That's it. So this is how you can do. Now what if I had asked you, what is the time period of 5? Here also I could have written one more thing. For xt it is t naught. What if I multiply with the factor of, what will be the time period of a of xt? Or here also I will multiply with here only I will multiply with the factor of a. So what will be the time period of a of, what will be the time period of a into x of at plus b? So this example we took, no? These examples we took, that it is being repeated. So it is being repeated after every 4 seconds, right? If I increase the amplitude, does it make any impact in this 4 seconds? No. These 4 seconds is unchanged. If I increase the amplitude, let's just say if this amplitude was previously 2 and this amplitude was minus 2. So if I multiply with the 3, what will happen? The waveform will increase. This will go to 6, this will go to minus 6. But the time window doesn't change. This will be minus 2 only, this will be plus 2 only. So it will be 4 only. Are you getting this point? So even if you multiply with any factor, it doesn't make any impact. Say yes or no. So here also, what if I ask you, what will be the time period of 5 into sine
pi by 3 is given 3 pi by 5 t plus pi by 6. So does this pi by 6 make any impact? No, this is just a shift. Does this 5 make any impact? No, only impact will be made from here. So from here 5 sine of omega naught t plus 5, what you will read it, sine a into sine of omega naught t plus 5. 5 is pi by 6 here. So only omega naught you need to see. Your all eyes will be on omega naught. So what is the value of omega naught? 3 pi by 5. So they can ask you this angular frequency as well, or they can ask you the time period as well. 2 pi, 3 pi by 5. So what will be the answer? 10 by 3. Right? Answer will be 10 by 3. Okay. Same goes for cos as well, but let's see more example of sinusoid. What if I had asked you this question? Six sine under root 3 by 2 pi t plus pi by 2. Although you know that sine pi by 2 plus theta, that would be cos theta. Sine pi by 2 plus theta would be cos theta. But you don't need to change it to cos. Are you getting this point? Where will be your eyes? You can read it in this manner: a of sine omega naught t plus pi by 2. Right? So what is the value of omega naught? Under root 3 by 2 pi. So this they can ask, or they can ask time period. So that would be 2 pi by omega naught. Under root 3 by 2, 2 goes upward, pi gets cancelled out, 4 by under root 3. So t naught is 4 by under root 3. This is the answer of t naught. Say yes or no. Okay, in that manner you can solve. Same goes for cos function as well. What you will read it? A of cos omega naught plus 5 plus 5. 5 is 0 here, a is 1, doesn't matter, only omega naught. What is the value of omega naught? Pi. So this can also be asked, or they can directly ask t naught. What that would be? That would be 2. Right? So here fundamental angular frequency, that is omega naught, fundamental time period would be 2 pi by omega naught, and that we can denote it by t naught. Okay. What about the answer of this particular question? Let's make it better. Okay. Let's make it better. 3 cos of pi by 60 plus pi by 3. So nothing matters, only what matters? Omega naught, and omega naught is pi by 6. So what will be your t naught? 2 pi divided by pi by 6. That would be 12. So t naught will be 12. So in that manner you need to answer. Say yes or no. Right? Try doing this question on your own. You are adding a DC in this particular function, 3 sine pi by 2t, and you are adding a DC. DC is 2 volt. 2 volt, or you can say 2 unit. So try making the waveform, you will understand what is the time period. So try making the waveform on your own. How will you make the waveform? You need to add up two functions. Do you know the graph of this thing? Yes. Do you know the graph of this thing? Yes. Do you know how to add up two function? Yes. So try making the waveform and then let me know what is the time period, and we will make an interesting conclusion out of it. So I will take a pause, drink some water, then I will come back. You try doing it on your own. Yeah, welcome back. So did you try this question? So let's start solving it. So what we need to do, first we need to draw this graph, and then we need to shift this graph upward by 2, right? Because in this particular graph 2 is added, so the graph will be shifted upward by 2. So let's make this graph first. 3 sine pi by 2t. So can I make this graph? Certainly I can make this graph. Just one second. 3 sine pi by 2t plus 3 minus 3 plus 3 minus 3 on both of the sides, right? The same thing will be happening here as well. So this is your plus 3 and this is your minus 3.
This is your xt. And now I need to add this graph 2. So this 3 point will go to 5 and this minus 3 will go to minus 1, right? This will be shifted upward. 3 will go to 5, minus 3 will go to minus 1. So that will be shifted upward. So what will happen eventually? Can I draw it in this manner that I take this axis downward? What I am doing, I am taking this t axis downward. Okay. Basically, I need to shift this graph upward, or what I can do, I can take this t axis downward. So let me pause the video and I will take this as a t axis downward. Okay. Because 3 point will go to plus 5 and minus 3 will go to minus 1. So let me make the graph now. Yeah. So this is the graph you would see. So previously in the previous graph when we did not shift it, so at that time what was the gap here? Between this point to this point, what was the gap? Basically now you can see that this waveform is being repeated. If I mark it up, then you can see that this waveform is being repeated. This particular part is being repeated. So from 0 to again 0 you are reaching in this manner, then again the same part is being repeated, right? Again from here as well the same part is being repeated. In that manner this part is being repeated. From 0 you start, you reach at 0 only. From 0 you start, again you reach at 0. From 0 you start, again you reach at 0. So previously when I did not shift it by 2, what was the gap here? Between 0 to 0, what was the gap? This is your pi by 2t, right? Pi by 2t. What is the value of omega naught here? Pi by 2. So what will be your time period? That would be 4. 2 pi divided by pi by 2, that would be 4. So this gap was 4 seconds at that time. Now what happened? You only shifted the graph either upward or downward. You only shifted the graph. You did not do anything else. So still that time constant remains same only, no? Still that, sorry, not time constant really, sorry. Still your time period remains the same. You did not do anything. You just shifted the graph upward or downward. So that will not change your time period. Say yes or no. Are you getting this point? By the waveform also we can verify it. This is being upward and then downward. If you want to find this point, how much this second would be, how much this second would be, can you find out the point? Certainly I can find out. When it will be 0, so you put that equals to 0, then you find the value of t. One value will be negative, one value will be this, other value will be this, these values would be there. So you can find out these values. That we don't need to find out. As of now we need to just see that what will be the gap between this 0 and this 0. That would be 4 seconds only. Now another intuition. What is the another intuition? What is this? This is your some DC. And what is this? This is some periodic signal, right? This is some periodic signal. So now this periodic signal would be having some fundamental time period, that is t naught dash. This periodic signal would be having some fundamental time period, that is t naught dash. What is the quality of DC? DC says that I can make my time period equals to anything. What DC will say? I can make my time period equals to anything. This guy is saying that I have the time period of t naught dash. So DC will say yes, I can make my time period equals to t naught dash. So whatever the time period that you are having, the complete function will also have the same time period. So the conclusion is, in the xt, if there is some DC plus there is some signal which is periodic with t naught dash, DC plus some yt which is periodic with t naught dash, and if they ask you the time period of xt, that would be equals to t naught dash only. So in a periodic signal, if you add a DC, then time period doesn't change. You can write down this statement. Always it is true. And why it is always true? Because DC says that I can make my time period equals to anything. In the later part of this video, we will study if there is a linear combination of a periodic signal like x1t plus x2t plus x3t, then how do we find out the equivalent time period? Basically, this is your periodic signal with the time period of t1. This is your periodic signal with time period of t2. This is your periodic signal with time period of t3. Then what will be the time period of this yt? So that we are going to study. There we need to take the LCM. LCM of t1, t2, t3. We will take the LCM. Whatever the LCM that we are getting, that will be our final answer. So here, this is periodic with t naught dash. This will say that I can be periodic with t naught dash as well. So if you take the LCM of t naught dash and t naught dash, what you will get? You will get t naught dash only. Although DC is not a periodic signal, we said that DC is non-periodic signal, but still DC has the capability of making any kind of time period, and that time period added with the same time period. So linear combination of both of them will give the same time period as the output. So this is the statement that you need to remember. If you add a DC to any of the periodic signal, then the time period doesn't change. Say yes or no. A very good point. By the waveform also we satisfied. Okay. Sin pi by 2t, but mode is there. Do you know how to draw the graph of sin pi by 2t? Yes. Sin pi by 2t. This point is 0. What will be this point? What is the time period of this one? Only inside. If I talk about only sin pi by 2t, let's just say I take my yt equals to sin pi by 2t. So I have drawn the graph of sin pi by 2t, right? I have drawn the graph of sin pi by 2t. It is not the graph of mode of sin pi by 2t. So if I draw the graph of sin pi by 2t, then what will be the time period? 2 pi by omega. That would be equals to 4. So if this is 0 second, this would have been 4 second. And then this would have been 2 second. Now what I need to do, I need to take the mode. I need to draw the xt waveform. This yt I have drawn. If I need to draw the xt, what does that mean? I need to take the mode. So negative value will become positive values. Negative values will become positive values. So all these values will become positive. So what did you understand here? 0 to 2, 2 to 4, 4 to 6, 0 to minus 2, minus 2 to minus 4. So what is the repeating window? This is the repeating window. Although you supposed this time period you supposed to be 4, but since you have added a mode there, the time period became half. Now the time period is 2. So whenever there is mode, we will try to make the waveform. If we are not able to make the waveform, then how we will solve it, that also I will tell. No need to worry about that. Okay. But as of now, in sinusoid or cosinusoid, if there is mode, then time period will be half. It was 4, now it became half. So time period would become half. Okay. But if what about this cos? This also you can do. Here what you would have expected. Let's just say if I call yt as cos of pi by 60. So what would be the time period I would be expecting? T naught would be 2 pi divided by pi by 6. So time period I would be expecting to be 12. So how I will make the waveform? Right. So this point is 0 and here you become, this point will be 12. What is the repeating window? This is the repeating window, right? This is the repeating window. From 1 to again 1 you are reaching. Then from 1 to again 1 you are reaching. So this is 12, this will be 24. Similarly from 1 to again 1 you are reaching. This will be minus 12. So repeating window is 12, right? But what we need to do? We do not need to make yt. Yt is having a time period of 12, but we need to make mode of yt. Basically we need to take the mode. So if I take the mode, this part goes and this part would become positive. Okay. Right. So what do you think? What is the repeating window now? Only this much part is the repeating window. If I see, or you can see this lobe is the repeating window. This lobe is the repeating window. This lobe is being repeated. This lobe is being repeated. Here also there was a negative part that would also become positive. So this lobe is being repeated. Here also this lobe is repeated. So actually this point was 12. This point was 0. What was this point? This point was actually, what was this point? At this point, this is becoming 0. Cos pi by 60 is becoming 0. Cos pi by 60 would become 0 when pi by 60 is equals to pi by 2. Say yes or no. That means t is equals to 3. So this point was 3. Again it is becoming 0. So what would have been this point? This point would have been 9 actually. Are you getting this point? First we drew this diagram, no? First we drew this diagram. So can you let me know what will be this point? This point will be 0. Cos becomes 0 at pi by 2, right? Pi by 60 is equals to pi by 2. So what you are getting from here, t is equals to 3. So this point will be 3. What will be this point? Again it will become 1. So pi by 60 is equals to 2 pi because cos 2 pi is equals to 1. So from here you get to know that this point is 12. What about this point? So if this window is 3, then this window also has to be 3. So what will be this point? This point will be 6. So now this waveform became upward. Negative waveform became positive. So this kind of waveform we are getting. So which window is being repeated? This window 6 is being repeated. This window 6 is being repeated. This window 6 is being repeated. Say yes or no. So which window is being repeated? 6. So now what is the actual time period? Let's call this as T naught dash. So actual time period is half of that. 12 by 2, that is equals to 6. But it is not necessary that in all the functions it will be half. It is true only for the sinusoids or cosinusoid that it is becoming half. So whenever you see a cosinusoid function or sinusoid function and you see there is a mode, what you are going to do? First calculate the time period for a simple function. If there was no mode, then just make it half. Or you draw the diagram. If you draw the diagram as well, it will be very easy. Or there will be another method that I will tell you in this lecture only. And that method is easier than all this kind of method. Okay. And that method will give you correct answer as well. Always that method will give you, always it will give you correct answer. So for that you need to wait. But as of now, we are going to write down the conclusion for sinusoids and cosinusoid. So previously we saw the simple thing, 2 pi by omega naught pi by 3. These things we saw, and the conclusion was if there is omega naught, so time period will be 2 pi by omega naught. You just need to find the value of omega naught, and then you can write down the time period of sine omega naught t, that would be 2 pi by omega naught. Same goes for cos as well. Same goes for cos as well. Then we saw if I add a DC, there is no impact. If I add a DC, that doesn't make any change in the time period. The time period remains the same because DC has the capability of making its time period equals to anything. So if this guy is saying that my time period is T naught dash, then DC will say that yes, I can make my time period to be T naught dash only. So my final time period would be the same time period that I was seeing from here. Okay. Now in a pure sinusoid or cosinusoid, there is no addition of DC. In a pure sinusoid or cosinusoid, if I take the mode, then time period reduces to half. Time period reduces to half. In a pure sinusoid or cosinusoid, there could be a shift here. There could be a shift of pi by 2 or pi by 3 or pi by 4. I don't care. Basically, if your xt was, what I mean to say, if your xt was mode of cos of pi by 3t plus pi by 6, shift doesn't matter. From here, what will be the value of T naught you are getting? T naught dash, that would be 2 pi divided by pi by 3. So that we are getting 6. So what will be the actual time period of this thing? That would be 6 by 2. That is 3. But there is no addition of DC here. If the DC is added, then the scenes will be changed. If here DC is added, then the scenes will be different. So if you solve this question, 2 plus 3 sine pi by 2t. Have you seen this particular waveform? Yes. Now if you take the mode, so will it make any change in the time period? This waveform you have seen, right? 2 plus 3 sine pi by 2t. So if I take the mode here, let's copy this particular waveform. So just let me know one thing. If I take a mode, then what will happen? This part will go upward. Basically, whatever the part was downward, that would go upward. This part was downward. This will also go upward. This part was downward. This will also go upward. And here, this part also was downward. So this will also go upward. Do you really think is there any change in the time period? No. Still, this much waveform is being repeated. Still, this much waveform is being repeated. Still, this much waveform is being repeated. The same waveform is being repeated. Just the negative part became positive part. But you cannot say that, sir, this part is being repeated now. No. In the previous, what happened? There was no addition of DC here. So whatever the negative part was there, that was ditto same as positive part. The negative part and positive part were same. If you take the mode of this particular graph, where is the graph of a simple sinusoid? If you take the mode of this particular graph, then positive part is ditto same as the negative part. That's why time period reduces to half. But if there is an addition of DC, then the positive part is not same as the negative part. That means the time period remains the same. Will you be able to keep these things in the examination hall? Will you be able to keep these things in your mind? It is very rare, right? You might not be able to remember all these things, but only two conclusions are there basically. For pure sinusoid, cosinusoid, you can write down the answer, right? If I add a DC, no change because DC has the capability of making its time period equals to anything. If I take directly the mode without the addition of DC, then the time period reduces to half. But if DC is there, sinusoid is there, and then you are taking the mode, still there is no impact. Are you getting this point? So again, what will be the time period? This window will be the time period. And what was this window? That you can find out from here. So what will be your T naught? 2 pi divided by pi by 2. So that would be 4 only. So this window was 4. So your time period is 4 seconds only. Okay. Same you can do with this particular function as well. You can draw the diagram. You can draw it on your own. What you will do? You will draw the graph of minus 3 cos omega naught, minus 3 cos pi by 3t. That graph will go something like this. Right? After that, what you need to do? In that graph, you need to add 3. So this point will be minus 3. This point will be plus 3. If I add 3, that means if I shift this graph upward, so minus 3 will go to 0 and plus 3 will go to 6, right? Because I need to add 3. I need to add 3. So the graph will be going from 0 to 6. The graph will be going from 0 to 6. So how the graph will look like? This is how the graph will look like. अरे यार, right? This is 0, 0 to 6. Now you need to take the mode. Does that matter? You need to take the mode, but the mode matters or not? No, it doesn't matter. Why? Because it is always positive. There is no negative value. So there is no impact of mode. So are you getting this point here? That if I have added a DC, the mode actually will not change my time period. Are you getting this point? Although you might not be able to remember all these things in the examination hall, but by the end of the lecture, you would realize that you don't need to keep a single thing in your mind. You will be seeing the circuit, you will be seeing the given signal, and you will be able to write down the time period in the examination hall very easily. Okay, so don't take any pressure that I need to remember this conclusion or that conclusion. I will give you a simple method that how to solve the problem in the examination hall. But as of now, if we are able to write down some conclusion, and if there are some students who can remember the conclusion, then it is good for them. Okay, because in the examination hall they will be able to do the problem quicker, right? Because if you remember the conclusion, okay, DC if I add with cosinusoid, no impact. Even if I take mode, no impact on the time period. So directly time period I will find from here. What will be the time period? 2 pi divided by pi by 3, 6. So you can quickly in the examination hall, you will write down the answer is 6. Say yes or no. Okay. So from here we can see the conclusion. Whatever that I have written down for sinusoid, the same goes for cosinusoid as well. So a cos omega naught t plus pi plus phi. What will be the time period? 2 pi by omega naught. Same goes for cosinusoid as well. There is no addition of DC. Pure sinusoid is being mode. Pure sinusoid is having the mode. That means time period will be half. Time period will be half. Rest anything you do. If you add DC, no change. If you add DC, no change. If you add or subtract DC and along with that you take the mode as well, still there is no change. Still there is no change. So in pure sinusoid and cosinusoid, where is the change? Only when you take the mode. Only when you take the mode, at that time you need to care about it. Otherwise, no need to care about anything. Okay, only this point is something that is different. If you add DC and take a mode, no need to worry. But there is no DC and directly you are taking the mode, then you just need to reduce the time period to half. Because 2 pi by omega naught divided by 2, that would be pi by omega naught. Is that clear to you? Solve this question, use your brain. Use your brain here, solve this question. 2 sin A cos B. So actually, 2 sin A cos B. You wouldn't be able to solve it because I did not teach you that linear combination, right? 2 sin A cos B you will not be able to solve. So what side I should give you? Here sin A cos B is there, no? So both are in multiplication. So I cannot solve it. So I will have to multiply by 2 and divide by 2. This is the thing I need to do. Then here I need to apply that formula 2 sin A cos B. What is the formula of 2 sin A cos B? Sin A plus B plus sin A minus B. Sin A plus B plus sin A minus B. Okay, it is 2 sin A cos A actually. Yeah, it is 2 sin A cos A. So what is the formula of 2 sin A cos A? look, in the examination hall, you saw this question. You saw this question in the examination hall. You know that two sinusoid and cosinusoid both are in multiplication. That means some trigonometric formula I need to apply and make it either pure sinusoid or pure cosinusoid or combination of sinusoid and cosinusoid. Basically, there is multiplication that I cannot take. I will have the rule for addition. I will have the rule for simple sinusoid, cosinusoid as well. But for multiplication, there is no rule. So what I'm going to do, I will multiply by 2 and then divide it by 2. So what you are getting? 2 sin A cos A. What is the formula? Sin 2A. Sin 2A. So what I am getting? Half mod of, okay, so the same thing I am getting. Here what did I apply? Sin 2A is equals to 2 sin A cos A. 1 by 2 doesn't matter. Sin 2 pi by 3 into t, and then there is a mod. What did I tell you? Pure sinusoid is being mod. That means first you calculate the time period from here. T naught dash I am calling it. 2 pi divided by 2 pi by 3, that is 3. Then what will be the actual time period? Half of this. That's it. Because pure sinusoid is being mod here. So that is the answer. Okay. So if there is multiplication or anything like that, then you need to think of trigonometric formula. 2 sin A cos B sin 2A. And we will solve enough problem in this lecture only, and you will build up the habit. Okay. Just by looking at the expression, you will get to know whether I need to apply some trigonometric formula or not. So have the patience, you will certainly understand a lot of new points. So let's see a basic mathematics. Just you need to solve relationship between A and B. So cos A is equals to cos B. Is it your answer A equals to B? What is the relation between A and B? Your answer is A equals to B. No, absolutely not. Why so? Cos A is equals to cos B. This is what is given, right? Cos 2 pi plus A, what that would be equals to? Cos A. Cos 2 pi plus theta. Cos 2 pi plus theta. What is that equivalent to? Cos theta. So cos 2 pi plus A would be equals to cos A, and that would be equals to cos B. So from here what you are understanding? Cos 2 pi plus A is equals to cos B. So from here 2 pi plus A is becoming equals to B. Here A is equals to B. This is the first equation for sure. According to the second equation, 2 pi plus A is equals to B. According to the third equation, what can happen? Cos 4 pi plus A will be equals to cos A, and that would be equals to cos B. So from here what is becoming equal? 4 pi plus A will be equals to B. Or what I could have done? Cos of minus 4 pi plus A would be equals to cos of A, or minus 2 pi. Basically cos of 2n pi plus theta is equals to cos theta, considering n is an integer. Do you know this particular formula? So from here what you will get to know, that cos A is equals to cos B. So cos A can be written as 2n pi plus A would be equals to cos A, and that would be equals to cos B. So from here what you are able to understand, that A plus 2n pi is equals to B. That's the answer. Basically here cos A is equals to cos B. Let's just say I take the value of A is equals to pi. So cos pi is equals to cos pi, that's for sure. But cos 3 pi is also equals to cos pi. Cos 5 pi is also equals to cos pi. So here 3 pi and pi are not equal. 5 pi and pi are not equal. Actually the thing is pi plus 4 pi is equals to 5 pi. Or you can say 5 pi minus 4 pi is equals to pi. So if you are making two angles equal, then always you need to consider all the cases. Not only one case where A is equals to B. 2 pi plus A, 4 pi plus A, minus 2 pi plus A, minus 4 pi plus A. So basically from here what we are getting, A plus 2n pi is equals to B. Say yes or no, right? Because we will be using it somewhere, that's why I am writing down this thing. Okay. Let's see this question. Xt plus cos t square and yt is cos under root t. Both of them are periodic or not, that you need to tell. Can I draw the waveform? No, it would be very tough actually. Drawing the waveform would be very tough. So what I will do, one thing I know, that for a periodic signal,
x of t plus t naught is equals to x of t, right? So cos of t plus t naught whole square would be equals to x of t square. Do you agree to this point? xt would be equals to x of t plus t naught. So cos of t plus t naught whole square. In place of t, you need to put t plus t naught. In place of t, I am putting t plus t naught whole square would be equals to cos t square. What you are getting? Cos t square plus t naught square plus 2t t naught would be equals to cos t square. This angle and this angle are becoming equal. So what I can write down? T square plus t naught square plus 2t t naught plus 2n pi is equals to t square, where n is equals to integer. Did you understand what did I do here? Both angles are equal, so I need to add up plus 2n pi, right? I need to add up plus 2n pi. T square and t square is getting cancelled. What we are getting? T naught square plus 2t naught plus 2n pi is equals to 0. What is this? This is a quadratic equation. If you solve this quadratic equation, one thing is for sure that your t naught will be a function of t. Are you getting this point? If you solve this quadratic equation, you will certainly see that your t naught will be a function of t, because what you are going to do? T naught will be equals to minus b plus minus under root b square minus 4ac, that would be 8n pi divided by 2a. So certainly it has to be a function of t. T naught is coming out to be a function of t. Is it possible? Not possible, right? Because in the first slide, what did I tell you? In the very first slide of a periodic signal, what did I tell you? That your t naught can never be a function of t. It can never be a function of t, but it is coming out to be a function of t. That means it is non-periodic. Although this much maths is not required in the examination, you just try to understand. If I put t equals to 0, this is the graph of, this is the axis of t and this is the xt. If I put t equals to 0, cos 0 will be 1. If I put t equals to under root pi by 2, if I put t equals to under root pi by 2, so at under root pi by 2, what I will be getting? Cos t square, that means under root pi by 2 square. So cos pi by 2, what that would be? 0. The next would be under root pi, so that would be minus 1. In that manner I will go. So all these points will be in terms of under root, right? All these points will be in terms of under root. What will be this point? This point will be under root 2 pi, because cos 2 pi would be 1, so under root 2 pi. The next points will also be the same. In that manner it will go. So this gap is under root 2 pi, but after that the gap would be different. Under root 2 pi minus 0. This gap is under root 2 pi minus 0. Now again when I will be getting 1, I will be getting at cos 4 pi. That means the next point here would have been under root 4 pi. Here this point would have been under root 4 pi. Are you getting this point? If I make the waveform, if I make the cosinusoid waveform, so this point would have been under root 4 pi. Why is that so? Because cos of under root 4 pi square, that means cos of 4 pi. Cos of 4 pi will be 1. So what will be the gap here? The gap will be under root 4 pi minus under root 2 pi. So is that equals to under root 2 pi? Absolutely not. This is your under root 2 pi. What is this? Under root 4 pi, that is 2 under root pi minus under root 2 under root pi. So that would be 2 minus under root 2 into under root pi. So now this gap and this gap is not the same. Are you getting this point? The waveform is not being repeated after a certain window, right? Or you can do this analysis, or very, very easily you can think that waveform will not be repeated after a certain window, right? Very easily you will be able to think it. The values will be repeating. Basically, cos t square will be between minus 1 to 1 only. It will be between minus 1 to 1. There is no doubt about that. But will the values will be repeating after a certain window, like these kind of functions? Like value will be repeating after a certain window. Values are repeating after a certain window. But will that happen here? No. Values will be repeating, but not after a certain window. First it is being repeated with under root 2 pi. Here it is being repeated with this value. Same goes for cos of under root t as well. You can try with cos of under root t as well. It will also be non-periodic. Okay? It will also be non-periodic. This will also be non-periodic. This will also be non-periodic. The same kind of analysis that I have done,
t plus t naught is equals to xt, then you write down this equation, then you see that t naught will also be coming out to be a function of t, which is not possible. That means it is also non-periodic, this is also non-periodic. So what is the conclusion here? The conclusion is a naught cos omega naught, if this t is a function, if t is having any power, the power could be anything, or here I will write down power could be anything, alpha power is there, okay, or cos of, same goes for sine as well, if it is having any beta power, any value of alpha and beta is there. If t is not linear, that means if t is having any power, that means both of them will be non-periodic, because I know that if I put t plus t here, if I put t plus t naught here, and the power of alpha if I do, then there will be t naught will be a function of t, and if it is a function of t, it can never be periodic. Is that clear to you? Okay, so cos of t square, cos of under root t, if these kind of examples you see in the examination hall, directly blindly you can say that sir it will be non-periodic. Say yes or no. Okay, so this is kind of conclusion. Although you should not be remembering all these kind of things, you can think all these kind of things in the examination hall as well, like this much aptitude you should have, right? In the examination hall, this much aptitude you should have, that if I see these kind of functions, it should click to my mind that okay, it cannot be periodic. So this is also not periodic. Sin t plus ut, try doing it. Sin t plus ut, what will be the graph of sin t plus ut? What is the graph of sin t? That I already know. So you just need to think, nothing else. There is no formula. Only one thing is that sine of omega naught t. So omega naught is the angular frequency, time period will be 2 pi by omega naught. So only this thing, till now this thing only you should keep in mind. Rest all you will be able to think in the examination hall itself, right? So sin t, this is the graph of sin t. Value is between plus 1 to minus 1. And ut is being added. Ut, what is the graph of ut? This is the graph of ut. So this part is added with 0. This part is added with 0 and this part is added with 1. So this part will be shifting upward, this part will remain there as it is. Are you getting this point? Are you getting this point or not? So how will be that final waveform will be looking like? Here suddenly it will be shifted upward. This part is shifted upward. This part will go somewhat like this. Right? And the negative part is added with 0, so that will remain there as it is. Okay, so DJ has started by the dogs. मिडनाइट पे पता नहीं यार इनको क्या हो जाता है, लड़ने लग जाते हैं ये, दूसरे मोहल्ले के लोग आते हैं आपस में लड़ने लग जाते हैं ये लोग, पता नहीं क्यों. So yeah, this point would be 1, this point would be 2, and this point would be 0. So is this periodic? Absolutely no. By the waveform also you can see, sir, this part and this part is completely different. So same part is not being repeated, so this is not periodic, right? This is your waveform of xt. This is non-periodic. Okay. So what is this function? Periodic. What is this function? Non-periodic. So here what did you see? Periodic plus non-periodic will always be non-periodic unless it is a DC. Because what we saw, 2 plus sine omega naught t plus phi, it was periodic. This was non-periodic. This was periodic. So in a lot of textbook as well, I have seen people saying that non-periodic plus periodic will always be non-periodic. Why? This is periodic, no? This is non-periodic, 2 is non-periodic, and this is periodic. So what is the total answer? Non-periodic? No, it is being periodic. So the statement that periodic plus non-periodic will give you non-periodic, that is wrong. Periodic plus non-periodic will give you non-periodic unless your non-periodic is a DC. If your non-periodic is a DC, then DC has the capability of taking any kind of time period, and if it can take any kind of time period, then it will make this function as periodic. But if it is not a DC, ut is not a DC, right? DC means always it will be a same value. But ut, what does ut say? That for few time I will be 0, then after that I will be 1. For t less than 0, I am 0. For t greater than 0, I am 1. So this is what ut says. So ut is not a dc. Dc means it is always 1. So that ut is not there. So periodic plus non-periodic will give you non-periodic unless non-periodic is a dc, because dc has the capability of making any time period equals to its time period. dc can take any kind of time period. So the function is non-periodic. So there is no meaning of time period here, right? Okay. Sir, what will be periodic plus periodic? You cannot comment. What, sir, what will be non-periodic plus non-periodic? That will certainly be non-periodic. That will certainly be non-periodic. Why so? Let's take an example. ut plus rt. ut plus rt. What kind of waveform you will get? ut plus rt. For t less than 0, anything is 0. Then here there would be a jump and slope will be 1. So this is how the ut of ut plus rt waveform would be there with the slope of 1. This is your xt, right? So is this periodic? Absolutely not. What was this? This was also non-periodic. This was also non-periodic. So what you are getting? Non-periodic only. So non-periodic plus non-periodic will certainly be periodic. Okay. Periodic plus non-periodic will be non-periodic unless it is a DC. Now coming out to the point, what will be periodic plus periodic? So that we will see. You need to hold on here. Periodic plus periodic could be anything. You cannot comment. Okay. Periodic plus periodic could be anything. You cannot comment. So that we will see in this lecture only. Okay. Try finding the value of time period for cos square t, then find it for sin square t. Yeah, and after that we need to see some LCM, HCF, these kind of basic things, and then we will see the linear combination of periodic signal. So this particular part is very important. So this part is very, very important. So first try finding the time period of cos square t and sin square t. So think how you are going to do it. Okay, I will take a pause. You can also take a pause if you want to, and then we will see how to find the time period of rest of the things. Okay. Yeah, so did you try solving it? Cos square t. Have you seen any formula for cos square t? No, right? We have seen the formula of sin omega naught t, cos omega naught t. But if there is square, we did not see any formula. Square, we did not see any formula. That means I need to apply some sinusoid or cosinusoid trigonometric formula. Are you getting this point? We have the formula of cos 2t. What is the formula? Cos 2t would be equals to 2 cos square t minus 1, and that would be equals to 1 minus 2 sin square t. Sir, how it will click in the examination hall? There is only one formula for sin square t, there is only one formula for cos square t. Whenever you see cos square t or sin square t in the examination hall, always you need to apply this formula. So cos square t can be reduced as 1 plus cos 2t divided by 2. So what that will be equivalent to? 1 by 2 plus 1 by 2 cos 2t. Will that make any change in time period? No. Will this make any change in time period? No. What you need to see? Only these two you need to see. So from here what I am getting to know, that my omega naught value is 2. So what will be my t naught? 2 pi by 2. So that would be equals to pi. So t naught value is equals to pi. That's it. This is the answer. Same you can do for this thing as well. What will be your sin square t? So 1 minus cos 2t by 2. So 1 by 2 minus 1 by 2 cos 2t. Will that make any change here? No. Will that make any change here? No. So from here what do you see? Omega naught is equals to 2. So what will be your t naught? 2 pi by omega naught. That would be equals to pi. That's it. So always you need to make the function to be linear. If it is coming out to be non-linear, try making it linear. Are you getting this point? What if there was power 4? What if there was power 4? So shall I write it down? Do I have another page or I have already written it down? No. So what if there was power 4? What you would have done? My question is, okay, for power 4, later on we can see it. Cos to the power 4t. Later on we will see it because there will be a linear combination of a lot of functions. Basically what I would do, first I will apply this formula divided by 2. Then another square I will do. Then I will open this square. So when I open this square, there will be another power of 2 will be coming. Because 1 square plus cos square 2t plus 2 cos 2t. So this will be again opened. Then again I will have to see there will be a linear combination of a different trigonometric function. So that we can see in the further part of this video. Okay. So question is xt equals to cos to the power 4t. What will be the time period of that particular function? So that we can see in the other part of this video only. Okay. So we are moving towards the other part only. We need to see the linear combination of periodic signal, but let's see a basic aptitude problem. I hope you know it. You need to take the LCM of 3 by 4, 7 by 8, 21 by 10. What you will do? If I need to take the LCM of P by Q, P by Q, P by Q. So what I will do? I will take the LCM of 3, 7, 21 divided by HCF of 4, 8 and 10. So what will be the LCM of 3, 7, 21? What will be the LCM? What is the LCM? Least value which can be divided by 3, 7 and 21. That is 21 only. 21 is completely divided by 7 as well. It is divided by 3 as well, and certainly it is divided by 21 as well. What will be the HCF of 4, 8, 10? The least value which can divide 4, 8 and 10. Sorry, the highest value which can divide 4, 8 and 10. So 2 can divide 4. 8 can 2 can divide 8 as well, and 2 can divide 5 as well, right? 4 can divide 4, 4 can divide 8 as well, but 4 cannot divide 10. That means HCF would be 2. So answer would be 10.5. If I need to calculate the HCF of P by Q, P by Q, P by Q. So HCF of 6, 9, 18 divided by LCM of 4, 8 and 10. This is what I need to do. HCF of 6, 9 and 18. So 6 can divide 6, 6 can divide 18 as well, but 6 cannot divide 9. So 3 can divide 6, 3 can divide 9, 3 can divide 18 as well. 3 divided by LCM of 4, 8 and 10. The least number which can be divided by 4, 8 and 10. What that number would be? 10 is divided by 4, no. Then we can go to 20. 20 is also not divided by 8. Then 30, 40. Yeah, 40. 40 can be divided by 4 as well. It can be divided by 8 as well. And it can be divided by 30 as well. So 3 by 40. So this is what we do. HCF, then HCF of upper side, then denominator will be given to the LCM. Here LCM of numerator divided by HCF of denominator. So this is how we solve it. This is the answer 3 by 40. What all are the rational number? Can you give me the example? 2 by 3, 4 by 6. That would be 2 by 3 only actually. 2 by 3, 5 by 7, 2, minus 1, minus 3 by 7, 0. All these are rational number. Can you give me the example of irrational number? Under root 2, under root 3, pi, under root pi, or you can say 2 by pi. Whenever you see pi, that would be irrational number, right? Or you can say pi by 2, or you can say under root 2 by pi. All these are irrational number. So under root and pi, if you see, that would be irrational. Under root 4 is a rational or irrational? Because under root 4 is equals to 2 only, so that is a rational number, right? But under root 6, that is irrational number. These are the example of rational and irrational. Why we are doing all these things? Why we are suddenly studying aptitude? Because it will be used here. So I am saying that x1t is a periodic signal with the time period of t1. x2t is a periodic signal with the time period of t2, and x3t is the periodic signal with the time period of t3. Then what will be the time period of this t? What will be the time period of this xt? That would be t. So how do I find this t? That I need to see. Okay. So first point I will do, I will find out t1, t2 and t3. Okay. Then what I'm gonna do is that this is having t1, this is having t1, this is having t2, and this is having t3. So I will take the ratio of t1 to t2, t2 to t3, and t1 to t3. What I'm gonna do? T1 divided by t2 I can do, or I can do t2 by t1. Along with that, I need to see t2 by t3, or I can do t3 by t2. Also, I need to see t1 by t3, or I can do t3 by t1. All these should be coming. What will happen? All these ratios could be either coming rational or irrational. Basically, any of the ratio is irrational. If any of these ratios is irrational, then it will be non-periodic. If all these are rational, then only it will be periodic. Basically, let's just say this is rational, this is also rational, and this is irrational, then it will be non-periodic only. So first you calculate the time period, then you see the ratios should be rational. So here, instead of writing irrational, I will only write that ratio should be rational. All ratios should be rational.
all ratios should be rational, and if they are rational, then it will be periodic. And if it is periodic, then how will you find the value of t? So simply the t will be LCM of t1, t2 and t3. There you go. Okay, what it would be? It would be the LCM of t1, t2 and t3. So basically I need to find the time period, then I just need to take the LCM. While taking the LCM, I need to consider one thing in mind, that t1 ratio t2, t2 ratio t3 and t1 ratio t3 all should be the rational number. Let's see the examples. xt is given. Can I find out the time period from here? What will be the time period of, let's call it t1. That would be 2 pi divided by pi by 2, because omega naught value is pi by 2. So 2 pi by omega naught, so that would be 4. What is my t2? 2 pi divided by pi by 3. So that would be equals to 6. And what would be my t3? 2 pi divided by pi by 6. That would be equals to 12. So what will be my time period? What is the next thing? I need to see the ratio. So 4 by 6, ratio is coming out to be 2 by 3. 6 by 12, ratio is coming out to be 1 by 2. 4 by 12, ratio is coming out to be 1 by 3. Rational number, rational number, rational number. All are rational. If all are rational, it is your periodic signal. So if it is periodic, then you need to take the LCM of 4, 6 and 12. The least number which is divided by 4 as well, 6 as well and 12 as well. What is that number? 12. So what is the time period? You can call it T naught or T, whatever you can call it. So xt has a time period of 12. Xt has a time period of 12. Okay. And if they ask you the angular frequency, what that would be? 2 pi by 12. 2 pi by 12, that would be equals to pi by 6. Okay. So that would be your angular frequency. For finding this angular frequency, there is another way. What is that way? What is the angular frequency omega 1 here? Pi by 2. What is omega 2? Pi by 3. And what is omega 3? Pi by 6. Right? Pi by 2, pi by 3, pi by 6. Let's take another page. So omega 1, pi by 2, pi by 3, pi by 6. Pi by 2, omega 2, pi by 3, omega 3, pi by 6. You take the ratio omega 1 divided by omega 2. It would certainly be rational. Say yes or no. You can check as well. Omega 1 divided by omega 2. So pi by 2 is divided by pi by 3. So what is coming out to be 3 by 2? Rational only. So all these ratios will be rational. Right? Omega 2 divided by omega 3 and omega 1 divided by omega 3. All these will be rational. Say yes or no. And if all these are rational, what is the meaning of that? That means it is periodic. And if it is periodic, then for time constant we did the LCM. For time constant we did the LCM. But for omega naught, we will take the HCF. HCF of pi by 2, pi by 3 and pi by 6. So since it is in the form of p by q, so HCF of pi, pi and pi divided by LCM of 2, 3 and 6. What is the HCF of pi, pi, pi? The highest number which will be divided by pi, pi and pi. LCM. Sorry, the highest number which will be dividing pi, pi and pi. That would be pi only. What is the meaning of LCM? The least number which can divide 2, 3 and 6. The least number, okay, I am saying opposite, sorry. LCM, least common multiple. So that least number which will be divided by 2, 3 and 6. So what is that number? That is 6 only. So what is the answer? Pi by 6. Here did I do anything wrong? HCF, LCM. Yeah, so here it would be 40 only. The least number which is divided by 4, 8 and 10. The least number which is divided. Yeah, okay, this was HCF, this was LCM. So the least number, okay, HCF, the least number which, highest number which can divide. Highest number which can divide. Yeah, the least number which can be divided by 4, 8 and 10. Okay. Yeah, so it's all fine. So omega naught is coming out to be pi by 6. So from here, omega naught is pi by 6. So if I know the omega naught, from here I can get the value of t naught as well. That would be 2 pi divided by pi by 6. That would be equals to 12. So two ways are there. For t naught, you will always calculate LCM. For omega naught, you will always calculate HCF. Can you keep this thing in your mind? T naught LCM, omega naught HCF. We will see more examples. Solve this one. What is the value of omega naught here? 2. What is the value of t naught? 2 pi by omega naught. That would be pi. What is the value of omega naught here? Pi by 2. What is the value of, let's call it t1, not t, omega 1, omega 2. Let's call it omega 1, let's call it omega 2, this call it t1, this will be 2, t2. So 2 pi divided by pi by 2, that would be 4. And let's call it omega 3, that is 2 pi. So what will be the value of t3? 2 pi divided by 2 pi, that would be 1. Calculate the ratio. Sir, you will say that, sir, I calculate the ratio of t2 divided by t3. What that is coming out to be 4. It is rational. But what if I calculate the ratio of t1 divided by t2? Pi by 4. Is it rational? No. What is this? Irrational. And if there is any single relation which is irrational, what does that mean? It would be non-periodic. Right? Here you are getting the ratio to be pi by 4, which is irrational. That means it is non-periodic. Try this one as well. What will be the value of omega 1? That is 2 pi. That means what will be the value of t1? 2 pi by omega 1. That would be 1. What is the value of omega 1 here? Under root 2 pi. What will be the value of t1? 2 pi by under 2 pi divided by under root 2 pi. What that would be? Under root 2. What is the value of t1 here? Pi. Sorry. Omega 1 is pi. Omega 1 here is pi. So what will be the value of omega 3? Sorry. This is omega 2. This is your t2. Omega 1 was 2 pi, t1 was 1. Omega 2 was under root 2 pi. So t2 was 2 pi by under root 2 pi. That would be under root 2. Omega 3 is pi. So what will be the value of t3? That would be 2 pi by pi. That would be 2. So t1 is 1, t2 is under root 2 and t3 is 2. Take the ratio t3 divided by t2. What you will get? 2 divided by under root 2. What you are getting? Under root 2. What is this? Irrational. And what is the meaning of irrational? That means it is non-periodic. Say yes or no. This is the answer. Okay. Non-periodic. Irrational means it is non-periodic. Under root 2 we are getting here. So any ratio you can take. This ratio also you can take. T2 by T1 you will take. What you are getting? Under root 2. Irrational. T1 by T2 also you could have done. 1 by under root 2. Again irrational. That means it is non-periodic. Say yes or no. Okay. So in that manner you can see that if your ratio is coming out to be irrational, that means it is non-periodic. Find out the answer of this one. What will be the time period? Xt is equals to mode of sin t plus mode of cos t. Mode of sin t. What is the time period? Mode of sin t. You know that, sir, time period for sin t was 2 pi, right? But since there is a mode, at a pure sinusoid there is a mode. So 2 pi by pi, this time period would be pi. Are you getting this point? Sin t time period was 2 pi, right? Because omega value is 1. So what will be the time period? 2 pi by 1, 2 pi. But there is a mode, so time period would be pi, right? Here 2 pi divided by 2. What you are getting? Pi. Here also pi, here also pi. So what I need to do? LCM of pi and pi. What I will get? Pi. Here the time period was pi, here the time period was pi. LCM of pi and pi. What I need to calculate? T I need to calculate. LCM of pi and pi, I am getting answer to be pi. This I will click, this is wrong. In the examination hall, it will be wrong. The answer of pi is wrong. Why is that so? Because there is mode. Whenever there is mode in the examination hall, you should keep your full concentration there. This was a linear combination, there was no mode. If there is no mode, then whatever the formula that you have studied, these kind of concepts that you have studied, everything will be working. I can take more example for you. Okay, let's take another example for you because you might be confused. Let's take another example. Xt equals to sine 3 pi by 2t plus cos 3 pi by 4t plus sin pi by 2t. Okay, so if I see here, what will be the time period here? 2 pi divided by 3 pi by 2, 4 by 3. What about this one? 2 pi divided by 3 pi by 4, that would be 8 by 3. And what about this one? That would be 4. So I need to take the LCM. 4 by 3, 8 by 3 and 4 by 1. So what will be the time period here? If I am saying the time period is t naught. So LCM of 4, 8 and 4. What will be the LCM? LCM of 4, 8 and 4. The least number which is divided by 4, 8 and 4, that is 8. HCF of 3, 3, 1. The least number which can divide 3, 3 and 1. Sorry, the highest number which can divide 3, 3 and 1. So what is the highest number which can divide 3, 3 and 1? That is 1 only. Because 1 can divide 3, 1 can divide 3, 1 can divide 1 as well. 2 cannot divide 3, 3 can divide 3, 3 can divide 3, but 3 cannot divide 1. So what is the value of t naught? T naught is 8. From here, if I find the value of omega naught, that would be 2 pi by 8 and would be equals to pi by 4. So this is the answer. All these formulas are working everywhere. No need to worry about that. Okay, for this question as well, this formula is working. Answer is 8, no doubt about that. But whenever there is a mode in the examination hall, answer would be wrong. So whenever there is a mode, I have written down one line. If modulus is present in the question, then go by the options. Sir, what if options are not mentioned? Sir, what if options are not mentioned? Then you find the time period, whatever the method you know. I know this method. My time period is pi. So this I am pretty sure that at least my time period would be lesser than pi. What I am saying, if options are not mentioned, let's just say in the examination hall options are not mentioned. So whatever the method that I know, I will find out the time period with that method. Answer is coming out to be pi. This I am pretty sure that this xt will be periodic with pi for sure. But it can be periodic with pi by 2 as well. It can be periodic with pi by 4 as well. What I mean to say is that if I say that my t naught is 2, then your function, if I say my t naught is 2, that means x of t plus 2 will be equals to xt. X of t plus 4 will also be equals to xt. That means if I say my t naught is 2, that means if my fundamental time period is 2, so now the function will be repeating after 4 seconds as well, 6 seconds as well, 8 seconds as well, 10 seconds as well. That means my function will be repeating after every 2 seconds. So if I am saying that at least my time period is pi, so it might happen that your function is repeating after pi by 2, or it might happen that your function is repeating after pi by 4, or it might happen that your function is repeating after pi by 6. Are you able to understand this point? What I am saying? If I am saying my function is repeating after 6, my function is repeating after 6 seconds, but I am not saying that 6 seconds is the least value. So what should come into your mind? That less than 6 other values are also possible after which the function is repeating. Say yes or no. Less than 6, here I am getting the value to be pi. So less than pi as well, there are other options possible where the values would be repeating. Say yes or no. Are you able to understand this point? At pi, after every pi seconds, the waveform will be repeating for sure. But less than pi also, there are some options available for which the waveform can repeat. So if I go by the options, I can see only one option. So I need to verify after pi by 2 if my function is repeating or not. There is 99.99% chances are there that if they are asking the question on time period, they will certainly mention the options. 99.99% chances are there that if they are asking about time period, they will mention the option. But in this 0.01%, if options are not mentioned, then you need to go by hit and trial. If I see this question, I get my time period to be pi, then I will see that there are mode. So I will think, okay, there is a mode, so my method may fail here. If my method is failing here, what I need to do? I need to go by hit and trial. So what should be the value of less than pi which can repeat this particular signal? Certainly what should come into your mind, that is pi by 2. So I will check at pi by 2, right? There the thing would be hit and trial only if options are not mentioned, but certainly options would be mentioned. So if I am always getting the answer to be pi here, then I don't even need to check these values, because signal is certainly repeating after pi. So it will certainly repeat after 2 pi as well. So I don't need to check the values which is higher, I just need to check the value which is lower. So if I say my function is periodic with pi by 2, so what I will do? Sine of t plus pi by 2.
plus mode of cos t plus pi by 2. What is sin t plus pi by 2? That is cos t. Plus what is cos t plus pi by 2? That is minus sin t. Since there is mode, so this mode can eat up the negative sign. So what we are getting? That is equals to mode of cos t plus mode of sin t. And what that is equivalent to? That is equivalent to xt. So here what did you see? That this is the case here. And what does that mean? That means that here the time period is pi by 2. Say yes or no. So actual answer is this. This answer is wrong. So this is the best possible way, and in the examination hall, if they are asking the question on time period, they will certainly ask with the mode only. Okay, if they want to frame a good question on time period, they will give the mode there. So whenever in the examination hall, if you are sitting and you see in the question there is mode and they are asking you about the time period, always you need to be aware there that I will go by the options. And if options are not mentioned, then I will have to go by hit and trial. And how I will intelligently cancel out the options? That first I will find out my time period with the method that I know. The method is find the time period here, find the time period here, then take the LCM. So by the method I am getting pi. That means certainly after pi the waveform is being repeated. But less than pi as well, there are some possible options where the waveform might be repeated. So less than pi I will see the options. Only one option is there, so I need to check at pi by 2. I got to know that yeah, it is being repeated. This year only the question was asked and a lot of educators did that wrong. This question was asked. Where is this question? This question was asked. Where is that? I have written it. Okay, we will see later on. Yeah, this question was asked this year. And I don't know why everyone got it wrong. Some people were solving it with trigonometric and all these kind of things. Like bigger solution they were giving. 2 pages, 3 pages, and still they are getting it wrong. But you need to go by the options. Okay. So we will certainly check these questions. But first let's get started with this question now. So whatever that is mentioned, if modulus is mentioned, always go by the options. So xt is equals to sine of mode of t. Is it periodic? This time where is the mode? Mode is not here. Mode is there with respect to t. So what is my function? Sine of mode of t. So if your t is greater than 0 and if your t is less than 0. If your t is greater than 0, then how it will be opening? It will be opening as sine t. Do you know the property of mode x? Do you know the property of mode x? How mode x opens? If x is greater than 0, it will open as x. If x is less than 0, it will open as minus x. Basically, let's just say value of x is minus 5. So it will open as minus of minus 5. So value will be 5 only. Mode of minus 5 is equal to 5 only. That I already know. Mode of minus 5 is equal to 5 only. So if x is less than 0, then it will open as minus of x is less than 0. What is the value of x here? Minus 5. So it will be equal to 5 only. Right? So for t less than 0, how the mode will be opening? Sine of minus t. And what is the value of sine of minus t? That can be equivalent to minus of sine t. Minus of sine t. So for t greater than 0, whatever the graph of sinusoid you see, that same graph you need to draw. For t greater than 0, whatever the graph of sinusoid you see, the same graph you need to draw. But for t less than 0, this was your sine t. But you don't need to draw sine t. You need to draw the minus of sine t. So minus 1 will become plus 1, plus 1 will become minus 1. So this is how the graph should go. This is how the graph should go. Is it periodic? No. This waveform is not being repeated, right? Here everything was going fine. Okay, this much waveform was repeated. But what happened here? This is not being repeated, no? Are you getting this point? If the waveform was like this, that it was going like this, or here also it was going like this, then you would say that yes sir, it is periodic, it is being repeated. But here you started from 0 to 0 you are going. Then it, like, if you see this point, what I mean to say is that from minus 1 to 1 it is going. Then from 1 to minus 1 it was going, but it is actually going from 1 to 0 only and then again rising up. Are you getting this point? Here what is happening? From 1 to minus 1, then from minus 1 to 1. 1 to minus 1, then minus 1 to 1. Then again 1 to minus 1 it should have gone, but it has gone till 1 to 0 only. Are you getting this point? 1 to minus 1, minus 1 to 1. It should have gone from 1 to minus 1 only, but it is going till 0 only. From 1 to 0 only it is going, then from 0 to 1 it is going. Are you getting this point? Say yes or no. Right? So this is not a periodic, non-periodic. So whenever this kind of function is coming in the examination hall, you need to try drawing the waveform. Okay, mostly you will be able to draw the waveform. If you are not able to draw the waveform, then go by the options. At least here I am able to draw the waveform. This function is non-periodic. So don't worry, in the examination hall they will not ask any kind of functions where you cannot even draw the waveform. If you study mathematics, after the mathematics you will be able to draw any kind of waveform that you see. Okay, so you can draw the waveform xt versus t. xt versus t. Cos of mod of t. Think about it. Cos of mod of t. Think about it. You can do it. Again, I will open it. Cos of mod of t. So how it will be opened? For t greater than 0, cos of t. For t less than 0, cos of minus t. Right? And what is this? Cos t only. Cos can eat up the negative sign. No, cos of minus t is equal to cos of t only. So here what did you understand? That cos of mod of t, for t greater than 0 also it is cos t, and for t less than 0 also it is cos t. So this cos of mod t is actually cos t only. There is no meaning of mod. For t greater than 0 as well you need to draw the graph of cos. For t less than 0 as well you need to draw the graph of cos only. For t greater than 0 and for t less than 0. So graph will not change. It will go like this. Say yes or no. So it is the graph of cos only. Is it periodic? Yes. What is the value of omega naught here? From here if you see, what is the value of omega naught? 1. What is the value of t naught? That is 2 pi by omega naught. So what is the time period? 2 pi. Same option, same question. So time period is 2 pi. Answer. And here answer was non-periodic. Here answer is 2 pi. So always if mode is mentioned, first open it up. The mode is mentioned with t, right? Mode is mentioned with respect to t, not with the complete waveform. If it was mentioned with the complete waveform, you already know that inside I will get the time period and then I will take the mode. Like this kind of question. Have you seen it? Have you seen this kind of question? What did I say? There is a sinusoid which is being added with DC. If it is being added with DC, then there will be no change. No change in the time period. So what you will do? Omega naught is equals to pi by 2. So t naught will be equals to 2 pi divided by pi by 2. So answer would be 4. But in the examination hall, I might be curious that what if the answer is less than 4 as well. So certainly I am saying that after 4 the waveform is being repeated. So do I need to check at 3? My point is I am getting the answer to be 4. I just saw here omega naught value is pi by 2. Then I am thinking that at least after 4 my waveform will be repeated. That means at least after 4 seconds my waveform will be repeated. Do I need to check at 3? That means will I do this thing? X of t plus 3. No. Why is that so? Because if it is being repeated after 4 seconds, then it cannot be repeating after 3 seconds. Because if it is being repeated after 3 seconds, then the next possible option would be that it can repeat after 6 seconds. It can repeat after 9 seconds. Basically, after every 3 seconds it will repeat, no? Or it can repeat after 12 seconds. Are you getting this point? If I am saying that my waveform is certainly being repeated after 4 seconds, my waveform is certainly being repeated after 4 seconds, then the next possible option would be 2 seconds, or it could be 1 second as well. That your waveform will repeat after every 1 second. Your waveform will repeat after every 1 second. It will repeat after 2 seconds as well, 3 seconds as well, 4 seconds as well. So yeah, 4 we are getting. If it is repeating after every 2 seconds, that means if my fundamental time period is 2, then other time period would be 2, 4, then it can repeat after 6, 8. So I do not even need to check 3. I will check 2. Right? I will check 2. So what I'm gonna do? X of t plus 2. X of t plus 2. So t minus 3 sine pi by 2
sine pi by 2 t plus 2. 2 minus 3 sine pi by 2t plus pi. What is the value of sine pi plus theta? Sine pi by 2t plus pi. Sine pi plus theta, that is minus sine theta. So what you are getting? 2 plus 3 sine pi by 2t. Is this equivalent to xt? No. This is not equivalent to xt, right? Here you are getting 2 plus 3 sine pi by 2t. Here it was minus sine. So it is not equivalent to xt. That means this is not equals to your fundamental time period. So this is the correct answer. Now you are saying that, sir, why you did not check at 1? So just let me know one thing. If after every 2 seconds your waveform is not being repeated, then can it repeat after 1 second? If I say that waveform is repeating after 1 second, then certainly it has to repeat after 2 seconds, certainly it has to repeat after 3 seconds as well, and certainly it has to repeat after 4 seconds as well. So if 1 second is possible, if 2 seconds is not possible, if 2 seconds is not possible, then there is no chance that 1 second would be possible. Are you getting this point or not? Say yes or no. Right? So first I checked that 4, then I saw that 2 as well. Or if you don't need to think all these things in the examination, then check at all the options. Check at 1 as well, 2 as well, 3 as well, or 4 as well. And if you remember the things, what did I tell you? With respect to sinusoid, I told you, if pure sinusoid is having a mode, then only you need to reduce the time period by half. If DC is added, even if there is mode or no mode, still the time period would be 2 pi by omega naught only. This I have already told you. If DC is added, even if there is mode or no mode, still the time period would be 2 pi by omega naught only. So if you are able to remember this thing, then in the examination hall directly you will be putting the answer to be 4. But if you are not confident enough, then you can check the options as well. But there is 100% chances, or you are 100% sure that at least I am not gonna mess up the problem of time period. At least my time period problem will be solved correctly in the examination hall. And I have seen a lot of students messing up in this particular topic because they try to remember methods. Okay, only one method is there. Calculate the LCM. Sorry, calculate the T1, T2, T3 if linear combination is there, and then you take the LCM. That's it. That is the only method, nothing else. Okay. What about this one? Mode of cos t plus 30 degree. What is the value of omega naught here? Omega naught is 1. What will be the t naught? 2 pi. But is this correct? No. Here pure cosinusoid is having the mode. That means my t naught would be 2 pi by 2. Answer would be pi. In the examination hall, I will see, okay, I am getting 2 pi. So lesser option I will check. 3 pi by 2, pi I will check, pi by 2 I will check. And then I will get to know that pi is being the correct answer. And you can check here as well that x of t plus pi. X of t plus pi. What that would be? Cos of t plus pi plus 30 degree. So what is cos pi plus theta? That is minus cos theta. Cos pi plus theta, that is minus cos theta, but there is a mode, right? That is minus of cos of t plus 30 degree. But since there is a mode, so that mode will be gone because the mode can eat up the negative sign. So if mode is eating up the negative sign, so what you are left with? T plus 30 degree, and which is equivalent to xt only. That means pi is the time period. Okay, pi is the time period of this function. Well and good. Let's see this question. What is the time period? What you are going to do? Here I did not give the option. So try doing it on your own. I will pause the video, drink some water. You try doing it on your own. No options are mentioned. Is there any method? No method is there. There is no method, nothing. Here your pure intuition should work. What you will do? What did I tell you? First we will find out the worst case time period. What will be the worst case time period? Here what is the value of omega 1? That is 2. What is the value of omega 2? That is 1. What is the ratio? 2. So that means it is rational. Certainly it will be periodic. Here what is the value of t1? That would be 2 pi by 2 pi. And what is the value of t2? That is 2 pi. So what will be your t? T naught dash I am saying. So LCM of pi and 2 pi. Right? And what is the LCM of pi and 2 pi? The least value which will be divided by pi and 2 pi. So what is the answer you are getting? 2 pi. Right? So you feel like that worst case answer is 2 pi. But you can check at the lesser option as well. What I mean to say is that if your worst possible case answer is 2 pi, then I will check at 3 pi by 2. I will check at pi. I will check at pi by 2.
and more options I can check. But my intuition says that I should check at pi first. This is what I feel like that, because here t plus pi, if I put t plus pi here, then what will happen? 2t plus 2 pi, and here if I put t plus pi, so cos t plus pi, that would be minus cos t. Actually it will not come. What I mean to say is that if I do x of t plus pi, what I will get? Sine of 2 t plus pi plus cos of t plus pi. Say yes or no? So sine of 2t plus 2 pi, basically it is sine of 2t plus 2 pi plus cos of pi plus t. So what is the value of 2t plus 2 pi? That would be sine 2t only. This is your sine 2t only. Plus what is the value of cos pi plus t? Cos pi plus theta is equals to minus cos theta. So it will be minus of cos t. Is that equivalent to xt? Absolutely not. Right? This is not equivalent to xt. Sine 2t plus cos t is not equivalent to sine 2t minus cos t. So this option is gone actually. I don't think I should check at pi by 2 as well. Why so? Why I don't need to check at pi by 2? Because if it is not being repeated at pi, then how you can expect it to repeat at pi by 2? Because if it is repeating at pi by 2, then certainly it has to repeat at pi. So this option is also gone. Say yes or no. Next, what you are going to check, you can check at 3 pi by 2. Okay, so I will check at 3 pi by 2. Although in the examination hall I am telling you 99% chances are there that option would be mentioned. 99% chances. So first you will find the worst case. Worst case, omega 1 2, omega 1 1 here. Then t1 would be pi, t2 would be 2 pi. Then from the worst case you got to know that my LCM is 2 pi. Say yes or no. Or you could have directly seen from the omega 1 as well. You need to calculate the HCF. HCF would be 2 only. If HCF is 2, okay, HCF would be 1, then time period would be 2 pi. So this time period is coming to be 2 pi. For lesser than 2 pi we are checking. Now we will check at 3 pi by 2. So x of t plus 3 pi by 2. So sine of 2 into t plus 3 pi by 2. So this would be 2t plus 3 pi. Say yes or no. Sine 2 should be multiplied with t plus 3 pi by 2. So sine 2t plus 3 pi plus cos t plus 3 pi by 2. Right? So sine 2t plus 3 pi, where it will go? 3 pi plus theta. If I make that coordinate, this is 0, pi by 2, pi, 3 pi by 2. Right? So cos of 3 pi by 2 plus theta, you are here. And all student take copy. So here cos is positive. Cos is positive, but since it is 3 pi by 2, so sine will be changing. So this will become sine only. So this will give you sine t. Right? So you are again not getting anything. And what about this one? 3 pi plus theta. So where will be 3 pi? 3 pi will be here. So all student take. So this will give you negative. So here you are getting minus sine 2t plus sine t. Minus sine 2t plus sine t. Right? You need to have good idea of trigonometric. I hope you know that trigonometric function, that how to write down these functions. Cos of 3 pi by 2 plus theta. How will you write down cos of 3 pi by 2 plus theta? Here all are positive. Here only sine and cosec is positive. We don't need to worry about cosec. Here tan is positive. And here cos is positive. All student take coffee. All student take coffee. So here cos is positive. So 3 pi by 2 plus t. So cos is going here. But at 3 pi by 2 and at pi by 2, function changes. Cos becomes sine. So sine t. Sine 2t plus 3 pi. If this is pi, this would be 3 pi by 2, this would be 2 pi. Then this would again be 3 pi. So 3 pi plus theta. Here tan is positive, sine is negative. So 3 pi plus theta. So it will give you, at 3 pi nothing will change. So sine 2t only you will get, but negative sign. So is that equivalent? Is that equivalent to xt? Absolutely not. So x of t plus 3 pi by 2 is also not equivalent to xt. So where else you would check? I don't think you need to check at anything else. But at least you should check at 2 pi. Okay? If you are going to write down in the examination all that my answer is 2 pi, then check at 2 pi at least. You can check here cos of t plus 2 pi. That means cos of 2t plus 4 pi. Sorry, sine. Sine of 2t plus 4 pi. If I put t plus pi, basically if I need to check t plus 2 pi. So what will happen? Sine of 2t plus 4 pi plus cos of t plus 2 pi. Sine of 2t plus 4 pi, what that would be? Sine 2t.
cos of 2 pi plus t, what that would be? Cos t. What is that? It is equivalent to xt only. So what is your answer? This is your answer only. Okay. So our first case is the final answer. So in this question, I checked for the lower option as well. I got to know that lower option, nothing is being satisfied here. Here also it was not being satisfied. Then certainly, if it is not being satisfied at pi, then why I need to think about pi by 2? Then it is not being satisfied at 3 pi by 2 as well. Then best possible option remains 2 pi only, right? So the answer is 2 pi only. Okay. So this is how you need to do in the examination hall. Whenever there is mode mentioned, okay, there is no certain method for the mode. You need to apply your own aptitude. Here you apply your own aptitude and think what you are going to do. I told you the formula for linear combination of addition, right? You know the formula for this one. Is there any formula for this one? x1t into x2t. No. What we studied? Linear combination of x1t, x2t and x3t. So here you are adding it up, but I don't have any formula for multiplication. I don't have any formula for multiplication. Then what I'm going to do? I need to make a trigonometric function from here, right? What I need to do? I need to make trigonometric function, and for that I need to apply some formula. Which kind of formula? 2 cos A sin B, right? xt is equals to 1 by 2 sin A cos B, 2 sin A cos B. Now try remembering the formula of 2 sin A cos B. It is equals to sin A plus B plus sin A minus B, right? Sin A plus B, sin A plus B plus sin A minus B. 2 sin A cos B, sin A plus B plus sin A minus B. So t minus 2t would be minus t. So what you are getting? 1 by 2 sin 2t minus 1 by 2 sin t. Can I find out the value of time period for this one? Yes. What is your omega 1 here? 2. What is your omega 2 here? 1. What is your t1? 2 pi by omega 1. 2 pi by omega 1. So t1 is pi. What is your t2? 2 pi by omega 2. So t2 is 2 pi. You can see the ratio. Ratio is certainly your rational. So what will be your t naught? If I call the time period for this is t naught. So t naught would be LCM of pi and 2 pi. So least value which will be the least value which will be divided by pi and 2 pi, that would be 2 pi. So t naught will be 2 pi. What will be the value of omega naught? 2 pi by t naught. So omega naught will be 1. So this kind of question can be coming in your examination hall. So you need to do by this. Okay. If there was mode mentioned here, let's just say I mentioned the mode here. So more things you need to understand there. What I will do here also, I will put the mode. So worst case answer is 2 pi. Worst case answer is 2 pi, but I will check at pi as well. I will check at 3 pi by 2 as well. So do you really think you can get anything out of it? If you check at pi, this will not be the answer. Why is that so? Because sin 2t plus 2 pi, that would be sin 2t only, but sin t plus pi will be minus sin t. So that will not be the case. Are you able to understand? This is my xt. If I check at t plus pi, and if I add a mode here, let's just say in the examination hall, this question was having a mode. Then also I guess the answer would be same. If mode was there, then I would have to check other options as well. That 2 pi is my worst case. I would check at pi. I would check at 3 pi by 2. I would check at pi by 2 as well. But I would not check at pi by 2 and 3 pi by 2. Why is that so? Because I know that at pi by 2, this function will be changing. If I put t plus pi by 2, so sin t plus pi by 2 will be cos t. And if it is changing, it is killing the complete function. What I need to have, I need to again have the same xt. So if I check at 3 pi by 2 or pi by 2, if I check at 3 pi by 2 or pi by 2, then sinusoid will be changing into cosinusoid. But I again need the same function, sin 2t and sin t I need. So this I will not check. At 2 pi I already know that it is being repeated. If I check at pi, so sin 2t plus 2 pi, that would be sin 2t. Sin t plus pi would be equals to sin t plus pi. That means you are in the third quadrant. Sin pi plus t, all student take. So that is also negative. So that would be equals to plus 1 by 2 sin t.
So again it is also being killed. So this is also not a possible option. So answer will be 2 pi only. If the mode was mentioned. If the mode is not mentioned, then this is the answer. Even if the mode was mentioned, that means for mode of xt, what would have been the time period? That would also be 2 pi. Okay, that would also be 2 pi. But we have checked at 2 pi, pi, 3 pi by 2 and pi by 2. When we checked here, we got to know that it is being cancelled out. This is also being cancelled out, and this will also be cancelled out. In place of here I will put pi by 2, and this is also being cancelled out. So pi by 2, 3 pi by 2 and pi all are being cancelled out. Only 2 pi is the waveform, or only 2 pi is the time period where it is being repeated. So answer here also would have been 2 pi. So are you able to understand the conclusion? The conclusion is you need to check. In the examination hall, you need to check. That's it. That's the only conclusion of all the discussion. And one conclusion is the LCM you need to take if there is linear combination. What is the other conclusion? Other conclusion is if sinusoids are there in the multiplication and all these kind of things are there, then what you need to do? You need to multiply, you need to apply those sinusoid functions that we have studied in the last class, right? Let's take another example. I will add a page. Which example I'm going to take? That example. Cos square xt is equals to cos to the power 40. If this was mentioned, then what you would have done in the examination? Cos to the power 40. So try doing it on your own. Now you have enough aptitude. You should be able to do it on your own. What is the time period that I am asking? What is the time period of this function? If it is periodic, so first you need to get to know if it is periodic or not. And if it is periodic, then what is the time period? So try doing it on your own. I will take a pause now, because previously I thought of taking a pause, but I couldn't take the pause. Now you do it on your own, and then we will proceed in the lecture. Okay. After that, we will see complex exponential. So you already have an idea of complex exponential. Now you need to see how to calculate the time period. Okay. Yeah. So did you try this one? What we need to do? I can do in this manner, cos square t, because I don't really remember the formula of cos to the power 40, but I remember the formula of cos square t. What that would be? 1 plus cos 2t by 2, and then there would be whole square. Can I open it up? 1 plus cos square 2t plus 2 cos t, right? A plus b whole square plus 2 cos 2t divided by 2. So this is actually equivalent to 1 by 2 plus cos 2t. This is your cos 2t. Basically what I am going to do, okay, not 1 by 2, it would be 4, right? It would be 4. Cos square t to this power 2. So cos square 2t can be written as 1 plus cos 2t by 2. So 1 plus cos 2t whole square divided by 4. So a square plus b square plus 2ab. So 1 by 4 plus 2 cos t divided by 4. So that would be cos 2t plus 2 plus 1 by 4 cos square 2t. What would be cos square 2t? Cos square 2t would be 1 plus cos 4t divided by 2, right? So 1 by 4 plus 1 by 2 cos 2t plus 1 by 8 plus 1 by 8 cos 4t. Now DC value 1 by 4 plus 1 by 8, what that would be? 3 by 12, 1 by 4 plus 1 by 8. So 2, 8, 3 by 8. So DC is 3 by 8 plus 1 by 2 cos 2t plus 1 by 8 cos 4t. One thing I told you, what is that? That if a DC is being added with any kind of periodic signal, is this periodic? Yes. What you can see? What is the value of T1? 2 pi by 2, that is pi. What is the value of T2? 2 pi by 4, that is pi by 2. T1 is pi, T2 is pi by 2. So if a DC is being added with any periodic signal, then xt will be periodic only. So forget about DC. You just get to know what will be the LCM of pi by 2 and pi. So LCM of pi by 2 and pi, what that would be? That would be equivalent to LCM of pi divided by HCF of
2 and 1. So what is the LCM of pi and pi? That would be pi. What will be the HCF of 2 and 1? That would be 1. So what is the answer? Answer is equivalent to pi. What is the answer? This is the answer. Answer is pi. Okay. So this is how we need to solve in the examination hall. Are you getting this point? So this is how we need to open it up. So I opened it up again, cos square 2t. That would have been 1 plus cos 4t by 2. How did I open it? Cos square theta. 1 plus cos 2 theta divided by 2. So that would have been 1 by 2, and from here I got to know that I could have solved with the omega as well. Omega 1 is 2, right? So HCF of 2 and 4. So the highest value which will divide 2 and 4, that would be 2 only. So value of omega will come out to be 2. And if the value of omega is coming out to be 2, then what would be t? That would be 2 pi by 2. That would have been 2. So this is also I would have solved it, right? And this is also the way of solving it. Very easy thing, just you need to apply trigonometric formula. Let me check the calculation if everything is all right. Yeah, here 2 and 4, HCF would be 2 only. Yeah, all right. Now the complex exponential is coming. So do you know how to break down the complex exponential? How you will break down e to the power jt. That would be cos t plus j sin t. So that would be equals to 2 cos t plus j2 sin t. It should be written as 2j sin t actually. What is the time period of this thing? Is this periodic? Is this periodic? Yes, both are periodic. What is the time period? What is the time period of 2 cos t? 2 doesn't matter. Time period of cos t is equals to 2 pi, because 2 pi by omega is omega is value here is 1. So t1 would be 2 pi. And what is your t2? T2 would also be 2 pi. So what will be your t? LCM is 2 pi and 2 pi. So the LCM would be 2 pi only. So the time period would be t only, right? So here what is the time period coming out to be? T. What do you think what will be the time period of e to the power j4t? Sorry, e to the power j pi t. So e to the power jt, e to the power jt, e to the power jt is having a time period of 2 pi. So what will be the time period of e to the power j pi t? That would be 2 pi divided by pi. Say yes or no. This was your xt. So what this would have been? X of pi t. So time axis is being multiplied with, time domain is being multiplied with pi. So time axis will be divided by pi. So what will be the time period? 2, right? So here what will be the time period? Time period is 2. So from here what you are understanding, that this value is actually omega naught. Omega naught here is pi. So what will be the time period? 2 pi by omega naught. 2 pi by omega naught. Omega naught is pi. So time period is 2. Are you getting this point? Here what was the value of omega naught? Here omega naught was 1. So what will be the time period? 2 pi by omega naught. So time period would be equals to 2 pi. Are you able to understand this point? This value here is omega naught. So a e to the power j omega naught. So angular frequency is omega naught. What will be the time period? 2 pi by omega naught. What about this? What is the value of omega naught? 5. What will be the time period? 2 pi by omega naught. Right? This would be the answer. Now the linear combination. So can I try the linear combination? Certainly I can try. What is the value of omega 1 here? 4. What is the value of omega 2 here? 3. What is the value of omega 3 here? 2. What I will do, I will directly go with the HCF, because I know that my omega would be the HCF of 4, 3 and 2. So the least value which can divide 4, 3 and 2, that would be 1. That means my time period would be 2 pi by omega. So my time period would be equals to 2 pi. Or I could have gone with the time period as well. Basically, I could have find out T1, that would be 2 pi by 4, pi by 2. T2, 2 pi by 3. T2 would have been 2 pi by 3. And what about T3? T3, 2 pi by 2. That would have been pi. So LCM of pi by 2, 2 pi by 3 and pi by 1. That would be equivalent to LCM of pi, 2 pi and pi. What would be the LCM of pi, 2 pi and pi? The least number
which can be divided by pi, 2 pi and pi, that would be equals to 2 pi only, right? And divided by HCF of 2, 3 and 1, that would be equals to 1. So T naught is coming out to be, from here also T naught is coming out to be 2 pi. Say yes or no. So in that manner also I could have done. So you should be remembering both of the things, that for omega naught it would be HCF, omega H homework. In that manner you can remember omega H homework. So if omega is there, you need to do the HCF. And TL for time for, or you can remember LT as well. LT you will not be able to remember. Let's remember TL. From TL transmission line is there, from TL timeline is there. So TL will be able to, you will be able to remember. So if you need to find a time period, then you need to take LCM. So in that manner you can remember. Okay. So both of the things you need to do, because in the examination hall this will take some time and there are chances of error as well, but this will not take time, right? Before this we can write down another question. Let's take this question. Xt is equals to, you need to try it on your own, 3 e to the power j2t plus e to the power, there could be minus sign as well. So try doing it on your own, e to the power minus j pi t. Minus sign doesn't matter here, okay? Minus sign would not matter. I don't need to care about the minus sign. Are you getting this point? Why I don't need to care about the minus sign? So let me explain you one thing. How will I explain? You extend it, no, you just open it. E to the power, my question is, or your question would be, let's add a page. Your question would be that, sir, what will be the time period for xt equals to 4 e to the power minus j pi by 3t? Can I apply that formula, sir, that omega naught is pi by 3 here? Sir, omega naught is pi by 3 here and my t naught would be 2 pi divided by pi by 3. That would be equals to 6. Can I apply this formula? Yes, you can apply. Let's verify it. How will you open it? 4 of cos pi by 3t minus j sin pi by 3t. This is how I will open it. So I am getting 4 cos pi by 3t minus j 4 sin pi by 3t. From here, what did I get to know? That my omega 1 is pi by 3. Does this sign matter? No. What is your omega 2? That is also pi by 3. So what is your complete omega? HCF of pi by 3 and pi by 3, that would be pi by 3 only, right? So here omega naught is pi by 3 and t naught would be 2 pi divided by pi by 3. Say yes or no, right? So t naught is 6 only. So directly from here as well you can see the same thing. So here also what I will do, what is my omega 1? That is 2, and what is my omega 2? That is pi. If I take the ratio omega 1 divided by omega 2, what I am getting? 2 by pi. What is this? Irrational. And what does that mean? It is non-periodic. Say yes or no. Okay. It is non-periodic. Why is that so? Because the ratio is coming out to be irrational. Well and good. So we have seen enough example. Now try doing this on your own. First you need to find the time period for xt. What is your xt? So from here what do you see? Omega naught is equals to pi by 2. So t naught would be equals to 2 pi divided by pi by 2. That would be equals to 4. So time period for xt is 4. Okay. Time period for xt is 4. What is your mode of xt? What is your mode of xt? If I take the mode of this thing, 3 e to the power j pi by 2t. If I take the mode, this 3 goes outward, e to the power j pi by 2t. Tell me what is the mode of this particular quantity. I told you the mode of e to the power j omega naught t is always equals to 1. Say yes or no. So what is the mode here? That is 1. So answer is coming out to be 3. So actually your mode of xt is a constant value. Mode of xt is a constant value. What is this? Mode of xt is actually a DC. And if it is a DC, what does that mean? It is non-periodic. So here the answer is non-periodic. Directly if some guy goes on solving without even thinking anything, he would do that, okay, omega naught is pi by 2. Then I will think, okay, pi by 2, pi by 4, all these kind of things he will keep on applying. But actually what did you get to know? That the mode of xt is always constant. That means it is a DC. And if it is a DC, that means it is non-periodic. Now this question was asked in GATE examination. These options were mentioned. These three options were mentioned. I mentioned this option as well. So now you try doing your, giving your answer here. Okay, you need to try giving your answer. We can see multiple method for this one. So let's try. Xt is equals to e to the power j5t plus e to the power j9t. Xt is equals to e to the power j5t plus e to the power j9t. But what you need to find? Time period for mode of xt. Mode of xt you need to find. That means I need to take the mode here. So for what I'm going to do, first I'm going to calculate the worst case. What will be the worst case? So from here, omega 1 and omega 2. Omega 2 is 9 and omega 1 is 5. So what I need to do? I need to take the HCF. So omega would be HCF of 5 and 9. What that would be? HCF would be 1, right? HCF would be 1. So what will be your T naught dash? HCF means what is the highest value which can divide both 5 and 9. So that is 1 only. So what will be your T naught? 2 pi by 1. So T naught dash is 2 pi. Okay. So T naught dash is coming out to be 2 pi. But this is the worst case. Worst case. I need to check at these cases as well. Then from 2 pi, the value, lesser value is pi as well. It is equals to pi by 2 as well, pi by 9 as well, pi by 5 as well. So let's check. Where I will check? I will try to go with the minimum one, because I know that if pi by 2 is periodicity, if my time period is pi by 2, then certainly pi will also be the time period, no? If I satisfy the condition of pi, that means that I need to check at pi by 2 as well. But if I have checked at pi by 2 and my answer is correct, then at least I can cut down pi. Now you will say that, sir, by this logic you should get started with pi by 9, because pi by 9 is the minimum one. So if minimum one is being satisfied, then you don't even need to think about the higher one. But do you really think that pi by 9 will be the periodicity? What I mean to say is that you would say that, sir, better get started with the minimum one. No, you start with pi by 9. If it is the answer, if pi by 9 is the answer, then you don't need to check other options. You don't need to check pi by 2. You don't need to check pi. You don't need to check pi by 5. You don't need, and 2 pi is the worst case only. So let's get started with pi by 9. This is what you would be saying. But do you really think that pi by 9 could be the answer? From here only you can check. If I put t plus pi by 9, let's check. X of t plus pi by 9. So what I will see? Mode of x of t plus pi by 9, sorry. So e to the power j 5t plus pi by 9. So 5t plus pi by 9 plus e to the power j 9t plus pi by 9. That is equivalent to e to the power j 5t plus e to the power j 5 by 9 plus e to the power j 9t plus e to the power j pi. What is the value of e to the power j pi? If you remember, e to the power j pi, in the last lecture I told you e to the power j pi, what was the value? -1, right? Or you can check here, cos theta plus j sin pi. Sin pi is 0, so cos pi is -1. So this value is -1. So what you are getting? E to the power j 5 pi by 2. What is the value of this e to the power j 5 pi by 9? You don't know. E to the power j 5 pi by 9 would be cos 5 pi by 9 plus j sin 5 pi by 9. I don't know this value, but certainly I am pretty sure that this value will not make my function equivalent to this function. Like from here only I can get to know that it will be some value, I don't care, plus e to the power jt, and this value is -1. So 100% I can say one thing, that this is not being equivalent to mode of xt, that's for sure. That this is not equivalent to mode of xt, that's for sure. 100% I can check here, because plus sign has been replaced with minus sign. So certainly this is not equal to mode of x of t. So this option I will not check. Why I am not checking? Are you able to understand? And same will go with pi by 5 as well. Same will go with pi by 5 as well, because here you will put t plus pi by 5. So this will become e to the power j pi, but here again you don't know the value. Again it will become e to the power j 5 pi by 9. So again there also you don't know the value. So pi by 5 is also not a good option. Then I would check at pi by 2. Because 2 pi is my worst case, I can go with pi by 2 now. So now I will go with pi by 2. So x of t plus pi by 2. So e to the power j 5t plus 5 pi by 2 plus e to the power j 90 plus 9 pi by 2 e to the power j 5t. Now e to the power j 5 pi by 2, e to the power j 5 pi by 2, what will be the value? E to the power j 5 pi by 2, that would be cos 5 pi by 2 plus j sin 5 pi by 2, right? What is the value of cos 5 pi by 2? Cos 5 pi by 2, what that would be? Cos pi by 2 is 0 actually, cos pi by 2 is 0, then pi by 2 plus 2 pi, what that would be? 5 pi by 2. So it is written as cos 2 pi plus pi by 2, that would be equals to cos pi by 2 only. And what is the value of cos pi by 2? That is 0. So this value will be 0 plus j, it is written as 2 pi plus pi by 2, 2 pi plus pi by 2, sin 2 pi plus pi by 2, that would be equals to sin pi by 2. What is the value of sin pi by 2? That is 1. So what you are getting, this value is equivalent to j plus e to the power j 90. What will be the value of e to the power j 9 pi by 2? What is the value of e to the power j 9 pi by 2? What will be the value of e to the power j 9 pi by 2? That would be j only. Why so? Because 9 pi by 2 can be written as 4 pi plus pi by 2. So cos of 2 pi plus pi by 2 or cos of 4 pi plus pi by 2 would be the same as cos of pi by 2 only. What is this? 9 by 2 is 4.5. So 4 plus 0.5, 4.5, right? So e to the power j 5 pi by 2 would be equals to e to the power j 5 pi by 2, and that would be equals to e to the power j 3 pi by 2, and that would be equals to e to the power j pi by 2. Say yes or no. And all those will be equals to j. Because after, wait a second, after 2 pi it will be repeated. No, really sorry, this will not come, after 2 pi it should be repeated. So e to the power j pi by 2, and that would be equals to j, right? Because pi by 2 plus 2 pi would be 5 pi by 2, 5 pi by 2 plus 2 pi, what that would be? 9 pi by 2, right? So here also we will get j. So what we are getting? J as common, e to the power j 5t plus e to the power j 90. So I need to add another page. So my mode of xt is coming out to be j e to the power j. In the examination hall you will do it very quickly, right? Actually you will see that e to the power t plus 5 by 2, okay, t plus 5 by 2, 5 pi by 2, 9 pi by 2, okay, it would be j, this would also be j. So j comes common here, mode of j e to the power j 5t plus 90. Now you would know one thing, that if mode of AB is given, so that would be equals to mode of A into mode of B, right? So mode of J into mode of e to the power j 5t plus e to the power j 90. What is the value of mode of J? I told you one thing, mode of J is 1 only, right? Mode of J is 1 only. So what you are getting? This was not actually x of t, this was actually mode of x of t plus pi by 2. So mode of x of t plus pi by 2. So mode of j is 1. So e to the power j 5t plus e to the power j 90. That is coming out to be mode of xt only. So from here, what did you understand? That your fundamental time period is equivalent to pi by 2. So what is the answer? Pi by 2. So this is how I would have checked. This would not take much time to me, because I would see pi by 2, 5 pi by 2, 9 pi by 2. Then e to the power j pi by 2 would be plus j, e to the power j 5 pi by 2 would also be plus j. Then you take the mode would be 1 only, e to the power jt plus e to the power 90, t naught is equals to pi by 2 only, right? Other method is also there. What is the other method? Let's check that out. What was your mode of xt? Method 2. Mode of xt was e to the power j 5t plus e to the power j 90, right? What I can do? I can find a common ground. What do I mean by common ground? Between 5 and 9, what is the number in between? 7. So what I am going to do? I am taking e to the power j 70 as common. So what I will be left with? E to the power minus j 2t plus e to the power plus j2t. Say yes or no. Did you understand what did I do here? Why I am doing so? I found the common ground e to the power j70. So this would be e to the power minus j2t plus e to the power j2t. This is how I can take common. If I divide by 2 and then multiply by 2. And I know one thing, mod of AB is equals to mod of A into mod of B. So mod of e to the power j70. And what about this? Mod of e to the power minus j2t plus e to the power plus j2t divided by 2. What is the value of this thing? A e to the power j omega naught t. What is the mode of that? Equals to A only. So mode of this would be equals to 2. And what is this? E to the power minus j theta plus e to the power j theta divided by 2 is equals to what? Cos theta. So did I teach you this thing in the exam? Did I teach you this particular formula in the last lecture? Yes. So 2 into mode of cos 2t. What is the time period of, now your mode of xt is coming out to be what? Mode of xt is coming out to be 2 into mode of cos 2t. Pure cosinusoid. Pure cosinusoid is in the mode. So what you need to do? T naught would be equals to 2 pi by omega naught divided by 2. That would be equals to pi by 2. There you go. Answer would be equals to pi by 2. Although it is very tough to think in the examination hall, right? This I have thought of it like again and again I am solving the problem. So it might click to a teacher, but to a student it might not click. But student would know one thing, what is the basic meaning of time period, that it should be repeating after that certain time window. So for that, pi by 9, pi by 5 doesn't seem like a good option. When I calculated directly, blindly, worst case was 2 pi. So answer would be lesser than 2 pi. If I check at pi by 2, then certainly pi will also be satisfying. So first I checked at pi by 2. Then I got to know that if I am checking at pi by 2, then I see that this would be plus j, this would be plus j, j would be coming out, amplitude will be 1. So it is directly coming out to be equals to x of t only. Here I can see that this is the equation that I am being satisfied. That means t naught is pi by 2. This is how I will be doing with the options. If I am very smart, then I would see that I can get a common ground, take it out, magnitude will be 1 there. This will be becoming a cos function. So if this is becoming a cos function, then from here I can get to know my value of t naught, that is pi by 2. You would see in the PYQ's book solution, this will be solved using big trigonometric functions. What they would do? First they will break it down. E to the power j5t, cos of 5t plus j sin t plus cos of 90 plus j sin 90. Then cos they will keep one aside, then sin they will keep one aside. Then they will do cos square theta plus sin square theta. Then they will open the cos square theta, then they will open a plus b whole square plus c plus d whole square. Then they will open it, then they will apply more trigonometric formula, then they will take under root, and after that they will get this function, that is mod of cos 2t. After all these, doing all these things, they will get this particular function. You can see the solutions which have been given on YouTube by a lot of coaching institute. This is how they are solving it. But use your aptitude there. We are not going to be a mathematician here. We are an engineer. And engineer use the aptitude. Engineers use the aptitude. What is the name of the examination? GATE, where A stands for aptitude. General aptitude test in engineering. So they are checking your aptitude of engineering, not your mathematics there, right? So these kind of things I should be aware. I will go in my examination hall with the mindset that even if I don't remember anything, even if I don't remember a single formula from my complete electronics subject, still I can score 80 marks. Believe me guys, in the examination hall, 95% of the marks, 95% of the marks doesn't depend on a single formula. All will be analysis based. You can check the paper of 2025, 2024, 2023, 2022. They never ask any question which is based on pure formula. If they ask, it would be hardly for 4 to 5 marks. That's it. Rest all are analysis based. Like, is this based on any formula? No. You keep on mugging up the formula in, like for sinusoid, this would be the method. For cosinusoid, this would be the method. Then these kind of question would come in the examination hall. You apply formula, nothing will work here. So in the examination hall, whenever this, I'm telling for all the subjects, not for signal system. In the examination hall, whenever you go, always remember that even if I forget all the formulas, still I can solve the problems based on my aptitude that I am having, right? if I give you a problem of class 8 mathematics, will you say that, sir, I don't remember the formula, I cannot solve it? If I give you a problem on a simple interest and compound interest, so there will you say that, sir, I don't remember the formula, I cannot solve it? If you are in class 8, if you are in class 8, class 8 कैसे लिखते हैं भाई? Yeah. So if you are in class 8, at that time you would have said that, sir, I don't remember the formula of simple interest and compound interest, I cannot solve it. But if you are an engineer, do you require the formula of solving it? If I give you a problem on percentage, do you require to remember any formula? If I give you a problem on average of number, do you require any remembering the formula? No. Using your own aptitude you can solve it. Same goes with engineering. Using your own aptitude you can solve the problems. Say yes or no. Okay. So this was just a message I wanted to give, that in the examination hall you should be confident enough, even if I don't remember any formula, I will be able to solve the problem with my aptitude, because I have studied from PrepFusion. And PrepFusion never ever believes in mugging up the things. I certainly ask you to remember few things so that the problem becomes easier for you in the examination hall. You can solve the problem fastly. But I always make sure that I give least possible stress to my student, and I will teach the maximum part. Take any single topic from any particular chapter, from any particular subject on PrepFusion, and you will see that no one has taught in that depth. No matter if the educator is having an experience of 10 years, 20 years or 25 years. Whatever that they are teaching, certainly I am teaching. And whatever that they are not teaching, I will certainly teach that as well. Because that can be asked in GATE 2026 or 2027 or GATE 2050 as well. Okay. So future is also something that we need to see, not only the past. Say yes or no. And you will see our test series. In our test series, we will make such questions which will be asked in future. And a lot of people will be saying these are out of the syllabus, but not actually out of the syllabus. If people are not able to solve a particular problem, then they say it is out of the syllabus, right? And this happens in every year in the examination. The question paper would come, GATE 2025 question paper came. Till now, a lot of educators are yet to solve some problems from their particular subject. Okay, no one gives the complete 65 to 65 answer. The very next day of the examination, on 15th Feb, we had the examination of EC. On 16th Feb, at 1 PM, I came up with the answer of all 65 to 65 questions. Okay, this only happened on PrepFusion for the first time. Next year, I will try to bring the answer. If the examination is on 15th Feb, I will try to bring the answer on 15th Feb itself. Next year, in 2026, I am saying. Okay, this year, I was a bit busy because I did not have any other guy with me. I was only doing on my own, and one guy I hired for writing down the problems. But next year, I will try to bring the solution on the same day. Okay, on the very same day, I will try to bring all the solutions, and certainly I will bring it correct. That's for sure. And I'm not gonna skip any problem. If I'm not able to solve any problem, then I will be able to accept that I will be the first person to accept that I'm not able to solve a particular problem. For this, I need time. Okay, I will be the first one to accept it. I don't know why people cannot accept the thing that they are not able to solve the problem. Why they do give the reasoning? Why do they give needless reasoning that why they are not able to solve the problem? You can just simply accept it. No, if someday you give me a problem and if I am not able to solve, I will be the first one to accept it. But within 2 to 3 days, I will be coming up with the answer and the correct answer with the best possible approach. That's my short guarantee. Okay, you can see the solution of GATE 2018. GATE 2018, that which problem? The traffic light problem from digital electronics. Traffic light digital electronics. You see that solution on PrepFusion. What you need to type? GATE 2018 traffic light problem solution. Digital electronics PrepFusion. You type and see the solution. There was a question on ADC. I forgot the year. You see the solution of that particular problem. In GATE 2013, there was a problem in oblique incidence from EMFT. Oblique incidence from EMFT. Till now, everyone has given the answer to be wrong. Till now, everyone, all the coaching institute, even the IITs gave the answer to be wrong. Although answer key was not released at that time, so we cannot say whether IIT gave it correct or they gave it MTA, but everywhere the answer is wrong till this date. You check the solution, it was asked in GATE 2014, I guess. One question was there on analog electronics. That was based on average current through diode. You check the solution of that particular question. Everywhere it is written wrong. Everywhere the things are wrong there. So these kind of things we are solving on PrepFusion. That's why I am always confident about my content, and kind of I am arrogant about my content as well, because I know that kind of content we are delivering here, that will make an impact. Okay, certainly some people are not able to understand this thing in their gate journey, but once they get into masters, because after masters they will come back to me, because for the placements they have to come back to me only, right? Every student who is a gate aspirant, if he goes for masters, for the placement preparation they have to come back to me only. And when they come back and when they study network, analog, digital, microwave, EMFT, transmission line, when they study all these kind of things, I will teach Fourier series and Fourier transform as well. You will see a complete different approach would be there. Like you would fall in love with electronics when I teach Fourier series and Fourier transform. So they will come back and they will see all this kind of content, and then they would realize what was the thing that has been taught here. I receive a lot of messages after the results that sir, now we are looking at the content and you are teaching like absolutely brilliant. Like from AIR 1, AIR 2, AIR 3, these guys also tell the same thing. Okay, they are also having my placement courses. So enough self praise, but yeah, I wanted to tell a few things about the courses because I hope it reaches the people. This is what I hope. I should reach as many people as it can. And I try to bring most of the content on YouTube itself. Like if someone is studying from some other platform, let's just say you have bought a PW or you have bought an academy, then I never say that come to my platform. You might be feeling underconfident in a particular topic, just let me know that particular topic, I can bring that on YouTube. But I cannot teach all the courses comprehensively on YouTube, because if I teach everything on YouTube, then what I will have? Because no one will come to my paid courses then, and if no one is coming to the paid courses, then how I will be earning the money? So everything cannot be coming onto YouTube. But if you have get any other subscription and you are feeling underconfident in a particular topic, then certainly I will bring it on YouTube. No need to worry about that. And basics I always bring, so that people get to know that what he is teaching, because it will be very tough to believe on a guy who is just 24 years old. You would be thinking he is 24 years old, what he is teaching? He is teaching this much things. Okay, and this is just one topic. This is just one topic of a signal system. There are n number of things. N number of things are there in electronics which can be taught in a good manner, right? So I know I wasted your time. Those who wanted to skip it, they could have skipped it. But yeah, let's go to the next question now. Tell the time period. Do it on your own. I will take a pause. Try doing it on your own. How you will open it up, that you also know. So open it up and then you let me know whether it is a periodic or not. If it is a periodic, then what will be the time period? Okay, think about it. And then this also you can try on your own. Maximum of sin pi by 2t cos pi by 2t, minimum of sin pi by 2t cos pi by 2t. I hope you know the meaning of maximum and minimum. If you don't know the meaning, then you can drop it, but this you can try on your own. Okay, so I will pause the video, then I will come back. Yeah, so did you guys try this problem? What did you do? Sir, omega naught is pi by 2, sir. So sir, my time period would be 2 pi divided by pi by 2. That would be 4. Wrong. This answer is wrong. First, I need to modify one error that I just now noticed. So in the last lecture here, I mistakenly wrote 2. It would be 4, right? It would be 4. This would have been 4. 0, 1 by 2, 1, 3 by 2, 2 is here, then 5 pi by 2, sorry, then 5 by 2, then 3, 7 by 2, then 4. It would be 4, right? Then after 4, it will be keep on repeating. So that was an error that I did. So let's get back to our question now. So this 4 answer is absolutely wrong. Why is that so? First, open it, no? Xt is equals to, how it will open? For t less than 0. So sorry, for t greater than 0, this will be opened as positive. So 3 e to the power j pi by 2t. And for t less than 0, how it will be opened? It will be opened as negative. So 3 e to the power minus j pi by 2t. So this is how it will be opened, right? Someone would say that, sir, this is having a time period of 4. This is also having a time period of 4. So total time period would be 4. No, this doesn't happen, right? Sine of mod of t. How did we open it? Sin t and minus sin t. So this was also having a time period of 2 pi. This was also having a time period of 2 pi. Did I say that yes, it is periodic with 2 pi? No. When we draw the waveform, we got to know that this kind of waveform we are getting. This kind of waveform we are getting. So is it periodic? No. This is non-periodic. So it doesn't mean that, sir, minus sign doesn't make any impact. But it is for t less than 0. This is for t greater than 0. So both are different thing, right? So here what you can see, The functions are completely different. Wait a second. Yeah. So this 4, 4 and 4, that would not be there. So here what you can see, the functions are completely different. Here you are having e to the power minus j pi by 2t, and here you are having e to the power plus j pi by 2t. So functions are completely different. So there is very high chance that it would be non-periodic. If the functions were same, then certainly it would have been periodic. Functions are different, then there is very high chance that it would be non-periodic. Can I draw the waveform? Yes. Let's verify it with the waveform as well. So what this would be? This would be imaginary part, this would be real part. I'm not gonna draw the time axis. I can only draw a circle. I will only draw a circle. Why is that so? Because based on the circle only I can make my conclusions. Say yes or no. Based on this circle only I will make my conclusions. I will only draw the circles. Because I know that it is having a constant amplitude. Mode of xt is 3. So the amplitude is constant here, that is equals to 3. Now I need to get started with the different time windows. So at t equals to 0, what is the value? E to the 3 e to the power 0, that would be 3. So here you are having at t equals to 0. At t equals to 1, e to the power j pi by 2. At t equals to 1, e to the power j pi by 2. At t equals to 1, what will be the value? E to the power j pi by 2, that would be 3j. At t equals to 1, the value will be 3j. So this will be the point at t equals to 1. This I have already taught, right? This would be the point at t equals to 2. This would be the point at t equals to 3, and this would be the point at t equals to 4. In between, this would be 1 by 2, 3 by 2, 5 by 2, and 7 by 2. This we have already seen. So how we are going? From 0 to 4, in this direction I am working. So from 0 to 4, then 4 at t equals to 5 I will reach here. You can check at t equals to 5. At t equals to 5. So xt at t equals to 5 would be 3 e to the power j 5 pi by 2. That would be equivalent to 3 e to the power j pi by 2 only. Why is that so? Because 2 pi plus pi by 2 and 2 pi plus pi by 2 would be equivalent to pi by 2 only. So 3 e to the power j pi by 2, what that would be? 3j only. So at 5 you will reach here. This would be your t equals to 1 5. This would be your t equals to 6. Previously it was t equals to 2. 2 6. Then this would be 3 7. Then this would be 4 8. Then 9 10 11 12. So you can see that it is being repeated after every 4 seconds. So you will say that the time period is 4 seconds. This is where you are going wrong. Why is that so? You will say that, sir, from 0 to 4 we are just revolving anti-clockwise. We are just revolving anti-clockwise, but you checked it only for positive value of t. You did not check for the negative value of t, right? Now you need to check at negative value of t as well. So what will be the value of x of minus 1? X of minus 1, what that would be? 3 to the power j pi by 2. X of minus 1 you put here. Minus 1, then mode is there, that would become plus 1 only. So this is equals to e to the power j pi by 2, that is equals to 3j only. So x equals to minus 1. T equals to minus 1 is here. T equals to 0 was here, t equals to minus 1 is here. Where would be t equals to minus 2? Check at t equals to minus 2. 3 e to the power j pi by 2 into minus 2 mode, that would be 2 only. E to the power j pi, what that would be? J pi would be 1. J pi would be minus 1 actually. E to the power j pi would be minus 1. So minus 3. So you would be somewhere here. Because this is the point of minus 3. So at t equals to minus 2 you are here. At t equals to minus 3 you would be here. And at t equals to minus 4 you would be here. So in the negative cycle, this was your time axis. Let's just say this is your time axis. This point is 0. 1, 2, 3, 4. Minus 1, minus 2, minus 3, minus 4. So if you clicked on the time button, you are at minus 4. I clicked on the time button at minus 4. So in minus 3, if I need to go from minus 4 to minus 3, then where I am working? If I am going from minus 4 to minus 3, that means I am actually working clockwise. From minus 3 to minus 2. From minus 2 to minus 1. And from minus 1 to 0. And when I started from 0, so when I am going from 0 to 1, I will reach here. When I am going from 1 to 2, I will reach here. That means for positive value of t, I am working anti-clockwise. For positive value of t, I am working anti-clockwise. For negative value of t, I am working clockwise. So you would see two different kind of spiral. One would be going like this, and for the negative value, the spiral rotation would be in the opposite direction. For positive value, the rotation, and for negative value, the rotation, both would be opposite to each other. Are you able to understand this point? Rotation of spiral. In the last lecture, we studied about complex exponential function. So rotation of spiral will be going forward. In minus t, it would be coming backward. But the rotation would be in the opposite direction. One will be moving anti-clockwise, other one will be moving in clockwise. Here you can check as well. At t equals to 0 you are here, at t equals to minus 1 you are here, at t equals to minus 2 you are here, at t equals to minus 3 you are here, at t equals to minus 4 you are here. What about at t equals to minus 5 as well? Because whatever the result that you are getting at 5, the same result you will be getting at minus 5 as well. Because t is mod here. Whatever the result that you are getting at 6, the same result you will be getting at minus 6. Whatever the result that you are getting at 7, the same result at minus 7. Whatever the result that you are getting at 8, the same result at minus 8. Right? So if you are going backward, if you are going in this direction, if I clicked on the time button, I started with minus 4, minus 3, minus 2, minus 1, because time will always increase. What if there was minus 8? So if I was at minus 8, that means I am here. Then I clicked on the time button, I would have reached to minus 7. Minus 7 is here. That means I am working that means I am working clockwise. But when the t became positive, I suddenly started working anti-clockwise. So clockwise, 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 suddenly anti-clockwise, anti-clockwise, anti-clockwise. So at t equals to 0, first it was clockwise, 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 and at t equals to 0, it changed to anti-clockwise. That means it is not periodic. The same thing was happening with sinusoid as well, no? This was your sinusoid. That here you feel like that it is periodic. Here also you felt like that it is periodic. But you can see that at t equals to 0, it is changing. Right? You are going increasing, decreasing, increasing, decreasing. It should have decreased, but again it increased. Then at t equals to 0, it completely broke the periodicity. So same thing is happening at t equals to 0, periodicity is being broken. So you don't need to think this much of things in the examination, okay? You will not be thinking this much of things in the examination. What you will think there? Both functions are different. That's it. That means it will be non-periodic, right? But if someone asks you a good question in interview, this is how you would explain him, okay? Or they can ask some good question in your GATE examination as well based on this concept. Here I asked about periodicity, but they can frame something good out of it. They can just ask you the rotation as well, that how will be the rotation for positive value of t, how will be the rotation for negative value of t. These kind of questions they can ask. Okay, so you know everything about this signal now, right? Do this one. What is the meaning of maximum? If I say maximum of 1 and 0, what will be the answer? 1. If I say minimum of 2 and 1, what will be the answer? 1. If I say maximum of minus 1 and 2, what will be the answer? 2. If I say minimum of minus 1 and minus 2, what will be the answer? Minus 2. Minimum value. So this is the thing here. So sin pi by 2 t, sin pi by 2 t, xt is given as maximum of sin pi by 2 t, cos pi by 2 t. What does that mean? That let's just say what is the value of x of 1. So that would be equals to maximum of sin pi by 2, cos pi by 2. What is the value of that would be equals to maximum of, what is the value of sin pi by 2? That is 1, cos pi by 2 is 0. So what that would be equals to 1. So x of 1 would be equals to 1. So I cannot check at all the points like this, right? So what I will do, I will draw the waveform of sin pi by 2t and I will draw the waveform of cos pi by 2t. Then I will start working. I will start working on t. So this is your t equals to 0. What is this point? This point is t equals to 2. And what is this point? T equals to 4. What is this point? T equals to 3. What is this point? T equals to 1. Similarly here as well, what is this point? T equals to minus 1. What is this point? T equals to minus 2. What is this point? T equals to minus 3. And what is this point? T equals to minus 4. So this is how I will start working. So let's work here. Let's work for maximum of sin pi by 2t cos 2t. So if I am working on t axis, this is the value of cos function and this is the value of sin function. Let's use the red color of pen. This is the value of cos function and this is the value of sin function. So which is greater? Let's talk about at this point. At this point the value of sin is this thing and at this point value of cos is this thing. So value of cos is larger, no? So till this point, till this particular point, value of cos is larger. That means this will come as my output. Whatever the value is larger, 1 or 0, whatever the value is larger, that will come as the output. So between this value and this value, which value is larger? This value is larger. So that will come as the output, right? So this will come as the output. So this will come as the output. After that, from this point to till next point where it is cutting both of them. After that, cos is going downward like this and sine is like this. So which one is larger? Sine value is larger, right? Here cos value is negative but sine value is positive. So till this point sine value is larger. So this will come out as the output. Now from this point to where it is cutting next? Here it is cutting next. From this point to this point where it is cutting next. So which value is larger? This is your cos and this is your sine. So what will come as the output? This will come as the output. Right? Are you able to understand what is happening? Like this. First it goes like this, then it goes like this, then it goes like this till this point, right? Then again what will happen? Again sinusoid will come as the output. In that manner the waveform will keep on repeating. So the waveform will repeat like this, here, downward, then again goes like this. Are you getting this point? Are you getting this point or not? So it is being repeated in the window of 4 seconds again. Time period is actually 4 seconds only. Basically what you can do is that this part then goes like this, then goes like this. Now again this kind of part going downward, again this kind of part is being met here, right? Again this kind of part going downward, then going like this, then what will happen? Go will like this, then again downward. In that manner it will keep on repeating. So basically if you take the maximum or minimum in both of the cases, your time period will come out to be 4 only. From here only you can get to know the time period is 2 pi divided by pi by 4, the time period, sorry, pi by 2. So time period would be 4. For this thing as well, the time period would be 4 only. This is the value of t naught, this is the value of t naught. I just wanted you to explain the meaning of this thing, that maximum of sin pi by 2 cos pi by 2t, minimum of sin pi by 2t cos pi by 2t. What is the meaning of this thing? I hope I am able to give the visualization, right? And how will be the output waveform looking like? For minimum one, how will the output waveform look like? Just the opposite, right? Just the opposite. So here the minimum value is this, minimum value is this, minimum value is this. So this brown one is the, who wrote brown run? Brown run किसने लिखा था भाई? Okay, this is not the question UPSC would ask, or this is not the question the gate examination would ask, but this is the question that a lot of Lallan top subscriber would ask. Okay, if you are not getting the reference, no need to worry about this joke. This is just a joke. Okay, this is not a concept. This is just a joke. So what I was saying, whatever that is shown in the brown color, whatever that is shown in the brown color, I am very good, not very good at making jokes. Okay, I am very good at making lame jokes. Yeah. So whatever that is there in the brown color, that would be your minimum of sin pi by 2t cos pi by 2t. Again you can see that it is being repeated after a certain window, that from here to here it is being repeated, from here to here. Same goes for this thing as well. Now you are able to, better you are able to visualize. This point you need to see, this point you need to see. Again the same point we are getting. And what is this window? This window will be 4 only. This window is also 4 only. Okay. So what is the time period? 4 seconds. So that's it. That's it about the time period completely. Okay. Next we need to study about energy. So in the next lecture we will study about energy of a signal. So periodicity you have understood. Next we need to study about energy. Okay. Thank you very much. Hi everyone. Welcome back. So what we studied in the last lecture? In the last lecture we studied about power. Sorry, not power. We studied about periodicity. We studied about the time period of a particular signal, whether it is periodic or non-periodic, whether it is a linear combination or if there are modes. So all kind of cases we have seen in the last lecture about the periodicity. Now we need to study about energy, power, RMS and average of a signal. If a particular signal is there, you can calculate its energy, you can calculate its power, you can calculate its average value and you can calculate its RMS value. But before that, we need to see a very important concept that is known as orthogonal signals. Orthogonality. So this concept we need to see because it will be used in all the analysis. So there will be one separate video only for orthogonality. Okay. After that, we can study about energy or we can study about power and all these kind of things. So only about orthogonality we are going to study now. Okay. So before going towards orthogonality, first let's see a very simple thing which you might be already knowing, but even if you don't know, now you can understand here. So if I want to take conjugate of a particular signal, what this is known as conjugate. So conjugate of xt would be x conjugate t. That means the if I am taking a conjugate of a particular signal, then what I need to do, I need to replace j with minus j. That's it. If I am taking conjugate of a particular signal, that means I need to replace j with minus j. So x conjugate of t, what that would be? Just replace your j with minus j. That's it. Okay. Here what will be the conjugate? Just replace your j with minus j. This is known as taking the conjugate. If I have written down x conjugate t, that means j will be replaced with minus j. That's it. Okay, nothing else. Basically, it is just 180 degree shifted. If the number is written as 2 plus 3j, 2 plus 3j, it would be somewhere here, right? 2 plus 3j, if this is imaginary and this is real, so it would be somewhere here. If I take the conjugate 2 minus 3j, so that would be 2 minus 3j, it would be here. So you have just shifted it by 180 degree. So this is the meaning of conjugation. If you take the conjugate, that means you are shifting it by 180 degree. Okay, so plus j would be replaced with minus j. Now for this particular signal, if you take the conjugate, you need to replace plus j with minus j. Do you see any j here? No. You don't see any j here. So plus j will not be replaced with minus j. Basically there is no j, so nothing should be replaced. So here what you are getting, x conjugate of t is equals to xt only. So for a real signal, there is no meaning of conjugate. Basically for the real signal, even if you take the conjugate or even if you don't take the conjugate, both are the same things, right? Now let's talk about the orthogonality. What is the meaning of orthogonality? So if I say my two signals x1t and x2t are orthogonal, okay, just listen to it very carefully. A very important concept it is. It is important for your complete signal system, not for one chapter. I am saying it is important for complete subject signal system. Okay. So if I am saying that x1t and x2t are orthogonal signal, or I would say a pair of orthogonal signal, then for periodic signal what I will do, I will multiply x1t with the conjugate of x2t. I will multiply x1t with the conjugate of x2t, then I will integrate it over a time period of t naught. And how will I calculate the time period of t naught? This is periodic with t1, this is periodic with t2, so t naught will be LCM of t1 plus, LCM of t1 and t2. So over a time period window, I need to integrate. What does that mean? That I can integrate from 0 to t naught, or I can integrate from minus t naught by 2 to t naught, or I can integrate from minus 3 t naught by 4 to plus t naught by 4. Basically this window has to be t naught. That's why I have written down integration sign and then t naught. So over a time window of t naught, I need to integrate. Okay. What I will do, x1t is being multiplied with the conjugate of x2t, and then I need to integrate it over a window of time. Okay. And when I integrate and this answer is coming out to be 0, at that time I will say my signals are orthogonal. x1t is multiplied with the complex conjugate, or you can say directly conjugate of x2t, and when I integrated it over a time period, then it is coming out to be 0, then I will say it is orthogonal signal. Or what I could have done, I could have taken the conjugate of x1t and then I would have multiplied with x2t. Only one conjugate you need to take, and the same thing I would have integrated it over a time period. So only one conjugate you need to take, whether you take the conjugate of x1t or you take the conjugate of x2t. So if this condition is satisfied, then I will say that my signals are orthogonal. But this is true only for periodic signal. What if your signal is aperiodic? What if my signal is aperiodic? So now you will integrate from minus infinity to infinity. If signal is aperiodic, same thing you are going to do, just you are integrating from minus infinity to infinity. Here you are integrating for a particular time window, that was t naught. But If for aperiodic signal, you will integrate from minus infinity to infinity. And the same thing you will do. You can first check with the conjugate of 1. Or then you take the conjugate of 1 and second remains as it is. This is for aperiodic. Okay. Now secondly, for real signal, this is known as real signal. Xt is real. This is known as real signal because there is no conjugate part here. There is no part of j. This was your complex exponential. There was j involved. So this was a complex signal. This was also a complex signal. But this is a real signal. So for real signal, x1 conjugate t would be equals to x1 t and x2 conjugate t would be equals to x2 t. So in real signal, you don't need to do all these kind of things. Basically, here you don't need to take a conjugate for real signal. For real signal, what you will do? X1 t is multiply with x2 t and then you will integrate over minus infinity to infinity. Or here x1 t is multiply with x2 t and then you will integrate over a time period t naught. So there you don't need to take a conjugate. Even if you take the conjugate, both will come out to be same only. So is that clear? How do we see the orthogonal signal? So let's try out with the examples now. X1 t is there, x2 t is there. Let me know if both are orthogonal or not. Both are real, say yes or no. Both are real, right? This is also real, this is also real. When I multiply both of them, what will happen? Let's just say this value is 1, this is not given, I can assume this value to be 1 or any value I can assume. So 1 will be multiplied with 0. Between 0 to 1, this guy is 1, this guy is 0. So 1 will be multiplied with 0. So if I make x1 t into x2 t, because first task is to do the multiplication. First task is to do the multiplication. So x1 t will be multiplied with x2 t. So between 0 to 1, 1 is multiplied with 0, so it would be 0 only, right? It is not, so it is 0 only. Between 1 to 2, this signal is being multiplied with 0, so it will also be 0 only. And after that, 0 is multiplied with 0, all are 0. Previously also all are 0. So complete signal is 0. Complete signal is 0. And if you integrate it from minus infinity to infinity, if I integrate it, what I will get? 0 only, because complete signal is itself 0. Here I am not putting conjugate. Why so? Because both are real signal. That's why I don't need to put any conjugate here. So if I integrate it, I will get 0 only. Say yes or no, right? What about this one? Are both orthogonal? Multiply both of them. This particular signal will be multiplied with 1 in this time window from 0 to 1. This particular signal will be multiplied with 1 in this particular time window. So if you multiply both of them, what you are getting? From 0 to 1, and that is being multiplied with 1. So let's make it 2. Otherwise, people will not understand what we are doing. Let's make it 2. So 1 will be multiplied with 2. So this point will be 2 between 0 to 1. After that, everything is 0 only. Before that as well, everything is 0 only, right? And if I need to calculate the area, this was your x1 t into x2 t. So certainly the area is not coming out to be 0. That I can directly see. Whatever it is coming out to be, it is not coming out to be 0. So half into base into height, that would be equals to 1. So that is not equals to 0. So it is not orthogonal. Okay, so from now onwards I will write not orthogonal. Okay, and for here I am writing orthogonal. O dot means orthogonal, not orthogonal means not orthogonal. NO. Okay, so this is not orthogonal. Try with this. What you need to do, this is also real, this is also real. There is no meaning of taking conjugate. So I'm not going to take any conjugate here. First thing, find the time period of this one, t1, because I need to know that for which time window I need to integrate. So what is the value of t1 here? 2 pi divided by pi by 2? 4. What is the value of t2 here? 2 pi divided by 3 pi by 2. So that would be 4 by 3. So what will be t naught? LCM of 4 and 4 by 3. That would come out to be 4 only. So the value of t naught is coming out to be 4. So I at least know that for which window I need to integrate. So let's start solving it. What thing I need to calculate is, I will integrate from 0 to 4. I can integrate, right? Because I need to take a window of 4. So from 0 to 4 I am integrating sine pi by 2t into x1t into x2t sine 3 pi by 2t dt. This is what I need to do. Can I multiply with 2 and divide by 2? Yes, because sine A into sine B, I can see sine A into sine B. So if I multiply with 2, divide by 2, to 2 sine A sine B. What is the formula? 2 sine A sine B. 2 sine A sine B, I guess cos A minus B minus cos A plus B. Cos A minus B minus cos A plus B. Yeah, so that would be the formula. So 1 by 2 cos A minus B, that would be cos A minus B, pi by 2t minus 3 pi by 2t, that would be minus of pi t, but cos can eat up the negative sign, so cos of pi t minus of cos A plus B, so minus of cos 2 pi t dot dt from 0 to 4. Can you draw the graph of cos pi t? Can you draw the graph of cos 2 pi t? Although you can do the integration, but why should we do the integration? Just use your aptitude. If I draw the graph of cos pi t, sorry, this point will be 0, this point will be half. What will be this point? This point will be cos 2 pi 1 and this point will be 3 by 2, right? And the same cycle will keep on repeating. Here the time period is 2 seconds, here the time period is 1 second, right? This is the graph of cos pi t, this is the graph of cos 2 pi t. Why I am making the graph? For calculating the integration. I don't want to do the calculation here, I just want to see with respect to graph, because when I see with respect to graph in the examination hall, I will not have to do this analysis. If I do only the mathematics here, that integration of cos pi t would be equals to sin pi t, then put the limit from 0 to 4. I know the answer would be 0, but how to see with respect to graph, that I am telling. Because in the examination hall, I don't want to do much mathematics. The more mathematics you do, the more chances of minor mistakes are there. That's why I always try to avoid mathematics. So now I am avoiding the mathematics here, nothing else. So here what is the time period? Time period is 1 second. So you would know that this point will be 1 second. This point will be 1 second. So you are integrating from 0 to 4. That means for this is your cos pi t, this is your cos 2 pi t. Cos 2 pi t. Integrating from 0 to 4, that means you will integrate this kind of 2 cycles, right? If you integrate from 0 to 2, what you will see, this area, this much area, this area is negative, this area is equivalent to this area plus this area. For one complete cycle in a cosinusoid function, for one complete cycle, this area and then this half area, this is equal to 0, right? This area, whatever the area that you get here, that would be equal to this area plus this area, but this area is negative, so that would be equal to 0. So from 0 to 2 you are getting 0, from 2 to 4 as well you will get 0 only. So if you are integrating for 2 cycles, this kind of 2 cycle you will integrate. Are you getting this point? This kind of 2 cycles you will integrate. This much area for 2 cycles you will integrate. So what will be the answer? 0 only. The answer of this thing will go to 0. What about cos 2 pi t? So here this kind of 4 cycles you will integrate, right? Because the integration is from 0 to 4. So this kind of 4 cycles you are going to integrate. This is one cycle, then another cycle will be from 1 to 2, then next cycle will be from 2 to 3, and the next cycle will be from 3 to 4. So this area is 0, 0 plus 0 plus 0 plus 0, all will be 0 only. So what you are getting? Answer coming out to be 0. So my point is, here you could have done with the basic mathematics as well. What kind of mathematics you would have applied? What is the integration of cos? That is plus sine. So here you would have written sine pi t, and it would be divided by pi, minus cos 2 pi t, it would be divided by 2 pi. Now you need to put the limit. Sorry, this will be sine. right? If you put the limit, sine pi 4 pi will be 0, sine 8 pi will be 0, sine 0 will be 0, sine 0 will be 0. So what is the answer? 0 only. You could have done this mathematics, or you could have thought of in this manner as well, right? So answer is coming out to be 0. So if my answer is coming out to be 0, that means they are orthogonal. Orthogonal. Try the next one on your own. Try this one on your own. One is sine, one is cos. Okay. So let's make it simple for you. What I'm gonna do is that I'm making a bit more simple for you because it would be a bit tougher. So here I'm just removing these shift. This shift I'm removing. Now you can try it on your own. Okay, shifts have been removed. For the next question, we can see the shift. Here we will see the shift. Without shift, you try doing it on your own. I'm pausing the video. You try it on your own and then you see the solution. Okay, so let's start. What I need to do? First, I will need to find T1 value. 2 pi divided by pi by 2, that would be 4. Here 2 pi divided by pi by 3, that would be 6. This is T2. So what will be your T naught? That would be LCM of 4 to 6, right? What is the LCM of 4 to 6? 4 and 6. LCM, the least number which will be divided by 4 and 6, that would be 12, right? Say yes or no. The least number which is divided by 4 and 6, that would be 12 only. So time period T naught is 12. So you need to integrate for any window of 12. So from 0 to 12 we are integrating. Then you need to multiply both of them. So 9 sine pi by 2t into cos pi by 3t dt. So 9. Here again I can see that I need to apply some formula, right? So 9 by 2 comes outward into 2. 2 sin a cos b. 2 sin a cos b. So what will be the formula? Sin a plus b plus sin a minus b. From 0 to 12. Sin a plus b. Sin pi by 2t plus pi by 3t. What that would be? Pi by 2 plus pi by 3. So 5 pi by 6. This is 2 sin a cos b, right? So here I can write down the formula for you because if you are not able to remember, 2 sin a cos b. Sin a plus b plus sin a minus b. Sin a plus b. So what did we get? 90 degree plus 60 degree, 150. 150 is 5 pi by 6 only. Plus sin a minus b. 90 minus 60, that would be 30 degree. So that would be sin pi by 6. And then you need to integrate dot dt. Okay. Now what is that time period for this one? 2 pi divided by 5 pi by 6 into 2. So that would be 12 by 5. If I see why I am seeing the time period for this one, why I am seeing the time period, what do you think? I got to know that my time period is 12 by 5 seconds. And what is the time period for this one? 2 pi divided by pi by 6, that is 12 seconds. Why? What do you think why I am looking at the time period? Because I need to see the number of cycles. Here, one cycle will be completed for sinusoid, one cycle will be completed in 12 by 5 seconds. And I need to integrate over 12 seconds. From 0 to 12 seconds, I need to integrate. That means how many cycles would come here? 1 cycle, 2 cycle, 3 cycle, 4 cycle, and then 5 cycle. These 5 cycles will come. This is 12 by 5. This will be 24 by 5, 36 by 5, 48 by 5, 60 by 5, which will be equals to 12. What is the area? This plus minus 0, plus minus 0, plus minus 0. So what you will see in the examination hall, whenever there is sinusoid, cosinusoid, first you will calculate their time period. Here also I would have done the same thing. Here I would have calculated the time period. What is the time period? 2 seconds. What is the time period here? 1 second. So I would have got to know that I need to see these kind of 2 cycles. From 0 to 2 and 2 to 4, area would be 0. From 1 to 2, from 0 to 1, 1 to 2, 2 to 3, 2 to 4. Sorry, 2 to 3, 3 to 4. There would be 4 cycles like that. Area would be again 0. 0 minus 0, it would be 0 only. Here what I can see, there are 5 cycles. Here I need to integrate from 0 to 12. So this kind of 5 cycle would be there. Area would be 0. And this kind of 1 cycle will be there. For this particular function, only 1 cycle would be there. So in that also area would be 0 only. So 0 plus 0 would be 0. So answer would be 0. That means it is orthogonal. So you can solve these kind of problems very quickly in the examination hall. Needlessly you go into integration. In sinusoid, cosinusoid, you don't need to do a single integration there. Or people usually mug up, okay, whenever I see sinusoid, I will put that equals to 0. That is also wrong. What if this was coming out to be, if here the time period was coming out to be 24 seconds, let's just say, if the time period was coming out to be 24 seconds, then how will be the sinusoid? This point will be 24 seconds. That means this point will be 12. Now you need to integrate this area. So now this area you need to find. So you cannot say it will be directly 0. This area I need to find. And in the next lecture, I will tell you, you can remember this area as well. How will you remember this area? That also I will tell you. No need to worry about that. So actually in the examination hall, you will never ever have to do the integration, especially for sinusoid and cosinusoid, no matter what kind of problem they are asking. This I can guarantee today. If you watch next 2 to 3 lectures, like roughly around next 5 to 6 hours, if you watch with full concentration, you will never ever have to do the integration of sinusoid or cosinusoid in the examination hall. We will build enough intuition there. Okay. So answer is 0. It will be orthogonal. Okay, let's go to the next one. Here the same thing is there, ditto same thing is there. They are just shifted by a particular angle. This is pi by 2t, pi by 3t. This is shifted by 60 degree. This is shifted by 30 degree. Do you really think there would be any change? There might be some change. So we need to check it out. Okay. So, but there would be no change in the time period, right? The same time period would be there. T naught value will be 12 only. T naught value will be 12 only. There is no change in the time period, that's for sure. So I will integrate for a window of 12 seconds. This window I am not defining as of now. Okay. This window I am not defining as of now. So here I am putting T naught only. As of now, I did not define the window, but I know that I will be integrating it for 12 seconds. I can integrate from anywhere. So multiplication, 9 by 2 I can write down because I will have to multiply with 2, right? Because sin A cos B. Sin pi by 2t plus pi by 3 into cos pi by 3t plus pi by 6, right? Dot dt. So 9 by 2 sin A cos B, sin A plus B plus sin A minus B, sin A plus B, sin A plus B. What is the value of pi by 3 plus pi by 6? That would be pi by 2 plus sin A minus B. Two sin A cos B, sin A plus B plus sin A minus B. I have done the calculation well. 60 plus 30, 90 degree. 60 minus 30, 30 degree. 2 sin A cos B, sin A plus B plus sin A minus B. Yeah, all good. Okay. Now you need to integrate it for 12 seconds, right? You need to integrate these two for 12 seconds. Let's write down T naught here. What I can do, I can break it down in this manner, no? Sin 5 pi by 60 plus pi by 2 plus 9 by 2, because this is the complete integration here. This is the complete integration here. So I am just breaking down this integration. This also I need to integrate for T naught. Sin pi by 60 plus pi by 6. So what you are getting to know from here, what will be the time period? 12 by 5, right? And here what will be the time period? 12. Even if there is a shift, the time period is not changing. Now I need to integrate with respect to 12 seconds. I need to integrate with respect to 12 seconds. If I make the waveform of sin pi by 60, it was somewhat like this, right? Sin pi by 60. It would be somewhat like this. Then I was integrating from 0 to 12 seconds. In the previous problem, this is what I was doing. And then I told that from 0 to 12 seconds, there would be 5 cycles and all cycles will be cutting out each other's area. So answer would be 0. Now what is the scene here? There is a shift of pi by 2. Now I don't know how much it will be shifted. I don't care about that. But this waveform will be shifted now, right? Either it will be shifted here or there, but waveform will be shifted. That I am pretty sure, because there is a shift of pi by 2. So my waveform will be shifted. But let me know one thing, will there be any impact on the integration from 0 to 12? I am not going to integrate from 0 to 12. I can take any window. What I am going to do, let's just say my waveform was shifted this side. Let's just say my waveform I shifted this side. So now what I'm going to do, I'm going to take my integration limit from here to the point after 12 seconds. Are you getting this point? The window of 12 seconds remains the same. If this is 12 seconds, let's just say till this point it was 12 seconds. Now if my waveform is being shifted, what I will do, I will shift this 12 seconds as well. That means this 0 point and whatever the 0 point that you get here, the 0 point will remain same. That means the area will also remain the same. Are you getting this point or not? The graph is symmetric, no? Sinusoid graph is symmetric. So even if you are shifting it by any angle, and then the limit I need to take for 12 seconds, I am not saying that I am taking from 0 to 12 seconds. No, I can take any 12 seconds. I can take from 2 to 10 minus 2 to 10 seconds as well. So let's just say if it was shifted for 2 seconds on this side, let's just say this point is minus 2, then what I would have done, I would have taken the limit from minus 2 to 10 seconds. Then the area would be 0 only. Are you understanding this point? What is happening here? Are you able to understand this point? Right? So here again the area would be 0, or you can simply integrate with respect to whatever the formula you know. Again the answer would come out to be 0 only. But try visualizing it. If I am shifting it with respect to a particular value and the window I am having is 12 seconds. The window that I am having is 12 seconds. So here there would be 5 cycles of this particular waveform. Of this particular waveform there will be 5 cycles, and of this particular waveform there would be 1 cycle. So certainly my integration would be 0 only, no matter whether there is a shift or not. Basically, if this is my sinusoid, let's just say this time is 0, this time is t. I ask you what is the area between 0 to t, you will say sir the area is 0. Now what if I shift it? What if I shift it somewhere like this, and this point becomes, let's just say, minus t by 3, and this point becomes 2t by 3, because I have shifted it by t by 3 here. And now if I ask you what is the area of this particular function, what is the area of this particular waveform in the time window t, what is the area? Again the area is 0, because it is just shifted. And if you remember, if the area of x of t is a, then the area of x of t minus t naught, what that would be? It would be a only, right? So for a particular time window, if I am taking the integration, here there will be 5 cycles, here there will be 1 cycle, it would give the area to be 0 only. I hope I have given enough points now. So you don't need to do the integration, complex integration, you don't need to do in the examination hall. You just need to think one thing, that even if I am shifting, that means there will be no impact on area. So again the answer is 0. So again it is orthogonal. Okay, we will make conclusion out of it. In the examination hall, you will not have to do this calculation in the examination hall. We will make the conclusions. Okay, that's why we are seeing different kind of example. First we saw with sinusoid, different frequencies are there, pi by 2, 3 pi by 2. Sinusoid, cosinusoid, different frequencies are there. Sinusoid, cosinusoid, different frequencies, but shift is also there. Now sinusoid and sinusoid, same frequency is there. Try doing it on your own. Sinusoid and sinusoid, same frequency is there. So try doing this on your own. 4 into 3, 12, sine square pi by 2t. Say yes or no, right? Integrating from, what is the time period here? 4. What is the time period here? 4. If you take the LCM, t naught will be 4 only, right? Dot dt. And you need to integrate from 0 to 4. Say yes or no. Agreed? So 12, 0 to 4. Can I break it down in this manner? Cos 2t, that would be cos pi t divided by 2 dot dt. Because I know that cos square 2 theta is equals to 1 minus 2 sine square theta, right? So 2 sine square theta would be equals to 1 minus cos 2 theta is equals to 1 minus 2 sine square theta. So 1 minus cos 2 theta divided by 2. 1 minus cos 2 theta, cos 2 pi into pi by 2t. So 1 minus cos pi t divided by 2. So that would be your integration. So 2 can come outward. So this would be 6. Now 2 is coming outward, this would be 6. 1 into dt from 0 to 4, 1 into dt, minus from 0 to 4, cos pi t into dt. What is the time period here? Time period is 2, right? 2 pi by pi, time period is 2. You are integrating from 0 to 4, that means 2 cycles you are integrating. So this will throw 0 area, right? You are integrating 2 cycles of cos. The time period is 2, from 0 to 2 and from 2 to 4. So this much area, this much area, this much area, this much area, if you add all of them, answer would be 0 only, right? So this answer would be 0. And what this answer would come out to be? That would be 24, right? This answer is coming out to be 24. So you just what you did, 1 minus cos pi t divided by 2. So from here dt by 2, 4 by 2, 24. Yeah. So answer is coming out to be 24. That is the answer. So answer is not coming out to be 0. Although this was 0, but this is giving you a certain value. So answer is, if answer is not 0, that means it is non-orthogonal. We will write down the conclusions. As of now, you just need to solve the mathematics. That's it. Okay. Don't worry about the conclusions. We will write down everything. Same frequencies are there, but one is sinusoid, other one is cosinusoid. Same frequencies, one is sinusoid, other one is cosinusoid. Try doing it on your own again. 12, right? 4 into 3, 12. Yeah, time period will be 4 only. You can see time period will be 4 only. For 0 to 4, I am integrating. 12 sin pi by 2t cos pi by 2t. So 2 comes common, sorry, 6 comes common. So 2 sin a cos a. Basically, sin 2a is equals to 2 sin a cos a. This formula I am applying. So 2 comes common, 6 comes common here. 0 to 4. 2 sin a cos a. That would be sin 2a. So sin pi t. What is the time period? 2. Time period here is 2. You are integrating sinusoid from 0 to 4. That means 2 cycles will be repeated. In both of the cycles, area would be 0 only. So this area would be 0 only. So what is the answer is coming out to be 0. So what is this? Orthogonal. Should we start looking at conclusions? Like more examples are there. This example, and then this example. So 4 examples are there. After that, we can come to the final conclusion. But before that, let's see some conclusions. If different frequencies are there, pi by 2, 3 pi by 2t, different frequencies are there, no? So certainly it will be orthogonal, no matter whether it is sinusoid or cosinusoid. If different frequencies are there, answer is orthogonal. Different frequencies, blindly you can put answer would be orthogonal. No need to see the phase shift as well. Different frequencies, answer is orthogonal. Next, here, the frequencies are same. One is sine, other one is also sine. That means they are having a phase shift of 0 degree. Sin pi by 2t and sin pi by 2t. They are having a phase shift of 0 degree, no? There is no other phase. Frequencies are also same. So if frequencies are same, then there is a chance that it can be non-orthogonal. But after that, you need to see the phase shift. What is the phase shift between this and this? 0 degree. Basically, this is also phase shifted by 0. This is also phase shifted by 0 degree only. So what is the phase shift? 0 degree only. So whenever there is same frequency, then there is a chances that it can be non-orthogonal. Here there is same frequency. So yeah, there are chances that it can be non-orthogonal, but you need to see the phase shift. Sinusoid and cosinusoid. 3 sin pi by 2t plus 4 sin pi by 2t plus pi by 2. Say yes or no. Frequencies are same. 4 cos pi by 2t can be written as 4 sin pi by 2t plus pi by 2. Frequencies are same, but they are having a phase shift of 90 degree. So if there is a phase shift of pi by 2 or 3 pi by 2 or 5 pi by 2 or 7 pi by 2, similarly in the negative direction, minus pi by 2, minus 3 pi by 2 or minus 5 pi by 2. So if there is a phase shift of multiple of 90 degree, then they will be certainly orthogonal for sure. Are you getting this point? Okay. If frequencies are same, then you need to see the phase shift. If frequencies are same, you need to see the phase shift. If frequencies are different, we started from here. If the frequencies are different, close your eyes. This was the first question. Frequencies are different, close your eyes. write down orthogonal. Frequencies are different, close your eyes, write down orthogonal. Frequencies are different, close your eyes, write down orthogonal. Whether it is sinusoid, cosinusoid, doesn't matter. Different frequency, orthogonal. Frequencies are same, hold on a bit. Now you see the phase shift. What is the phase shift? 0 degree. Frequencies are the same, phase shift is 0 degree. It would be non-orthogonal. Frequencies are same, hold on a bit. What is the phase shift? 90 degree, orthogonal. Okay. Try doing it blindly, like without even writing down any equation. What you will see? Same frequencies. I need to hold on a bit. One is sine, another one is cosine. So phase shift is pi by 2. Is that so? No. Right? You need to see this phase shift as well, no? Basically, if I'm looking at phase shift, then I need to look here as well. Between them, between sine and cosine, the phase shift is pi by 2. But between them as well, there is a phase shift, no? Are you getting this point? So between them, how much phase shift is there? This is your 60 degree and this is your 30 degree. So between them, the phase shift is 30 degree. So here 90 degree phase shift is there, here 30 degree phase shift is there. Now I am not sure whether 90 plus 30 would be there or 90 plus minus 30 would be there, but I certainly know one thing, that it can never be equal to the multiple of 90 degree. Multiple of 90 degree. Actually, I can actually get to know what is the actual phase shift. What I am gonna do is that I can replace this cosinusoid with sine pi by 2t plus pi by 2 plus pi by 6. Right? So what will be the phase shift? Pi by 2 plus pi by 6. This is the phase this is having, and this is the phase minus pi by 3. So total phase shift is 60 degree. But in the examination hall, I am not going to do this process. One thing I will see, sine and cos, that means 90 degree phase shift. Then here 60 degree, 30 degree, another 30 degree phase shift will be there. It could be plus 30 as well, it could be minus 30 as well. That I don't care. One thing I got to know, that my phase shift will not be a multiple of 90 degree. Like 90 degree or 270 degree, odd multiple of 90 degree, sorry. 90, here what did I say? Multiple of 90 degree. Here I said multiple of 90 degree, I guess. No, odd multiple of 90 degree, okay? Odd multiple of 90 degree. Odd multiple of 90 degree. So here what I will see, that there is a 90 degree phase shift between sine and cos, but another phase shift is there, that is of 30 degree. This is your pi by 3, this is your pi by 6. So another phase shift is there, that is of 30 degree. So 90 plus minus 30, I am pretty sure that it will never be a odd multiple of 90 degree. So for sure, it would be a non-orthogonal signal. Okay? Because frequencies are same. Frequencies are same. So one chances are there, it could be non-orthogonal. Other one, I need to check the phase shift. If phase shift comes out to be odd multiple of 90 degree, then I am happy. It would be orthogonal. But if it is not coming out to be in the multiple of odd multiple of 90 degree, if it is coming out to be anything else, then it would be non-orthogonal. So let's verify it with the mathematics now. Okay, so these were the very interesting conclusion that were very important actually. T naught is again 4. So T naught is again 4. So here sine, I am putting 2 into 1 by 2. So 2 sine A cos B. 2 sine A. 2 sine A cos B. 2 sine A cos B. What that would be? Sine A plus B plus sine A minus B. So you can do it. Sine A plus B. Sine A plus B, that would be sine pi t plus pi by 2 plus sine A minus B. Sine A minus B. Pi by 2t, and this is pi by 2t and this is also pi by 2t. So that is being cancelled out. So pi by 3 minus pi by 6, that would be pi by 6 dot dt. And you need to integrate over a time period of 0 to 4. What is the time period here? Time period here is 2 seconds, right? Time period here is 2 seconds. So this integration will throw 0. But sine pi by 6 is a certain value, right? What we are doing, this is the integration we are doing. First we applied 2 sine A cos B. So sine A plus B plus sine A minus B. Sine A plus B, sine A plus B, pi by 3 plus pi by 6, sine A plus B plus sine A minus B. Sine A minus B, sine A minus B. Okay. So here the time period is 2 seconds. You are integrating for 4 seconds. That means 2 cycles would be there. Integration would throw 0 value. But now you need to integrate from 0 to 4. Sine pi by 6. What is the value of sine 30? That is 1 by 2. Because it is a certain value, no? Sine pi by 6 is a certain value. Dot dt. So what is the answer coming out to be? 1. Is it equals to 0? No. That means it is non-orthogonal. And that we already predicted as well. Right? So our prediction was correct. So I hope you are able to see the conclusion now. Right? Different frequencies, I need to hold on a bit. Then I need to see the phase shift. That's it. This is the only conclusion. And it is a very, very typical topic. People usually don't understand this. And in the examination hall, they try doing different things and mess up the problem based on orthogonality. But now I hope you have a good idea. So without even solving it, can you let me know whether it will be orthogonal or not? What I will do in the examination hall? Same frequencies, hold on a bit. Sine, cosine. Phase shift is pi by 2. But another phase shift is there. What is that? This is having plus pi by 3 and this is having minus 2 pi by 3. So the phase shift is plus pi by 3 minus of minus 2 pi by 3. So that would be pi. So one phase shift is 90 degree, another one could be plus minus 180. I don't care, whatever it is. But I certainly know even if it is plus, then answer would be 270. And then if it is minus, then answer would be minus 90. So certainly it would be an odd multiple of pi by 2. And if it is an odd multiple of pi by 2, it will be orthogonal for sure. Say yes or no. Right? Same frequencies are there. I stopped there a bit. Sine, cos I saw 90 degree already I am getting. From here, how much I am getting? 180 degree. 90 plus minus 180. Either it would be minus 90 or 270. Certainly it has to be the odd multiple of pi by 2. And if it is the odd multiple of pi by 2, certainly it will be orthogonal. That's it. Okay. So this is what I need to do. Let's do by mathematics now. Time period again 4. Let's do the mathematics. So 24 will come out, but I will put it as 2 into sine A cos B. 2 into sine A cos B. So 2 sine A cos B will be equals to sine A plus B plus sine A minus B. Sine A plus B plus sine A minus B. Sine A minus B would be minus pi dot dt. Okay, sine A plus B plus sine A minus B. So pi by 2t minus pi by 2t, that would be equals to 0. Sine of minus pi. Sine of minus pi here. Right? 2 sine A cos B. So sine A plus B, sine A plus B, sine A plus B. So minus 2 pi by 3 plus pi by 3, that would be minus pi by 3 plus sine A minus B. So this minus this. So 2 minus 2 pi by 3 minus pi by 3 minus pi only would be there. Right? And you need to integrate over a time period of t naught, which is 0 to 4 seconds. So what is the value here? What is the value of time period here? 2. Right? So time period is 2 seconds here. But you are integrating from 0 to 4. So this will throw 0. What is the value of sine minus pi? 0 only. This is already 0, no? Sine pi is 0. Sine minus pi is 0 only. So 0 plus 0, answer would be 0. And what did we predict? We predicted it to be orthogonal. Is it coming out to be orthogonal? Yes. It is coming out to be orthogonal only. Why is that so? Because between sine and cos 90 degree, between pi by 3 to 2 pi by 3, there is 180 degree. Even if it is being added or subtracted, it will be an odd multiple of pi by 2. So orthogonal it will be. Right? You are seeing the conclusions now, right? Directly I will solve here. Try doing it on your own directly. Same frequencies, hold on a bit. Sinusoid, 0 phase shift. Sinusoid and sinusoid, 0 phase shift. But here there is a phase shift, right? Here there is a phase shift. So what is the phase shift? One is saying pi by 6, another one is saying minus pi by 3. So 30 degree minus of minus 60 degree. Phase shift is 90 degree. What it would be? Orthogonal. Now do the mathematics on your own. Do the mathematics on your own. 9 by 2 2 sine pi by 2t plus pi by 6 into sine pi by 2t minus pi by 3 dot dt. 2 sin a sin b, cos a minus b plus cos a minus b minus cos a plus b, cos a minus b, cos a minus b, and integrating over a time period of 4 seconds. Cos a minus b, cos pi by 2 minus cos a plus b, cos a plus b. Time period is 2 seconds. Cos pi by 2 already 0. Cos pi by 2 already 0. And this is a time period having 2 seconds integrated over 0 to 4. This will also throw 0. What is the answer? 0. That means it is orthogonal. And this is what we expected. Say yes or no. Right? Yeah, so let's try this one now. x1t is given, x2t is given. Both are complex exponential and n are integers. You need to let me know whether they are orthogonal or not. So there you need to consider two situations. One would be n equals to m, or you can say first one would be n is not equals to m, the second one would be n equals to m. Frequency is different, frequency is same. Basically, what is the frequency here? N omega naught, right? And what is the frequency here? M omega naught. Say yes or no. So if n is not equals to m, that means frequency would be different. If n is equals to m, that means frequency would be same. So let's try it out. What I need to do? Do I need to multiply x1 into x2? No. What I need to do? x1t conjugate with x2t. Say yes or no. Any of them I can do it. Either I can do x1 conjugate t into x2t, or I can do x1t into x2t conjugate t. Right? Why I am doing the conjugate? Because both are complex signal. So if there is complex signal, that means certainly I need to take the conjugate. Right? In the previous one as well, you need to take the conjugate, but they are real signal. So no need to worry about it. Right? So here, and I will integrate over a time period of t naught. So from 0 to t naught I will integrate. What is my x1t? Jn omega naught t plus e to the power minus j would be replaced with minus j, right, dot dt. From 0 to t naught e to the power j, omega naught t would come common, n minus m. So here what I can write down? E to the power j n minus m omega naught t dt, right? Let's keep it aside. Let's solve here. So if I integrate here e to the power j, can you do the integration of this thing? What is the integration of e to the power x dx? E to the power x only. So if I integrate this, what I'm gonna get? E to the power j n minus m omega naught t divided by j n minus m omega naught. Say yes or no. Right? And from 0 to t you are integrating, 0 to t naught you are integrating. Now e to the power j n minus m omega naught t naught minus e to the power j n minus m omega naught into 0, n minus n omega naught into 0, right, divided by e to the divided by j n minus m omega naught. Omega naught into t naught, what do you think, what will be the value of omega naught into t naught? What do I know? Omega naught is equals to 2 pi by t naught. So omega naught into t naught, what that would be? Is equals to 2 pi. And what do you think, what will be the value of e to the power j n into 2 pi? Basically, e to the power j 2 pi would be equals to e to the power j 0 only, no? Say yes or no? Because after 2 pi everything will be repeated. 0, 2 pi, 4 pi, or you can see minus 2 pi. Say yes or no. Are you able to understand this point? E to the power j theta, what is that? Cos theta plus j sin theta. This gets repeated after 2 pi. this also gets repeated after 2 pi. So e to the power j theta also gets repeated after 2 pi. So e to the power j would be equals to e to the power j 2 pi, would be equals to e to the power j 4 pi, would be equals to e to the power j 6 pi. So omega naught into t naught is 2 pi, right? Omega naught into t naught is 2 pi. And e to the power j multiple of anything 2 pi would be equals to 1. So this value is equals to 1. Are you able to understand this point? N minus m will be an integer. Integer minus integer, n minus m. Integer minus integer would be an integer. Let's just say n was 2, m was 4. So e to the power minus j into 2 omega naught t naught, that is 2 pi. So what is the value of e to the power minus j 4 pi? That is equivalent to e to the power j only, e to the power j 0 only, and that would be equivalent to 1. So the value will be 1, right? So what you are getting? 1. What is this? E to the power j only, because anything multiplied with 0 would be e to the power 0 only. That would also be equals to 1 divided by j n minus 1 omega naught, and that is coming out to be 0. So if it is coming out to be 0, what does that mean? It is orthogonal. So if frequencies are different, it will be orthogonal for sure. There is no doubt about that. And you could have verified in other way as well. How you could have verified? I am solving the option A only when n is not equals to m. So what was my x1t? X1t was, let's not break it down in this manner. Let's just do the integration over a time period. X1t was e to the power j n omega naught t. So if I break it down, how I will break it down? Cos n omega naught t plus j sin n omega naught t, and that will be multiplied with cos m omega naught t, right? That will be multiplied with the complex conjugate of x2t. So cos m omega naught t minus j sin m omega naught t dt. Now can you do the multiplication? This will be multiplied with this. Different frequencies, answer is 0. Cos n omega naught t multiplied with cos m omega naught t. Different frequencies over a time period t naught, answer would be 0. Cos is multiplied with sin. Different frequencies n and m. Different frequencies, answer is 0. Sin is multiplied with cos. Different frequencies, answer is 0. Sin is multiplied with sin. Different frequencies, answer is 0. So if the frequencies are different, always the answer is coming out to be 0. Basically, this will be multiplied with this, integrated over a time period, answer is 0. This multiplied with this, integrated over a time period, answer is 0. This multiplied with this, integrated over a time period, answer is 0. This multiplied with this, integrated over a time period, answer would be 0. So answer would be 0 only. In that manner also you could have done it, or by this method also you could have done it. Now n is equals to m. For the second case, n is equals to m. So you need to integrate over a time period t naught. So what is x1t? That is e to the power. So n equals to m, I am taking equals to k. Okay. So e to the power k omega naught t, e to the power k omega naught t is multiplied with e to the power minus j k omega naught t. Why is that? Why minus sign? Because I need to take the conjugate dot dt. What this will make? E to the power j theta into e to the power minus j theta. E to the power j theta into e to the power minus j theta. So e to the power j theta minus theta. E to the power j 0. What that would be? 1. So this value is 1. So what is this value? This value is 1. So 1 dot dt over a time period of t naught. So what is the answer? T naught. T naught is the answer, which is not equals to 0. That means it is non-orthogonal. So if frequencies are same, then they are non-orthogonal. If the frequencies are different, then they are orthogonal. Frequencies are same. Here different angular frequencies, and here same angular frequency. If the same angular frequency was there, then non-orthogonal. If different angular frequency is there, then they are orthogonal, right? Then they are orthogonal. Now someone would be having the doubt that, sir, what if I make them, what if my frequencies are same? What if this kind of question is there, that my frequencies are same, and what if my phi 1 minus phi 2 is pi by 2, or odd multiple of pi by 2, or I can say 2n plus 1 pi by 2. What if, sir, if in sinusoid and cosinusoid, what did I see? Here in sinusoid, cosinusoid, what did I see? If my frequencies are same, then there has to be a phase shift of odd multiple of pi by 2. If there is a phase shift of odd multiple of pi by 2, then it will be orthogonal, because here there was a shift of pi by 2 plus pi. That means the phase shift was of 3 pi by 2. So you are happy with that. Is that applicable for exponential function as well? Is that applicable for complex exponential function as well? That even if the frequencies are same, if my phase shift is a odd multiple of pi by 2, will that be orthogonal? So let's check that out. What I need to do? Just 1 second, guys, just 1 second. Yeah, so x1t conjugate with x1t is multiplied with the conjugate of x2t and over at time period, right? e to the power j omega naught t plus phi 1 into b e to the power j omega naught t plus phi 2 over a time period dt. What do you see here? E to the power j omega naught t, a into e to the power j omega naught t is there, plus e to the power j phi 1 into b e to the power minus j omega naught t is there, plus e to the power minus j phi 2 dt. So this and this is getting cancelled, right? Both will be getting cancelled. Here there is AB, so AB comes out for a time period of t naught, e to the power j phi 1 minus phi 2 into dt. Is this a function of t? No. So this is also a constant that can also come out. So AB into e to the power j phi 1 minus phi 2 into, now if this is coming out and you are integrating over a time period of t naught, so that would be equal to t naught. So what is the answer you are getting? This is the answer you are getting. Can this answer ever be equal to 0? Can this answer ever be equal to 0? Look, a and b cannot be equal to 0, right? If a and b are equal, that means x1t, x2t will be equal to 0. So that doesn't make any sense. So from here, a and b can certainly not be equal to 0. So if these are not equal to 0, t naught cannot equal to be 0. So what about this one? Can this ever be equal to 0? E to the power j theta, can this ever be equal to 0? No. It can be equal to j, it can be equal to 1, it can be equal to 1 by under root 2. It can never be equal to 0. Although it will be equal to j1 or anything, not 1 by under root 2. Because what is the magnitude of this thing? Magnitude of this thing is 1. It can never be equal to 0, right? You can't make it go down to 0. No matter what value you put here. No matter what value you put, it can never go to 0. So this is not equal to 0. That means even if the phase shift is pi by 2 or it is pi or it is anything, if your frequencies are same, then it will be certainly non-orthogonal. Non-orthogonal. So complex exponential and pure sinusoid cosinusoid both are different things. Are you getting this point? Complex exponential and pure sinusoid cosinusoids are both different things. So what is the conclusion? In sinusoid and cosinusoid, you need to look for the shift of pi by 2 if the frequencies are same. If the frequencies are different, no need to worry, your signals will be orthogonal. But if the frequencies are same, you need to look at the shift of odd multiple of pi by 2. In case of complex exponential, if the frequencies are different, orthogonal. But if the frequencies are same, then no matter whatever the shift is there, it will always be non-orthogonal. Say yes or no. Is that conclusion clear? Yes. So this is the conclusion we have written down. A sin omega, omega 1t, B sin omega 2t, C sin omega 3t, or you can write down D cos omega 4t. Whatever it is, if the frequencies are different, orthogonal. Frequencies are different, omega 1, omega 2. Don't look at sin, cos, nothing. Orthogonal. All are orthogonal. Now frequencies are same. Here frequency is same. Yes. Hold on a bit now. What you will look at? Sin and cos. Sin and cos is already giving me a phase shift of pi by 2. Now another phase shift that I am having, that is a multiple of pi. So phase shift could be 3 pi by 2, or it could be only pi by 2, or it could be minus pi by 2, but it will certainly be a odd multiple of pi by 2. So this will also be orthogonal. Did you understand this point? Right? Just conclusion I am writing down. Now this and this both are same, right? Now both are sin as well. So they are not giving you any phase shift, 0 degree phase shift they are giving. But here I am having the phase shift. Now they are saying that this phase shift is not equals to the odd multiple of pi by 2. It could be anything, but it is not equals to the odd multiple of pi by 2. So certainly it is non-orthogonal. But if this omega sine 0 degree phase shift, but this phase shift is, if it is equals to odd multiple of pi by 2, then it will be orthogonal. Always my task would be, if I see the same frequency, then I need to see the phase shift that should be odd multiple of pi by 2. If it is not odd multiple of pi by 2, then it is non-orthogonal. If it is the odd multiple of pi by 2, then it is orthogonal. Right? What about this one? Same frequency, same frequency. What is the phase shift? Pi by 2. Sine cos is there, so already pi by 2 phase shift is there. But now phi 1 minus phi 2 is not giving me equals to multiple of n pi. That means already I am having a phase shift of pi by 2. Now I am not getting multiple of n pi. I can get pi by 2 again. So if I get pi by 2 again, my total phase shift becomes pi. This is something that I don't want. Or I can get minus pi by 2, then total phase shift will become 0. Or I can get 3 pi by 2, the total phase shift will be 2 pi. Or I can get minus 3 pi by 2, total phase shift will be minus pi. So all these I don't want. If I want the odd multiple of pi by 2, that means I need to either add plus n pi or I should subtract n pi. So if my phase shift is not equals to plus minus n pi, then it will be non-orthogonal. I hope you are able to understand all these points, right? So you don't need to mug up anything. Whenever you see an example, it will be all clear to you. Now we are going to solve more examples. So directly you are going to tell me that whether it will be orthogonal or not. And if it is not orthogonal, then you need to break down in the set of orthogonal function. So how will you break it down? That I will tell you. Okay. Pi by 2, 3 pi by 2, pi by 6. Blindly you can put orthogonal. Pi by 2, pi by 2. Hold on a bit. Sine 0 degree phase shift. Pi by 3 minus pi by 6. Pi by 3 minus pi by 6. Pi by 3 minus of pi by 6. 60 degree minus of minus 30 degree, 90 degree. Orthogonal. Okay. Same, different. Okay. Pi by 2, 3 pi by 2. Different, blindly orthogonal. 3 pi by 2, 3 pi by 2. Same. Hold on a bit. Sine and cos. Sine and cos. Pi by 2. 2 pi by 3 minus of pi by 3. 2 pi by 3 minus of minus pi by 3. Pi. So it could be pi by 2 plus minus pi. So that would either give you minus pi by 2 or it would give you 3 pi by 2. And both you are fine with that. And if you are fine with that, this is also orthogonal. So this is also orthogonal. Okay. Same frequency I saw for sine cos, already pi by 2 shifted. Now I need the phase shift from here. I need the multiple of pi. And am I getting the multiple of pi? Yes, I am getting the multiple of pi. So I am happy with that. That means it is also orthogonal. So all these are orthogonal. What about this one? Same frequency. Look for sine cos, pi by 2. But here, what is the phase shift? Again pi by 2. So now pi by 2 plus minus pi by 2. What you will be getting? Either 0 or pi. And both of them you don't want. That means it is your non-orthogonal. Non-orthogonal. But now I can break my xt. How will I break my xt? Can I open this? Sine a plus b. Can I apply the formula of sine a plus b? Yes. I am applying the formula of sine a plus b. So sine a cos b. Sine a cos b plus cos a sin b. Cos a sin b. Plus 3 cos a cos b, cos a cos b, cos a minus b. That would be cos a cos b minus sin a sin b. Minus sin a sin b. Let's start again. Cos a plus b, sorry, sin a plus b, sin a cos b plus cos a sin b plus 3 cos a minus b. So cos a cos b minus sin a sin b. Because in all these kind of problems, there is very high chance of calculation error. Okay. So calculation error you don't need to do. So cos pi by 6, cos pi by 6, that would be cos 30. That is equals to under root 3 by 2. So under root 3 by 2 into sin pi t. So that would become under root 3 sin pi t, under root 3 sin pi t, right? Cos pi by 6 is under root 3 by 2. Sin pi by 6 is 1 by 2. So 1 by 2 into 2, that would be cos pi t, plus cos pi by 3. Cos pi by 3 is 60, that is 1 by 2. So 3 by 2 cos pi t, minus sin pi by 3. Sin pi by 3, sin 60, that is under root 3 by 2. So under root 3 by 2, so that would be 3 under root 3 by 2 sin pi t, right? Okay. So what you can see, sin pi t and sin pi t, what it would be? Under root 3 minus 3 under root 3 divided by 2. Under root 3 minus 3 under root 3 divided by 2. So under root 3 comes common, into 1 minus 3 by 2, that would be minus 1 by 2. So minus under root 3 by 2. Under root 3 minus 3 under root 3 by 2. So what it would be? 1 minus 3 by 2, that would be minus half only. So this is what we are getting. Plus 1 plus 3 by 2, what that would be? 5 by 2. 5 by 2 cos pi t. Now you let me know. Same frequency? Yes. But what is the phase shift between both of them? Pi by 2. So now they are becoming orthogonal. So a non-orthogonal signal and non-orthogonal sinusoid-cosinusoid signal has been broken down into orthogonal sinusoid and cosinusoid signal. Now in the power we can apply certain formula. When we study about power, at that time it will be highly used. So there I am not going to teach about orthogonality or orthogonal signals. There you should have a basic idea already that what do you mean by orthogonal signals. And if you already know the orthogonal signals, you would see, okay, it is non-orthogonal, so I will break it down into orthogonals. Now I can apply a certain formula. So that formula will be very easy, a square by 2 plus b square by 2. So here you cannot apply that formula, that 2 square by 2 plus 3 square by 2. That answer would be wrong. After you have broken it down, so this will be the value of a, this will be the value of b. Okay, a very good conclusion we are making from here. Otherwise, people just mug up some formula and they don't even know when to apply, when we don't apply, what is the meaning of phase shift. They just mug it up a lot of things, and then they find power calculation very difficult. But now we have built up good enough concept on orthogonality, and after that it will be just a cakewalk for us. Solve this question. Try doing it on your own. So here omega naught is 1, here also it is 1. Both are same. But what is the phase shift? Phase shift sin 0 degree, pi by 3 minus pi by 4. What is the phase shift? Pi by 3 minus pi by 4. So 60 degree minus 45 degree, that is 15 degree. So certainly not orthogonal, not orthogonal. So I need to break it down. What I will do? 2 sin A cos B. Sin A plus B, sin A cos B. Cos pi by 3. What is the value of cos pi by 3? Cos pi by 3 means 60 degree. So that is 1 by 2. Sin A cos B plus cos A sin B. Cos A sin B. Sin pi by 3. What is the value of sin 60 degree? Under root 3 by 2. Plus 3 sin A cos B. Cos B. Cos B plus cos A sin B. Right? So sin t plus 3 under root 3 by under root 2. So 1 plus 3 by under root 2 sin t plus here under root 3 by 2, and that is multiplied with 2. Under root 3 by 2 is multiplied with 2, so under root 3 we are getting, plus here 3 is multiplied with 1 by under root 2, and that is equals to cos t. Right? So sin t and cos t, what is the phase? 90 degree. So they are orthogonal. And after that you can apply your whatever the formula that you want to apply. Okay, so now they are orthogonal. So first you just break down in the sinusoid cosinusoid, then you see that sin t and cos t, 90 degree phase shift is there, orthogonal signals are there. I hope I have applied the formula correctly, because sin A cos B, in this kind of formula there is very high chance of getting the error. So here we should solve with good amount of patience. So 1 plus under root 3 by 2, 3 by under root 2 plus 1 by under root 2. So
3 by under root 2 is here, and 3 by under root 2 is here, and this is under root 3. Yeah, so orthogonal. Now I have broken it down into orthogonal signals. So that's it about our complete orthogonality. Okay, orthogonality we have studied. Now some basic mathematics we are going to see. Okay, you try this question, try breaking it down into two orthogonal signals. Everyone can do it. Okay, what is the meaning of orthogonal signal? That I need to break it down in a manner that x1t dot x2t, because both are real only, that should come out to be 0. Since they are non-periodic, so I will take the integration from minus infinity to infinity. How will I break it down into two orthogonal signals? So how I can break it down? I can directly see here. One I will break down from 0 to 2. One I will break down from 0 to 2. 0 to 2. And this point is 1. Okay. And another one would be from 3 to 4. From 3 to 4. This would be your x1t. This would be your x2t. If I multiply both of them, what I will get? From 0 to 2, this guy is something, but this guy is from 0 to 2, this guy is 0. So something into 0 would be 0. 3 to 4, this x2t is 1, but this guy is 0. From 3 to 4, this is 0. So 1 into 0 would be 0 only. So all integration would be 0. So both are orthogonal to each other. One into 0 is 0, something into 0 would be 0. So both are orthogonal to each other, and I have broken down the signal into two parts. Try this thing on your own. Basically, I need the formula of x1t plus x2t mod whole square. How you will break it down? How you will open it? That formula I need from your side. That's why we are taking this example. Okay, and a very good conclusion we will make out of it. So I need to drink some water, then I will come back. Yeah, so let's get started. So first we will solve this problem. Mode of yt square I need to find, right? So what I will do, x1t plus x2t whole square, this is what I need to find. What is my x1t? x1t is e to the power minus jt. What is my x2t? That is minus 2 e to the power minus jt whole square. That is equals to e to the power minus jt minus 2 e to the power minus jt. That would be minus e to the power minus jt whole square. What is the mode of minus e to the power minus j theta? E to the power minus j theta, what is the mode? 1. And if there is negative sign, that will be eaten up by the mode, right? Or you better take it 3 here. You better take 3 here, okay? So 1 minus 3, because this is not a problem that that is going to be asked in your examination. Here we need to build some conclusion out of it. That's why we are dealing it here. So this will be minus 2. So mode of minus 2 whole square, basically mode of minus 2, because what will be the mode of this guy? What will be the mode of this thing? That would be 1, 1 square, that would be 1 only. Mode of minus 2 whole square, that would be 4. So for this, answer would be 4. But how do I open it up? How do I open it up? I will open it up in this manner. Mode of x1t whole square plus mode of x2t whole square. Then what do you expect? 2ab, right? 2x1t into x2t. But no. What we will do? x1t into x2t conjugate plus x1 conjugate t into x2t. This is how we will open it up. A square plus b square plus 2ab. No. A into b conjugate plus a conjugate into b. This is how we will open it up, and let's verify. x1t whole square. Mode of x1t whole square. Just 1 second. Yeah, so mode of x1t whole square. Actually, I am having a bit cold. That's why I need to pause in between. Okay. So I hope like these are basic things only. So here even if your concentration breaks down in between, so that is fine. Basic mathematics it is. So the only motive of this problem is that how would you open this? How would you open if there is addition and then there is a mode? So a square plus b square plus a dot b conjugate plus b conjugate dot a, and we are verifying it as well. E to the power mode of e to the power jt whole square
plus minus 3 e to the power minus jt whole square plus x1t e to the power minus jt into x2t conjugate. What that would be? Minus 3 e to the power jt. Conjugate means plus j will be replaced with minus j, or minus j will be replaced with plus j. So minus 3 e to the power jt. Are you getting this point? Now conjugate of this thing, that would be e to the power jt, and conjugate of this thing, that would be e to the power. Sorry, here you don't need to take conjugate, it will come as it is. In conjugate only plus j is replaced with minus j. You are not going to do anything with this minus sign, right? You are taking the conjugate, that means plus j will be replaced with minus j. Here plus j is replaced with minus j. So let's see what is the answer we are getting. Mode of e to the power minus jt is 1. 1 whole square would be 1 only, plus minus 3 whole square, because mode of e to the power minus jt would be 1. 1 whole square will be 1 only, minus 3 whole square, that would be 9, plus minus 3 into 1, that would be minus 3, because e to the power minus jt into e to the power plus jt, e to the power minus jt into e to the power plus jt, that will get cancelled out, and 1 into minus 3 will be minus 3. Here e to the power jt and e to the power minus jt, that will cancel out, and 1 into minus 3 will be again minus 3. So 1 plus 9 minus 3, what you are getting? 4. So yeah, this formula is verified, right? This formula is verified. That how would you open this mode? So mode of x1t whole square plus mode of x2t whole square plus x1t dot x2t conjugate plus x1t conjugate dot x2t. So this you can see here, this is how it will be opened up. Mode of x1t whole square plus mode of x2t whole square plus x1t dot x2t conjugate plus x1 conjugate t dot x2t. And if x1t and x2t are real signal, what does that mean? That means this. If this is the scenario, then x1t plus x2t, how will you open them? That's our mode of x1t whole square plus mode of x2t whole square. Sir, plus I'm not gonna do 2ab, no. A into B conjugate. But what is the value of B conjugate? There is no meaning of conjugate here. Plus, or I will put conjugate for one side, plus A conjugate into B. But this value is equals to this value, and this value is equals to this value, right? So what you are getting from here? Mode of x1t whole square plus mode of x2t whole square plus 2ab, right? Because x1t dot x2t plus x1t dot x2t both are same, so 2ab. So only for real signal this is valid. Only for real signal you can break it down in this manner. Also, important point to notice is here there is mode, here there is mode, but here there is no mode. Okay, so always remember these two formula, this formula as well, this formula as well. If you remember this one, you can easily write down this one. So mode of x1t whole square plus mode of x2t whole square. Now whole square is gone. So now whatever the term will come out, that will come out without mode. That's it. Okay, so that's it about this lecture. In the next lecture, we are going to study about energy. So here we study about orthogonality and some basic mathematics we see. Okay, so now we need to study about energy, power and average. Thank you very much. Hi everyone, welcome to PrepFusion. So till now we have studied about aperiodic signal, periodic signal and orthogonality. So orthogonality was kind of a prerequisite for energy, power and area, and RMS value also you can say. So that previous video was very important. Now we need to study about energy. So in this video we will study about energy, a very straightforward topic, very easy topic. Okay, so how do you calculate energy of a particular signal? So energy is shown by E. It is not a function of time, it is a certain value. Energy is a certain value, it is not a function of time. Why is that so? Because you will be integrating from minus infinity to infinity. If I was integrating from a particular value from minus infinity to t, then it would have been a function of t. But now I am integrating from minus infinity to plus infinity. So I will integrate minus infinity to plus infinity. What I will integrate? So first I will take the mode of xt and then I will do the square. So this is what I will be integrating from minus infinity to infinity, okay, with respect to t, of course. So first you take the mode and then you take the square. Now some people would be having a doubt that, sir, if we are doing the square, then what is the meaning of mode here? Basically, let's just say my magnitude is minus a. So if I do the square, then eventually it will become positive only, no? Let's just say my magnitude was minus 3. So if I do the square, it will become positive only. So what is the meaning of mode here? Because what is the job of mode? To make anything positive, but square would make anything positive on its own. So why we are using mode? We are using mode because xt can be a complex signal as well, right? What if it is e to the power j omega naught t? So there the mode will be 1. So for complex signal we are using the mode. So what happens is that student eventually forget the formula. They say that it is x square t dt. This is what happens. But never ever forget it is mode of xt whole square. Mode of xt whole square. Okay. For real signal you can write down in this manner, x square t dt. But for any kind of signal in a general way, if there is an imaginary signal or you can say complex signal, then first you will take the mode, after that you will do the square. So now can you start doing the problem? Can you do this problem? Xt is given, you need to find the energy of this particular signal. What you will do? Mode of xt and then square. So mode of xt will be the same thing only, and you need to take the square. So if I take the square, what I mean to say is that let's keep it here for once. Yeah, so what will be my mode of xt square? Mode of xt square. So this value will become a square. That's it. 0 would be 0 only, 0 would be 0 only, a would become a square. Say yes or no. So this value would become a square. What I need to do? I need to integrate from minus infinity to infinity. Mode of xt square. So basically this function I am having, I need to integrate from minus infinity to infinity. That means I need to calculate this area, right? So what will be my energy? Energy will be a square into, what is this length, or you can say width, whatever you can call it. So 2t minus 3, and this is t by 2 minus 2t by 3, sorry, not 2t minus 3, minus 2t by 3 and t by 3. How much is this length? This length is t. Okay, so a square into t. So what is the answer? Area is a square, sorry, energy is a square into t. That's it. So this is what you need to do. Very simple thing, but just some certain results we are going to remember in this particular chapter or in this particular topic. You need to remember some certain results. That is the first result that you need to remember, and it is very easy. You will see this signal xt. Okay, a is there, a square into t. That's it. What about this one? What do you think? What will be the answer of this one? If you do the square of this particular signal, what you will get? Can you do the square of this particular signal? This will become a square and this will become 2a square, right? If I do mode of xt square, if I do mode of xt square. So if I calculate the area, what will be the total area? Area would be equals to energy. That would be a square into this width. What is this width? 3t by 2. Say yes or no. T by 2 minus t, 3t by 2. A square into 3t by 2 plus 4a square into t by 2. Okay. So 3a square t by 2 plus 2a square t. So what we are getting? 3.5. That means 7 by 2. 7 by 2 a square t. Very simple thing. Very easy, right? Just do the square and then calculate the area. What about this one? 3 rect t minus 3 divided by 4. Can you draw the graph of this particular function that is given? What is the rect function? T minus center upon the complete width. The complete width is 4. That means the width on one side would be 2. So this point will be 5 and this point will be 2. Say yes or no. Did you understand this point? I hope you remember the rect function. T minus center upon the complete width. So t minus center upon the complete width. Complete width will be 4. So, complete width will be 4. Really sorry. So 2 ahead and 2 backward. So complete width has to be 4. And the magnitude is 3. So this point is 3. This is my xt. So what do you think, what will be the energy? What I need to do? I need to take the square of it. What that would be? 9 into the width 4. 36 joule. What is the unit? Unit is joule. Okay. So previously also you can write down joule. 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 Okay. Very simple, right? So from here only you could have seen 9 into 4, because what you need, just the magnitude into the width. So that would be 36. So if this kind of function is given and this length is, this is from there, from minus alpha 1 to alpha 2, or it could be from anywhere. Basically the width you need to calculate. This width you need to calculate. Now this width here is coming out to be alpha 1 plus alpha 2. And the magnitude here is A. But what I need to do when I calculate the energy? When I calculate the energy, I need to do the square. So what will be my energy? A square into alpha 1 plus alpha 2. Let's just say if this A was negative, what I am saying, this magnitude was negative, still the answer would have been the same, right? If this A was negative, still the answer would have been the same, because if you do the square, it will become positive only. What if here there was a minus sign? So what would have happened? This would become minus 3, right? If there was a minus sign here, so this would have become minus 3. This would have become minus 3, right? This width remains 4 only. Now, if I do the square of minus 3, if I do the square of minus 3 here, minus 3 square, what it will become? It will become positive only, 9 into 4, 36 only, right? Are you getting this point? Now, find the answer for this one. A sine pi by 2t, ut minus ut minus 2. Basically, this particular function is being multiplied with this particular function. Can you draw the graph of this particular function? Yes. Ut t minus 2. That means it will start at t equals to 0. It will start at t equals to 0. And then there is a jump of 1 at t equals to 0. And then it will be having a decay of 1 at t equals to 2. So this is the graph of this particular function, right? And can you draw the graph of this particular function? A sine pi by 2t. A sine pi by 2t. What is the time period here? 4, right? 2 pi divided by pi by 2. Time period is 4 here. Time period is 4. So what kind of function you will get? This kind of sinusoid you will keep on getting at this place as well. So this is 0, this point is 4, this point is 2. Now this particular function is being multiplied with this particular function. You can call it rect pulse. It is like a rect pulse only, you know. This is a rect pulse only. So this function is being multiplied with this rect pulse. So what do you think, what will be the final answer? Whatever that is greater than 2, that will be multiplied with 0. All these values will be multiplied with 0. Although it is there till infinity. This is there till minus infinity. This point is actually minus 2, minus 4. So whatever that is greater than 2, that will be multiplied with 0. And whatever that is less than 0, that will also be multiplied with 0. And whatever that is there between 0 to 2, that will be multiplied with 1. Whatever that is there between 0 to 2, this amplitude is A here, right? This amplitude is A here. This amplitude is A. So whatever that is between 0 to 2, that will be multiplied with 1. So if I multiply both of them, what will be my resultant? My resultant will be having a simple sinusoid pulse. I can call it a sinusoid pulse is there. That's it. Only this much part is there when I multiply both of them. Just a second. Yeah. So this will be your xt. Okay. And this point is 0. This point is 2. Say yes or no. Right. Now what I need to do? Square this. What is my energy? Minus infinity to infinity. Mod of xt square dt. Will I write down in place of mod of xt square? Will I write down a here? No. I will not write down a. I will write down a sine pi by 2t. Here, why did I write down a directly? Here, in this particular problem, why did I directly calculate the area? Because for this window from minus t to t by 2, it was always a. But here this is not the scene, no. Here for 0 to 1, at 1 it is a, at some other value it is some other value, at 1 by 2 it would be some other value, at 3 by 4 it would be some other value, at 3 by 2 it would be some other value. So you cannot write down it as a, right? Mod of xt square, that doesn't mean it would be a. It is a sine pi by 2t. It is a sine pi by 2t, a sine pi by 2t whole square dt. But the limit will be from 0 to 2, because apart from that it is 0 only. From minus infinity to infinity I was putting the limit, but now I can put the limit from 0 to 2, because apart from that it is 0 only, right? So what I will be left with, let's try solving it. So what I will be getting, a square 0 to 2 1 minus cos pi t divided by 2. I hope you would have understood how did I write it down, right? You understood or not? 0 to 2 sine square pi t, it was sine square pi by 2t, right? Sine square theta, what that would be, 1 minus 2 1 minus cos 2 theta divided by 2, because cos 2 theta is equals to 1 minus 2 sine square theta. So that certain formula I have applied here. So should I keep this integration on you? Can you draw the diagram of cos pi t, and will you be able to let me know what will be the value of this integration? Because these kind of integration we have already seen in the last video, right? So what we will do here, 1 by 2 I can keep aside, 1 by 2 dt from 0 to 2 minus cos pi t by 2 0 to 2 dt. What is the time period? 2. Time period is 2, and you are integrating for one time period. That means this will be equals to 0. Here the time period is 2 and you are integrating for one time period only. That means this value will be equal to 0. And if this value is equal to 0, what does that mean? From here, what is the answer we are getting? So a square into 1 by 2 into 2. So what is the answer we are getting here? Energy is a square by 2 into 2. So first thing, I will keep this answer in my mind. Okay. And actually the answer is coming out to be a square. Look, we will make interesting conclusion out of it. You will not have to remember all these results. Basically, sorry, you will not have to do all these calculation in the examination. We will remember certain results, and for that as well you will never have any confusion that, sir, how would I remember all the results? For that as well I will tell you a trick. Okay, no, not trick, I will tell you a concept only. So you will be able to remember the results. Just the point is, as of now you need to see the calculation only, that how we are doing the calculation. Try doing the same calculation for this particular problem, and you will understand why did I write it down my energy in this form. When you solve this problem, you will understand why did I write it down, why did I write down my energy in this form. So try doing it. Sin t into ut minus pi. So can you draw the graph of sin t, how it will be looking like? In that manner it will be looking like, right? Sin t, this point will be 0 and this point will be pi. And how will the graph of ut minus pi would look like? This is how the graph would look like, from 0 to pi, with the amplitude being 1. Okay. Now both will be multiplied. That means whatever that is there between 0 to pi, that will be multiplied with 1. Rest all will be multiplied with 0. Here I should keep a. Here I should keep a. Okay. So what will be the resultant graph? Resultant graph will be same as this. Right. Now what you need to do, you will integrate energy minus infinity to infinity, a square sine square t dt. Did you understand what did I do here? What is the energy? Mod of xt whole square. So minus infinity to infinity. Now I can change the limit actually. Where will I put the limit? I will put the limit from 0 to pi. I am putting the limit from 0 to pi. Look, we are integrating with respect to t, not with respect to omega t. Look, those who have previously studied this subject, they would have always confused in this particular problem that sir, the limit is from 0 to pi. So pi is an angle here. So sir, here I should put angle. No. The limit is of t, no? Where did you make the graph? X of t versus t. So how you can say the limit is of angle here? Limit is of t, where t is going from 0 to 3.14. So this is not showing 180 degree here. This is showing 3.14. Okay, are you getting this point? So this confusion will be clear. No need to worry about that. When you see the results, it will be clear to you. So yeah, a square, we will be integrating from 0 to pi. So what we are getting? 1 minus cos 2t by 2 dt. So same thing is happening here. Ditto same thing. This 2 can come outward. A square by 2. Then you need to integrate 0 to pi dt, and then you need to integrate cos 2t dt from 0 to pi. So what is the time period here? Pi. That means you are integrating for one time period. You are integrating for one time period, and if you are integrating for one time period, that means this will give you the value 0. So what we are getting here? What is the energy you are getting? A square by 2 into this value. What is this value? This is pi. 0 to pi dt. What that would be? Pi only. A square by 2 into pi. This is the answer you are getting. So what did you understand from here? Here your width was 2. What was your answer? A square by 2 into 2. Here your width is pi. What is my answer? A square by 2 into pi. If my width is alpha, what will be the answer? A square by 2 into alpha, right? So if this is the scene, that this particular lobe is given, this particular lobe is given, so what will be the answer you will be putting? Sir, the energy would be a square by 2 into, what is this width? This width is alpha 2 minus alpha 1. Will you be able to remember it? Look, just tell me one thing. If it was a square, let's just say it was a square box of amplitude A. If it was a square box of amplitude A and the width is, let's just say I am calling the width to be, this width I am calling to be alpha. Okay. So what would have been the energy? A square into alpha. Now what is there? A sinusoid is there, or it could be cosinusoid as well. What I mean to say is that it could be some structure like this as well. Basically this lobe, this kind of lobe will give you a square by 2. So that if I need to make this kind of lobe, what I am saying lobe, L-O-B-E, lobe. The word I am using, that is lobe. So this kind of lobe, if I need to make with an amplitude of A, so this is how I will be making it, no? How I will be making it? This is how I will be making it, right? So certainly whatever the area this guy is enclosing, whatever the area this square box is enclosing, whatever the area this square box is enclosing, that would be certainly more than this particular lobe, say yes or no. And that is simply the double. Okay, so here this arrow is not correct. This arrow should be here, that this square is giving you a square into alpha, but now this particular lobe will give you a square by 2 into alpha. Say yes or no. Now what if I make a triangle? What if I make a third triangle with the third structure I am making? Okay, first it was a square, then it was a lobe, now it would be a triangle. And triangle I am making such that the peak amplitude is A. So how will I make it? This is how I will make it, right? So what do you think? The triangle will have more area or lesser area? The triangle will enclose more energy or lesser energy? Lesser energy, right? Square would have the maximum, then this sinusoid lobe will have, and then this triangle will have. You can directly see it here, no? This guy was enclosing this much, then your lobe was enclosing this much, and now your triangle is enclosing this much only. So for triangle it will come out to be, a square by 3 into alpha. So a square by 2, a square by 3, a square by 1, a square by 2, a square by 3. I don't think it would be very tough for you to remember, right? Although for triangle we did not prove it, we will prove it as well, but here only I am telling you the results. So now I guess it will not be tough for you to remember the result for this one. A square by 2 and whatever the width is there, that is the energy. This is not the area of this particular thing, no. This is the area of mode of x square t, a square by 2. a square by 2 is the complete a square by 2 into this width, that is the area of mode of xt whole square, okay, not of xt. Are you able to remember this thing? Like this area is mode of xt square. Here I am drawing the xt. Actually, I should have first drawn the mode of xt, then I would have taken the square, and after that I would have written down this final answer. Okay. And what if they give only this much lobe? So what do you think? What will be the answer? Half of this, right? What I am saying, if they reduce the lobe to half in that manner, if they cut it right from in between, so what will be the answer? Half of it. Say yes or no. Okay. So all these kind of examples we can see there. So no need to worry about all these examples. Okay. Let's go to this one. Triangular. A triangular T minus center upon width of one side. Right. Can you draw this diagram? Certainly I can draw. So whatever that I showed previously, that thing only we need to prove now. So this would be A. This is your xt. T minus center upon width of one side. So total width will be 4. Now just tell me one thing, guys. I need to integrate. What I need to do? Energy I need to find. So my step is minus infinity to infinity mode of xt whole square dt. Now I know that this function is going from minus 2 to 2 only. So in place of writing minus infinity to infinity, I can write down minus 2 to 2. Can I reduce it like this? 2 into 0 to 2 mode of xt whole square dt. Can I reduce it like this? I am not integrating from minus 2 to 2. I am integrating from 0 to 2. Because whatever the area this will enclose, the same area this will enclose. Although first I need to do the square. This I am talking about xt only. What I need to do, first I need to do the mode of xt square. And after that I need to see how much area it will be enclosing. But I am pretty sure that it will be symmetric. Whatever the area that is enclosed from 0 to 2, the same area is enclosed from minus 2 to 0 as well. Say yes or no, right? Okay. So now for this particular from 0 to 2, what is the value of xt? I cannot say it is A. No, it is this line. From 0 to 2, what is the equation of xt? That is this line. So what is the equation of this line? So if t is from 0 to 2, so what is the value of my xt? That is, how do I write down the equation of line? Y equals to mx plus c. So what is the slope here? The slope here is minus a by 2, right, into t plus whatever the point it cuts on y axis. So this equation I have already told you how to write down this equation. I hope you know how to write down this equation. What is the slope? Minus a by 2. Del y divided by del x. So minus a by 2 is the slope into t plus whatever the point it cuts on y axis, that is a. Now what I need to do? Here I need to do the square. If I take mode of xt, it will not make any impact because it is already positive. This is already positive, right? So mode of xt doesn't make any sense for me. What I'm going to do? Minus a by 2 into t plus a square into dt. So from 0 to 2, a square by 4 into t square plus a square minus a square into t into dt. A square plus b square plus 2ab, that I am applying. So a square by 4 into t square plus a square minus plus 2ab. So here there is a minus sign. So this 2 will be getting cancelled out and minus a square t will be coming here, right? So this calculation you can do on your own. I hope this much calculation is easy for you, right? So here I will just keep it aside and I will write down the energy. So 2 into a square I can take common. So 2a square I am taking common. So what I am getting, 2a square is taken common. So here we are getting t to the power 3 divided by 12 plus t minus t square by 2 from 0 to 2.
Okay, so 2a square, then 8 by 12 plus 2 and minus 2. I'm just putting the limit, nothing else. Okay, this is simply mathematics that I am doing. That's why I'm not explaining it. So just put the limit, 8 by 12 plus 2 minus 2. This is what we are getting, right? So what we are getting, 4a square by 3. Say yes or no. And can I write it down in this manner? A square by 3 into 2 minus 2 into 2 minus minus 2. Basically this width is 4. So a square by 3 into 4. Can I write it down in this manner? A square by 3 into 4. So this is the answer we are getting. Okay, 4a square by 3 you can say, or I am writing it down as a square by 3 into 4. This is what I told you here. A square by 3 into the width. Now the next doubt would be coming into the student, sir, what if the structure is like this? Sir, what if the structure looks like this? Here it was a triangle like this. But now what if the triangle is like this? Triangle is like this. Okay. So in place of t, here I am putting 4 only. In place of t, what I am doing? I am putting here 4. So try doing it on your own. In place of t, here there is 4. So do you think the answer would be half? Like here you are getting a square by 3 into 4 divided by 2. Because you feel like that, sir, it is half of this particular structure. So answer should be half. Do you think like that? If it was full, let's just say if it was full, if it was like this, I will use white color of pen. If it was full like this, minus 4 to 4, then what would have been the answer? If it was from minus 4 to 4, what would have been the answer? Sir, a square by 3 into 8. Now it is half of that. That means divided by 2. So what is the answer we are getting? A square by 3 into 4. This is the final answer. Did you understand what did I do here? If I am saying it was a triangle like this, not like this. This is a right angle triangle, right? But I made it a full triangle like this. So if it was a full, then what would have been the answer? A square by 3 into the width. Width is 8, but it is half. So it should be divided by 2. So what is the answer? A square by 3 into 4. So what did you understand from here? What point did you understand from here? Here, instead of dashed line, I should have made a dashed line here, right? Otherwise, in the notes, you will be getting confused. So what point did you understand from here? That in the examination, you only need to look at the triangle. If you are getting the triangle, your job is done. What you need to do? A square by 3 into the width. No matter whether the triangle is like this or it is like this. Are you getting this point? And just try thinking, if the triangle is like this and the width is 4, just push this triangle. What I am saying, just push this triangle. Just push this triangle from here. You will get the same structure. So, or you can think in the another manner, that what is the area enclosed by this triangle? That would be half divided by base into height. That area would be 2a only. Say yes or no. And what will be the area enclosed by this particular triangle? That would be half into base into height. That would also be 2a only. Area is same. So the square of area is also the same. If area is same, the square of area, no, square of area I should not say, square of function and then area. Square of area would be different, right? Here I am saying square of area, that would be 4a square. That is a different quantity. I should not say square of area, I should say function square and then area, right? First I will take the square of function and then I will calculate the area. So are you understanding my point, that both structures are same only? This structure and this structure both are same only. So just in the examination hall, you just need to see the triangle and you need to apply this formula, a square by 3 into the width. Okay. So if you see this kind of structure, what will be your answer? For energy, this graph we are drawing for xt. This is not the graph of mode of xt square. This is the graph of xt. Okay. Which graph is that? Xt graph is that. So if you see this xt graph in the examination hall, what will be your answer? A square by 2 alpha 2 minus alpha 1. If you see this one, what will be the answer? Sorry, not a square by 2, a square into alpha 2 minus alpha 1. If you see this one, what will be the answer? A square by 2 minus alpha into alpha 2 minus alpha 1. If you see this one, what will be the answer? A square by 3 alpha 2 minus alpha 1. And if you see this one, what will be the answer?
a square by 3 alpha 2 minus alpha 1. Will you be able to remember all these things? And no matter, even if the amplitude is negative as well, the same answer would be there, because what we are doing, we will be taking the square. So if the amplitude is negative, still the answer would be same. Will you be able to remember all these kind of things? I don't think it would be too tough for you. Square, a square. Sinusoid lobe, a square by 2. Triangular, a square by 3. And then multiply with the width. Okay? Well and good. Find the energy of the following functions. So these are very, very important from the in the examination. The questions will be coming right from here. Like straightforward, some people will be calculating it, but we will be remembering it. Only 3 formula I am asking you to remember. And I don't think it is tough as well, because I have told you the way as well, that sinusoid will be inside and then there would be triangular. So certainly maximum area will be enclosed by your square, then the sinusoid, and then the triangular. A square by 1, a square by 2, a square by 3. Don't forget to multiply with the width. The width is alpha 2 minus alpha 1, alpha 2 minus alpha 1, alpha 2 minus alpha 1, alpha 2 minus alpha 1. What do you think? What will be the energy of these following functions? Try doing it on your own. First one, step. Energy I need to calculate. Minus infinity to infinity, mod of ut square dt. One thing I know, that ut goes from 0 to infinity. 0 to infinity. What is the value of ut? 1. What is the answer we are getting? Infinity only. Right? Mod of ut is 1, 1 square, 1 would be, it would be 1 only. So t 0 to infinity. What is the answer? Infinity only. So what is the energy? Infinity. How you can see it? If you see the graph of ut, if you see the graph of ut, this is the graph of ut, and it will keep on going till infinity. And if I calculate the energy, that means I need to do the square and then I need to see the area. So what I am seeing here, the area will just keep on increasing. If I move in the direction of t, from minus infinity to infinity, if I move, my area will keep on increasing and it will go to infinity. Here the area would be something different. Let's just say this point is 1. So area would be 1. This point is 2. Area would be 2. Then 3, 4, 5. And with the respect to time, the area will keep on increasing. That means the energy will be going towards infinity. So try doing the same with RT and sin t. I will drink some water, and you try doing the same with RT and sin t. RT you will be able to understand, but think about sin t as well. That would be a very good point. What will be the energy of sin t? Okay, will that be a square by 2 into something or something else? So try thinking about it. I will drink some water and then I will come back. So what was your answer? Your answer was infinity here and infinity here. So how did you do it? For the second one, again from minus infinity to infinity, r of t mod of r of t whole square dt. But I am going from minus infinity to infinity. But rt is defined from 0 to infinity only. So here I will put 0 to infinity. What will be rt from 0 to infinity? That would be t only. So t square into dt from 0 to infinity. What I will be getting? T cube by 3 from 0 to infinity. What will be the answer? Infinity only. And you see here now. What is the graph of RT? This is the graph of RT. Right? So first thing, you will do the square, and when you do the square, after that you calculate the area. RT will keep on increasing. That means here the area will also keep on increasing. So it will go towards infinity only. Right? It will go till infinity. Right? RT versus T I am doing. What about sin t? What is the graph of sin t? This is the graph of sin t, right? But do you need to calculate the area of sin t? No. You need to calculate the area of sin square t, right? You need to calculate the area of sin square t. What does that mean? That I need to take the square. So this negative part will become positive part, right? If this point is minus 1, if I take the square, it will become plus 1. So negative part will become positive part. Are you getting this point? Until infinity, I need to keep on adding the area. This part will become positive part. This part will also become positive part. This part will become also positive part. Although the graph will not look like this because it is a square. Here previously, if the value was 1 by under root 2, that value would become 1 by 2. So the graph will change a bit. But what do you see here? This area would keep on adding. This area will add. This area will add. This area will add. This area will add. Same thing will be happening in the negative side as well. This will also become positive. Then again positive, again positive. So areas will keep on adding, and that will be going towards infinity only. So what will be the answer of C? That will also be infinity. right? So what did you understand here? That this was your periodic signal. This was your periodic signal. All the periodic signal will have infinity energy. That's for sure. All the periodic signal. You take any random example of periodic signal. Any random example we will take. What is the meaning of periodicity? What is the first condition for periodicity? That it should be repeating itself, but from minus infinity to infinity. Say yes or no. That means your function is spread from minus infinity to infinity. So let's just say I take this example, that this function is being repeated. This particular function is being repeated from minus infinity to plus infinity. Now what I need to do? This is my xt. Let's just say this point is a, this point is minus a. So first I do the mode and then I will take the square. So if I do the mode and take the square, what will happen? This minus a will become plus a and then the square, a square. So whole function will become a square only. Are you getting this point? What I am saying, I need to first take the mode and then do the square. So this was a, this was minus a. So this will also become a square. This will also become a square because minus a square would become a square only. So from 0 to t by 2, it would be a square. From t by 2 to t as well, it would be a square. So whole function would become a square. Now if you calculate the area, what will be the area? Infinity only. So there could be no periodic signal which will give you finite energy. There could be no periodic signal which will give you finite energy. All the periodic signal will give you infinite energy. The reason is clear, because the function will be repeating itself, and even if the function is having a negative value, but once you do the square, the value will become positive. And if the signal keeps on repeating, that means the area will keep on adding up. The square area will keep on adding up, and if the area keeps on adding up, it will go towards infinity only. Is that clear to you? Say yes or no, right? So every periodic signal will give you infinite energy. Now what about this signal ut? Ut was still existing at t equals to infinity. That means at t equals to infinity, ut was not 0. What I am saying, at t equals to infinity, ut was not equals to 0. Same goes for rt as well. At t equals to infinity, rt was also not equals to 0. Look, ut is periodic? No. Rt is periodic? No. Both are not periodic. Still you are having infinite energy. So infinite energy doesn't mean that signal will be periodic. Even if the signal is not periodic, still the energy could be infinity, right? In ut and rt you see. But in ut and rt you see one thing, that is that at infinity they are not equals to 0. They are having a finite value. Okay? So they are spreaded from 0 to infinity. But at infinity they are having a non-zero value. I should not say finite value, I should say they are having a non-zero value at t equals to infinity. Rt is having infinite value actually, and t is having a non-zero value. So that means at t equals to infinity they are not equals to 0. And if there is any function which is not equals to 0 at t equals to infinity, that will also give infinite energy. If there is any function which is not equals to 0 at t equals to infinity, if it is not equals to 0 at t equals to infinity, it will give you infinite energy only. And you are able to think it as well, right? You will be able to think it. Just take any random example. Let's just take this example. You need to do the square. You will do the square. This a will become a square. This will also become something. You need to do the square and then you will calculate the area. So this area will be a finite non-zero value. But here the area will keep on adding up. Area will keep on adding up. It will keep on adding up, and where it will go till infinity. If it is like this, so area will keep on adding up, keep on adding up, keep on adding up. It will go towards infinity only. So do you need to mug up all these things? Whatever the points that I am telling, do you need to mug it up? No. You just need to think in the examination hall. Okay, periodic signal is there. It will keep on repeating. Square I will take, area, infinity. ut, rt. That means at t equals to infinity, they are not giving you t equals to infinity or t equals to minus infinity as well. What I mean to say, what if the function is like this? What if the function is like this? So this will give you a finite area, but this will keep on adding up and this will give you infinity area. So you just need to see at minus infinity and plus infinity. At minus infinity or plus infinity, if your signal is not equals to 0, that means the square area will keep on adding up, and the square area will keep on adding up, it will give you infinity. Say yes or no? Okay.
So you don't need to mug up all these things, you can think in the examination hall. And when we study periodic signal, after that we will write down all the results. Basic, no, sorry, not periodic signal. When we study about power, after that we will write down all these kind of results. As of now, you just see it and just keep it in your mind. We will certainly write down all the results, that for periodic signal, what will be the energy, what will be the power, for non-periodic signal, which is absolutely integrable or which is bounded in time, which is not bounded in time, what will be the energy, what will be the power, all these kind of statement we will write, but after studying the power. Okay, once we are done studying the power, after that we will write down all these points. All good? What will be the energy of this one? So this will give you any finite area, although first I need to do the square. Then I would get to know that this will give me a finite area, but this will give me infinity, right? So what will be the energy? Energy will be infinity. E to the power minus 80 ut. Try thinking about it and calculate the energy. E to the power minus 80 ut, you can draw the diagram, right? Ut is connected, that means it will be going from 0 to infinity only. E to the power 0 is 1. E to the power infinity is 0. Look, this function is also spread till infinity only. Here let's put a. Okay, let's put a here. So at t equals to 0, the value will be e. This signal is also spread till infinity, but at t equals to infinity, here xt is equals to 0. Okay, so let's find out the energy. Let's see whether it is coming out to be non-zero, sorry, whether it is coming out to be infinity or not equals to infinity. So let's check that out. So energy, that would be equals to minus infinity to infinity mod of xt square, right? So mod of xt square. Look, mod of xt I need to take, and then I need to take the square. So it will be positive only, no? Mod of xt is already positive. So what I can do? A square e to the power minus 280. What I am doing? I am just taking the square. Nothing I am doing, I am just taking the square into dt. And from 0 to infinity, I will put the limit, because I know that from minus infinity to 0, it is 0 only. So a square 0 to infinity e to the power minus 280 dt. So a square by minus 2a e to the power minus 280 0 to infinity. A square by 2a e to the power infinity is 0 minus 1. So what is the energy we are getting? A square by 2a, which is finite. Why did that happen? Why the energy is becoming finite? Because it is not going towards infinity. Here you can see that this much energy is bounded in this particular box. You can say box, or you can say in this loop, this much energy is bounded. If I see the previous examples, if I see these examples, so here I can say that this much energy is bounded in this box, this much energy is bounded in this lobe, this much energy is bounded in this triangle, this much energy is bounded in this triangle. In these examples, what is happening? This much energy is there and it is not bounded. This much energy is there, it is not bounded. In sinusoid, you can say that in one lobe it is bounded. In one lobe the energy is bounded, but a lot of lobes are there. So a lot of energy are there, 1, 2, 3. So all these bounded energy, what will be this bounded energy? That would be a square by 2 into, let's just say this width is t. So a square by 2 into t. But that will be multiplied with infinity. Are you getting this point? A square by 2 into t, a square by 2 into t, a square by 2 into t, infinite times. Here the ut function can also be broken into pulses. I can break it into pulses like this. Ut I am breaking into pulses. Basically from 0 to t I can say 1 pulse is there, from 0 to 2t 1 pulse is there, from 0 to 3t 1 pulse is there. So a square into t, then what is the width here? Again the width is t. So a square into t, then again the width is t, a square into t. In that manner it will be added till infinity time. So what will be the answer? Infinity only, right? And now the next example that we saw, what was the example there? The next example that we saw here. Here you can see that at infinity actually xt is going to 0. So energy could be bounded here. Whatever the energy is there, that would be bounded in this particular loop, or you can say in this function only.
So energy is not going towards infinity here. Although the signal is non-periodic, although the signal is spread till infinity, right? The signal is spread till infinity. It is spread from 0 to infinity. Still, you are getting the finite energy. The reason is, what is the reason? The reason is that it can bound the energy. Okay. So if you want to remember this answer, you can remember it. People actually remember it actually. Okay. A e to the power minus at ut, they remember the answer, the energy would be a square by 2a. But within seconds, you can derive in the examination as well. So if you are not able to remember it, it is fine. Because I myself do not prefer remembering this answer. I myself would have derived in the examination. Okay, are you getting this point? I remember the answer for these. A square, here it is not required. I remember the answer for these two. But for this one, I prefer deriving it because this is exponential. No, exponential integration is very easy. So a square by 2a there, I would be able to derive it. Say yes or no. Okay. Now do this one. Tell the answer on your own. Here also keep a. Or let's keep b here. So t equals to 0, value will be b. At t equals to minus infinity, because it is being multiplied with u of minus t. It is being multiplied with u of minus t. Right? This would be the graph. What do you think? What should be the answer? Do I need to calculate it? The same structure is there, no? Whatever the energy, this will bound. The same energy, this will bound. Ditto the same thing is there, no? Ditto the same thing. So what will be the energy? B square by 2a. That's it. Or you can derive it as well. You can put the formula from 0 to infinity. Not 0 to infinity. Really sorry. Minus infinity to 0. Minus infinity to 0. Minus infinity to 0. Okay. From lower to higher limit we need to take. From minus infinity to 0. B square a to the power 2at dt. B square by 2a e to the power 2at minus infinity to 0. What we will get? B square by 2a. That is the energy. Okay, that's it. This is the answer. Right? What if I ask you this question? If your xt is, what I am saying, your xt is e to the power minus at. This is your xt. No ut, nothing. E to the power minus at. What will be the energy? What will be the graph of it e to the power minus at? At t equals to 0, it will be 1. At t equals to 0, it will be 1. At t equals to infinity, it will be 0, because e to the power minus infinity will be 0. At t equals to minus infinity, what it would be? E to the power infinity. So the graph would be exponential like this. Okay, the value is 1, this value 1 I am showing here. The graph would be exponential like this. What do you think? What will be the energy? Infinity. Say yes or no. The energy here will be infinity. Why it is infinity? Because you can see that at t equals to minus infinity, at t equals to minus infinity, here xt is not equals to 0. Because this will give you finite, okay, finite, but it will just keep on adding up, and the energy will go to infinity. So what will be the answer here? Energy will be infinity. So just if you see exponential, that doesn't mean you will say that energy would be finite. You need to see whether ut is connected, u of minus t is connected or not, whether my signal is bounded or not. So this is becoming this is becoming unbounded. Inbounded is not a word. Unbounded. So this is becoming unbounded, because at any point of time, if the function is going towards infinity, then it will be unbounded. Any point of time. At any point of time, if the function is going till infinity, that means it would be unbounded. So for unbounded signal, your energy will be infinity. Can the energy be 0? No. If there is function, then energy, there would be certainly some energy. Energy can never be 0. What I am saying, can the energy be 0? Infinity energy was there, a square by 2a energy was there, a square by 2, these energy were there, but energy can never be equals to 0. Right? Energy can never be equals to 0. Okay, it could be infinity, it could be anything else, but it can never be equals to 0. Let's do this one. Find the energy of this particular signal. Okay, so
You need to find the energy. What you will do? What is the formula? Energy of xt minus infinity to infinity mode of xt square dt. I need to take the mode. I know that this is just a pulse. This is just a square pulse. How this square pulse will look like? This is how the square pulse will look like. It is from 0 to 2 pi. It is from 0 to 2 pi. So this pulse is there just for the sake of making this as bounded. Basically, you need to take the limit from 0 to 2 pi now. This is what they are saying. You need to integrate this function only, but take the limit from 0 to 2 pi. That's it. This is the job of this pulse now. Because this pulse will be multiplied with this function. Can you draw this function on xt versus t? No. You cannot draw xt versus t because this is a complex signal, right? 3 to the power j 2 pi t. It will be a complex signal. It will be drawn as a circle. Although in 2D it will be drawn as a circle. In 3D it would be like this, that here there will be a circle and it will keep on moving ahead. We have seen it, right? We have completely seen, we have spent 1 hour only in understanding this particular complex exponential function, right? So that 1 hour we have spent. So you know that I cannot draw it with respect to only t. Xt versus t I cannot do here. I need 3 axes here: real, imaginary and t. This function will be multiplied with this pulse. That means it will be there from 0 to 2 pi only. That's it. It will be there from 0 to 2 pi. And now what I need to do? What I need to do is that I need to take mode of this xt. What will be mode of this particular signal? This will be the mode of this particular signal, right? So mode of 3 e to the power j 2 pi t square. So what will be the mode of AB? Did I tell you this thing? That mode of AB can be written as mode of A into mode of B, and then there is a whole square. So this whole square I can put here. That means it can be treated as mode of A square plus mode of B square. So 0 to 2 pi. Let's make it minus here. Let's make it minus. Let's make it minus. So 0 to 2 pi minus 3 whole square e to the power j 2 pi t whole square dt. What is the value of this? Mode of e to the power j theta whole square. What is the value of mode of e to the power j theta? 1. 1 whole square will be 1 only. So this value is 1. So what you are getting? 0 to 2 pi 9 into dt. What is the answer? 9, and this will be 2 pi 18 pi. Answer is 18 pi. Okay. So for complex signal, this is how we will do it. So here you are actually using the mode now to calculate this value. If you don't use the mode, then it will be there as it is. So you are using the mode now to calculate this particular value, and that would be 1. Okay, and I needed to define it between 0 to 2 pi. Otherwise the limit would have gone from 0 to infinity. Again the answer would have been infinity. If I did not put 0 to 2 pi here, then what would have been your integration? The integration would have been from 0 to infinity 90 dt. So this answer would be infinity only. Say yes or no, right? But it is being defined from 0 to 2 pi only, right? So all these are extra steps that I can keep here. So this is how you can do the calculation. Try finding for this one. I will take a pause. Okay, you try finding the energy of this signal. I will take a pause. You try doing it on your own. Okay, so let's start with this one. What we need to do? E to the power minus alpha t ut. Here alpha should have been written that first thing, alpha is positive here. This should have been written here, right? Because if alpha is negative, then it would become, let's just say alpha is minus 2. So it would become e to the power 2t ut, right? If alpha is negative, if I am saying alpha is negative, so it would become e to the power 2t ut. So how would you draw the graph? At e to the power 0, what is the value? 1. And at e to the power infinity, the value will be infinity. So this would be the graph. So that doesn't make sense. It should be given in the question, because if this is the graph, then what would be the energy? Energy would be infinity, right? So it should be given in the problem that alpha is positive. Okay, so I will write it down in other color of pen that alpha is positive. So this should be given. So now let's start. And the graph you can certainly make. If alpha is positive, so at infinity the value will be 0 only. Because if alpha is positive, e to the power minus 2t. So at t equals to infinity, value will be 0 only. At t equals to 0, what is the value? A plus jb. and at t equals to infinity the value will be 0. Right? At t equals to 0, e to the power minus alpha t will be giving 1, right? But a plus jb magnitude is there, so a plus jb magnitude is there. Although this magnitude is complex, but still it is the magnitude a plus jb. I am just saying that this is the magnitude, nothing else. And at t equals to infinity, it is 0. It is not a function of t. Are you getting this point? This is just showing the amplitude, although it is an imaginary amplitude. Are you getting this point? Now what I need to do? I need to calculate the energy, and that I will calculate from 0 to infinity. Mod of xt square dt, right? From 0 to infinity. Mod of xt, a plus jb e to the power minus alpha t dt. Can I do in this manner? E to the power minus alpha t whole square dt, right? Mod I am breaking down. Mod I am breaking down. So what is the value of mod of a plus jb? The number is a plus jb. If I take the mod, what will be the mod? Under root a square plus b square. And then I need to take the square. Then I need to take the square. So what that would be? A square plus b square. A square plus b square. Then from 0 to infinity, a to the power. Now this value is already positive, no? A to the power minus alpha t. A to the power minus alpha t. So there is no meaning of mod here. When I was calculating the energy of a to the power minus alpha t here, so was there any meaning of mod? No. In this one, a to the power minus at. Here also it should have been written that a is positive. Okay. Here also it should have been written a is positive. Here also it should have been written a is positive. Because if a is negative, then it wouldn't make sense. Here a is negative, then it would not make any sense. A to the power minus 2t u of minus t. So at t equals to minus infinity, it will give you infinity value. So that's why a has to be positive. Yeah. So here I was. So here there is no j. Actually, if it was e to the power j alpha t, and then I would have taken the mode, it would have been 1. But here it would not be 1, right? It would simply be e to the power minus 2 alpha t dt. Do I know the answer of this integration? You can do it on your own, but we have done it a lot of times. Here we have done it a lot of times. The answer of this integration is 1 by 2a. So what is the answer we are getting? The answer we are getting is a square plus b square divided by 2 alpha. So this is the answer we are getting. So actually whatever the amplitude that is being shown here, whatever the amplitude that is being shown here, b, whatever the amplitude that is being shown here, b, just do the square of that. Just take the amplitude and do the square of that divided by 2 and this value 2a. Just make sure that at t equals to infinity, your graph should not be going to infinity, or at t equals to minus infinity, your graph should not be going to infinity. If it is not going to infinity, it is all fine. What you need to do? A square divided by 2a. Here, square of this b square divided by 2a. And in this case, what is the scene here? Here our amplitude is a plus jb. So first I need to take the mode, then square divided by 2 alpha. What is the mode of this? Under root a square plus b square and then whole square. So a square plus b square divided by 2 alpha. That's the answer. Or you can do the integration in the examination hall as well. It will take a minimum of time. This will be very easy. First I need to take the mode. So mode of square, that means a square plus b square will come outward. Then e to the power minus 2 alpha t. Directly I can write down this step. All these steps I will miss. Directly I can write down this step. And from there a square plus b square divided by 2 alpha would be the answer. Okay. Now yt is equals to x1t plus x2t. That means it is a linear combination of two signals, x1t plus x2t. You need to find the energy of yt. Two cases you need to consider. X1t, x2t are real signal and x1t, x2t are complex signal. we will be using reference of something that we have already studied in the last lecture. What did we study? Mode of x1t plus x2t whole square, how it can be broken. Did we study that? Certainly we have studied it, right? So let's calculate the energy of yt. That would be minus infinity to infinity mode of yt square dt, minus infinity to infinity mode of x1t plus x2t whole square dt. Integration, let the integration be there as it is. Do I know how to open it up? Yes. If you have followed the last lecture, you know how to open it up. It will be opened as mode of x1t square plus mode of x2t square plus x1t x2t conjugate plus x1 conjugate t x2t into dt. Now the integration limit can be given to each function. Say yes or no. The integration limit can be given to each function. Plus minus infinity to infinity minus infinity to infinity plus minus infinity to infinity conjugate x2 t dt. Say yes or no. Although in the examination hall you will not be able to, you will not have to do all these steps, because directly you would see, okay, it is being added, then I can open the square in this manner. Now what is this? If you closely observe it, what is this? If you closely observe it, what is this? This is the energy of x1t and this is the energy of x2t. Say yes or no. If I purely see what will be the energy of x1t, that would be mode of x1t whole square integration from minus infinity to infinity, and this is the energy of x2t, and these are some certain values, right? So energy of yt would be energy of x1t plus energy of x2t plus minus infinity to infinity. I am writing it down in this manner only. x1t into x2t conjugate plus x1t conjugate into x2t dt. That's it. Now if x1t and x2t are orthogonal signals, if they are orthogonal, then what will be the value of this integration? If they are orthogonal, what will be the value of this integration? That would be equal to 0, right? Because for orthogonal, minus infinity to infinity x1t multiply with conjugate of x2t and minus infinity to infinity x1 conjugate t multiply with x2t, that integration will give you 0. So 0 plus 0, it would be 0 only. So what we are getting? Eyt is equals to Ex1t plus energy of x2t. So this is true for the orthogonal signal. Here I did not tell real signal, imaginary signal, nothing. Real, imaginary, we did not even discuss. All these points are true for both of them, whether it is real signal or complex signal. So everything is true for both of them. Now what will come? If x1t and x2t are real, x1t and x2t are real. Now this point will come, that if both are real, then what will happen? If both are real, then x1 conjugate t would be equals to x1t and x2 conjugate t would be equals to x2t, right? x1 conjugate t would be equals to x1t, x2 conjugate t would be equals to x2t. So x1t into x2t plus x1t into x2t, that would be 2 into x1t x2t. So what will be your energy of yt? Energy of yt would be energy of x1t plus energy of x2t plus 2 into minus infinity to infinity x1t into x2t into dt. There you go. And if x1t, x2t both are imaginary, or you can say complex signal, here I have here I have written complex. So if they are complex, then this would be the formula. This is the formula for complex. Okay, if both are complex, because if both are complex, then nothing will change, it will remain there as it is. But if both are if both are real, then there is no meaning of conjugate. That means I can combine both of them. So what I need to do, I will calculate the energy of x1t, I will calculate the energy of x2t, and then what I'm gonna do, I'm gonna just take, first I will multiply x1t and x2t, then I will calculate their area, and then I will just multiply by 2. What this is? What is this? This is equals to 2 into area of x1t into x2t. So there I will be having two signals, right? In one signal only I can break it down into two signals. We will see the problem. Okay, so there I will get to know that if they are not orthogonal, then my energy would be energy of x1, energy of x2 plus 2 into area of x1t into x2t. Let's try out some problems. So first let me know, here can you break down this particular signal into three orthogonal signal? This is your xt, this is your xt. Okay, can this particular signal be broken down into three orthogonal signal? Say yes or no. Certainly it can be broken down. That sir, from 0 to 1 you keep this one. This would be, sir, this point is 2. This would be your x1t, sir. From 2 to 3, and then you keep all these 0. So this would be your, and this point is also 2. So this would be your x2t. And then from 3 to just a second. Yeah, so we were breaking it down into orthogonal signals. So x1t is there, x2t is there, then this would be 3 to 5, x3t is there, right? And all three are orthogonal to each other. Basically, I will break down x1t where it is defined from 0 to 1. For rest of the time, it would be 0. Then I will break down 2 to 3, rest of the time it would be 0. Then 3 to 5, rest of the time it would be 0. So if I multiply x1t into x2t, if I multiply both of them, what I will be getting? 0. If I multiply these two, what I will be getting? 0. And if I multiply these two, what I will be getting? 0. So this and this x1t, x2t are orthogonal, x2t and x3t are orthogonal, and x1t and x3t are orthogonal, right? x1, x2 orthogonal, x2, x3 orthogonal, x1, x3 orthogonal. That means all are orthogonal to each other. So what will be your energy of xt? So your energy of xt would be equals to energy of x1t plus energy of x2t plus energy of x3t. So 2 square into 1 plus, even though it was negative, then also it would not be a problem for us, right? Even though here the amplitude was negative, then also it would not be a problem for us because we need to do the square, right? So here a square into t, then this is triangle. Triangle will be the minimum one. So a square by 3, a square by 3 into t plus a square by 2, a square by 2 into 2. Okay, so what we are getting? 4 plus 4 plus 4 by 3. So what that would be? 8 plus 4 by 3. 16 by 3. So not, sorry, 28 by 3, right? 28 by 3. So that would be the answer, right? 4, let's check the calculation. A square by 3, a square by 2 into 2. So 4 plus 4, that would be 4 by 3. So answer would be 8 plus 4 by 3, that would be 8 plus 4 by 3, 28 by 3. Yeah, right. Okay. Let's do this question. Can you break it down into two signals? Can you break it down into two signals whose energy you already know? What I am saying, break it down into two signal. Those signal are signals whose energy you remember by some formula. Can you break it down into these two signals? Yes. How will you break it down? minus 2 to 0 and this amplitude is 2. So this one will be my x1t. What will be my x2t? X2t would be somewhat like this. This is 0, sorry, this is 0, this is 2. What will be the amplitude here? 3? No, amplitude will be 1, no? If you add both of them, if you add x1t into x2t, if you add x1t into x2, sorry, if you add x1t plus x2t, what will happen? This waveform will be shifted upward by 2. So if this is shifted upward by 2, so 0 will reach at 2 and 1 will reach at 3. So this will be shifted upward by 2, right? So x1t, x2t. Are both of them orthogonal? No, right? Because what is the condition of orthogonal? Are those periodic? No, they are not periodic, they are non-periodic, right? Here, what is the condition I wrote down? Yeah, if x1t, x2t, because here I wrote down the condition for non-periodic only. I did not write down the condition for periodic, right? I wrote down the condition for non-periodic only. For periodic, we will integrate for a time window t naught. Here we are integrating from minus infinity to infinity. So if I multiply both of them, basically x1t into x2t, conjugate there is no meaning because both are real. If I multiply both of them and then I integrate from minus infinity to infinity, I am not getting anything equals to 0. That means they are not orthogonal to each other. Not orthogonal. Say yes or no. So what will be my answer? My answer will be energy of xt would be energy of x1t plus energy of x2t plus 2 into area of x1t into x2t. What is the energy of x1t? That is a square into 2. Basically this square into the width, that is 2. What will be the energy of x2t? A square by 3 into 2. Why a square by 3? Because this is the minimum one. Square, sinusoid lobe and then triangular. So a square by 3 into 2 plus this value we need to find. So for that what I need to do? I need to multiply both of them. If I multiply this signal with this signal, what will happen? This is a constant value of 2. Between minus 2 to 0, between minus 2 to 0, this particular function will be multiplied with the constant value of 2. So what will be my x1t into x2t? My x1t into x2t would be somewhat like this. Minus 2 to 0. 2 into 1, that would be 2 only. So this is your x1t into x2t. What is the area you are having? What is this area? This area is half into base into height. Half into base is 2, height is 2. So the area is 1. And then you need to double it. That's it. Okay, so in the examination hall, these kind of questions you will do with good amount of patience. These questions will just test your patience because there is very high chance that you can do minor mistake because one term you forget and everything is gone. What if I forget to multiply here by 2? This is what I used to do when I was a student. I always used to forget multiplying by 2. Energy of this one, then multiply both of them, wrote down the area directly. Multiply by 2 is also there, no? Okay. So these kind of questions will always test your patience in the examination hall. And am I doing the calculation correctly? Half into base into height. Arey wah. Look. Here the value will be 2, no? Half into base is 2, height is 2. So 2 and 2 get cancelled, value will be 2. I don't know how did I get 27 rank. Do you guys also think that? Look, I did a lot of minor mistake in my 2022 attempt. Okay, there was a lot of minor mistakes. These kind of mistakes were there. And that costed me 27 rank. Okay. I'm not being arrogant of it, but you would see I got control system questions wrong, where phase margin, gain margin were asked. This is just an example I'm giving. So lot of easy questions were wrong there, but I got all the tough questions correct. Yeah, this happens with a lot of students actually in the examination hall, and like certainly with me as well. I'm good with my concepts, but these kind of calculation error, these are just
unforgettable. So people ask me, sir, how to reduce the calculation error? The simple thing is you be confident with your concepts. If you are confident with your concepts, then the calculation error, either it will be very less or it will dominate your performance. Basically, your calculation mistake will not be affecting so much if your concept is pretty good, because there you will be able to solve the tougher problems as well. So let it be. If your calculation mistakes are there, let it be. If you keep on solving more and more problems, the calculation mistakes will reduce as well. Your efficiency will go up if you keep on solving problems again and again. So this is the only method by which you can reduce your calculation mistake, that is keep on solving more and more problems. Okay. As an educator, I might not be able to solve more and more problems, but as a student, you can certainly solve, right? Because students need to practice a lot, but educator need to practice their concept, not their calculations, right? Here we are not there to teach you this calculation. Although these kind of errors should not happen, but still we are not here to teach you these kind of calculation that you can do on your own. So that's the only way that you can reduce your calculation mistake, that is practice as much as you can. Okay. So 4 into 2, 8 plus 2 to the power 3, 8 plus 4, 12 plus 2 by 3. So 12 plus 2 by 3, that would be 12.66, 12.67 joule. Well and good. So this is how we will be solving it. Okay. Now just answer me this thing. If your signal xt is having energy E naught, what will be the energy of A into xt? What do you think? Let's take a simple example. We can take the example of the square box. This square box, let's just say this was having a width of t and the magnitude was A. Then what would have been the energy? A square into t. This would have been the energy. Now if you multiply it with A, if you multiply this signal with A, then what will happen? This amplitude will become A. Previously the energy was t. Now the energy would become A square into t. Basically your amplitude is being multiplied with A and then you take the square. So that means my energy will be A square. Say yes or no? Area was getting, let's just say my area was A naught and then I multiply with the factor of A. Then my area was A into A naught. Say yes or no? This was the property of area. If xt is having area of A naught, then A into xt would be having an area of A into A naught. But here in the energy, square would take place, right? If I shift it here or there, will it make any impact in the energy? No, it will be E naught only. If I shift, will that make any impact? No, shifting will not make any impact. Let's just say this box is shifted here, still the energy would be A square into t. If the box is shifted here, still the energy would be A square into t. So shifting will not make any impact. Reversal, will that make any impact? This box is being reversed. Will that make any impact? No. Reversal will also not make any impact. It will be E naught only. X80. What will happen here? What is this? This width is t, right? So this width is t. So what I can do? T by 2, 3t by 2. So this width is t here. T by 2 here, 3t by 2 here. So this width is t. Now what I am doing? I am scaling it by a factor of a. That means my time domain is being multiplied with the value a. So my time axis will be divided by the value of a. So now what will be my width? T by a. Previously my width was t, but now my time axis is divided by a factor of a, because in the time domain it is being multiplied with a. So time axis is divided by a. So what will be the width now? 3t by 2a minus t by 2a. So that would be equals to t by a. So this width would be equals to t by a. So what will be the energy now? A square into t divided by a. Previously it was a square into t. Now it has been a square into t divided by a. That means E naught divided by a. Say yes or no? Did you understand this point? Okay. Same thing was there with area as well. Xt was having an area of a naught. So what was the area of x into at? That was a naught divided by mod of a. Why we wrote down mod of a? Because a could be negative as well. Let's just say a is negative, a is minus 2. So just there would be reversal and it would be divided by 2. Basically this point was t by 2 and this point was 3t by 2. Now what will happen? It will be divided by 2. First it will be divided by 2 and then there will be reversal. So there will be no impact of reversal, only the impact will be of these two. So that's why mode of A is written. Okay, mode of A is written here. And what about this one? A is multiplied, so A square into A naught and divided by this mode of A. That's it. Okay, because shifting will make no impact, only this A will make the impact. If I need to go to here, how will I go? From xt, if I have the energy of xt, that is E naught. So from xt to I will go to A into xt, then I will go to A into xt plus b, then I will go to A into x at plus b. So here my energy is E naught, here my energy would become A square E naught, here it would become A square E naught only because shifting makes no impact, and here it would be A square E naught divided by mode of A. Well and good. So this would be the answer. Okay. Do this question on your own. Xt is given. You need to find the energy of minus 5x 2t plus 4 divided by 3. Do this question on your own. If you are able to solve it on your own, your job is done. You have understood the energy completely. This is the last question of this particular video. I hope this is the last one. Yes. So if you are able to do it on your own, you have understood the energy completely. What will be my first task? If I say my energy of xt is E naught, then what will be the energy of this particular thing? That would be 25 E naught. Let's break it down. It can be broken down into 2t plus 3 plus 4 by 3. So 25 E naught divided by 2 into 3. That would be 75 E naught by 2. Did you understand what did I do here? क्या हुआ भाई? Yeah, 5 mode of minus 5 square 25 E naught, and then your time domain is being multiplied with 2 by 3. That means your time axis will be divided by 2 by 3. So divided by 2 by 3. So what that would be 75 by 2 E naught. So my target is to find the energy of this thing, and then I will multiply with 75 by 2. Break it down into orthogonal signals. Can I break it down into two orthogonal signals? Yes. One will be from 0 to 2, another one will be from 3 to 4. So let's break it down into two orthogonal signals. So let me just copy this diagram actually. From here only I can break it down. What I will do first, this is how I can break it. This is the first way. And what could be the second way? In the second way, what I could have done, I would have just removed it off. These two are my two orthogonal signals. Both are orthogonal to each other because one is defined from 0 to 2, another one is defined from 3 to 4. Although both are defined for minus infinity to infinity, what do I mean by defined? That means I mean to say both are non-zero. One is non-zero from 0 to 2 and another one is non-zero from 3 to 4. Say yes or no. So this is your x1t and this is your x2t versus t versus t. Okay. Now this signal cannot be broken into two orthogonal signals, right? This signal I can break, but that will be broken into two signals. This will be also broken into two signals. This can also be broken into two signals, but both will not be orthogonal to each other. Do you understand this point? Right? Both will not be orthogonal to each other.
So here I am breaking it down into two parts. What name I should give? I am not giving any name. Okay, just I am breaking down into two parts. One is this, another one is this. Zero to two, and this is one. Right? This is how I can break it. What about this one? That also can be broken into two parts. So minus 2 and this is minus 1. Yeah, so this is how it is broken. Now both are non-zero between 3 to 4. This is also non-zero between 3 to 4. So if you multiply both of them, you are not getting the zero value, right? If you multiply both of them, you are not getting the zero value. So can you multiply this and this? If you multiply both of them, what you will be getting? Here, what will be the energy of this one? What will be the energy of this one? Basically, what will be your final energy? I am asking you, what will be the energy of xt? That would be energy of x1t plus energy of x2t. Now you need to find the energy of x1t first. What will be the energy of x1t? So energy of x1t will be energy of this signal, that is a square into 2, plus energy of this signal, that is a square by 2 into 2, a square by 2 into 2, right? Plus 2 into, if you multiply both of them, then what would be the area? If you multiply both of them, then what would be the area? So now I need to multiply this function with this sinusoid. So if I multiply both of them, what I am getting? This is what I am getting. 0 to 2, and this value will be 2. Basically, this sinusoid is being multiplied with 2. So amplitude will become 2. Now in the next lecture, I will tell you the area of this particular lobe. Okay, in the next lecture only. As of now, I am directly writing it. In the next lecture, we will derive it. Are you getting this point? In the next lecture, we will derive it. As of now, I am directly writing it. Is that okay for you? No need to worry about it. No need to worry about this issue. Okay. So the area would be 2 Vm. 2 Vm means 2 into peak amplitude divided by pi into this width. What is this width? This width. So that would be 2 Vm by pi into the width. Is that okay for you? 2a by pi into the width. We can derive it in the next lecture. Certainly we will derive it there. No need to worry about that. Okay. Just here, as of now, I am writing down the area directly. But in the next lecture, it will be derived, and you can derive it on your own as well. What you need to do, you just simply need to do this calculation. 2 sine. What will be this function? What do you think? This function is sine pi by 2t. Say yes or no. This function is sine pi by 2t because there is one lobe. That means my time period would be 4 seconds. And for the 4-second time period, this would be my function into dt. And you need to integrate from 0 to 2. As of now, if you are not able to understand this, it is all fine. We will see it in the next lecture. And when you do it, this is the answer you will be getting. So what is the answer? 8 by pi. So 2 into 8 by pi. Okay. So the answer you would be getting is 2 Vm 2 into a by pi into this width. This width is 2. So 2 into 8 by pi. Usually we will forget this 2. So always remember 2 into the area of both of them, multiplication of both of them. 2 into the area of multiplication of both of them. So that is very, very important. Usually we forget this 2. So this is our Ex1t. What about our Ex2t? What will be the area of this one? Minus 2 square into 1 plus, what will be the area of this one? Minus 1 square by, not area, sorry, energy, minus 1 square by 3 into 1. And what will be the energy of multiplication of both of them? So when you multiply both of them, just 1 second guys, 1 second. Yeah, sorry for the interruption. Yeah, when you multiply both of them, when you multiply this signal and this signal, what you get? Minus 2 into minus 1. So between 3 to 4, minus 2 into minus 1. This minus 1 will be multiplied with minus 2. That means the value will become positive, right? The value will become positive. 3 to 4, it will become positive. So what is the area? Just 1 second guys, I need to pause. Yeah, so what will be the area here? Half into base into height. So area would be 1. Area would be 1. Okay. So 2 into 1. So here 8 plus 1 plus 16 by pi. And here 4 plus 1 by 3 plus 2. This would be 6.33. And here I need to add this up. So let me do the calculation and then I will write down the answer. Yeah, so energy of xt is coming out to be 20.42 joule. Okay. So what will be the final energy? Final answer, what that would be? What I need to find, let's just say this is your yt. So energy of yt would be 75 by 2 into E naught. Into E naught. So into 75 by 2. That is coming out to be 765.86. So there are a lot of calculation. If you just solve it with good amount of patience, you will be getting it correct. Okay. So that's it about the energy. I hope you would have enjoyed it. I hope you would have understood a lot of new concepts here, right? So the conclusion is like energy you would be able to revise within very few time. You will be starting from here, or directly you can start from this conclusion. Wherever is our conclusion? A square into alpha 1 minus alpha 2, a square by 2, a square by 3, and then multiply with width. Then you would know that if my function is not being 0 at the infinity or minus infinity, that means the energy will be infinity. Or if it is a periodic, then also the energy would be infinity. Here you can see energy would be infinity. If it is being 0 at t equals to infinity, then yes, yeah, it is enclosing a certain amount of energy. That would be a square divided by 2a. Here b square divided by 2a. Now this was a complex signal. So what I am going to do, I am going to define it between 0 to 2 pi, 0 to 2 pi, and then just I will take the magnitude and will do the calculation. 18 pi would be the answer. Here also it is just exponential signal. Now the amplitude is complex here. Amplitude is a plus jb. So what will be the amplitude here? If I take the square, that would be a square plus b square divided by 2 alpha again. Okay. Addition, the energy of xt plus energy of x2t plus, actually it is integration minus infinity to infinity x1t conjugate x2t, x1t conjugate dot x2t. Okay. But if they are orthogonal to each other, that means energy of x1t equals to x2t. And if they are real, then 2 into area of multiplication of both of them. Then we saw this question, we can break it down into 3 parts. All 3 are orthogonal to each other, right? Then we can simply add up the energies. So here 2 square into 1, here a square by 3 into 1, and here a square by 2 into 2. Okay. So what we are doing here? Yeah. So 4 into, yeah, this was 4 only, 4 plus 4 by 3. Yeah. So answer is 28 by 3. Then these two. Okay. Here I broke it down, but I got to know that both are not orthogonal to each other. If both are not orthogonal to each other, so I need to calculate x1t into x2t, and then I need to do that twice of the area. Twice of the area, that would be half into base into height. Okay. So that would be 4, and here you can see a square by 3 into 2 and a square into 2. So 8 plus 2 by 3 plus 4. Then we saw this thing that if I multiply with a, then a square into e naught, and if my time domain is being multiplied with a, that means time axis will be divided by mod of a. Okay. Now xt is given as this, then you need to find the energy of this particular signal. So this will be your revision question. You just need to do it on your own, and everything is clear here, because here we have broken it down into 3 signals, whichever the formula we remember. Here you can see the concept of orthogonality as well and non-orthogonality as well. all the concept you can see, and finally you just need to add up the energy, and also this kind of concept also you can see here. If your function is being multiplied with a certain amount of value and your time domain is being multiplied with a certain amount of value, then how your energy will be affected. So that also you can see, and this would be a revision question, and very slowly you will solve it and you will get the final answer. Say yes or no. Energy is very straightforward, very easy. The important point was orthogonality, the last lecture. The last lecture is base of all the signal system. Okay, so last lecture was very important. Here one more point, let's just say if someone wants to solve this problem without orthogonality, this point I forgot to explain. If someone wants to solve this problem without orthogonality, then how would he solve it? He will have to write down the equation of this particular line. Okay, let's do it. What we need to do, डिवाइस हैंग हो रहा है यार एकदम. Yeah, sorry for the interruption. So what I was saying, if someone wants to solve this problem without all these concept, like all these concept, whatever that I have taught, orthogonality and all these kind of things, he will just go by the basic definition. The basic definition says that minus infinity to infinity mod of xt whole square dt. So how will he solve it? He need to write down the equation, no? He need to define xt now. So he need to write down the equation of this line. What will be the equation of this line? Y equals to slope. What is the slope? Slope is 1 by 2t plus c, whatever that is, where it is cutting on y-axis. So xt equals to t by 2 plus 3. So that is the equation of this line, and that is your xt now, and it is defined only between, basically it is 0. If I need to define my xt, how would I define it? So my xt is 1 by 2t plus 3 when your t is there between 0 to minus 2 to 0, otherwise it is 0. Otherwise it is 0. So now I need to integrate from minus 2 to 0 only. Minus 2 to 0. T by 2 plus 3 whole square dt. Okay. Minus 2 to 0. T square by 4 plus 9 plus 3t into dt. Now you do this integration, what you will get? T cube by 12 plus 9t plus 3t square by 2, 0 to minus 2. And if you solve it, here what will be the value of energy? 0 minus, you put this value, minus 2 you put here, minus 8 by 12 minus 18 plus 6. So what we are getting? 6 minus 2 by 3 minus 18, right? 6 minus 2 by 3 minus 18. So what that would be? 18, 6 minus 18 would be minus 12. So it would be 12 plus 2 by 3 basically. Minus sign will be getting cancelled out. Some calculation error is there. Let me check. So equation I have wrote down correctly. Y equals to mx, slope is 1 by 2. Okay. So t by 2 whole square minus 2 to 0. T square by 4 plus 9 plus 2ab 2 into 3t by 2 into, okay, 3t dot dt. Then t cube by 12 plus 9t plus 3t square by 2. And you need to integrate from, actually you are integrating from minus 2 to 0, not via interchange the limit. It would be from minus 2 to 0. So when you are putting 0, it would be all 0 minus of these values. So it would be minus 8 by 12 minus 18 plus 6. No issue about that. 6 minus 2 by 3 minus 18. 6 minus 2 by 3 minus 18. So let's check that out. 6 minus 2 by 3 minus 18. I don't think there is any error. Minus 6, 12.66. Yeah, same answer we are getting. No calculation error is there. So when you solve it, you are getting the same answer only. Right? So what is the answer? Here the same answer you are getting, that is 12.67 joule. Okay, so the point is here you can do the direct calculation as well. Okay. In that manner you can do the calculation. What about this one? If I need to calculate the energy of this one, how will I do the calculation? What I will do for this particular thing, okay, for this particular signal, what I will do is that from, shall I add it anywhere? Let's add it. So only for this particular signal I am calculating the energy without even anything else. Because now you can calculate the energy for this particular signal, right? For this particular signal you can calculate the energy without even orthogonality concept. If you don't know the concept of orthogonality, still you can calculate the energy for this particular signal. What you will do, you will just write down the equation of this line and then you will define it from 3 to 4 and then you will just simply integrate the way we have done previously here. The same thing you are going to do. Okay, here I will write down method 2. Now what about for this one, for this particular signal, how will I do it? So again I will have to write down the equation. So what do I see here? This is a kind of sinusoid which is shifted upward by 2. The sinusoid is shifted upward by 2. Basically it would have been 2 plus 1 sine pi by 2t, and it is defined from t equals to 0 to 2, and otherwise it is all 0. Say yes or no. And now what I need to do? Energy. So from 0 to 2, 2 plus sine pi by 2t whole square dt. 0 to 2, a square plus b square plus 2ab, so that would be sine pi by 2t dt, right? 0 to 2 you need to do. So a square plus b square plus 2ab plus 2ab, so 4 sine pi by 2t. Will this integration be 0? What is the time period here? Time period is 4 seconds. That means this is the sinusoid, but you are integrating from 0 to 2, so this will not be equal to 0 here. Are you getting this point? You are integrating from 0 to 2, but this sinusoid signal is from 0 to 4, so this value will not be equal to 0. This value will be equal to this area. So don't do the mistake of putting that equals to 0, because people see the sinusoid and they put it equals to 0 and they will put this equals to 1 by 2. This is what they do, but that is not correct. This will also result in something. Okay, so this something we already know. Do we know this particular something that I told you? In the next lecture we will get to know about it. So here the amplitude is 4, so answer would be 2 into the amplitude divided by pi into 2, so that would be 16 by pi. So this particular integration, we will see the integration in the next video. This particular integration will give us 16 by pi. Now what this particular integration will give? So 4 will come common here. This is the definition, so let's keep it in a box. So this is the definition which we can keep in the boxes. Now 4 will come outward and then you are integrating with respect to dt, so 4 into 2. Then this integration I have told again and again. What we will do? 1 minus cos pi t divided by 2. Then what I will say, that here the time period is 2 and you are integrating from 0 to 2, so this will go to 0 and 2 will come outward. So this will be simply 1 by 2. Say yes or no. 1 by 2, but 1 by 2 will come common and then you are integrating from 0 to 2, so multiply with 2 as well, plus 16 by pi. Were we getting the same thing? 8 plus 1 plus 16 by pi. Yes, 8 plus 1 plus 16 by pi. So without even knowing any orthogonality, I can still solve it. Same applies for this one as well. You can try solving it without the concept of orthogonality. So in the worst case, in the examination hall, if you are not able to think in terms of orthogonality, then at least you can write down the equation and solve it.
Okay, go by the basic definition and solve it. But 100% chances is there that these kind of signals only will be coming in the examination hall, and you will be able to break it down in orthogonal signal, because this will be a faster process. No, this will take time, but this will be a faster process that you break it down into two. Like when you have the practice, you will get to know, okay, this energy, you will just see this particular signal and you will write down the answer. How will you write down the answer? One pulse will be there and one sinusoid will be there. So you know that pulse will be of height 2 and width 2. So 2 square into 2 plus, what about the sinusoid? The width, the height of sinusoid will be 1. So a square by 2 into 2. Then there will be a common area. So 2 into, what would be the common area? Pulse will be multiplied with sinusoid. What that would make? The amplitude of sinusoid will go to 2. So 2 Vm, that would be 4 divided by pi into 2. So that would be the energy of this particular pulse. Now talking about this one, so what we will do? Here, again the same thing, 2 square into 1 plus a square by 3 into 1. Now 2 into, multiply both of them. So width of your triangular will go to 2. That means half into base into height. So just add all of them. That's it. So what did you get? Here 8 plus 1 plus 16 by pi. Then here 4 plus 1 by 3 plus 4 plus 1 by 3 plus 1. Same thing we are getting. Plus 2 here. 2 into, yeah, height was 2. So minor mistake. Okay. Base into 1 by 2 into base is 1 and height was 2, no, because this was multiplied with minus 2. So height was 2. So this would be 4 plus 1 by 3 plus 2. And this calculation you will do. So in the examination hall, you will not be doing this process if you have enough practice. Once you build the practice, directly you will be writing down the answer. Okay, so I hope I have given enough intuition in terms of energy. Let's meet in the next video where we will study about average. Thank you. Hi everyone, welcome back. So in this video, we are going to study about average. Okay, we need to study the average value of a particular signal, and that is known as DC value as well. So we will move to the topic, but before that, let's study a simple mathematics. So in the last lecture, I told you the area of this particular signal, right? If you remember. So now you need to derive it. Very simple derivation it is. You need to tell how much area this is enclosing. So do you remember the formula of area? What was the formula of area? Area was minus infinity to infinity xt dt. Say yes or no. So here what will be the area? Area would be 0 to 1, because for rest of the time it is 0 only. So from 0 to 1 xt dt. Write down the equation of xt. For t equals to 0 to 1 xt. How will you define xt? It would be 0 otherwise. But if t is from 0 to 1, if t is from 0 to 1, then what would be the value of xt? Let me know. What will be the value? That is Vm sin pi t, right? It is your Vm sin pi t. Why is that so? Because what will be the graph of Vm sin pi t? What will be the time period? 2. Time period would be 2. So this is how it will go, right? This is how it will keep on going here as well. So this point is 2. This point will be 1. So from 0 to 1, only this much waveform I need. So that is Vm sin pi t. So Vm sin pi t. So your xt is Vm sin pi t between 0 to 1 only, right? Between 0 to 1, Vm sin pi t dot dt. This integration you can do. This pi will come downward. This would be minus cos 0 to 1. You can interchange the limit. Cos pi will be minus 1, cos 0 would be 1. So minus 1, 2 Vm. It would be 2 Vm by pi. So what is the area we are getting? 2 Vm by pi. Should be there in your mind, okay? But remember, this width was 1. This width was 1. This width was 1, then this was your area. If you remember that if xt is having an area of a naught, then what will be the area of x of at? A naught by mod of a, right? Because your time axis will be divided by a factor of a. That means the area will be reduced. Are you getting this point? So here the width is 1. If the width was alpha, then what would have been the area? 2 Vm by pi into alpha. Look, xt was having an area of a naught. Now here in place of 1 you are having alpha. In place of 1 you are having alpha. In place of 1 you are having alpha. So this was your xt, 0 and 1. So you need to multiply your time axis by alpha. That means you need to divide your time domain by alpha. Time domain is divided by alpha. That means you need to multiply your time axis by alpha. What does that mean? That your area would be a naught divided by 1 upon alpha. So that would be alpha a naught. That means alpha into 2 Vm by pi. So from now onwards, what you will remember that, sir, this loop gives me 2 Vm by pi area. This loop gives me 2 Vm by pi area. Then I will multiply with width. So 2 Vm by pi into width. This is how I will be remembering it. Say yes or no. 2 Vm by pi into width. In energy, what did we remember? Vm square by 2 into width. So here, in place of area, if it is not squared, if it is squared, then what will be the answer? If it is squared, then answer was Vm square by 2 into the width. Width is alpha here. So if it is squared, then this was the answer, Vm square by 2 into alpha. But if it is not squared, then this was the answer. Just tell me one thing. Is it the energy of this signal? What I am saying, this is the energy of this signal. Is that true? This value Vm square by 2 into alpha is the energy of this particular signal. Is that statement true? No. Vm square by 2 into alpha is the energy of this signal, right? If this was your xt, then what you would do, you would take mode of xt and then you do the square. And if you do that process, you will reach here. Are you getting this point, what I am saying? If I am saying that this is the square of sinusoid, this is the square of sinusoid. And here I am writing Vm square by 2 into alpha. You know that area would be Vm square by 2 into alpha. But area of what? Area of this particular signal. So this is the area. This is the area. Area of this particular signal. But if I ask you what is the energy of this particular signal, that would be Vm square by 2 into alpha. Just very simple point I am telling. Okay, needlessly it is becoming complex. But people might be confused in the examination. The simple thing is, this is giving you this area, 2 Vm by pi into alpha. Now talking about the energy, in the energy what do? We take the square of it, taking the square of it here. And after taking the square, what do we calculate? We calculate the area. After taking the square, when we calculate the area, that value is your basically area of mode of xt square is equals to your energy. Say yes or no. Say yes or no. Do you agree to this point? Area of mode of xt square is equals to energy. Energy of what? Here again I need to, energy of what? Energy of mode of xt square? No, energy of xt. So this value is the energy of xt. Are you getting this point? This value is the energy of this xt. But if I give you this particular waveform, if I give you Vm sine square pi t, it is there from 0 to 1, and I ask you what will be the area of this, what will be your answer? Will you integrate here? No. You know that, okay, this will be the energy of Vm sine pi t. This will be the energy of Vm sine pi t. And I remember the formula for energy of Vm sine pi t. That would be Vm square by 2 into the width. Width would be 1 here. So this would be the area. For this particular signal, this is the area. But for Vm sine pi t, that would be the energy. For Vm sine pi t, 0 to 1. So this would be the energy. Okay, very simple point, but people can get confused here. That's why I took it separately. First lecture, whatever the formula that you remember these two things, Vm square by 2 and 2 Vm by pi. You remember these two things. But you remember these two things for different things. Vm sine pi t will give you an area of 2 Vm by pi. And Vm square sine square pi t would give you the area of Vm square by 2. That's it. Okay. I hope this conclusion is clear. Right. Now we will move to our topic, concept of average value. So we have seen the formula of area, we have seen the formula of energy as well. What was your energy? Minus infinity to infinity, mode of xt square dt. Then we saw the expression of area, that was minus infinity to infinity xt dt. So these two formula, both of these formula was working for periodic signal as well, for aperiodic signal as well, right? When we studied energy, when we studied area, did I say for periodic signal it would be different, for aperiodic signal it would be different? No. For periodic and aperiodic, for both of them the formula was same. Say yes or no, right? Now we need to study average, and after that we will study power. So for average and power, the formula will be different for periodic signal and for aperiodic signal. For aperiodic signal there would be different formula, and for periodic signal there would be different formula. One more thing, average value is known as DC value as well. So sometimes I would be using the word DC value. Okay. Now for periodic signal, what would be the formula for periodic signal? So what you are going to do, again, this is the average. What you need to calculate? Average. So what you are going to do? xt dot dt. There is no mode, right? I am not taking any mode here. Here also we did not take any mode. It was purely xt. Whenever we do the square, at that time we take the mode. So it is purely xt dot dt. Now it is periodic, right? So you will integrate it over a time period only. Since this is periodic, so I am gonna integrate it over a time period only, and then I will divide that particular time period as well. That's it. So this is the formula of average for a periodic signal. So if you need to calculate the average for this particular signal, so what is the T naught here? This is the T naught. Okay. So if I write down the average, so what will be the area for 0 to 2 in a particular time window or in a particular time period? What is the total area? The total area is 2 divided by the time period, that is 2. So what will be the average? 1. This is the answer. Okay. The area is 2 divided by the time period, that is 2. 2 by 2, average value is 1. What about this one? Although here we will see only 2 examples, after that we will take more examples. As of now we are just trying that how to apply the formula. What is the scene of formula? First you need to see what is the time period. Time period here is 4. In this time period, what I need to do? I need to calculate the area. In this time period, what is the area? Plus and minus. Whatever the area it will give you in positive side, the same area it will give you in the negative side. How much area this will give you? 2 Vm by pi into 2. And how much area this will give you? 2 Vm by pi into 2, but with the negative sign, because the area is negative here, no? 2 Vm by pi into 2. Why 2? Because this window is 2. That's why I am putting 2. So 2 Vm by pi into 2, 2 Vm by pi into 2, but with the negative sign. So what will be the total area? Total area, positive and negative, total area would be 0. So area in a particular time period divided by the time period. So average value will be 0 only. Okay. Now what about for aperiodic signal? So for aperiodic signal, the formula will be different. So in aperiodic signal, there is a process. How would you follow the process? So that I will tell you now. So what you need to do? You will take a time window of capital T. What you need to do? You need to take a time window of capital T. That window you will take in a manner that it is symmetric about the origin. That means minus T by 2 you will take here and plus T by 2 you will take here. You need to take a time window of capital T in a manner that it is symmetric about the origin, and then you need to integrate for this particular time window. Minus T by 2 to T xt dt. Again the area only you need to find, but you need to divide by this particular time as well. After that you need to divide by this 1 by t as well. You need to divide by this time, because this window is from minus T by 2 to T. Minus T by 2 to T by 2. That means the window is of T. Then I am dividing by that particular time T as well. And here I will put limit T tending to infinity. What is the actual meaning here? Actually, we are calculating the area from minus infinity to infinity only. For a aperiodic signal, if I put T tending to infinity, that means this point will go towards minus infinity and this point will go towards plus infinity. If I am putting T tending to infinity. So you are calculating the complete area and then dividing by 1 by infinity. But this formula doesn't make any sense, right? Mathematically, this doesn't make any sense. That's why we write down in this manner that symmetric minus T by 2 you take here, symmetric plus T by 2 you take here. then calculate the area for a particular time t, and then divide it by t, and then put limit t tending to infinity. Look, I know it might be a bit tough for you, that sir, how we will be remembering it, but you will be remembering it. No need to worry about that. Okay, you will remember it because it is very common. You will again and again use it. So no need to worry about that. But process is very simple. First you take the value, then you calculate the area, then divide by time t, and then put limit t tending to infinity. So minus t by 2 to t by 2 I took, right? Then this area. So what I need to do, I need to find the value of average. So here I know that limit t tending to infinity I will be putting, and I will be dividing by 1 by t as well. But I need to calculate the area from minus t by 2 to t by 2, xt dt. So between minus t by 2 to t by 2, how much is the area? The area is, this width is t by 2. For this width, the value is 0. So a into t by 2. So the area is a into t by 2. A into t by 2. So t and t is getting cancelled. Limit t tending to infinity, a by 2. Now here what I am saying, put the limit t tending to infinity. What I am saying, put the limit t tending to infinity. But here there is no term of t, no. There is no term of this capital T. Where I am saying that put the limit t tending to infinity, but there is no term of this capital T. That means answer would be a by 2 only, because a by 2 is a constant value. Now a by 2 is a constant value, but there is no term of t, so a by 2 would be the answer. So what is the average value of your step function? That is a by 2, right? Since it was a aperiodic, so this is how we calculated it. What was the energy of this signal? You have calculated the energy as well, right? What was the energy of this signal? Here, energy cannot be stored in this loop. This is how we remember the formula, right? Energy will keep on adding up, and it will go till infinity. So energy for this signal was infinity, and the average value is coming out to be a by 2. We will relate all these things. As of now, you just need to see the process. Everything will be related. No need to worry about that. Okay? Everything will be related in the end. You tell me the energy of this particular signal. Although we need to calculate the average value, but you tell me the energy. What was the energy? Energy was 2 square into 2, right? 2 square into 2, 8 joule. This was the energy. Let's calculate the average. Now there will be a very interesting point. So when I write down average, limit t tending to infinity, 1 by t, and after that I do the integration. Now if I put limit, now what I need to do, I need to take that t by 2 window, minus t by 2 here plus t by 2 here. Now someone will say that, sir, I will take my minus t by 2 here and plus t by 2 here, right? Someone can say in this manner that, sir, minus t by 2 here and plus t by 2 here. But what do you know? You know that limit t will tend to infinity. Limit will tend to infinity. That means this point will be actually going towards minus infinity, and this point will be actually going towards plus infinity. That means this point will actually be somewhere here, and this point will be actually somewhere here. So the point here is, or the conclusion here is, that we will take t by 2, but in a manner that it is very far away. We will take t by 2 in a manner that it is very far away, or it should take the complete nature of xt. It should take complete nature of xt. That means somewhere in between I am not going to take it. I will take it somewhere here, so that complete non-zero value is actually included in this time window. In this particular problem, if I would have taken t by 2 here, or here, or here, or here, would that matter? No. Answer would have been the same only. A into t by 2, a into t by 2, a into t by 2. Everywhere the answer would have been the same. Just a second, someone is there. Yeah, so what I was saying, anywhere I could have taken t by 2, the answer would have been the same, right? Because the nature is constant here, no? The nature is constant. After t equals to 0 plus, it is always a. After t equals to 0 plus, xt is always a. But what about this xt? At t equals to 0 plus, it is 0. Then it became 2, and then it again became 0. So this is the complete nature, 0 to 2, 2 to 0. So I need to take my t by 2 in a manner that at least the complete nature is taken in this window. So I will take t by 2 very far away. Are you getting this point? Are you understanding this point? the t by 2 would be taken very far away. So here the t by 2 is taken. So now I need to do the integration from minus t by 2 to t by 2 xt dt. So t by 2 is somewhere here, but between minus t by 2 to t by 2, what will be the area? This will be the area. And what this area would be? This area would be 2 into 2, because this width is 2 only. So 2 into 2, the area would be 4, right? The area would be 4. So limit t tending to infinity, the area would be 4 divided by t. I will put t tending to infinity now. What is the value we are getting? 0. Average value is coming out to be 0. If I ask you this particular question, what will be the average of this particular xt signal? What do you think? What will be the answer? What will be the average of this signal? Such kind of signal is there. 0 only. Why is that so? Because what I will do? I will take minus t by 2 here and then plus t by 2 here, and then I will integrate. Now in this integration, what will be this area? This area will be a finite value. Say yes or no. It will not be a function of t by 2. Here it was a function of t by 2. Here the area was a function of t by 2. A t by 2. It was a function of t by 2. Or it was a function of t. Then t to t got cancelled and answer was a by 2. But what about this one? This area would be a non-zero finite value. This area would be a non-zero finite value. So like 4 here came, it could be some alpha. This area could be some alpha. Then we will divide by t and we will put limit t tending to infinity. What would be the answer? 0. Now just tell me one thing, what will be the value of energy for this signal? Non-zero, right? The value of energy for this particular signal will be non-zero or not equals to infinity. Or we should say the value of energy for this particular signal will be finite. Energy will be finite. Why is that so? Because we will say that energy can be clubbed or stored in this loop. This is how we remember it, right? For a finite duration signal, I hope you know what is the meaning of finite duration signal. Did I use this term in the last lecture? I don't remember actually. Did I use this term in the last lecture? Finite duration signal. What is the meaning of finite duration signal? That it is there for a particular time window only. That means this signal is there for 2 seconds, or it could be there for 3 seconds, or it could be there for 1000 seconds, it could be there for 1 lakh seconds. But it should not be spread till plus infinity or minus infinity or from minus infinity to infinity. But that means it should be there for a particular time window only. It should be non-zero for a particular time window. After that, at t equals to infinity, it should give you 0 value, and at t equals to minus infinity, it should give you 0 value. So this is known as finite duration signal. And for a finite duration signal, we always said that your energy would be finite, because we said that energy can be stored in this loop. This is how we remembered it. But for these kind of signal, energy would be infinity, because energy will keep on adding up, keep on adding up, keep on adding up, and it will be going towards infinity only. Right? So this is how we remembered it. So here what we got to know, if if it is a finite duration signal, then your average will always be 0. Say yes or no. Your average will always be 0. Why is that so? Because for a finite duration signal, you will get a finite non-zero area. For a finite duration signal, you will get a finite non-zero area, because I will be taking minus t by 2 somewhere here and plus t by 2 somewhere here. Minus t by 2 here plus t by 2 here. Then I would have to calculate this area. That would be a non-zero finite value divided by time t and limit t tending to infinity. That would be equal to 0 only. We will write down all these points, we will relate all these points, but you need to have the patience. But keep on connecting the dots, okay? Keep on connecting the dots. Whatever the dot we are connecting, that energy value here, it was finite value, but average came out to be 0. Here energy was infinity, but average came out to be non-zero. Are you getting this point? So all these points will be related. And in the end, when you study the power, after studying the power, everything will be interrelated and every single thing will be cleared. Okay? But once you need to have the patience. Now find the average value of these signals. So what we need to do? Let's draw the diagram. Both of the signals will be periodic. Say yes or no. Both of the signals will be periodic. Right?
first A I am drawing. This is how it will go because there is mode, right? Sin pi by 2t. What will be the time period? Omega value is 2 pi upon pi by 2. So omega value is 4. So time period will be half of this. That means time period will be 2 seconds. So this point will be 0. Sin pi, this point will be 2 seconds. This point will be 4 seconds. So what is the time period here? 2 seconds. And here what is the peak value? That is 2. Okay. So what will be the average? So what is this area? What is this area? So this area is 2 Vm by pi into the width. So this area is 8 by pi, but divided by the time period. Don't forget the formula. What is the formula of average? That for a particular time window, you will calculate the area, but you need to divide by the time period as well. So don't forget this thing that I am dividing by the time period. So what will be the answer? 4 by pi. What answer you are getting? 4 by pi. Okay. So here I will write down in a good manner. 8 by pi divided by 2. So answer is 4 by pi. This is the average we are getting. Now second one, xt is equals to 3 sin square pi by 40. You write down the answer on your own. Without drawing the waveform, you try writing down the answer. Without drawing the waveform. Do you know the area of this particular signal directly? Xt is equals to 3 sin square pi by 40. Can I write it down in this manner? Say yes or no, right? So if now if I write down the average, so that would be 1 upon time period, and then for a particular time window you need to calculate this thing. So isn't it like the energy of this particular signal? But divided by the time period. What will be the waveform of this particular signal? So this is 3 sin square pi by 40. So what will be the time period? You will say that the time periods are 8, but not 8. It would be half because square is there, no? So whatever the negative side is there, let's just say I make the waveform of 3 sin pi by 40. So time period would be half. This is how I will make the waveform. Time period would be 8 seconds, sorry. Time period would be 8 seconds. So this is how I will make the waveform. But when I do the square, what will happen? This negative part will become positive part. So here the time period would become 4 seconds. So for this particular signal, your time period is 4 seconds. So for 4 seconds, this would be the loop for 4 seconds. This is 0, this is 4 seconds, right? And this is your 3 actually, but I am writing it under root 3 square. This point is under root 3 square. So what is the area of this? Vm square by 2. Say yes or no. The area of this would be Vm square by 2. 3 by 2 into 4. So answer would be 3 by 2 into 4, but divided by the time period. Answer would be 3 by 2. Look, this seems like a very bad approach, to be very honest. Okay, a very bad approach it would be. Better we should integrate. Why should we think all these kind of things in the examination? Better integrate, no? Time period you already know, 4 seconds. Time period you would be able to find, right? Time period you would be able to find. Rest I need to integrate only. So from where to where I will go? 0 to 4. Then there is 3 sin square pi by 40. So 3 sin square pi by 40. How will I write down sin square pi by 40? That would be 1 minus cos pi by 2t divided by 2. Right? You can apply the formula. And from here you get to know that your time period is coming out to be 4 only. So here you will write down the value as well. So it is very easy question. Needlessly I made it complex. Okay, that was my mistake only. Needlessly I made it complex. So what we can do, 1 by 4, 0 to 4, 3 by 2 is here, that can come out, this 3 by 2 can come common. So what we will get, 3 by 8, 0 to 4. This integration we have seen like 10 times actually, right? So what is the time period here? 4, and you are integrating for 0 to 4 only. That means you are integrating for one time window. So this integration will go to 0. Now 1 dot dt. What integration you are going to do? 1 dot dt for a time window of 0 to 4. So 3 by 8 dt. dt is going from 0 to 4. That means 4 here would come. So what is the answer? 3 by 2. So that's the answer. Okay. This is the answer. What would have been the energy of these two signals? What would have been the energy of these two signals? Energy, infinity. For this as well, energy would be infinity. Because cycles will keep on going, no? This particular loop will have some energy. Then this loop will have some energy. Then this will keep on going. So energy would be infinity. Same goes here. This will have some energy. This will have some energy. But it will keep on going. It will keep on going. So what will be the energy? Infinity. So in both of the cases, energy was infinity. But average here became non-zero, right? Average here became non-zero. That is 3 by 2. And how did I solve this one? Did you understand this point? Vm, it is under root 3 sine pi by 40 square. Actually, I need to calculate the area, but I remember the energy. Energy of under root 3 sine pi by 40, that would be Vm square by 2 into the width divided by the time period. So answer would be 3 by 2. Although if I had been the educator who is writing down the examination, then I would understood what we are doing here. Actually, we are calculating the area, then I would multiply with the time period and then divide by the time period. So I will not calculate the time period. T0 will get cancelled. Simply the answer would be 3 by 2. But don't do all these kind of things in the examination hall. Simply go by this method, method 2. Needlessly, I just made it complex. No intuition is required, only just solve the mathematics and you will get the answer. The answer is 3 by 2. Or from here as well, if you are able to understand, then it is also good for you. Okay. Let's go to the next question. You find the average. Very simple. What is the time period? 4. So what formula I will apply? 1 by 4 integrate from 0 to 4 xt dt. Always remember there is no mode here. Okay, no mode here. What will be the area? 1 by 2 into half into, basically this is 1 by 4 only, and the area would be 1 by 2 into base into height. The average would be 1. So average value is 1. That's it. Okay. Find the average of this particular signal. Yeah. What would be the average of this signal? Keep on adding up, and it will going till infinity. I told you for a periodic signal, the energy was infinity, right? A to the power minus t ut. What was the energy? If you remember, what was the energy? A square. Here a value is 1 divided by 2a. Again a value is 1. So what was the energy? 1 by 2 joule. Or you can calculate. You can simply do the what you need to do. You just need to do this calculation. Dot dt. What you will get? 1 by 2 only. Or I told you, you can remember the formula as well. A square by 2a. So energy was 1 by 2 joule. So what do you think? What will be the answer? Without even calculating, what do you think? Because we have seen a lot of questions now. So if energy is coming finite, that means average will be 0. Let's check that out. Is it periodic? No, it is not periodic. You can take minus t by 2. T by 2 we are taking long only. Actually, this is very long. This t by 2 is actually very long only. But here we cannot tell that this would be t by 2 or this would be t by 2. So minus t by 2 to t by 2, this is how I am showing it. Then you need to take the average. Limit t tending to infinity, 1 by t minus t by 2 to t by 2 xt dt. This limit I can change from 0 to t by 2, right? Because for minus t by 2 to 0, it was 0 only. 1 by t 0 to t by 2 e to the power minus t dt. Limit t tending to infinity, e to the power minus t 0 to t by 2, but there would be a negative sign. So if I eat up the negative sign, then I can interchange the limits from t by 2 to 0. So what we are getting, limit t tending to infinity 1 by t 1 minus e to the power minus t by 2, right? Okay, if I put e to the power infinity here, so what is the value I will get? It was e to the power minus t ut. Okay, the limit is from 0 to t by 2. Okay, it is also fine. 1 by t e to the power minus t e to the power 0 would be 1 by, and then this is t by 2. So if I put t equals to infinity here, what this value will be? E to the power minus infinity, that would be 0. What I need to do, average here, what I am doing now, I am putting t equals to infinity. So 1 by infinity into 1 minus e to the power minus infinity. So what is the value of e to the power minus infinity? That is 0. 1 minus 0 would be 1. 1 by infinity. What is the answer? 0. And we expected this as well. What we expected? Our average will be 0. So whenever I see this kind of signal in the examination hall, what first I would think? That, sir, can I calculate the energy for this? Yes, energy will be stored in this loop. If energy is stored in this loop, that means energy will be non-zero. I don't need to calculate the energy. I will just see the waveform. Okay, energy would be non-zero. And if the energy is non-zero, average will be 0. That's it. Okay. Very, very simple. Right? Whether it is, this will be a non-periodic signal. So this is how you can calculate, or you can just think that average has to be 0 only. What about this one? E to the power t ut. E to the power t ut. Just have good amount of patience here. E to the power t ut. So at t equals to 0, the value is 1. At t equals to infinity, the value is infinity, right? At t equals to infinity, the value is infinity actually. So this is the waveform. So what was the energy for this one? It was 1 by 2a. No, it was infinity, right? I told you energy cannot be stored in any loop. It will be keep on going on till infinity. So energy was infinity. Yes or no? What I need to calculate now? We need to calculate the average. What do you think average would come out? Finite value. Check that out. Okay, check out. Minus t by 2 to t by 2. This is going till infinity only. So what I need to do? Average. So limit t tending to infinity 1 by t minus t by 2 to t by 2 e to the power t dt. Limit t tending to infinity 1 by t. Can I interchange this limit? I can change this limit from 0 to t, right? Because from minus t by 2 to t by 2, it was all 0. Before this, it was all 0. Yeah, so integration would be e to the power t only 0 to t by 2. So limit t tending to infinity 1 by t e to the power t by 2 minus e to the power 0, that would be 1. So if I put t equals to infinity here, e to the power infinity will be infinity only divided by infinity. So it is the form of infinity by infinity. So what I can do? I can apply the L'Hopital rule. I don't remember the spelling again. L'Hopital rule. So what I need to do? I need to differentiate. So e to the power t by 2 into t by 2 divided by t, and then limit tending to t tending to infinity. So this t and t gets cancelled. What we are getting? Limit capital T tending to infinity e to the power t by 2 divided by 2. You put t tending to infinity here, e to the power infinity will be infinity only. So average value is coming out to be infinity. Yeah, sorry for the interruption. So average came out to be infinity here. Okay, so we are seeing a lot of example, and the conclusion of all the examples we are going to write down. You need to have the patience. As of now, we are seeing the energy as well, average as well. Energy infinity coming out to be average, coming out to be a non-zero value, or energy average, both are coming out to be infinity, or energy is coming out to be a non-zero value or a finite value, but average is coming out to be a zero value. So all these things we are going to see now. Okay, but in the conclusion we will write down
Just one more example we need to see. After that, we will write down the conclusion that what is actually happening in all these waveform. Okay. So just to calculate the average of this particular signal. After that, we will write down the conclusion. So what do you think? What will be the average of this particular signal? Can you draw the diagram of tan t? Do you know how to draw the diagram of tan t? Xt is equals to tan t. So at t equals to 0, tan value is 0. At t equals to pi by 2, the tan value is infinity. And at t equals to minus pi by 2, the tan value is minus infinity, right? Infinity minus infinity. Then the waveform keeps on repeating. This waveform only keeps on repeating. This waveform will keep on repeating here. Okay. So this is the graph of tan. Xt versus t. So average we need to find. Is it periodic? Yes, it is periodic by pi. So what formula we will apply? 1 by pi, and then take any window. You can integrate from 0 to pi as well, or you can integrate from minus pi by 2 to pi by 2 as well, right? You can integrate from minus pi by 2 to pi by 2 as well. Tan t dot dt. Okay. What do you think? What will be the answer? People will say 0. Do you think answer would be 0? That sir, this area and this area, both would be, one area would be plus infinity, one area would be plus infinity, other area would be minus infinity. So answer would be 0. Is that so? No, it is undefined. Infinity minus infinity is not equal to 0. It is undefined, right? But sir, when we were studying doublet function, you said that this is plus infinity, this is minus infinity. Plus infinity minus infinity, you said that area is 0. But there I said that it is just there is no practical meaning of doublet function. There is no practical meaning of doublet function. That's why I said that infinity minus infinity is equal to 0. That is, there is no practical use of that. That's why doublet function is never asked in the examination. So don't go by this method. Just go by your mathematics. What your mathematics say? Infinity minus infinity. Is that equal to 0? No. So same kind of condition will occur here. Let's do the integration. 1 by pi. What is the integration of tan t? ln sec t, right? Limit is from minus pi by 2 to pi by 2. So what you are going to get? This would be, since there is mode, so ln sec pi by 2, ln sec minus pi by 2, both would be the same only, right? And even if there was no mode, still it would have been the same. So I can write down in this manner actually. ln sec pi by 2 and then double of it. So 2 I will put here. So what is the value of sec pi by 2? Sec pi by 2 would be equals to 1 by cos pi by 2. That would be equals to 1 by sine 0. That would be equals to infinity. So what we are getting? Infinity only. Here don't go by this method, sir. This area and this area plus infinity minus infinity would be 0. No. If you do the integration, you get to know that it is coming out to be infinity, and plus infinity and minus infinity is not equal to 0. It is not defined. So answer is coming out to be infinity only. So average is coming out to be infinity. So what are you understanding from here? What would be your energy here? Average is coming out to be infinity. What would be your energy here? What do you think? Here you see that energy is not enclosed in a loop here. In the previous examples, this kind of loop was there, it was enclosed here. Exponential, it was enclosed here. So energy cannot be enclosed anywhere, right? Energy cannot be enclosed. Energy cannot be enclosed. It is going towards infinity only, and again it is repeated. So infinity, one energy, another energy, it will keep on repeating. It will keep on adding up. So energy would be infinity only. Are you getting this point? Or let's just say, even if this was not there, or this was not there, only this waveform was there, only this waveform was there, and they asked you what is the energy. Again you would say infinity, because your signal is going till infinity, no? If your signal is going till infinity, so energy is not enclosed in a loop. Kind of, you can say it is not enclosed in any loop. So it is completely spread. It is completely spread like this. So it is going towards infinity only. So here your average is also infinity, and here your energy is also infinity. And you can calculate by your mathematics as well. What you need to do? Minus infinity to infinity, tan square t dt. You calculate this thing. You will get infinity answer only. Okay. So average here, energy is infinity, average is also infinity. Or you can see this is a periodic signal. If it is a periodic signal, that means energy would be infinity only, because in the periodic signal energy will keep on adding up and energy would be going towards infinity. So here you saw that energy infinity, average infinity, energy infinity, average infinity. So there is a term called bounded signal and unbounded signal. Okay, two terms are there, bounded signal and unbounded signal. So let me write down here briefly, bounded signal and unbounded signal. So what do you think? Is it bounded signal or unbounded signal? Even though I did not tell you the definition, but just by looking at the term, what do you think? Whether it will be bounded or unbounded? Unbounded, right? Because it is going till infinity. So if your xt goes to infinity or minus infinity, that means it would be unbounded, and bounded means xt can never be equals to infinity or minus infinity. So it was unbounded, right? This signal was unbounded. At any point of time, if your signal is going towards infinity, it would be unbounded. What was this? Unbounded. What was this? Bounded. It is not going to infinity. Here this was going to infinity here, that's why it was unbounded. This is bounded. What about this one? This is also bounded, no? Because at no point it is going to infinity. The amplitude, I am talking about the amplitude, xt, not about the time. Time can go to infinity. I am talking about the amplitude. Here amplitude is going to infinity. Here amplitude is going to infinity. Here time is also going till infinity, but amplitude is never going to infinity. That's why bounded. Here also time window is from minus infinity to infinity, but amplitude is never going to infinity. That's why it is bounded. This is also bounded, right? And this is also bounded. What about this? Is it unbounded? No. Although at t equals to infinity, the value is non-zero. Here at t equals to infinity, the value is non-zero. Value is 1 or a. But it is not infinity. If it is not going to infinity, then it is unbounded. Sorry, yeah, unbounded only. Here unbounded. Bounded, sorry. What I am saying. What did I say? Unbounded or bounded? This is bounded because it is not going to infinity, no? So at any point of time, if it is not going to infinity, that means it is bounded signal, right? So it is bounded, not unbounded. So all these are bounded. Okay. So this is also bounded, this is also bounded. Only unbounded signal where we saw the unbounded signal. This was bounded, this was bounded, this was bounded, this was bounded. Here we saw the unbounded signal. They are going to infinity. And here at t equals to pi by 2, they are going to infinity. At minus 3 pi by 2, at minus pi by 2 as well, they are going to infinity. So they are unbounded signal. So what did you see here? For unbounded signal, energy is also infinity and average is also infinity. For unbounded signal, energy and average both are infinity. But for rest of the cases, we will see something now. So this was our first example. What was the energy here? A square into, let's take the window, let's call this window to be alpha. So A square into alpha. This would have been the energy. What was the average? What was the average? Average was 0, because what did I tell you? I will take minus t by 2 here, plus t by 2 here, then I will integrate in between. That would be a finite value, and that finite value, let's just say that finite value is a, that I will be dividing by t, and I will be putting t tend to infinity. So if I put t tend to infinity here, it would be 0 only. So what was the average? 0, right? Here what was the energy? Energy will keep on adding up, it will be going till infinity. But what was the average that came out to be? That came out to be a by 2. Okay. Here what will be the energy? It will keep on adding up, it will be going till infinity only. So here the energy was infinity, but what was the average? This width is alpha. So what we need to do? 2 Vm by pi into the width divided by the time period. So 2a by pi. So this was the average. So till this point you thought that if your average is finite, if your energy is finite, then average would be 0. If your energy is finite, then your average would be 0. This is what you are thinking. If your energy is infinity, then average would be non-zero. If your energy is infinity, average would be non-zero. First, let me know one thing. Is it possible that energy is zero? Never ever. Energy can never be equals to zero. Okay? Energy can never be equals to zero. Zero energy means death. When you are on your death bed, at that time you are having zero energy. If you are having a life, that means you are having energy. Zero energy means it is not there. So if there is something that exists, that means it has some energy, right? Your energy might be low, but you can never say my energy is zero. So energy can never be zero, but average can be zero. Average can be a by 2 as well, and average can be infinity as well. Average can be infinity as well, but energy can never be equal to zero. Okay. In this example, what did we show? What was your energy? Let's call here this point is A. So energy was A square by 2, and we need to tell xt is A e to the power minus alpha t, where alpha is positive. So A square by 2 alpha. But what was your average? Average was 0. So one thing from here we can see that if my energy is finite, then for sure my average would be 0. What I can say, if my energy is finite, if energy is finite, then for sure your average will be 0. That means if you can store an energy in the loop, if you can store some energy in the loop, that means certainly your average would be 0. Here I can store it, average would be 0. Here I can store it, average would be 0. If I give you this kind of structure, that rest of the time it is 0, rest of the time it is 0. What do you think, what will be the average of this particular thing? That would be 0 only. If I give you a sinusoid like this and I ask you what is the average, will you do, sir, 2 Vm by pi into alpha divided by alpha? Will you do like that? No. Only one sinusoid pulse is there, no? Only one sinusoid pulse is there. That means it is not periodic. Here we did this thing. In these examples, we did 2 Vm by pi because it was periodic. But if it is non-periodic, then what you need to do? If this pulse is there, then you need to take minus t by 2. You need to take plus t by 2 here. Then you calculate this area. That would be a finite value. That finite value, let's just say, that would be actually 2 Vm by pi only. 2 Vm by pi into alpha, and then divided by that value t and limit t tending to infinity. So what will be the value? 0 only. That means if there is a finite duration signal or these kind of signals which are at t equals to infinity, which are 0. So if there is a finite duration signal or these kind of signals which are 0 at t equals to infinity or minus infinity, that means if you can store the energy in the loop, that means if your energy is non-zero, or you can say if energy is finite, then certainly your average would be 0. If your energy is finite, certainly your average would be 0. But in these cases, in which cases? In these cases, here your energy was also infinity and average was also infinity. Here your energy was also infinity, average was also infinity. What was the reason? The reason was both were unbounded. So you see the waveform. In the waveform, if you feel like that, anywhere if it is going till infinity, that means certainly the average would be infinity. And if average is infinity, if your signal is going towards infinity and average is infinity, then energy will also be equal to infinity. Basically, for unbounded signal, average and energy both would be infinity. Unbounded signal. For unbounded signal, energy and average both would be equal to infinity. But it is not certain that if your energy is infinity, then your average will be non-zero. It could be non-zero as well, or it could be infinity as well. What I am saying, if your energy is infinity, that doesn't mean your average would be non-zero value. Your average can be infinity as well. And how will you check? What you will say, sir, I need to check the waveform. If in the waveform at any point of time I am getting infinite amplitude, that means my average will also be equal to infinity. What you will say, sir, in the waveform at any point of time, if I am getting my amplitude to be equal to infinity, that means my average will also be infinity, and my energy will also be infinity, my power will also be infinity, and my RMS value will also be infinity. So whatever the concept that you are seeing with respect to average, the ditto same concept you will see with respect to power. Ditto same, nothing will change. All these things will remain as it is. Here energy is coming out to infinity, power will come out to be infinity. Average infinity, power come out to be infinity. Okay. Energy energy is non-zero here, power will come out to be 0. Energy is non-zero here, power will come out to be 0. Energy is infinity, in this case power will come out to be a square by 2. We will see that, but power will come out to be non-zero. Energy is infinity, in this case power will come out to be non-zero. Why power is coming out to be non-zero? Because at any point of time, this signal is not giving me infinity amplitude. At any point of time, this signal is not giving me infinity amplitude. Okay. Yeah. So these things we have seen. Now solve this question. You need to find the average of this particular signal. Is this periodic? No. The signal is not periodic. So what is the method? Minus t by 2 plus t by 2. Right. After that it is exponential, it is written. So what I need to do? Average limit t tending to infinity 1 by t minus t by 2 to t by 2 xt dt. Can I break it down? Limit t tending to infinity 1 by t. If I break it down from minus t by 2 to 0 a into dt plus t by 2 to 0 to t by 2 0 to t by 2 a e to the power minus t dt. Say yes or no. Have you done this calculation? A e to the power minus t 0 to t by 2 0 to t by 2. Have you done this calculation? Yes, you have done it. Where? Here. 0 to t by 2 e to the power minus t dt 1 by t. Value was 0. So this value will be thrown out to 0. Okay, you can do the calculation. What you will get here? Limit t tending to infinity 1 by t into a into t by 2. So this and this is getting cancelled out. Then you will get to know that a by 2 is a constant value. So what is the average? Average is a by 2 only. So what did you see from here? That average is coming out to be equals to the average of step. Your final average, your final answer is coming out to be equals to the average of step. Why is that so? Because there are kind of two signals. Two signals are added here. Can I break it down into two signals? Yes. I can break it down into two signals like this. What was the average of this particular signal? A by 2. What was the average of this signal? 0. So a by 2 plus 0, a by 2. That's it. Average of this signal was a by 2, this signal was 0. So answer would be a by 2 only. Okay. If I ask you, what would be the average of this signal? What would be the average of this signal? Or let's just remove it off. So all these is 0 only. So what would be the average of this signal? Let's call this point as A, or let's write it down as a next question only. I will take one more problem. What I'm gonna do? I'm gonna ask you this question, that tell me the average of this signal. This point is A, then let's make it 0, then let's make it a by 2. Okay, so this point is A. Let's make it like this. Okay, so this point is A, this point is a by 2, and this point is minus a by 2. This is your xt versus t. Tell the average value of xt. Think about it. Without even picking the pen, you can solve it. Otherwise, you can apply the method as well. No one is stopping you to apply the conventional method, because in the examination, whenever you struggle, just go by the conventional method. Why I have taken plus t by 2 here? Why not here? Because I told you the complete nature should come, right?
So average would be, complete nature should come. So limit t tending to infinity 1 by t minus t by 2 to t by 2 xt dt. Okay. So limit t tending to infinity 1 by t. Now you see one thing. You start your journey from minus t by 2 to whatever this point is. Let's call this point as alpha. Or should I give a finite number? Let's call this point as 1. T goes to 1 second it is. So from minus t by 2 to 1, only this much signal is there, no? From 0 to 1 it is 0. From minus t by 2 to 0, this is A is there. So what would be the area? AT by 2. Say yes or no? Right? Plus. Then from 1 to this value, let's call it 2. From 1 to 2, this finite area is there, right? From 1 to 2, this finite area is there. That is equals to A by 2. Say yes or no? Right? From 1 to 2, this is equals to A by 2. After that, plus this particular area is from 2 to t by 2. From 2 to t by 2. That is minus A by 2. This is minus A by 2. So what I will write down? How much will be this area? That area would be minus A by 2 is already there into t by 2 minus 2. Amplitude is minus A by 2 and the width is t by 2 minus 2. Is that fine? How did I write down the area? Is that clear to you? From minus t by 2 to 0, I wrote down the area. 0 to 1, area is 0. 1 to 2, area is A by 2. And from 2 to t by 2, the area is this. Is that clear to you? All fine? Okay. So this remains as it is, 1 by t. Now, this is AT by 2 only. This is A by 2. Here what you are going to get? Minus AT by 4 and minus E. Right? This is A by 2 and this is minus A. This is minus A. Now all will be divided with T. All these will be divided with T. So in the division, everywhere T would come. Everywhere T would come. Everywhere T would come. So T and T is getting cancelled here. T and T is getting cancelled here. But for these T is not getting cancelled. For A by 2 to A by 2 divided by T and A divided by T. So here I will put T tending to infinity. This will be constant and this will also be constant. So if I put T tending to infinity, what I am getting? A by 2 minus A by 4. What is the answer? A by 4. This is the answer. Or actually, how you could have solved it? One signal plus another signal. Here let me make it. One signal is this plus another signal is this, that is between 1 to 2, plus another signal is this, that is there from 2. So this has amplitude of A, this has amplitude of minus A by 2 and this is 1 2, whatever it is. Okay. So what will be the average of this value? What will be the average of this A by 2? What will be the average of this? Energy is finite. If energy is non-zero, average would be 0. What would be the average of this? You know that average of this thing is A by 2. If xt is having an average of A naught, if I shift it, my average will change or not? No. If I do any shift, my average will not change. Here my amplitude is minus A by 2, so my average will simply be minus A by 4, just half of that. Just half of that. So this I will prove it as well. If I shift, then my average will not change. You can see it, you can just try shifting it and you will get to know that average will not change. Just try shifting it and we have calculated no, how much this portion is giving us, minus A by 4. What I am saying, just shift this waveform and then apply the same thing, minus T by 2 to T by 2. Then apply the same thing, you will get to know that average is not changing. Average will not change if you shift the waveform. Okay. So here whatever the amplitude was, minus A by 2, half of that, minus A by 4. So this will give you average of minus a by 4, this will give you average of a by 2. Total, what you need to do, you need to add them up. Total, what you need to do, you need to add them up. So if I add them up, a by 2 minus a by 4, that would be a by 4 only. That's the answer. Okay, a by 2 here, 0 minus a by 4, that's the answer. So a linear combination of average, if I take the average on both of the side, what I do, average on both of the side, that means simply it would be average of x1t plus average of x2t. In that manner it will keep on going. Do I need to check the orthogonality here? Think about it. Do I need to check the orthogonality here? What is your answer? No. Why is that so? Because orthogonality I will check only if this kind of term comes, or this kind of term, or simply without this conjugate sign. Then only I check the orthogonality. No, because in energy what was happening? x1t plus x2t whole square. And how I was opening it up? When I was opening it up, these terms were coming. And if these terms are coming, that means then I need to check the orthogonality, that whether it will throw 0 or not. If it is throwing 0, that means energy of x1t plus energy of x2t. And if it is not throwing 0, then that area formula came out to be. But here these kind of terms will not come, no, because addition will also be linear. If I am calculating the average of a periodic signal, what I will do? T naught x1t plus x2t plus x3t. In that manner I will add it up, and then I will take dt. So average of this plus average of this plus average of this. So no need to check orthogonality. Okay, no need to check orthogonality. To check orthogonality. So what do you think? What will be the answer of this one? Average of xt. What will be the average of this? That would be 2Vm by pi into the width. I know that width will be equal to time period only, because this is a mode of sinusoid. So width will be equal to the time period only. Say yes or no? So width will be equal to time period divided by the time period. Are you getting this point? What I am doing? I am not even calculating the time period here, because I know that width is equal to time period, and then I need to divide by the time period. So that will be getting cancelled. So 2Vm by pi into alpha by alpha. What will be the area of this lobe? This lobe will be 2Vm by pi into the width divided by the time period. Here the waveform will go something like this. So if sinusoid lobe was having, this lobe was having an area of 2Vm by pi. So same goes for this one as well. Here the lobe will be somewhat like this, and then it will be repeated in this manner. So you can take this much portion. This will also have 2Vm by pi. Or someone will say that, sir, I will take the limit from here to here. Someone will say that, sir, I will take this limit. So this area plus this area, that will also be 2Vm only. Right? If you cut it from the half, then this portion and this portion you are left with. Same goes for this one as well. This portion and then this portion. So this much plus this much will be equal to 2Vm by pi only. Okay. So 2Vm by pi into alpha divided, not alpha, time period would be different. No? So here I am writing width would be different divided by the time period. Beta I am writing. What about the average of this one? 2 sin pi by 60. This kind of waveform we will get, no? 2 sin pi by 60. 2 sin pi by 60. This kind of waveform we will get. And if I integrate positive, negative, area would be 0. So what would be the average? 0. If there is no mode, so simply sinusoid will give 0 average, right? So one more point we can see from here. Energy is infinity. When your energy is infinity, average can be 0 as well, right? If my energy is infinity, then average can be 0 as well. Are you understanding this point? What about this one? What was the energy of this signal? Energy of this signal is infinity. And what is the average of this signal? That is 0. So if energy is infinity, then average could be 0 as well. It could be infinity as well. or it could be a finite number as well. Anything it could be. 0, infinity, a finite number, anything it could be, right? Although no one will ask you this kind of reasoning in the examination hall. Either they will ask you this kind of problem that you calculate the average, or they will ask you something else that we are going to see in the next lecture. Mostly the problems are asked from power, but usually people find power to be very difficult because they don't study average in this manner. We have studied average now. Now power will be simply a cakewalk for us. Simple cakewalk would be the power. Okay. So next lecture we will study about power. So here what we are getting, 2 Vm by pi plus 2 Vm by pi, and here the average would be 0 only. So answer is 16 by pi. That's the average. Okay. And one more point we can see. Which point? Do I have that point for power as well? No. So I need to take the table. Signal versus average versus we can see energy as well. So just let me know this thing. If I am saying that my xt is having a versus, I can see area as well. Area. Okay. So if I am saying my xt is having a average of a naught, energy of e naught, and area of ar naught. Okay, because I need to differentiate both of them. So what if I shift it? If I shift my signal, will my average change? No. Let's take any example. The sinusoid you can take. It was 0 only, so this example we will not take. This you can take. This example you take. If you shift it, shift here or shift there, or you can take non-periodic as well. This as well we shifted, right? If I shift it here, still there will be no impact. So no impact on average. Was there any impact on energy? No. Was there any impact on area? Absolutely no. Because the complete area I need to calculate, and area I will be calculating from minus infinity to plus infinity. So there will be no impact on area, there will be no impact on energy, and there will be no impact on average as well. Right? Okay, let's keep those examples here only. If I take the mirror image, then also there will be no impact. If I take the mirror image, then also there will be no impact. If I multiply by a factor, now what will be my average? Here, let's just say this amplitude was 1. Then my average was coming out to be 2 Vm by pi. If I multiply with the factor of a, or it actually when it was 1, then it was coming out to be 2 by pi, 2 Vm by pi. Now if I multiply with the a, then what will be the average? 2a by pi. Here this amplitude was a, so my average was a by 2. If this amplitude become a into b, then my average will become a into b by 2. So simply your average will be, here instead of writing a, I should write alpha. Okay, so it would be alpha e naught. What about energy? Alpha square e naught. This we have already seen, right? Because in the energy there would be square, and area will also be in the same manner. Area would be increasing, right? Well, let's keep those examples here only. Now what about this one? If I do this thing, 80. So now think about it. Tell me about average, energy, and area. Energy you already know. What will happen to energy? This will be compressed energy. Your time domain is being multiplied with the factor of a, so time axis will be divided by the factor of a. So this width will decrease, and if this width is decreasing, that means your energy will also decrease. What about the area? Previously the area was this one, but now the width is decreased, so area will also decrease. Say yes or no? Because what will be the area? Amplitude into this width. Amplitude was a, amplitude into width. So now if your time domain is multiplied with the factor of a, that means your time axis is divided by the factor of a. If time axis is divided by the factor of a, that means the width is reduced, so area will also be reduced. Mod of a.
Now what about average? What do you think what will happen to average? In the average what will happen? Let's take this example. This is 0. Let's take this as 1. So what was the average first? 2a by pi into the width divided by the time period. 1 by 1. Let's take this as 2. So into the width divided by the time period. Now if I do, this is your xt, if I do x of 2t, if I do x of 2t, that means this will be divided by 2. So what I will write down now? Area 2 Vm by pi into the width. Width has become 1 now. Divided by the time period. Time period is also reduced. Are you getting this point? Here what do we write down? Area divided by the time period. So this time period is also reduced and area is also reduced. So that means this factor and this factor is getting cancelled out. So there will be no impact on average value. So average value is only impacted by this factor, nothing else. Are you getting this point? Average value is impacted by this factor only. So energy and area are following each other. Energy and area are following each other. Same will happen with average and power as well. Average and power will follow each other. Okay. So last point, which what I will write down in the last. In the last we will see everything combined. That means A x of at plus b, and should not write a here. What we can write? Alpha, right? So what will be the value here? A alpha into a naught, because I know that if my time axis is being divided or multiplied, that doesn't matter because my time period will also be divided and area will also be divided. So both will cancel out. So average will not change. But what about the energy? Energy would be alpha square E naught divided by mod of A. And what about the area? That would be alpha AR naught divided by A. That's it. Okay. So this is the complete information about average, energy and area. Next we need to study about power. What we need to study about? We need to study about power. So now it will be very easy for us because we have already studied energy in a very good manner, area in a very good manner, average in a very good manner. Along with that, we have also studied orthogonality in a very good manner because orthogonality will be very important in power. Okay, so let's meet in the next lecture. Thank you very much. Hi everyone, welcome back. So let's start studying about the power now. Okay, so till now we have seen the formula of area. This was your area. This is how we calculated your area. We saw the energy as well. In the energy, what we did, similar to area, just I took the mode of xt and did the square. So area and energy are interrelated. Say yes or no. Then we saw the formula for average. But there were two formula for average, right? One was for the periodic signal, that you will integrate it for a particular time period and then divide by the time period. Or what you are going to do, symmetric time window you are going to take, then divide by the time window, stating that the limit will be tending to infinity. Say yes or no. Now similarly, average is inclined towards power. Okay, so there is a relation between, there is no relation actually, you can say that say area and energy was inclined towards each other. So similarly, average and power will be inclined towards each other. So for periodic signal, what would be the formula of power? What do you think? Again you will integrate for a time period only and then you will divide by the time period as well. But now you will integrate mod of xt whole square dt. So this would be the formula of power for periodic signal. What you are going to do? You will integrate mod of xt square dt for a time window, or you can say for a time period, and then divide by that time period. So what is the time period here? 2, right? Here the time period is 2. So what will be your power? Power will be 1 by 2. You need to integrate for time window from 0 to 2. But it is there from 1 to 2, it is equals to 0 only. Okay, let's write it down. Let's write down the definition first. Now how will I break the limit? I will break the limit in this manner, that from 0 to 1 it is a square dt. That's it. Okay, so what we are getting? A square by 2. What was the energy of the signal? Energy was infinity. What was the average of the signal? What was the average? Area divided by time period, that was a by 2. Energy was infinite, average was a by 2, now power is a square by 2. Okay. Power is a square by 2. Let's go to the next one. Find the power of xt. Find the power of this particular signal. What was the energy of this signal? Since it is periodic, so energy was infinity. What was the average? Average was 0. Why average was 0? Because positive and negative both for cancelling it out. But in the power, what you need to do? You need to take the square. When I calculate the power, what I'm gonna do? I'm gonna calculate the square. So I need to do the square. So when I do the square, what will happen? The negative part will become positive. This negative part will become positive now. Right? This part will become positive now. So at 3, previously you were having the amplitude of 3. Here the amplitude of 3 you were having. Now the amplitude will be 9, plus 9 it would be. At 3 you are having the amplitude of minus 3. Now the amplitude will be plus 9. Okay. This point is 2, this point is. So what do you think? What is the time period? Time period is 2. Right? Time period is 2. And here the amplitude is 9. But this is not sinusoid. This is the square of sinusoid. So can I write it down in this manner? 3 square. So this is the square of sinusoid. That is 3 sine pi by 2t square. What I need to do? What I need to do is that I need to find the power. So 1 by time period. Then from 0 to 2, 3 sine pi by 2t whole square dt. One thing, you can do the integration. If you want to do the integration, you can do the integration, you will get the answer. Okay, very easy, very easily I can do the integration, I will get the answer. But what do I remember? This is your energy of a sinusoid pulse. Energy of a sinusoid pulse. What was that? Vm square by 2 or the peak square by 2, that would be 9 by 2 into the pulse width. So this would be the answer, 9 by 2. What is the power we are getting? 9 by 2. So the power is 9 by 2. Unit would be watt. Okay, unit would be watt. Previously as well the unit would be watt only. So are you able to understand how did I write down this integration very easily? Either you can do the integration, on your own. This would be 9 square sine square pi by 2. Then what will happen? Sine square pi by 2t, you will write down 1 minus cos pi t by 2. Then that 9 by 2 will come outward. That would be 9 by 4. And when you do the integration result will be 2. And the cosinusoid part will be going towards 0. So 9 by 4 into 2, that would be 9 by 2 watt only. Or you can remember that, okay, sinusoid energy of that particular sinusoid, that I already remember, that is Vm square by 2 into the time width. So 9 by 2 into the time width. So this is how we are getting it. Okay. Now let's see this formula carefully. So can you write down this formula of power in this manner? That sir, 1 by T naught, energy of a pulse. What do I mean by that? Energy of a pulse for time t. For time t naught, sorry. What do I mean by that? Can you see this particular expression? Is it like energy only? Yeah, it is nearly like energy. If it would be completely energy if you only take this much pulse into action. If I take only one time period into action, if this was the scene, that it is there for only this much time, after that it is all 0. It is not periodic. I am not saying that function is periodic. If this was only the scene, then what would have been my energy? My energy would be take the square of it and then integrate. So if I calculate the energy of a pulse and then divide by the time period, will I get the power? Yes. Are you able to understand this point? Although when you write down the formula of power, what you do, for a particular time period, you calculate its energy only and then divide by the T naught value. Here I am not saying that energy is finite. For this complete waveform, energy is infinity only. But what if I assume it as a single pulse only? I am taking all these pulses to 0, all these pulses are going to 0. I am taking it as a single pulse only. So what I am going to do, I am going to calculate its energy and then divide by T naught. That's it. Or you can simply write down the formula. When you write down the formula, you will feel like, okay, I need to calculate this area only. And if I remember this area, then my job is done. Right? Now power of a periodic signal. So what do you think, what will be the formula? Here your limit will tend to infinity. You will divide by the time window t, but the time window t you will take in a manner that here it is minus t by 2 and here it is plus t by 2. Okay, and then you will integrate from minus t by 2 to t by 2. What you will integrate? Mod of xt square dt. So if you have studied average in a good manner, then power is simply a cakewalk for you. So can you do this process? Can you write down the answer on your own? Certainly you can write down the answer on your own. So what will be my power? My power would be limit t tending to infinity 1 by t minus t by 2 to t by 2. Can I break the, okay, first write down the formula only. Mod of xt square dt. Now I can break the limit because I know that from minus t by 2 to 0 it is 0 only. So I will break the limit from 0 to t by 2 a square dt. So it would be a square t by 2 and then t to t will get cancelled out. Answer would be a square by 2. So this is your power. This is your power. What was the energy of this signal? Energy was infinity. So energy of this signal was infinity. This is the power. Let's go to this one. What do you think? What will be the power? Power will be actually 0, but let's check that out. Again minus t by 2. Will I take t by 2 here? No, I told you t by 2 should be very larger enough. If you are directly looking at the power portion only, so you are doing it wrong. First you need to see the orthogonality, then you need to see the energy, then you need to see the average, and then you should come to power. Because I know that some people on YouTube will be only looking at the power, because people have a lot of confusion in this particular topic, that is of power. But first you need to see the orthogonality, then you see energy, then you see average, and after that you come to power. Now power is simply a cakewalk for us. Everything we already know. Now power will not be difficult. But if we start without even building our base, then it becomes difficult for us, right? So this is what I need to do. Now, although I should not care whatever this value is giving me, because this will be a finite value. So although I should not care about it, but let's see what it will give me. So it would be 4 square into 2. 4 square into 2 divided by t, limit t tending to infinity. So if t tends to infinity, this would be 0. So what is your power is coming out to be? Power is 0. So here power is coming out to be 0. But what was your energy here? Here energy was 4 into 2, right? For this particular example, my energy was 4 into 2, because 2 square into 2. So that was 8 joule. So here my energy was 8 joule. Again we will write down the conclusion, but the conclusion will be ditto same as your average only. Okay, whatever that we saw in the average, the same conclusion we will see here as well. Now in the examination they can ask you root mean square value, RMS. What they can ask you? Root mean square value. Root mean square value. So whenever they ask RMS, the only task you need to do is that first you calculate the power and then take the under root. So if the question is coming on RMS, what is my task? That I will only calculate the power and then take the under root. That's it. If the question is on RMS, that means the question is on power only. So first calculate the power and then take the under root. Nothing else. Okay. Like what will be the RMS value for this particular problem? That would be 0. What will be the RMS for this particular problem? Here the RMS would be under root 9 by 2, right? Under root, just take the under root. In the same manner here as well you take the under root. What would be the RMS? RMS would be a by under root 2. Calculate the power of these two signals. What we need to do? A. Can you draw the graph? Certainly you can draw the graph. Which graph I am drawing? XT graph I am drawing. First I will draw the graph of XT. Now I know that when I do the square, it will be positive. When I do the square, this will be positive, right? When I do the square, this will become positive. All the negative part will also become positive. Here also there is a negative part. And here what is the time period? Time period is 4. So this point will be 2. And this point will be 4. This point will be 6. This point will be minus 2. Right? And here the amplitude is 2. Say yes or no. Okay. Now, when I do the square, basically what will be my power? My power will be 1 by T naught for a particular window. Now people will be having the doubt that sir, this T naught would be the time period of this xt, or it would be the time period of mod of xt square. This T naught here, what is the time period of xt? The time period of xt is 4 seconds, right? But what would be the time period of mod of xt square? That would be 2 seconds for this particular problem. So here I should put 2 seconds or 4 seconds. You can put anything, answer would be same. Mod of xt, whatever the time period it is having, or mod of xt square, whatever the time period it is having, you put anything, answer would be same. Why is that so? Because eventually you are dividing by the time period, no? Eventually the time period is being divided as well. Here kind of it is multiplication. When you are calculating this area, it is kind of multiplication, but the time period is being divided as well. So you can take anything, but ideally it is the time period T naught is the time period of xt. Actually you should put xt here. Here you should put the time period of xt. Okay, as per the formula. But you can put anything here. Any time period you can put, whether it is of xt or mod of xt square, both will give you the same results. So this is your xt, right? These are the points. Now I know one thing, what this value will give me. What I can do, if I am putting the time period to be 2 seconds, if I am putting the time period to be 2 seconds, that means I have already done the square. When I do the square, this will happen. When I do the square, this will happen. So negative part will become positive part. Now what I need to do, for this much window, I need to calculate my area. What that area would be? A square by 2 into the time width. A square by 2 into the time width divided by the time period. So this would be my answer, 4 by 2. Okay, or can I write it down in this manner? A square by 2. So here only I would have written a square by 2. That means I am writing 2 square by 2. So what I am writing, this is my answer, 2 square by 2. This is the answer. Or what I would have done, that sir, you take the time period to be 4. You take the time period to be 4. So what would be the power if I am taking the time period to be 4? So 1 by 4 into the area. Area of this lobe and area of this lobe. Both the area would be same, right? So what I will write down? A square by 2 into the width, that is 2, and then multiply with 2. Because this area and this area would be same. So what will happen? 4 and 4 is actually getting cancelled up. What is the answer we are getting? 4 by 2 only. So answer would be same. This answer and this answer is same. So you take any time window, any time period you take, whether you take the time period of xt or you take the time period of mod of xt square. In both of the cases, your answer would be same only. Okay, because time period is actually being divided. And how did I calculate all these things? Are you able to understand the point? Because I know what will be the area of this loop or of this lobe. So I will make the diagram, then I know the area, that would be a square by 2 into the width divided by the time period. A square by 2 into the width divided by the time period. Okay. What about this one? For B. If I solve for B, so what I can do, I can copy this diagram. My B signal is 2 sin t. 2 sin t. So what will be this point? This point will be pi, because 2 sin t, what will be the time period? 2 sin t, what will be the time period? Here you can see omega is equals to 1. So time period would be equals to 2 pi. So this point will be 2 pi. Right? Now square also I can do, or I can see from here as well. So what will be the answer? Eventually what will be the power of answer? What will be the answer of power? Can I take this? Can I take this much time period? Yes. If I am taking the time period of pi, that means what I am saying, only this area I will take. What will be this area? A square by 2. A square by 2 into the time period. into the time window. The time window is pi. So what I am getting? Again I am getting a square by 2 only. What did you see here? What I need to do? I made the waveform. This is the waveform I am having. Then I made the waveform. Then what did I do? I did the mode and then square. Take the mode and then square. Then what will happen? This positive part, this negative part will become positive part. Negative part will become positive part. So eventually your time period is being half. But you can take 2 pi time period as well. You can take pi time period as well. But whatever the time period you are taking, you need to write down the area of that time period. So if I am taking the time period of pi, so I need to write down this area only. But if I am taking the time period of 2 pi, then I need to write down this area plus this area as well. Answer would be same only. Okay. So when I take the time period of pi, then what was the answer? 1 by pi into what is this area? This area I already know because mode of xt square, what it will give me? A square by 2 into the width. A square by 2 into the width. Pi getting cancelled out. A square by 2 answer I am getting. So what did you see here? No matter whatever your function is, sinusoid, cosinusoid, whether you are having pi by 2 here your time period was 4 seconds. And in the second case, your time period was 2 pi seconds. Here your time period was 4 seconds and in the second your answer was 2 pi seconds. In both of the cases, your power is coming out to be a square by 2. So no matter any sinusoid or cosinusoid is there, no matter whatever the value of alpha, whatever the value is, power will be always a square by 2. Here it would be b square by 2. For sinusoid or cosinusoid, whatever that happens for sinusoid, the same happens with cosinusoid as well. So power will always be a square by 2. For a sinusoid function, the power will always be a square by 2. But what I have seen with what people remember that the area of this loop is a square by 2. No, the area of a mode of xt square would be a square by 2 into the width. Now divided by the time period. Are you getting this point? Are you understanding this point or not? Now let me frame a question. What I am gonna do? I can frame a good question out of it, I guess. This is your xt. Okay, this is a sinusoid lobe only. Sinusoid lobe then 0, sinusoid lobe then 0, sinusoid lobe then 0, and it is being repeated. And this is having amplitude of 3. Okay. Now if they ask you to calculate the power of this particular function, then what you are going to do? It is periodic. Okay, it is periodic. Now what I need to see? I need to see one time period. What is one time period? One time period is 2. So what will be the power? So power will be 1 by 2 into. Now what I need to do? Mode of xt square and then area for one time period. What I need to do? I need to calculate this thing from 0 to 2 mode of xt square dt. Isn't it like the energy only? This is energy only, no? For 0 to 2, if I only consider this pulse, then what would be the energy of this pulse? That only I need to remember. So what people usually do is that they only remember this formula a square by 2. That power is a square by 2. They don't even know what is the area of this lobe. They think that the area of this lobe is a square by 2. But the area of this lobe is not a square by 2. A square by 2 into the width. The area of this lobe is a square by 2 into the width. So here what will be the area of this lobe? What will be the area of this lobe? That would be a square by 2 into the width. 3 square by 2 into the width. So 9 by 4. So that would be 9 by 4. Okay, and then divided by the time period, that is 2. So what will be the answer? 9 by 8 watt. Same goes for average as well. In average, what people remember that area of this lobe is 2 Vm by pi. 2 Vm by pi. So that would be 2 into 3 by pi. But no, area of this lobe is 2 Vm by pi into 1 by 2. This width. Okay, so if in the examination they would have asked you what is the average value of this waveform? What is the average value of this waveform? What you would say? For average value, what I need to do? Divide by the time period and then calculate this area. What will be this area? So this area would be 2 Vm by pi into the width, that is 1 by 2. So this would be the answer. So cut this cancels out, 3 by 2 pi. So this would be the average. Okay, a very interesting concept. Like people usually just they only remember that okay, the area of this lobe is 2 Vm by pi. The area of this lobe is 2 Vm by pi into the width, 2 Vm by pi into the width divided by the time period. Time period is 2. That's it. Okay, so this was the average of xt, and this was the power of xt. But in the power, what I need to do? I need to take the square. So if I take the square, I already remember the result. What result I get? A square by 2 into the width. A square by 2 into the width. So two things are there, 2 Vm by pi into the width and a square by 2 or Vm square by 2 into the width. That's it. Okay. So if Vm is given, you can find out, and you know the time period or you know the width of sinusoid lobe, then you can find out everything. Is that okay for you? Only these two things are there for sinusoid and cosinusoid, and you would be able to answer all the things. And if they are only asking the power, then just remember for sinusoid and cosinusoid, power is a square by 2. For cosinusoid, power is b square by 2. That's it. Okay. No matter whatever the angle is there, a square by 2 directly, b square by 2 directly. Okay. Well and good. Let's find out the power for this one. Try it on your own. 0 to 4. What I will do? Power would be, since it is periodic, so 1 by 4, 0 to 4, mod of xt square dt. What do you think? What is this? Do you know the value of this particular function directly? Isn't it like the energy from 0 to 4? If I only consider this pulse, what will be the answer for this? This was a square by 3 into the width, right? Never ever forget this width. So what will be the answer? 1 by 4 into a square by 3 into the width. Okay, so 8 by 3. Power is 8 by 3 watt. A square by 3, 16 by 3 into 2 divided by the time period, that is 4. So 8 by 3 watt. So in the examination hall, I am not gonna solve these kind of problems again and again. Like I'm not gonna write down the equation and then I will do the integration, all these kind of things. No, I remember three results: square, a square into t, sinusoid, a square by 2 into t, and triangle, a square by 3 into t. So a square by 3 into width. Okay, well and good. Let's go to the next one. Find the power of the given signals. Find the power of all these given signals, and without even finding it, you should be able to tell the answer. Without even doing the calculation, you should be able to tell the answer, because we have seen average, and I am saying that whatever that happens with average, the same thing happens with power as well. So what do you think? E to the power minus t ut. E to the power minus t ut. This is how it goes. So at t equals to 0, it will give me value 1. At t equals to infinity, it will give me value 0. What I need to do? Minus t by 2 to plus t by 2. Then I need to calculate the power. Okay. So limit tending t tending to infinity, minus t by 2 to plus t by 2, mod of xt square. Mod of xt square would be, okay, first let's write down the definition only. Mod of xt square dt, and divided by time period, I forgot. So limit t tending to infinity, 1 by t. This is going from 0 to t by 2. 0 to t by 2, because minus t by 2 to 0, it is minus t by 2 to 0, it is not even there. So from 0 to t by 2, then e to the power minus 2t dt. Okay, you do this integration on your own, because I have told you how to do this kind of integration. It is very easy. Since it is recorded lecture, so I have to do it, because I don't know what how people will be taking it. But if you are watching it recorded and you already know these kind of integration, then just ignore this part. Okay, then you will put limit t tending to infinity here. So what you are going to get? Let's go on the next page. This is simple mathematics. You should be able to do it. So already negative sign is there. So that negative sign I can take downward here. And then I need to put e to the power minus t minus 1. E to the power minus t minus 1.
if I put t equals to infinity here, so that would be 1 by 2t. So 1 by, if you put t equals to infinity here, e to the power minus infinity is 0. 0 minus 1 will be minus 1. Minus 1 into minus 1 would be plus 1 divided by 2t, 2 into infinity. So that would be 0. So what is the power that is coming out to be? 0. So for this exponential function, what is the power? 0. For the second one, what do you think what will be the power? Yeah, for this one, what was the energy? For this one, what was the energy? You know that energy can be stored in this loop. So what was our energy for this one? It was a square by 2a. A value is 1, a square value is also 1. So energy was 1 by 2 joule, right? But what about e to the power t ut? E to the power t ut. So at t equals to 0, it is 1. At t equals to infinity, it is infinity only, right? So this is xt versus t. So find out the power for this one from here. So again the same thing, minus t by 2 to t by 2. So 1 by t. Now I can take the limit from 0 to t by 2, because from minus t by 2 to 0 there is no function, right? Before that it is all 0. Before this it is all 0, right? So what I will do, 0 to t by 2, then I just need to do the square, e to the power 2t dt. Okay, so 1 by 2t e to the power 2t. Yeah, one more thing I forgot to put here. What is that? Very important thing, power limit t tending to infinity. Limit t tending to infinity. Okay, divided by t, 0 to t by 2. Limit t tending to infinity, 1 by 2t e to the power t minus 1. So what will be the answer? Here what do you see? This would be also infinity, this would also be infinity. So you can apply the L'Hopital rule. So if I apply L'Hopital rule, what do I get? E to the power t upward divided by 2. Now if I put t equals to infinity, what I am getting? Infinity. So what is the power? Infinity only. And you kind of expected it as well, right? Because I told you, if any function is unbounded, what kind of function it is that? Unbounded. So in that unbounded function, our unbounded, क्या कर रहा हूँ यार मैं? Unbounded, our energy is also infinity and power is also infinity, right? What about the next one? What do you think? What will happen to tan t? So I am already having the graph of tan t. Here I am having this graph of tan t. I am already having. So I will just simply copy it. For tan t as well, the same kind of integration you need to do. Now simple mathematics is there, but your intuition also says one thing, that yeah, this is also unbounded signal. So for unbounded signal, we already know unbounded. No matter whether it is periodic or non-periodic. This was periodic signal, this was non-periodic signal. This was non-periodic plus unbounded. This is periodic plus unbounded. Okay. So even if it is periodic or non-periodic, if the signal is unbounded, the power and energy both will be infinity. So energy I already know, that would be infinity. What about the power? Power can you calculate? Certainly I can calculate. Tan t is given, so this would be minus pi by 2 and this would be plus pi by 2. That would be 1 by pi minus pi by 2 to plus pi by 2 tan square t dt. Just a second, light went off. Yeah, so let's do the integration. So 1 by pi, then tan square t, how would you do it? Although the answer we already remember, that is tan t minus t, but you can do sec square t minus 1, sec square t minus 1 dot dt, right? Because 1 plus tan square t is equal to sec square t. So sec square t would give you tan t and this would give you t, right? So 1 by pi. What is the integration of sec square t? That is tan t only. Tan t minus t. From minus pi by 2 to pi by 2, right? So 1 by pi tan pi by 2. What is the value of tan pi by 2? Infinity. Minus pi by 2 minus. What is the value of tan minus pi by 2? That is equal to minus infinity.
minus infinity, minus plus pi by 2. So what is the answer we are getting? Infinity only. Power is equals to infinity. Okay. So here energy also infinity, power is also infinity. So now there is a signal called energy signal, there is a signal called power signal, and then there is a signal called neither energy nor power signal. Are you getting this point? There are signals called energy signal. What is the meaning of energy signal? That here your energy will be finite and non-zero. Finite and non-zero. Okay. But your power would be 0. Power would be 0. Did we get 0 power? Yes. Here your energy was finite 1 by 2 joule, but power was 0. Are you getting this point? So people actually get confused. They don't remember that sir power will be infinity or power will be 0. Power will be 0 here. If energy is finite, your power will be 0. You always remember this example, exponential. You always remember that here my energy would be 1 by 2, but my power would be 0. So this is an energy signal. Okay. What do you mean by power signal? Power signal simply means that your power would be non-zero and finite. Finite and non-zero. Finite and non-zero. Okay. This is in the power signal. Power will be finite and non-zero, but energy would be infinity, not equals to 0. Okay. Energy would be infinity. What is the meaning of infinite energy? Energy is infinite. Meaning of infinite energy is infinite. In periodic signal you get infinite energy, but in periodic signal sin t, in periodic signal what is your power in this signal? A square by 2. But what is your energy? Infinity. Okay, so these two examples you remember. This is a power signal, this is an energy signal. Which is an energy signal? This is an energy signal. What about this signal? UT. Is this a power signal or energy signal? This is a power signal, because what was the power? A square by 2. But what was the energy? Infinity. Right? What about neither energy nor power? Both will be infinity. Energy will be infinity and power will be infinity. And one thing you have already seen, that energy can never be equals to 0. Energy can never be equals to 0. So this is known as energy signal, power signal, and neither energy nor power. Neither energy nor power. Okay. So these kind of signals are there, neither energy nor power. So let's see the signals one by one. What do you think? It is an energy signal or power signal? What was the energy of this particular signal? Infinity. What was the power of this particular signal? If I call this point as A, that was A square by 2. So what do you think? What kind of signal is that? Power signal. Power signal. Okay. Here at a particular, is this periodic? Or let's see more points about this. This signal is periodic, right? Is it bounded or unbounded? Bounded. Periodic plus bounded. This is your periodic plus bounded. Okay. What about this one? This is your periodic. Is it bounded? No. Unbounded. Right? What will be the, what was the energy? Infinity. What was the power? Infinity. So here energy and power both are infinity, that means it is neither energy nor power. So what is the important point here? The important point is unbounded. Because it was unbounded, that's why energy and power was infinity. If it is periodic, then alone periodic cannot tell that whether it will be energy or power signal, or neither energy nor power. Along with that, you need to see the boundation as well. If it is bounded and periodic, then certainly it would be power signal. And if it is unbounded, or it could be anything, whether it is periodic or aperiodic, if the signal is unbounded, then it would be neither energy nor power. What about this signal? Is it bounded? Yes. Is it periodic? No. Non-periodic plus bounded. So here you can see that energy will keep on ending up. But what would be the power? A square by 2. Right? If I assume this as A. This also we assume as A, and this width you can take as alpha. Right? So energy was infinity, but power was A square by 2. So what do you understand from here? That, and if it is a bounded signal is there. The signal is bounded, but the signal is non-vanishing. New word I am introducing, non-vanishing. What is the meaning of non-vanishing? Non-vanishing means at t equals to infinity. Non-vanishing means at t equals to infinity, it is xt is not becoming 0, or at t equals to minus infinity, xt is not becoming 0. Vanishing means at t equals to infinity at steady state. Steady state, the meaning of steady state is t equals to infinity only. So at t equals to infinity, the function is not giving you infinite value. But it is bounded as well, that at any point of time also it is not giving you infinite value. But at t equals to infinity, it is not giving you 0 value. Since it is not giving you 0 value, that means it is non-vanishing. If it was giving you 0 value at t equals to infinity, then it would have been vanishing. So what do you think, which signal is vanishing? This signal is vanishing. This is your, we will come back to this slide, but what you will call it? This is your non-periodic, aperiodic or non-periodic, whatever you can call it. What we are writing, non-periodic only. The other name is aperiodic, okay? Other name is aperiodic or non-periodic also you can say, non-periodic. Plus, is it bounded? Yes. Is it vanishing? Yes. So what would be its energy? Energy would be 1 by, let's call it a, and a e to the power minus alpha t, where alpha is positive. Okay, so that would be a square by 2 alpha. The energy would be a square by 2 alpha, right? But what was the power? Power was 0. Power was 0. What about this signal? Is it aperiodic? Yes. Is it bounded? No. Unbounded, not non-bounded. Unbounded. And if it is unbounded, there is no chance that it would be vanishing. So it is non-vanishing as well. Say yes or no. So what would be its energy? Infinity. And what would be its power? That would also be infinity. In these questions here, why did not, can we write down vanishing or non-vanishing? No, we cannot write down, because the value will be toggling, no? Like at t equals to infinity, can you tell me the value of sinusoid function? Can you tell me the value of this sine infinity? No, you cannot tell. Value will be between -1 to 1. It could be anything. Same goes for tan as well. Can you tell me the value of tan infinity? No. It could be anything. Between -1 to 1, it could be, sorry, between minus infinity to infinity, it could be anything. So here value will be toggling. Toggling means value could be anything there. So that I cannot comment whether the value will be 0, or it would be equals to -1, or it would be equals to -1 by 2, or it would be equals to 1, or it would be equals to 1 by 2, whatever it can be. So here I cannot comment whether it is vanishing or non-vanishing. So let it be. Just let it be like this. Yeah, this was done. This is also done. What about this one? Here, what was your energy? Energy was a square into alpha. But what would be your power? Power was 0. What about the nature of this signal? The nature is, it is bounded plus finite duration. Finite duration plus non-periodic plus vanishing. Right. So these are the scenes. Now in the examination hall, this kind of question will come. But first let me answer this question. If a signal is periodic plus bounded, what should come into your mind? Sinusoid. Periodic plus bounded. It is periodic plus bounded as well. Will it be energy signal or power signal? So it should come into your mind, okay sir, periodic it is, that means cycles will keep on repeating, that means certainly my energy would be infinity, because cycles will keep on repeating. Now what about the power? Okay, it is not unbounded. If it is not unbounded, then power will be finite. Power will be finite and non-zero. That means it would be a power signal. What you will think? Again I am telling. Periodic signal and bounded signal. Periodic, since it is periodic, cycles will keep on repeating, energy would be infinity. But now what about power? Power will be infinity, or it would be some non-zero value. So power will be a non-zero value because it is bounded. Now aperiodic plus bounded plus non-vanishing. Aperiodic plus bounded plus non-vanishing step. Aperiodic, yes. Bounded, yes. And non-vanishing, that means at t equals to infinity it is still existing. So you would think that okay sir, here the energy would go to infinity. Energy will certainly go to infinity, but here the power is finite, a square by 2. Why power is finite? Because it is bounded. If the signal is bounded, the power has no issue. The problem comes when signal becomes unbounded. Unbounded signal, whenever there is unbounded signal, it is neither energy nor power. You don't need to think anything else. Whether it is periodic, aperiodic, if the signal is unbounded, whether it is periodic, aperiodic, if you see it is unbounded, that means if xt is going towards infinity at any point of time or minus infinity, that means it would be neither energy nor power. Otherwise, it could be anything. It could be power as well, it could be energy as well. So that you need to think. So here what you will think, aperiodic, bounded plus non-vanishing. You will see non-vanishing. That means at infinity as well there is some value. And if at the infinity as well there is some value, that means certainly my energy cannot be equals to finite. Because at infinity if it is having some value, that means energy will keep on adding up. And if energy keeps on adding up, that means energy has to be infinity. And secondly, it is bounded, that means it will certainly be a power signal. Are you getting this point? First I thought of energy. I got to know that it is not energy signal. Then I will think of bounded or unbounded. So if it is not unbounded, that means certainly it has to be power signal, because a signal will either be energy or it will be power signal or it would be neither energy nor power. So I opted out energy signal. I opted out neither energy nor power signal as well. So what is left? Power signal. Finite duration plus bounded. Finite duration. But in the finite duration as well, it is bounded. What I mean to say is that, let's just say this is my signal. At t equals to, let's just say 2 seconds, it is going till infinity. Is it finite duration signal? Yes, because it is bounded between these 2 seconds only. After that it is all 0, after that it is all 0. It is finite duration, yes. But it will be neither energy nor power. Why is that so? Because it is unbounded. At a value of t, at t equals to 2, you are getting infinity value. So finite duration signal plus bounded, that means this kind of pulse. Finite duration plus bounded. So it will certainly be energy signal, right? Because here you can say that my energy is enclosed in this loop. Aperiodic plus bounded plus vanishing. Aperiodic plus bounded plus vanishing. Vanishing means at t equals to infinity it is going to 0. That means in this loop I can take my energy. Okay, in this loop I can take my energy. That means in this loop I can store my energy. And what do you see here is that no signal can be together energy or power signal. That means for a signal your power is finite and non-zero. Finite and non-zero. And energy is also finite and non-zero. Both together not possible. Both together not possible for any signal. So any signal can be either energy signal, or it could be power signal, or it could be neither energy nor power. But it cannot happen that it is both energy, both power. What I am saying, both energy and power not possible. Not possible. So are you able to understand all the conclusion now? So if I give you a random waveform, will you be able to tell me whether it will be a power signal or energy signal? If I give you this kind of waveform, after that it is all 0. So tell me whether it is energy signal or power signal. It is energy signal because it is bounded. So here I can enclose my energy, here I can enclose my energy. So yeah, it is energy signal. If I give you a signal like this, it goes up like this and then like this. So what do you see? The energy will be infinity here, right? Because it will keep on adding up, energy would be infinity. Is it unbounded? No. That means it would be power signal. It is not unbounded, right? It is not keep on increasing, right? Now what do I do? I make the same waveform, but this is something that I do. I am telling that first it rises linearly, then saturates, and then again rises exponentially. That means it is unbounded signal. At infinity, it is giving you infinity value. It is unbounded. What does that mean? That means it is not a energy signal, neither it is a power signal. So neither energy nor power. So by the waveform, you can tell now all kind of signal, whether it will be a energy signal, power signal, or neither energy nor power. Write down the answer of each statement. Okay, which of the statements are correct? Click on right or wrong. Okay, and have the patience. Consider all the condition and then click on right or wrong. I will take a pause and then you can check the answers. Okay. Yeah, so let's start. A periodic signal can never be an energy signal. Certainly it is correct. Why is that so? Because if it is periodic, that means cycles will keep on repeating, energy will keep on adding up and it will go to infinity. A periodic signal is always a power signal. Is that correct? A periodic signal is always a power signal. No. Take an example of tan t. So tan t is periodic with the time period of pi, but it is not a power signal. Why is that so? Because it is unbounded. So periodic plus bounded should also be there. What is the condition? Condition is it should be bounded. That is wrong. A finite duration signal is always an energy signal. Is that correct? A finite duration signal is always an energy signal. No. Which example I have given? This example I have given. That sir, it is 0, then it rises up, then it goes like this. So this is a finite duration signal, but it is unbounded. So what is the condition? Again, the condition is of bounded. So this is also wrong. So finite duration plus bounded signal is always an energy signal. A finite duration signal can never be power signal. That's for sure. A finite duration signal can never be power signal, whether it is bounded or unbounded. Look, if it is bounded, then it would be energy signal but not power signal. If it is unbounded, then it would be neither energy nor power. So it can never be, a finite duration signal can never be a power signal. That's for sure. For power signal, either you have to be someone periodic, or if you are aperiodic, then you should be non-vanishing, right? Because you see the condition of a power signal. If you has to be periodic, and if you are aperiodic, then you should be bounded and non-vanishing you should be. Take an example of UT, right? If it is vanishing, then it would be certainly an energy signal. People are like, this is a very complex topic for a lot of students, but now we have just broken it down in pieces. So now it would be easy for you, I guess, right? A non-periodic signal is always an energy signal, and non-periodic signal is always an energy signal. No, it is not necessary, right? Because it may go to infinity, or it may be simply UT as well, right? It may be simply UT. This is aperiodic, but it is not an energy signal. A non-periodic or aperiodic and bounded signal is always an energy signal. Yes. A non-periodic and bounded. Okay, wait a second. Okay, they did not say finite duration. Okay, wait a second. This is wrong. This is wrong actually. A non-periodic and bounded is always an energy signal. No. Take an example of UT, no? Just take this example. It is non-periodic, yes. Is it bounded? Yes. Is it an energy signal? No. So this is also wrong. Non-periodic plus bounded plus vanishing. This is the condition, right? Non-periodic plus bounded plus vanishing. This is the condition of energy signal. Or finite duration plus bounded. This is the condition of energy signal. Rest all will be neither energy nor power. All clear? Now the small topic is left. That is, this question we will solve, and after that we will see power of addition of mutually orthogonal signal. So if signals are mutually orthogonal, so what will be the power of xt? That would be equals to power of x1t. Same goes with energy as well. Ditto same thing is there, but x1t, x2t, x alpha t all should be mutually orthogonal. All should be mutually orthogonal. Now you will have the doubt, sir, what if they are not mutually orthogonal? So how we will calculate? So by examples we will see. Okay, by examples we will see if they are not mutually orthogonal, then how will you calculate? If they are mutually orthogonal, then calculate the power of x1t, x2t, and then just add them up. But if they are not mutually orthogonal, then how will you calculate? And do you remember the condition of mutually orthogonality? Yes, two conditions were there. For periodic signal there was different, and for aperiodic signal there was different. For periodic signal, what you will do? For periodic signal, you will take x1t, take x2t, conjugate, and it should come out to be 0 for a particular time period. For a particular time period, your x1 conjugate t dot x2t should be coming out to 0. And if it is aperiodic, then you will integrate for the whole condition, for the whole time window. Right? So these are the condition of orthogonality. Orthogonal. And what do you mean by mutually orthogonal? x1t, x2t, x3t mutually orthogonal. That means x1 should be orthogonal to x2, x2 should be orthogonal to x3, and x1 and x3 should be orthogonal to each other. That means you can see three axes, no? This is orthogonal to this one, and now let's take my thumb. So this my thumb is orthogonal to these two as well. So all three are orthogonal to each other. So we can say mutually orthogonal. Okay. You calculate the power of this particular function. First, you let me know what is the power of a DC. What is the power of a DC? What will be the power of this DC? Or you can say A, you take care. Can I break it down into two step function? Yes. One step would be this, plus other step would be this. Are they mutually orthogonal? Yes. Do I know the power of this step? Yes, a square by 2. Do I know the power of this step? Yes, a square by 2. What will be my answer? A square. That's it. So what is the power of this? Power is a square. Or what you could have done? Forget about mutual orthogonality or anything. Just go by the basic definition. What does the basic definition says? I'm only finding the power of DC. So what does the basic definition says? That says that since it is a aperiodic signal, so you need to take a window from minus t by 2 to t by 2 x mod of xt square dt. So between minus t by 2 to plus t by 2, what is the value? A only. So this will become a square. A square. So limit t tending to infinity, 1 by t, a square into t. So t gets cancelled out. What you are left with? Power is equals to a square. So this is the answer. Okay. Power is equals to a square. Or by breaking down into two steps also you can see. So this is the answer. Power is equals to a square. Now just let me know, are these two orthogonal? Are these two orthogonal to each other? First, you let me know, is this signal periodic? Yes. Periodic with how much time period? Time period is 2 pi. So can I apply the formula? Yes. But first let me know, are these two orthogonal to each other? They are actually, right? Because one is 2 and other one is sinusoid. When you multiply both of them, what will happen? This is 2, this is sinusoid, that is 3. 3 sin pi t. When you multiply both of them, what will happen? The sinusoid amplitude will increase. That will become 6. Since it is a periodic signal, what I need to do to check the orthogonality? Since it is a periodic signal, to check the orthogonality, what I need to do? I need to take the integration for one time period. I need to take the integration for one time period. Whatever it is, sin t. So in one time period, what will be the integration value? That would be equal to 0. So are they orthogonal to each other? Yes. A DC and a sinusoid is orthogonal to each other. If they are orthogonal to each other, what I can do? I can take the power separately. What will be the power of this thing? What will be the power of this? Power of this will be a square. And what will be the power of this? 3 square by 2. And they are mutually orthogonal to each other, that I have proved. 2 into the sinusoid, and then both sinusoid have multiplied. So this is what I will be getting, and then I need to integrate for a particular time period. So they are mutually orthogonal as well. Or what you could have done? What you could have done? You would have find out the power 1 by t naught, 0 to 2 pi, 2 plus 3 sin t square dt. I am keeping this integration on you for the first time. Okay, do this integration on your own. But I have proved these two are mutually orthogonal to each other. So if they are mutually orthogonal to each other, what I can do? I can separately calculate the energy. Sorry, I can separately calculate the power of this guy and then the power of this function as well, and then add them. So what will be my total power? A square plus, that's it. Okay, is that okay for you? All good? This I have already seen. Let's try finding out the power of this particular signal. Try it on your own. I will pause the video, try it on your own. Try finding out the power of this particular signal. You can do it. Certainly you can do it. Just think about it. Break it down. Break down the signal. When you break down, you will see something.
Yeah, so did you break it down? So how will you break it down? Let's copy this one. So here, first signal I will break as step. So all these I will remove. So first one is broken as step. Rest all part is 0. Okay. Plus second. This is gone. This would be the second part, right? This would be the second part. Secondly, I am breaking like this. Or some people would have broken like this part separately and this part separately. But conclusion you can see here now, right? Because why I am breaking like this? Because I know that this will be my energy signal. Because energy can be trapped here. Energy can be trapped here in this loop as well. So energy can be trapped. So this would be energy signal. And if it is an energy signal, that means power would be 0. For this I already know the power. And for the last one what I will do? The last one here, this was our 2a, right? In the last, this is our 2a actually, right? So this is t. So this is how in 3 signals I can break it. So what is the power? And all 3 are orthogonal to each other because this exists till this point only. Then after that, these exist till this particular point only, and after that, this only exists, right? So all 3 are orthogonal to each other. When you multiply all 3 of them, when you multiply this one with this one, here I should not write xt. Let's call it x1, let's call it x2, and let's call it x3. So x1 multiply with x2, 0. x2 multiply with x3, 0. x3 multiply with x1, 0. Right? So what will be the power here? A square by 2. What will be the power here? Since this is an energy signal, because energy can be trapped here. Energy can be trapped here. So this is a finite duration signal. This is a finite duration bounded signal, aperiodic as well. So here energy will be, sorry, here the power would be 0. Energy would be some finite value that I don't care, but power would be 0. And what about the power here? 2a square by 2. Yeah. So you would say that, sir, I have studied the power for this particular signal. What if I shift it? So shifting doesn't change anything. If you shift it, the power will not change. You can derive it. What you will do? Take minus t by 2, take plus t by 2, and then check the power. It will not change. Shifting will not change the power. Same goes with average as well. Average was also not changing by the shifting. Energy was also not changing, and area was also not changing. So by shifting, nothing changes. You can derive it. Okay? You put the formula and derive it. It doesn't change. So here the energy would be, sorry, power would be 2a square by 2. So what would be the total power? Now you can add them up. So a square by 2 plus 0 plus 2a square by 2. So that would be 5a square by 2, right? 4a square. So 5a square by 2. This is the power, and this is the answer. Okay, well and good. Let's see it for sinusoids. Sinusoid or cosinusoid. So all 3 are orthogonal to each other. Say yes or no. All 3 are mutually orthogonal because different frequencies are there. Why so? Different frequencies are there. Pi 1, pi by 2. Different frequencies orthogonal to each other. And this is a DC. So what I am gonna do? A square by 2 plus a square by 2 plus a square by 2 plus DC square. This would be the answer. For a sinusoid, what is the power? A square by 2, a square by 2, a square by 2 plus DC square. That's it. Here, orthogonal to each other. What you will see? Sir, same frequency. Okay, I need to wait now. Sine, 0 degree phase shift. Pi by 3 minus pi by 6. Pi by 3 minus pi by 6. So what is the phase shift now? Pi by 3 minus of minus pi by 6. So phase shift is pi by 2. And this is what I need.
If it is there, that means they are orthogonal to each other. So on orthogonality, I have spent good enough time. You should watch that orthogonality video. It is the video of roughly around 1.5 hours. So that is very, very important. So now all these are kickbook for you if you have studied orthogonality. So a square by 2 plus a square by 2. So dc square plus a square by 2 plus a square by 2. And why dc square? Because I know that the power of dc is dc square only. And all three are orthogonal to each other. What about this one? What you will see, sir? Same frequency, sir. One is cos, another one is sine. So already there is a shift of pi. Now, what is the shift in the angle? Pi by 4 and minus 3 pi by 4. Pi by 4 minus 3 pi by 4. 45 degree minus 135 degree. So what it would be? 180. So I don't care whether it would be plus minus, but one guy will say it could be minus pi by 2, other guy would say it could be plus 3 pi by 2. And I am okay with both. If my phase shift is odd multiple of pi by 2, I am okay with that. So it will certainly be a odd multiple of pi by 2, because 90 degree from here, another 180 degree I will be getting from these two guys. Okay. So my job is done here. Orthogonal. Again the answer would be 2 square plus a square by 2 plus a square by 2. Now what if this kind of signal is given in the examination? You will see, sir, different frequency, but here same frequencies. So this guy is orthogonal to this guy, and this guy is orthogonal to this guy as well. So this is ortho, and this is also orthogonal. But problem is between these two, they are not orthogonal. They are not orthogonal. Why is that so? Same frequency, but what is the phase shift? This is 60 degree, this is 30 degree. So phase shift is 30 minus 60, that is 60 minus 30, that is 30 degree, or you can say minus 30 degree. Phase shift is not an odd multiple of pi by 2. So that means they are not orthogonal. So now I need to make it orthogonal. So in the orthogonality video, did we see how to make a non-orthogonal signal orthogonal? Yes. What I need to do? I need to open it up. So now I need to open my sinusoid and cosinusoid, and when I open it up, you will see that everything has become, what everything has become? Everything has become orthogonal. Okay. So just open it up. So 3 plus 2 sin A cos B plus cos A sin B, right, into 3 sin A cos B plus cos A sin B plus cos A sin B plus, just keep it as it is. Don't do anything with that. Will you open it? Will you apply cos A plus B here? No. It is already orthogonal to each other. No. It is already orthogonal. So don't do anything with that. Cos pi by 2t plus pi by 6. So 3 plus 2. Cos 60, that would be 1 by 2. So sin pi t by 2. Sin pi by 3. Sin 60 under root 3 by 2 cos pi t plus 3 cos pi by 6 cos 30 cos 60, it was, yeah, cos 30. क्या कर रहा हूँ मैं यार? Cos 30 will be under root 3 by 2. Yeah, sorry. I always get confused between 30 and 60, and I don't know why I always take the example of 30 and 60, because that's the only good example. If I take example of 45 degree, then it would be very simple, no? Because sin 45 and cos 45 both would be 1 by under root 2 only. But yeah, cos 30 degree, that would be under root 3 by 2, and here sin pi t plus sin 30, that would be 1 by 2 cos pi t by 2 plus keep this signal as it is. So whatever that signal was there, I will keep that as it is, plus 2 cos pi by 2t plus pi by 6. Okay. So 3 plus sin pi t plus under root 3 cos pi t, right, because 2 and 2 will get cancelled, plus 3 under root 3 by 2 sin pi t plus
3 by 2 cos pi t plus 2 cos pi by 2t plus pi by 6. So what you are getting? 3 plus. Now sin pi t is here and sin pi t is here. So what you are getting? 1 plus 3 under root 3 by 2 sin pi t. Cos pi t is here and cos pi t is here as well. So under root 3 plus 3 by 2 cos pi t and rest as it is. So now I have broken it down into 3 orthogonal signals. Say yes or no. Pi t, cos pi t and sin pi t, are they orthogonal to each other? Yes. And then there is a different frequency. If different frequency is there, then they are certainly orthogonal. So this signal is orthogonal to this one? Yes. This signal is orthogonal to this one? Yes. This and this are orthogonal? Yes. Different frequencies, and here there is a shift of 90 degree. So now we have broken down into orthogonal signal. So now what will be the answer of power? So power would be DC square. What is the DC? 3. 3 square plus 1 a square by 1 plus 3 under root 3 by 2 a square by 2, right? A square by 2 plus under root 3 plus 3 by 2 a square by 2 plus again a square by 2. So that would be the answer. You can calculate it. So I will calculate it and check back my calculation as well. So this is how you need to solve. So when we studied about orthogonality, there we saw a lot of example like that. I guess 3 to 4 examples were there where your functions were not orthogonal to each other, but you made them orthogonal. How did you make them orthogonal? Just by opening up the sinusoid and cosinusoid. So this is the best possible method in the examination hall. Although this big calculation will not come in the examination hall, they will give it easy only. So if you feel like that they are not orthogonal, then just open it up and solve it. Open it up. Once you open it up by sinusoid and cosinusoid, you will see these kind of things there. They will become orthogonal, and if they are becoming orthogonal, you can apply the formula. So don't blindly put the formula 3 square plus a square by 2 plus 3 square by 2 plus 2 square by 2. That would be wrong. First you need to see the orthogonality. Here the formula will work, but first I need to see the orthogonality. If they are orthogonal, then this formula will work. So I will write down the calculation now and write down the final answer. You can also do the same. Yeah, so this is the answer you would be getting. So power is 22.69. So in this concept, we are not seeing more examples. The same example that we have seen in orthogonality, the same kind of example you can take and solve it on your own. So in orthogonality, we have reached till this step. When we studied the lecture of orthogonality, there we have reached till this step, right? So this step we have already done. After that, you can do this step, right? Now, if your signal is xt, your average is a naught, energy is a naught, area is ar naught, and I am saying my power is p naught. If I do the time shift, will there be any impact? No. If I do the mirror image, will there be any impact? No. If I multiply with the factor of alpha, so now what will happen? If it was 1, my average was a square by 2. If I make it a, then my average would be a square by 2. That means it would be alpha square into p naught. What about the, if I multiply my time domain by a, will there be any impact? No, because in the power, what do? In the power, you divide by the time period as well. Same goes with average. In average, we were dividing by the time period. So what will happen? The time period will also be divided by a factor of a, and here the area will also be divided by a factor of a. So this factor and this factor will be getting cancelled out, right? In the power, you can check this thing. You can take any example. Take the example of sinusoid. So in sinusoid, we saw no, like for sin t, what is the power? If it is a, so what is the power for sin t? A square by 2. What is the power for a sin 2t? That is also a square by 2. So even though you change the time, but here power is again a square by 2. So there is no impact on scaling in time domain. Okay. So even you multiply your time domain with a or you divide it by a, nothing will work. The power will be same as it is. So what about the last one? What about the last one? So in the last one, only thing that will be impacted will be alpha square p naught. Okay, that's it. Well and good. Let's solve this question. This was asked in GATE only. Very easy question. You need to tell the power of GT and RMS value of GT. Can you do it on your own? GT is xt minus 1 by 2. Xt function is given.
So can you let me know one thing? The power of gt will be equals to how much power of xt? Power of gt would be equals to power of xt only, right? Power of gt would be equals to power of xt. Say yes or no. And how will you calculate the power of xt? You will do the square, you will do mod of xt square, and then you will calculate the area for a particular time period. Why is that so? Because it is periodic with the time period of -1 to 2. That means it is periodic with the time period of 3. So how will I calculate the power? That would be, sir, 1 by 3. 1 by 3. Then I need to integrate from 0 to 3 mod of xt square dt. So it is like a energy of a pulse, energy of this particular pulse. And what that energy would be? This is your triangular. Do I know the mod of xt square triangular area? Yes, that area would be, sir, a square by 3. That means 3 square by 3 into the time window. This time window is 1. Then again the same thing is happening, a square by 3, because this will become positive. So a square by 3. Again this time window is again 1. After that this area would be 0 only. So this is the answer. So 9 plus 9, a square by 3, 9 by 3, that would be 3 only. This will also be 3, 3 plus 3, 6, 6 divided by 3. So answer would be 2. So here your power is coming out to be 2. I hope you are able to understand this point, because we have spent good enough time. 0 to 3, 1 by t. 0 to t, 1 by t. Since it is periodic, so 0 to t, 1 by t. So 1 by 3, then I know what will be the energy of this signal. What will be the energy of this signal? I just need to add them up. So a square by 3, 3 square by 3 into this time window, plus 3 square by 3 into this time window, plus 0. So power is coming out to be 2, and RMS will be under root 2. This is the answer. Okay. So yeah, that's it about our power signal as well. In the next video, we need to study about even signal, odd signal, and then we will study about conjugate symmetry and conjugate anti-symmetry signal. Okay, so these 4 signal we will study about. So that will be in the next marathon. So I hope this power, energy, and average area, everything is crystal clear to you, because these are very important. From this particular topic, there is very high chance that one question would come from energy, power, or anything. From there, usually questions come from there. Okay then, thank you very much.